This learning path is intended to help learners to prepare for their exam developing solutions for Microsoft Azure AZ-204 certification exam. Microsoft Azure developers are responsible for taking part in each phase of cloud development process. They define solution requirements and design, develop, and maintain those same solutions. Azure developers are also responsible for performance tuning and monitoring for those solutions they create. The content in this path can help you kickstart your exam preparation and build the beginning foundation for your journey to become a certified Microsoft Azure Developer Associate. Although this is just beginning and just start with Azure, if you are really familiar with Azure, well and good. If you are starting with Azure, this series can be also a good starting point for your concepts, and then from there on you can learn yourself. So please another suggestion, please write down your comments and questions and suggestion in the comment box. This channel really needs your support, so in order to make these videos visible, please like, share and subscribe if you haven't done so. To make this content free and available to everyone, I put around 100 hours of hard work and preparation, so I would appreciate your thumbs up, and I will not talk about it again in the video series. So let's sit back and enjoy. The AZ-204 exam is suitable for developers that want to prove their Azure cloud knowledge and skills, want to learn more about the Azure cloud, and want to become a better developer. Before you sit in the exam, you should ideally have at least 1 or 2 years of experience, professional experience, including experience with Microsoft Azure. In addition, you should have a certain degree of proficiency with Azure SDKs, Azure PowerShell, Azure CLI, data storage, data connections, APIs, app authentication and authorization, compute and container deployments, debugging, performance tuning and monitoring. But if you are new, if you don't have all this, still you don't have to worry. Everything can be learned, right? And this video series can be your starting point as well, because I kept things not that high level, not that low level, and I think for the beginners and also for mediocre, this series is gonna be a really good one. So let's continue. About I'm your host and host on this channel, Tech of the Day as well. I have started this channel 2 years ago, but I didn't have much time and didn't put much efforts. Content on this channel previously was not so good. The voice and the quality of videos were not so good. I didn't have enough time and I couldn't do that, so that's a problem. But now I promised to you all that I will try to create better content, and I hope this content is better this time. Let's start. Skills measured. Prerequisite according to Microsoft candidates for AZ-204 developing solutions for Microsoft exams should have, as I said already, 2 years of exams, 2 years of experience. But apart from that, you are measured on these 5 topics, and I created 5 parts out of these 5 topics. So develop Azure compute solutions, develop for Azure storage, implement Azure security, Azure monitor, troubleshoot and optimize Azure solutions, connect to and consume Azure services and third-party services. I created 5 parts out of these, and each part is having again detailed explanation about everything. So like develop Azure compute solutions itself is a really big part, which is developing Azure web apps, creating Azure virtual machines, or creating containers, Docker containers. We will talk all about it, and I will be using also sometimes Azure portal, sometimes Azure CLI, sometimes Azure PowerShell. So let's continue. Then future outlook. The average salary for Azure developers starts around $50K, let's say, and it can range up to $250K. Your salary will depend partially on your location, and if you live in a higher paid location, like say in New York City, or let's say Europe, somewhere in Amsterdam, then you might have a six-figure salary easily. Those with senior level of Azure developer roles understand the development aspects and most of the other Azure services extremely well, and they are typically leaders of engineering departments and go-to professionals for any Azure development related issues. So compensation for them will be really high. But I want to promise you one thing, that this is really trending, and if you are beginner in cloud, don't waste much time and start increasing your worth, because worth is a big word, so to say, but this will give you a lot of exposure, let's say on LinkedIn, and you will start getting messages from recruiters. What course, what tools are at your disposal? You have this video course, of course, this video series on this YouTube channel, and there are labs which I will be covering in a separate video, and then there is practice exam. Video for this video series, I promise I will cover most of the topics, and I will try to at least give you 30-40% of your knowledge you need to finish the exam, because once you have that knowledge, just you need to go on Microsoft Learn or do some practical labs yourself, and then you will be fine for the exam. On, or if you want to wait for my labs, then it's well and good, and then you can subscribe, and then you will be notified for the labs part and the practice exams. This video series is the first coming up in this, but you might, if you want to wait, you can wait for the next two as well. So that's it. Enjoy. Let's continue. So this is a goggle design which was done by Sean Bart, and I did not want to change it. I just wanted to use it because yeah, it's a lot of hard work he put in, and I'm just reusing it. Why not? So as you can see here, the whole syllabus for AZ-204 is put in here. I would highly recommend you to go through this and check it out. It's a really commendable job he did, and I just don't want to waste time doing this, but redoing this, didn't want it to waste time. Anyway, if you can see here, he has covered it according to the chapters. So develop for Azure storage, you see here. So develop for Azure storage, develop Azure compute solutions, and implements Azure security, connect to and consume Azure services and third-party services. And he has divided it according to the parts. So monitor, troubleshoot, and optimize Azure solutions. And then further, he had divided and created a nice goggle. So I would highly recommend you to go through it and use it. I would say that's the best thing. Perfect. Thank you. Azure App Service Web Apps. So this is itself. So as I said, out of 5 parts, this is the first part of the first part. So I will call this as module if in the future of this video, and then this itself is divided into 4 parts: explore and creating Azure App Service, configure web app settings, scale apps in Azure App Service, explore Azure App Service in deployment slots. So let's continue. If we talk about create Azure App service web apps. We will be going through introduction, understanding app service plans, isolation with app service environments, creating web app in the portal, creating web app in Azure CLI PowerShell, and creating web app using ARM templates. So how do you manage and scale web applications running on the Azure app service? That is the focus of this course. Hey there, this is Nitesh Sharma, your host, and I'm super excited to have you with me in this course. In this first module, we are going to talk about creating Azure App Service web apps. So let's go ahead and walk through what we are going to cover in this first module. So to kick things off, we are going to basically get an understanding of app service plans. App service plans are essentially the compute platform that run the web application. So we need to have a solid understanding of how those work. In addition to app service plans, there is also a concept called app service environments. This is where we could run isolated web applications. So we will go ahead and take a look at that, and then I will walk you through creating web apps in the portal. I will walk you through creating web apps with Azure CLI, as I already said, with PowerShell, with command line, and with ARM templates. By doing deployments using ARM templates, that becomes infrastructure as code implementation as well. And then in the remaining modules in this course, I'm going to show you how to manage your app service environments, how to manage your web applications, and then we will also take a look at how you can scale web applications for the production environment. Every module is going to include some hyperlinks where you can just go to Microsoft Learn and know more about it. So thanks for staying with me till now, and let's continue the course. Creating web apps in Azure App Service is actually really easy to do for most of the part, but it does require a good understanding of app service plans. But let's first make sure that we are all on the same page, and we'll just take a look at what Azure App Service actually is. So Azure App Service is the HTTP based service for hosting web apps, and it's just basically a very advanced version of web hosting. So that's what it is all about. Microsoft makes it easy for us to run applications that run on Windows platform or on Linux. There is all kind of different frameworks that we can use to run our applications. So for example, we could use ASP.NET or ASP.NET Core. We could also do Node.js, Python, PHP, and bunch of more other frameworks. And with these web apps, we can deploy code directly to app service, or we can use Docker containers. So we have got a lot of flexibility when it comes to running certain application types. A variety of different frameworks are supported, and since app service is managed service, meaning Microsoft does all the heavy lifting. They are going to make sure that environment is secured. There is basically integrated load balancing, and then just with any cloud service, like we always see, we have got the ability to do automation. So we got automation in terms of deploying code to our app service, and we also have got the ability to just automate the deployment of the infrastructure itself. Not only that, we can also auto scale at the compute layer. So behind the scene, the virtual machines are what really power an app service plan, and we can actually say, hey, let's scale out to 2 or 4 instances to support some kind of dynamic load, where we can scale on schedule. A lot of capabilities are there. And when it comes to working with app service, one of the biggest consideration is that costs are determined by the app service plan. So depending on the type of compute environment, the app service plan environment you select, that dictates the cost. So let's continue. There are two different types of app service plans. And this is very critical concept here. So two types of app service plans that you want to think about. So there is non-isolated app service plan and there is isolated app service plan. Let's continue to a couple of major points that I want to focus on here. Let's say user can come from the internet, hit the app service, web app, and ultimately our web apps run on top of a service plan. And now these web apps can integrate with other resources. So you can see storage account or other resources, SQL, Azure SQL, database infrastructure, or let's say other apps. The big takeaway that the app service plan can be one or more virtual machines. Behind the scene, Microsoft manages the compute layer. They make sure that the virtual machines are patched and they are highly available and that they are functional, all that kind of stuff. They are also doing a bunch of security things under the hood. Now we also have the ability to implement security controls as well as in terms of who can actually authenticate and open up our applications from the internet. But ultimately we can deploy multiple web apps on top of an app service plan, and that app service plan is scalable. So the big difference between non-isolated app service plan and isolated app service plan um, that are not inside a virtual network. So this app service plan that we are looking at here is basically your typical app service plan implementation with no isolation at the network layer. Now the majority of app service plan types are non-isolated types. Let's talk about what those are. So non-isolated app service plans types are free and shared. Now there is a big difference to think about these two. The pricing tiers are that they are not intended for production web applications. So free tier is kind of self-explanatory. You don't have to pay for that. And currently, yes, when I'm recording this video, the resources that they give are so pretty low. And the shared plan is also another non-production grade type of app service plan. Now again, low amount of resources, it's very inexpensive. And the other thing that you want to keep in mind that that the free and shared actually run on shared infrastructure. So that means that other apps running on the same VMs. And so again, that's another reason why we don't want to run production web apps on free and shared tiers. From there we have the basic service plan. So the basic service plan is designed for apps that have lower traffic requirements. We don't need advanced auto scaling and traffic management features. And again, this is just for maybe some more robust development and testing type of infrastructure, but it basically doesn't have the advanced control that you would need for production grade applications. And so that is why we have the standard tier. The standard tier service plan is designed for running production workloads, and the pricing is based on the number of instances you run. So we will talk about this and in more depth later. But you basically have an app service plan powered by one virtual machine to start with, and we could add more later. We can also add more automatically through auto scaling, which we will cover in the next chapters. There is the premium V2 service plan type. This is designed to provide enhanced performance for your production grade applications. And then finally, there is premium V3 service plan type. This is just upgraded premium plan for offering that came out recently, and this is now available, which offers faster processors and few other bells and whistles. Now you might be looking at some huge list here and getting worried about memorizing all these little details, but really you just want to make sure that you understand the difference between free, shared, basic, standard, and the premium pricing tiers. So the big takeaway for the clip is that if you want to run web applications in production, you should be using standard or one of the premium tiers or app service isolated, which will we talk about in the next one. um, that we have discussed running web apps in non-isolated environment. Let's talk about uh, isolation with app service environments, also known as ASE. So we had ASE 2 v2, and now we also have ASE v2, sorry 3. So with ASE, this is fully isolated and dedicated environment for running your web apps. So it is still app service, it is still a managed service, but just the big difference here is that you got the entire compute environment for yourself. And but and you also get the isolation of being able to put it in your own VNet. The other nice thing about ASE is that it's designed for high scale, it's designed for high memory utilization. So if you are looking to do more ambitious work on app service, maybe you have got really demanding web application and other pricing tiers that aren't working for you, ASC might be an option for you that you might want to explore. Now, the isolation and secure environment network access is one of the things that most interesting to enterprises. One of the sticking point with doing managed service is lack of isolation at the network layer. So Microsoft changed that with app service. Teams can now put the app service environment inside their own VNet and control all inbound and outbound traffic. So with controlling all the outbound and inbound traffic, ASE can take advantage of existing VPN connections back to on-prem, and you might have a real fast connection back to on-prem environment. And this might be really interesting way to allow on-prem applications communicate with apps that you have got running in your own VNet in ASE. So So as you see here, I am in my Azure portal, and I am going to create our first app service. So let's go to on my left side of my panel. Let's go to app service, and let's click here, and there is already one in the free tier. I have already created one, and I will just want to create one more. Let's say, so to create one more, it will go to take me to this space where it will say, it will by default select my one of the subscription if I have multiple, and then it will ask me to give the source group. I will select tech of the day, and then I can select one of the web app name. And to pay attention here, it should be unique. So if I say the same tech of the day, this name as you see here is already taken, so it is not available. Let me zoom it a little bit. Yeah, I hope it's visible. And you see here, um, how do I want to publish it? It is already asking me if I want to publish it via code, Docker container, or static web app. If I select static web app, then it just asks me to create accelerate your app development with managed global availability with static content hosting and dynamic scale. It is not asking me for anything else. If I go to Docker container, it just asks me for many things like which operating system I want, which region and app service plan, and blah blah blah. But if I just go with the code as well, it will ask me to which runtime stack I want to use, because yeah, if I'm using the code, then it will ask me what do I want to do. So let's say .NET, and which is like you have already .NET LTS, you have .NET Core, you have previous versions of .NET, and then you have Java, Node, PHP, Python, Ruby, have a lot of options. If I select .NET LTS 6, and then I need to select which operating system I want to use. This is really important because you might be using few things related to Windows or Linux. Then you should choose wisely according to your app service, and then you select the region where you want to deploy your app. This is still not clear, so I will just put 1 here. So yeah, it is unique now. It shows green. And then if you see here, it is asking me to select SKU, which is basically in the app service plan. So basically it is asking me to create an app service plan. It says new. If you don't have any, it will just create new, and you can select here with this and create your own tech of the day app service plan, and I just say okay. And then if I want to change the SKU, for now it is using by default standard S1 and 100 ACU and 1.75 GB memory. If I want to change the size, I can just go here, and you see here you have more options like dev test, which has shared uh, shared environment. Then you have for production, you have other options, really a lot of options. And because with the shared you have pretty low options, see additional options if you want, but you don't have many features like custom domain and all that. But and you see this one is free shared infrastructure. Others are also shared, but they have other more options. um, and the production one has having other options. You have, and these are changing every day, so I don't want to remember them all the time. And then you have isolated, which we just talked, like this is your own private virtual machine, and this is really expensive. You see 691, 1383, or 345. For the production, you still have pretty good options like 123 until 812. You also have other options, but yeah, you have a lot of options. And I will just go with this because yeah, I don't want to pay for it. Let's go. And I changed this the tier, and now I have shared infrastructure and 1 GB memory only. I don't think it is enough, but anyway, we just want to create review and create. So now I'm ready with my app service, and I can just press create and it will be creating. Perfect. Deployment is in progress, and we can see that it is going to create. All right, I will give it some time, and oh yeah, it is pretty quick. As you can see, yeah, it's pretty quick. Okay, and I can just go to resource, and it is ready. And here you see I have a lot of options which I can just play around. Scale up, scale out, web jobs, custom domain, although this might not be. Yeah, I can have a custom domain. Click here to upgrade service plan to assign custom host name to your app, because it is not allowed in the free domain. Anyway, I don't want to I don't want to do it. You have other options, and you also have getting over. If I go to overview, I have by default this sorry, these details for error and data in and out and other analytics work, which we will talk later. Quick start. In the quick start, I can just deploy it, follow the quick start guide with .NET, PHP, or Java, Python, Node.js, and I can just click here and just go with the .NET, and I can just yeah, do a deployment, which I don't want. Yeah, so that was it for creating a web app. Oh, sorry, I forgot deployment slots. So in the upgrade, you have to upgrade to standard or premium plan to add slots. But what I want to show you is it has production and staging slots, or you can have multiple slots and you can just switch slots so that your app can swap. So you see here you can add a slot and you can swap a staging environment which is working fine, then you can swap to production and then take the production app for testing. You can do a lot of things with it. Basically it is like you can swap with another ready to use app, and slot is basically like a copy of your existing app. So that's it for creating app using Azure portal. Let's continue with I'm here again in my Azure portal and we want to create web app using Azure CLI. So here I just can go to PowerShell, and you have an option in your Azure portal to do it with the PowerShell. So but before doing it, it just creates Azure Cloud Shell storage because it needs to store that somewhere. So it is going to create a storage account. I say create, and let's wait for it. It will take some time. Basically what is happening, it is creating under the hood, under the subscription, it is creating a storage account which will host my PowerShell or Azure CLI command lines, basically to run all this. And it also installs Azure CLI or PowerShell, because if I want to do the same thing if I want to do the same thing in my desktop, or I mean in my personal laptop, I have to install everything. So if I don't want to do that, then it will prepare an environment for me and then it will have the thing ready for me. So let's see. Okay, requesting Cloud Shell, and it is ready, kind of preparing for me. And the good part is it will already log in me and give me the ready environment. You can select Bash or PowerShell here. Now it is requesting Cloud Shell and then connecting to the terminal. So basically it is preparing the environment for me. And once it is ready, I can just go and execute my things. But before that, I will just show you what do I have already. So I have, so it is ready, and I just do it like this. It just created 3 resource groups. So I created tech of the day, and it created Cloud Shell Storage West Europe for the Cloud Shell itself. And let's go, and I can just copy paste what I have just from my series here. So I can just copy paste it. So I have this CLI command which says create AZ-create group, because we need a group, a resource group. I could reuse the existing one, then I don't have to do this one again. And then I'm creating web apps dev rg, which is for resource group, and the location is West US2. App service, so then I need to create an app service plan which is with the name web apps dev plan. In the resource group, this one SKUS1, a host is Linux. And then finally I'm creating my web app, which is a web apps dev rg web app this blah 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 with this runtime node.js. So let's hit and see what happens. So behind the scene, it is executing all my commands, and if I go here, it should, in some time, there should be a new resource group. Okay, so I see one thing. Region has a quota of 0 instance for your subscription, because my subscription is free. Unfortunately, I'll change the I will change the I will actually reuse the existing resource group, because yeah, that will give me um, now that will give me profit. I don't have to create then the new. um, I will use this one, the existing one, and let's continue. So if I just redo it and web app create g web app, but before that I need to create a plan, and resource group for that plan will be my resource group then. So I will delete this one, and I can change it to my resource group, take off the day, and then so this will create a plan. We are simply creating AZ app service plan create with this name and SKU S1 and the host Linux. Once it is created, then I can create the web app. Okay, the plan is created, and now I can just create the web app. But one thing I need to do is I need to change the resource group, because yeah, this didn't work. So I need to put my own existing resource group, because I'm having free subscription tier, so I'm not allowed to have multiple locations, and unable to retrieve the existing sorry part of the current subscription. Sorry, so I need to change the app service plan as well. Let's see. So finally it created my web app with I needed to change few names, but if I go to my resource group, take off the day, and check the resources here, refresh it, you will see it created app service plan, web app dev app plan, and then it created uh, look, I'll make it bigger. um okay, so it has quite a lot of number of sources. It created apps a web app dev plan, which I just created, and it created the web app service. I go back here, you see it has all the responses back from it. If I just go to it, and the name was take off the day 2. So if I just go to this one, copy, and just go to your app is running and waiting for your content, and it is saying Node.js built with Node.js. So my app is ready and deployed with Cloud Shell or Azure CLI. Same way we can do it with PowerShell. Created a web app using Azure CLI in the cloud. In the Azure portal, you already have that cloud Azure CLI, and you can make use of that to execute your Azure CLI commands or Azure PowerShell or PowerShell commands. And to do that, I just clicked in the portal as you saw in the previous step, and then that led to creation of a storage account, and it prepared an environment for me that could be used to execute CLI commands. And same for PowerShell. If I do it locally, I have to install it, as I said. So I don't want to do that, and that's why I used that option in the portal. Same way, I could do the same thing using PowerShell. And to do that in PowerShell, I'm here creating a PowerShell script, which is basically a PowerShell script having some variables. So get repo, location, web app name, and location. So these are the variables I am having for my PowerShell. So first of all, if you don't know how to use PowerShell, just go through it, and notice few differences between Azure CLI and PowerShell. In Azure CLI, everything starts with AZ, and then this source. Here you see everything starts with new or verb. So new, create, remove, blah blah. So everything starts with the verb. Uh, So you see here, I'm creating a new resource group. If I already have one, I don't have to, I will not create it. And here I'm creating app service plan in that location, and the name of the app service plan is name of the web app itself as well. And I'm putting it in the free tier. And then I'm creating a simply web app and its location, and then app service plan is the app service plan I just created, and then resource group name which I just created. So simply I'm creating resource group, app service plan, and then a web app. And in the end, I can just configure GitHub deployment from your GitHub repo and deploy it once. So you can just say you can set these properties, say properties object, you create a properties object with the repo URL, which is get repo here, branch is master, is manual integration is true, and set then Azure resource properties and set the resource properties like this. So you're simply saying you're setting properties for your Azure resource, which is which happen to be a type of web app. Here you see web Microsoft.web.website source control, and then you're setting the source control to that git repo. And you are applying API version here, which is another formality. So basically you can do the same thing with Azure PowerShell, Azure CLI, what we did in the Azure portal. Now next is creating. So now we want to do the same thing with, once we have done with portal, Azure CLI, PowerShell, and we can do the same thing with ARM template as well. And to do that with ARM template, I have this link here, which is from Microsoft Learn, which is quite good explanation of ARM templates, how you want to do it, what is ARM template, how you could do it, and it is explaining also the basic structure of an ARM template here, which has a lot of elements here. So basically to deploy from the ARM template, you can use Azure CLI. So you just say Azure group create, and then you create the resource group, and then you create a deployment. Pay attention here, it is a type of deployment. Let me make it bigger. I guess it is visible now. So you see here, it is, so resource group, creating resource group is like, yeah, whatever it is necessary for the deployment. But the basic thing is you need to create a deployment. You just create a deployment in this specific resource group with the parameters you want to apply. So you can send the parameters, and then you are saying template URI, right? And your template, which happen to be your template for the ARM template, so the which happen to be a template for creating websites, is here. So simply you are using ARM template to create your web app. What is the benefit of having it like this is simply it's like you can keep the template in your resource control, which means you can create a repository and store that there, and then you can have the version control as well. So you are not doing anything manually by going to the web app itself. Let's say when one resource is not working, you just go there and change few settings, and then oh, this was not working because then I changed few settings here and there, and then I don't know anymore. I don't keep the version of my web service, what changes I did, which was the problem in previous deployments, in previous technologies without cloud or without version controlling, without, yeah, like when we used to deploy an app using MVC to a on-premise service server, and when things were not working, let's say, and then we used to change something manually, and we don't know anymore what we changed actually. So it's really something really useful. If you want to do it, you should just store your all the changes in source control, and then you can easily track the changes you made. So simply it is an ARM template, and then I can just go here. You see, I can just go here. I can just say deploy to Azure. For Linux or Windows, they have pre-built ARM template, and I can make changes for them as well. You can also do one more thing. You can use your existing, I can use my existing web app, and I can create ARM template for this. So if I go here and if I look for um, export template, and it will simply generate an ARM template, and this will be actual copy of my existing app service. That means I can be rest assured that whenever I will deploy, I will be having proper exact copy of my app service. So it creates everything from the existing settings and creates an example of ARM template here, and you have a big ARM template here. You see, I can use it, and I can click deploy, and it will start the deployment. You see here, and here I'm just using the existing things, resource group, blah blah blah, site stack of the day name, blah blah blah, and it will creating the ARM template. I will explain you again in detail about the ARM template parameters, template properties. Here I will talk about everything. You see here, report your variables, resources, everything I will talk about, uh, but I hope it's clear how you can use ARM template to create a web app. I will create also a separate video about ARM template and infrastructure as code, which will be a detailed video, because if I continue doing this, it will be a big series. But in terms of exam, it is not that interesting. It is interesting, but I mean, you don't have to go that deep. But I will create another video which will specifically talk about ARM template and bicep as well. So for now, let's continue and see. So let's talk about ARM template structure. If I go to the same page, and if I review the template, and if I just check the structure here, you see a schema, you see content version, you see metadata, and so in metadata it just talks about how simply metadata, the properties about the template itself. Then you have parameters. Parameters are which are really important for creating the web app, but parameters in the template itself are the parameters which you can then reuse later on while creating the web app itself. So parameters are, let's say here you see web app name, and then it's an object itself which describes the type of the parameter, default value, minimum, metadata, description. Again, location, same thing, type, default value, and you see here it is reusing the default value as it is source group dot location. So default value is always the resource group location. SKU, which is a property for the app service plan, and I'm taking here F1, which is free tier 1. And then you have the version for that, and here you see it is taking default value .NET Core 3.1, version for the Linux runtime stack, then repo URL, it is taking repo URL. Then you have variables, which is app service plan portal name. So then it is creating the variable, the name itself, from the values which you have provided from the parameters itself. App service plan dash parameter web app name. So you see it is creating it from the parameters itself. Then sorry for that. And then you are creating the actual resources. How many resources you are creating here? You see resources, it's an array, it's a list. So you creating one server farms, which is actually creating for your web app. Then you're creating a website. Then you have some conditions with that, and you also have the deployment conditions. So you have depends on, so this will not be executed until blah blah is done. So here once you create the server plan, server farms, and then you create the website. In the website itself, you say the type, so the resource type, version, name of the resource, location, and then the properties of that specific resource. So then you have properties http only, site config, blah blah blah. Then one interesting thing is identity. You can assign, you can add system assigned identity or manage user assigned identities here, and then you can, if you have created in advance, you can use that uh, value here, which we will talk in the video I was talking about to create for working with ARM templates, infrastructure as code. I will be creating that video, and I will talk about how you can reuse the resources you have created previously and then assign or reuse those variables here, resources here. And then it has some conditions, contains parameters, repo URL, blah blah blah. So basically, if you could understand from here, you had 5 parameters, and yeah, simply using those parameters, you can create variables, and then you can create resources. So that's it for the structure. Let's continue. This is the second module of the first part of the first part. Don't be confused. So this is the second module inside Azure App Service, configuring Azure App Service. Module overview, if I talk about, so once your web applications are built and running in Azure App Service, the next step to configure those applications, that what we are going to take a look at this module. So first we are going to talk about securing a web app with SSL, setting up SSL certificate for your web application. This is very simple to do. There is a couple of different options available to us from the Azure platform itself. In addition to securing our web application within SSL certificates, we should also understand how to configure a database connection string, because your web app might be connecting to the database, and then you will need to configure the database connection strings. It is very common for us to have a database here in web application architecture, so we need to understand how to do that. From there, we will take a look at enabling diagnostic logging. This is an important concept. Anytime you are doing continuous monitoring of your web application, then finally, at the very end of the module, we will take a look at the deploying code to Azure App Service web application to your application, to get your application up and running. So that the game plan for this module is, let's move to the next video, and we will get started with securing web app with SSL. So to secure web app with SSL, securing web app application in Azure App Service with SSL certificate is fairly straightforward, but there are several options. So let's ahead and break down the details of the important points that we need to understand. So we have seen how to create app service web application, and we know the external users can come from the outside world. They can navigate over to your host name or your website that you provide under azurewebsites.net, or not only under this, but you might have registered your own host name as well. And if they come, and we have seen so far that now user can head over to your URL, and they can use both HTTP or HTTPS requests. So by default, there is wildcard certificate available for your applications after you provision them. So any host name under the Azure websites.net will be secured or available for a secure connection over HTTPS. Now in the real world, we usually don't want our end users going to some host name under Azure websites.net, and because of that, that's why we have the ability to map custom domains to our application. So for example, we could take the tech of the day by nk.com domain if we wanted to do, and we could make that resolve over to a web application in app service. And we could also even map the SSL certificate to that web application, and that would ensure the external user going to that domain would get secure connection. And once you have a secure connection to the tech of the day by nk.com domain if you wanted to, and then tech of the day nk domain as one of the subject names. So now there are several considerations when it comes to securing a domain with SSL and TLS binding in your app service implementation. So let's talk about this consideration. Now if you remember back to the first module, we were talking about app service plans. So we need to make sure that we are using at least basic, standard, premium or isolated plans types, because it is not available in free tier. So the free and shared tiers are not going to work. We are not going to be able to do SSL certificates with those type of tiers. The next consideration is public versus private certificate. So we could purchase a commercial certificate from a popular certificate authority, something like VeriSign. We can also generate private certificates using our own certificate authority. And so the big consideration here is trust. Is the client devices going to trust the issuing certificate authority? So you are welcome to use private certificate that you generate on your own. You can upload those and bind those to your web application. Just remember that every client device in the world could potentially trust the certificate or the issuing authority. So with that said, public certificates are commonly used, especially with public web application. And here is what where it gets the kind of interesting. So we have the concept of managed versus unmanaged certificates. So if you see here, I cannot do the custom domain as it say you need to upgrade. So I could just configure the custom domain for this and continue. And then if I talk about TLS and SSL settings, I can say HTTPS only. I can set it true. And then I can also specify the minimum TLS version required. So because TLS version is a kind of encryption version which your website needs. As you see, it's a basic plan. I cannot do it. SSL bindings can be used in basic plan and higher scale up to this feature. This feature includes creating managed certificates and adding certificates to your app. So binding TLS SSL lets you specify which certificate to use when responding to request to a specific host name over HTTPS. TLS SSL binding requires a valid private certificate issued for the specific host name. And I can just go and buy a certificate. It will just get me certificate from App Service Certificates, allows to purchase SSL managed SSL certificate within the minutes, and I can just buy a certificate which will be a publicly valid certificate for 1 year, auto renewal, blah blah blah. I can just create it here, or I can generate my own. I can also store private SSL certificates, so private certificate keys and public certificate keys, and I can just upload the public certificate key here. So basically, as you see here, you could do a lot with the SSL, TLS, and custom domains to secure your app. Let's continue. Bring a web application in Azure App Service with an SSL certificate is fairly straightforward, but there are several options. So we broke them down and we talked about SSL TLS certifications you could have, and then we talked about how you can do the custom domain configuration. To do that, you can simply go to your web portal as I shown you in the previous one, and then assign the custom domain. Either you buy it from the Azure portal itself, or you have bought it from third party, and then you can configure your custom domain with taking properties from there, so like IP address and other settings, and then you can simply secure your app. So like then external users, they can go directly uh, to this domain instead of going to tech of the day by nk.azurewebsites.org. They can directly go to this one, and Azure will redirect your traffic to this domain. Simply this domain is registered on that IP address to this one. So simply it will all your traffic to this one will be listened. Let's continue. Configuring a TLS SSL binding. Once you have got the custom domain configured for your Azure App Service web application, it is easy to do set up a SSL certificate. You just go into the properties of your web app, scroll down on the left, and as I shown you in the portal, and you select the TLS SSL certificate, and there you can just enforce HTTPS only and TLS certificate, and you can upload your certificate for TLS SSL. So which is very important for securing your web app. And and you already have configured the custom domain name. You can also you might just have an IP based SSL certificate. So what we are going to do here is pick SNI based SSL certificate, and then we will add to the binding, and then your step is done if you have a SNI based certificate. I would suggest you go through this topic on Microsoft Learn for more details, but the key takeaways are: you have to use basic, standard, and premium or isolated plan. Then we talked about public versus private certificate. Then we talked about managed versus unmanaged certificates. And then how can you enforce HTTPS and TLS versions only. So these are the takeaways for this configuration part. Then configuring a secure connection string. Having a database here in your web application architecture is so common that Microsoft has given us some really cool controls here to work with the database connection strings in Azure App Service. So here is the big idea. We have seen building web app service with service web applications, but we might want those to interact with some kind of database. So we can do an Azure SQL database. We could do Azure database on VM, or again leading with managed services is a nice way to go. It makes life a lot easier, but yeah, expensive as well. So let's imagine that we have got an app service web app and an Azure service SQL database. Okay, so you have Azure uh, so back in the portal, and for my website tech of the day, I have configuration part here. If I click here, I go to configuration part, and I can, below down here you have connection strings port, and then in my code I don't have to change a lot, because generally we how do we reference connection strings is we have separate configuration folder in our application which says connection strings, and then inside that XML we write down our connection strings. So you don't have to change your app, and you can just add connection strings here. and then let's say audit db connection string, and then I will add the value and type SQL server, SQL Azure Postgre SQL server, and then I can say okay because I don't have the connection value here, it just added it, but yeah, I can just edit it and change the value here again, and then it will be using sorry and then I have my connection string simply, and then I can make use of that connection string in my application. If I go here, use no connection, that was lost. So in here, as I can just add that connection string, and that will stay here. So what I want to say is you don't have to change your application and then you can provide connection strings from the portal. This is manual, but you can do the same thing using your deployment methods. So while you were creating the web app itself, you could configure the web app. After you have created, you can then configure the web app using Azure CLI, Azure PowerShell, and you can also do the same with ARM templates or Bicep. That is simply straightforward procedure. Or you can also configure in your CI/CD pipeline where you just set up you just set up the deployment flow, and then you can, while you are deploying your web app, you can also provide your settings in the connection string. So there are multiple ways to do so. This is one of them, and yeah, let's continue. I hope it is a bit clear. Your web app is up and running, especially for production, it is going to be important for you to keep an eye on it and make sure that there is no performance issue, there is no error, and there is and things like that. So that's why enabling diagnostics logging is so important. Now there is variety of different ways that we could do logging. Number one we have got is application logging, and this could be done with Windows or Linux based app service. This is just a way for us to log messages generated by our application code. So this code would be specific to the web frameworks that we are using, like .NET Core, Node.js, and so on. When you are doing application logging, the messages are assigned to a different category. So for example, you might want to key on critical messages from your application. You might want errors, you might want warnings only. So there is a few different levels that we could do in terms of application logging, and those logs could be stored on a file system of the app service that's running your code, or it could be stored in Azure storage. And next we have got web server logging, and this is specific to the Windows platform in app service, but this is just raw HTTP requests that are coming in. So each message when we are doing web server logging here has all the information about, like, HTTP request that was made, the method, client IP address, a bunch of information. So just a standard web server log. This could be stored on app service like file system or Azure storage again. From there we have the concept of detailed error message. This is concept when you are working in the Windows platform, when you are doing a Windows based app service, and this is a scenario where you might not want to show detailed information to the users about errors that are coming up, but when you are developing, that can be pretty helpful. So if you want to, or you can turn on detailed error message, and you will see those in the browser when you are hitting your web application. By default that is turned off, so we are not exposing sensitive information to users through error messages. We also have support for failed request tracing, and this is again specific to the app service environment where you are running on Windows. And this is just detailed tracing information on failed request. This includes the trace of IS component and that were used to process the request and the time it takes in each component to finish that process. And finally, we have got deployment logging. This works on Windows and Linux based app service, and these are just logs that you got when you are pushing code to your app service. And that way you can reverse engineer any error that might take place during your deployments. So those are the different options here for enabling diagnostic loggings. Let's jump into the portal and I will show you where you would turn this on all the right. So in the monitoring section, you have a lot of options here. In the monitoring section, you have alerts, metrics, logs, advisor recommendations, health check, diagnostic settings, which we are talking about, app service logs, log stream, process explorer. So we were talking about diagnostic settings, and do you want to update them or add them? So to have the diagnostic settings, you see here you can have storage account, event hub, log analytics workspace, and then partner solutions edit settings. So if when I clicked here and when I'm here, I can just add diagnostic settings and then I can give it a name, test back, let's say just like that. And then I have many options. What do I want to log and do the settings for? So I want HTTP logs, app service logs, everything, let's say for the first time I'm saying. And then where do I want to send those diagnostic settings? Do I want to send them to the log analytics workspace? Do I want to archive them to the storage account? Do I want to stream them to Event Hub and then Event Hub further can process them? Or do I want to send them to partner solution, where that partner solution is another application which might execute my diagnostic settings and do something about it? So there are many ways to do it, and you can of course do that and let's say send to partner, and then you can just select the destination here, or you can just do multiple things. You can do it for multiple part. So same way you could do it and send diagnostic settings to a specific location. I will discard it. I hope it's clear. Let's continue. There are so many third-party systems and tools that you could use to deploy code to Azure. Built in this section, we are going to take a look at the deploying code to app service, deploying code to app service using native capabilities. So let's talk about configuring continuous deployment. So there is a couple of different options here. So when we are going to app service, you could pull your code from GitHub, Bitbucket, or Azure Repo, which is part of Azure DevOps. And really what we are doing here is we are associating our web app to basically point to these repositories, a specific branch in these Git repositories. And anytime those branches are updated, it's going to deploy the updated version to your app service application. So this is a continuous deployment option. If you wanted to do continuous delivery, where there was more check along the way, you could use something like Azure DevOps, or you could, some other options like CI/CD systems. So continuous deployment literally means when we change the code, we are going to do an update in the app service. Now, in order to make this work, number one, you have got to have your code in something like GitHub or Bitbucket or Azure Repo. But when you have got to, but you also have got to authorize app service to go to retrieve that code. So that's something that you need to do. I'm going to show how to do that in this video, and then once that's done, you can enable continuous deployment there. And again, anytime the developers are updating the code and pushing those updates into the repository, that's going to trigger a deployment, and if you ever want to turn that off, you could just go on into app service and disable continuous deployment. I will show you that as well. So when you are using this native continuous deployment model in app service to get code deployed, it's very simple to do. Let's jump into the Azure portal and I will show you how to set it up, the continuous deployment. Let's go. All right, so in the deployment center here in my application, I am in deployment part of the app service, and then deployment center. I click this one and then I have these options: settings, logs, FTPS, credentials. So I have already connected my GitHub account to this, and I already have these settings like this. So it is pointing to my repository, and then this is the user I'm signed in, organization, and then GitHub. It also has the logs from the previous deployments and app logs which are there, and then you also have FTPS credentials, which I'm not going to show you. In the settings part, I can this is already connected, so I can just disconnect it, and it is asking me from this workflow file, and I'm going to you see I'm going to disconnect from this repository. I can copy it again to connect it, and I'm also saving the workflow here, which means it is when I connected this, it created a workflow in the YAML in this GitHub repository, and that workflow is simply a workflow which says how to deploy my application when there is any change. And I am just saying save workflow. I can also say delete workflow file, and it will delete the workflow file, and I say okay, and then it is now disconnecting my GitHub from the source control. So I don't have any setting here now, and I can do the same thing. So to do the CI/CD continuous deployment, I can connect to my GitHub, Bitbucket, local Git, Azure repo. I'm going to connect with the GitHub, and then I'm signed in as Nitesh Sharma because it recognized me from previous sign in, and then I can select the organization. I can select, then it is fetching the repositories. I can select and then I can select main branch, and then that's it, and then I can just save it, and then I have the deployment center deployment here, the deployment profile, and it has created the same thing again, a file in the YAML code, which is simply a workflow file, and whenever I will push anything to this GitHub repository, it will create it will simply publish that to this service. So let's continue. I hope it's clear what is a deployment center, how to use. This is the third module. Once you have created your app and then you have configured your app, then you need scaling your app service, Azure app service. In this module, in the final module actually of this domain, we are going to take a look at scaling Azure app service. So after you build your web application, after you configure them, how do you actually run Azure app service in production? That's the focus of this module. We are going to take a look at the understanding of vertical and horizontal scaling. From there, we will take a look at manual scaling Azure app service. We will see how we can scale based on the schedule, and then we will finally take a look at implementing auto scaling in Azure app service. So that's the game plan for this module. Let's go and check out in the next slide. Understanding vertical and horizontal scaling. When it comes to running application in production, one of the things that we have to think about is scalability. So let's review scaling up vertical versus scaling out horizontally. Now let's imagine you have got a virtual machine, a standard A1 V2, 1 core, 2 GB RAM. In that scenario, you have one CPU core and 2 GB memory, and over time the application demands might increase. You might need more resources. So with the virtual machines, we can easily just go to the properties of that VM and make an API call to make the virtual machine bigger, change it to a different size. So we could go to something like a standard A8 MV2, and suddenly we have the 8 CPU core and 64 GB of RAM. And that's just like a small outage to take the machine from the one size to another. So that's the idea with scaling up vertically. Now we know that app service plans are powered by virtual machines. So let's imagine you have got a standard S1 app service plan that is going to give you virtual machine with a single CPU core and 1.75 GB of RAM. And now, just like we discussed, what if over time the resources change and we say and we need to uh, scale up. But the good news is that production grade app service plan tab supports multiple virtual machines, and that's where scaling out horizontally kind of comes into play. Now if we were building all this manually, we would set up in Azure load balancer. We would have some virtual machines connected to that load balancer, and as user hit the load balancer to access web application, the load balancer will spread the connections across the available machines in that pool. And production grade app service plan works the same way. There is an implicit load balancer here which actually see it, and there is an ability to scale out to multiple virtual machines under the hood. So in vertical virtual machine, we were what we were doing, we were upgrading the existing virtual machines to upward, means we were increasing the strength of the existing virtual machines. And for that there was a downtime because we were increasing the existing virtual machine, that means we were taking it down and creating another one, and frankly, and that was not good idea, and might not be good as well, because over the time we might not need that strong virtual machine. We might go back to the same smaller virtual machine, then we will have to remove the existing one and go down. So scaling vertically might not be the best solution. Then the horizontal came in, and then we said, like, if what if we do the same thing, we increase the virtual machine numbers and we add the same instance of virtual machine and add to it. So we have then another virtual machine, and then we have the rule for that as well. And there is an implicit Azure load balancer, as we talked about it. The same thing we were doing in our on-premises applications, and we were having a load balancer, and that was doing the job. So so one of the things that we will see in this module later on is I will show you how to auto scale an app service, and basically we can create rules based on the Azure resource consumption on these machines. So for example, if you have an average CPU consumption, CPU utilization of something like 70%, and that's happening, or maybe 5 minutes straight, we can trigger an auto scale event. So we could do here is our auto scaling rule will add maybe the third virtual machine here, and then the traffic will be diverted to this one as well. So other two are also still working, but if we have more traffic, that the load balancer will start diverting it to third one as well. And again, this is something you could do on your own with virtual machines, but it's also built into app service. So you are going to see this into this module. It's really easy to set it up. Now, in addition to scaling out based on auto scaling rules, we might want to scale based on a schedule. So taking a look at this example, we might scale out at 9 a.m. up to 3 instances from 2 or 1 that we had previously. So we have a predictable workload and requirements. We can scale based on the schedule, and then of course we need to scale in. So we can have scale in rules. So maybe if we are going to doing auto scaling, CPU requirements go down, the CPU demands go down to 20% or less, then we can go scale down. So once at 9 a.m. we increase the CPU number of virtual machines, and then at a specific time we go down, then that means we move one of the virtual machine and we scale in. So if the CPU utilization is less than 20%, we remove that virtual machine, and that is also if it is more than 5 minutes, and then the virtual machine will be removed. So that is like, now when it comes to actually being able to do auto scaling, one thing to remember is that the auto scale feature is only available for standard, premium and isolated pricing tier. Now in addition to auto scale and scaling on schedule, we can also manually scale, and that's what we are going to take a look in this video, next video. Next slide, sorry. it's the same video. Next slide. Okay. So now I will go back to the Azure portal. Okay, so I'm back in the portal here, and you see I have selected scaling up, which means scaling with the vertical, scaling vertically. And that means when I have some specific traffic, what do I want to do? I have already this service plan. Basically we are changing the service plans actually when we are scaling up and down, or horizontal or vertical, scaling in or out. What we are doing, we are actually changing the app service plan, in simple words. And this is my selected existing service plan, and I can go to this, and then I have this option, apply option. This is manual scaling out, scaling up. I also have the same thing. When I say apply, it will change my existing app service plan to this one. And yeah, and if I want to do the same thing here, scaling out, the auto scale is currently not available for this resource. This resource pricing tier might have been changed, and auto scale is not supported. As I said, it is supported in standard. So I have to change it to standard, and to go that I have to go here and change it to the better version of that, and then I can do the scaling out things. But first let's look at the scaling up plans. So if I do B1 here and I just say apply, it is updating my app service plan. And once it is done, oh yeah, and now my app is ready. And now you see I have the option to upgrade scale out manually. So choose how to scale, and then I say one instance is there, 2 or 3 is instance. So the same type of 3 instance horizontally I can run. I can see the run history. I can again, this is not available in this pricing tier, but anyway, notify, diagnostic. So I only have one option, which is manually auto scaling, and that is also with the instance count, and I can just say save. So you see here it says auto built-in feature helps applications perform their best when demand changes. You can choose to scale your resource manually to a specific instance count, or via custom auto scale policy that scales based on metrics, threshold, or schedule instance count, which scales during design time windows. Autoscale enables resources to be performant and cost efficient by adding and removing instances based on the demand. So as we talked about it, that's it. I'm going to discard it, and I'm also going to change back to the shared, because I don't want to pay extra. Okay, that's it in this module. Let's continue. When you have a predictable application, you know exactly what the resource requirements are going to be. Scaling on a schedule is actually really nice. So let's take a look. Really nice. So let's take a look at the properties of this web application here. And as I talked about scaling out, um, how to, and then I shown you how to do custom auto scale, and I shown you how you can set up some rules in the previous one. And then I said, because I want to do something between because I know my application is using a lot of resources during 9 a.m. to 5 p.m., then I can add some basic rules saying scale out in during this time, and scale in during after this time. So basically I will be adding more instances of my application, of my app, and then decreasing the instances. When it comes to auto scaling app services, we are basically leaning on some of the capabilities in Azure Monitor. So let's talk from high level real quick about how this works, and then we will jump into the portal to set it up. We are doing auto scaling. We saw this in the video. We have the concept of auto scaling and we know all that, right? We have the basic knowledge about auto scaling, how you do that. And so here, what is happening is you are getting all the matrices from the Azure Monitor, and then based on those matrices, you are creating some rules, right? And these rules have some actions which are adding, removing virtual machines, emailing, or other webhooks. Or the same thing is used for creating your app, for scaling up your application. So we are doing auto scaling. We saw this in the last video. We have the concept of auto scaling, profiling, and everything. So we saw we could use the schedule, but in this video we are going to take a look using the Azure Monitor metrics. Uh, so now the resource metrics is for it can be for the existing, or you can perform your own search. So you could also do custom metrics with an app service. We are going to be relying on resource metrics available from Azure Monitor, and this tells us what things about like CPU utilization in our app service, compute instance, memory pressure, things like that. So we are designing auto scaling rule. We are essentially here trying to go into the metrics in Azure Monitor, and we have seen how you could do this based on the schedule. And then of course those rules are firing, and there are different actions that could take place. So for us, when we are dealing with app service in terms of auto scaling and outs or horizontal, we want to be able to add or remove virtual machines based on the rule that we define that are targeting metrics value for the resource we have got in the app service. So again, example, we might want to scale out CPU utilization, which is at 70%. We can also invoke other actions like sending emails, as I said, to the webhook, as a net notification to kick off. Or so that's the high level things. And then we need to think uh, about these things. So let's jump into the Azure portal, and I will show you how you can configure or do it. Let's continue. So here in the portal, you see I am in the monitor section and in the metrics. I have selected one metrics. When you just click here and there, and then you come here, it gives you a scope, my application, and then metrics namespace is just standard metrics namespace is just created. And then here it is giving me some options. You see CPU time. Basically for scaling rules we need CPU related things, or maybe other request related things. So if the average memory working set, average response time, connections, current, so let's say CPU time. Okay, and here it is giving me the average CPU time, and then I want to create a new rule. So I just can create an alert rule where the condition is whenever the total CPU time is greater than logic defined in the seconds, and it gives me this cost for every alert. It is expensive, and then I can add another condition here with the average memory working set, data in, data out, CPU time, current assemblies, whatever, handle count, and then aggregate for over last six period 12 hours, and then I can set instances, and then I can say okay, include all features, and then static, dynamic, average, threshold value, let's say 4, and then I can just say done. Okay, so I have two rules. This one is not set yet because I need to set value as well. So threshold value is, let's say, the CPU time is greater than, let's say, 20. So I have two conditions here now, and now I need to go and add actions, what actions I want to take. So I have already application sites smart detection. I can choose this one and then select it, or I could create action group. So I have already existing I could create another action group as well, which I don't want to. So I'll just go back here. Oh, my changes are not saved here. And then on the details, I'm going to write about the details about this alert and then review, and that's it. So basically you are setting up alerts based on your CPU performance. So that's about it. Same way you could just scale in and out, but okay, that's about it. Let's continue to the next chapter. Thank you. Next module, we will start our journey by looking at the provisioning and configuring Azure virtual machines. We will look at the core concepts and techniques for provisioning and configuring virtual machines in Microsoft Azure, and then next module we will look at creating and running containers in Azure, where we will learn how to create container images for solutions by using Docker, publish container registry, publish a container image into the container Azure Container Registry, and then learn how to deploy and run containers in Azure Container instances. These are three things very unique and different and confusing. Get started with a high-level overview of what a virtual machine is composed of. Let's look at virtual machine components. Azure virtual machines are deployed into resource groups and are contained in Azure regions. When deciding what region to put a virtual machine in, you will likely want to put a VM physically close to the applications or users that need to use the service deployed on that virtual machine. When building a virtual machine, you must choose a VM size of the VM. You pick from a selection of pre-configured virtual machine size based on the number of CPU cores, the amount of RAM, and also varying disk performance capabilities. What size you pick depend on the workload being deployed on that virtual machine. And the good news is size of the VM can be easily upgraded or downgraded after a virtual machine is deployed. The next core element of virtual machine deployment is networking. This networking connectivity for your virtual machine to rest of your environment, and if needed the internet. You will have an internal IP address for the internal communications on your Azure virtual machine virtual network or VNet, and if required a public IP address can be allocated that's reachable from the internet. And we will talk a little bit more about the security and remote access in few minutes. The next component in a virtual machine is virtual machine images, and that are the base image used to deploy into our virtual machine, most often operating systems like Windows or Linux. In this course we are going to focus on deploying Windows and Linux virtual machines built from Azure Marketplace images. There are many different virtual machines image available in the Azure Marketplace based on many different operating systems. There are varying editions, images, and pre-configured applications, and also even network virtual appliances. The final component of the virtual machine is storage. Each VM created will have a block device called Azure Virtual Disk or VHD. Each virtual machine will have at least one virtual disk or hosting the base operating system. For hosting the base operating system, you need that virtual machine, the virtual disk. And if needed, additional virtual disks can be added to support application data. How much disk capacity is required and its performance capabilities really depends on the amount of data that needs to be stored and your workload's performance profile. So now that we know what a virtual machine is composed of, let's look how to create a virtual machine. So just remember these 5 components for a virtual machine creation, and let's continue. When creating a virtual machine, you have the full suite of Azure tools to use, and first one that we are going to look at today is the Azure portal. This is web portal that you are used to use when working with Azure resources, and it can be used to create virtual machines. Now, if you want to build a responsible process to create virtual machines, you are going to want to do that in code. And core ways to create virtual machines using code in Azure are Azure CLI, PowerShell, and Azure, which with the Azure module and the Azure ARM templates. Because as I said, if you do anything from portal, that is good, well and good to get started. But if you want to keep it in the consistency of your resources, then you have to choose a solution, either use Azure CLI, PowerShell, or ARM template or Bicep, because then you can you can have the version control. You can store those scripts or code into your GitHub repository, and then you can keep the version control of it. And you can also use the continuous deployment and delivery. So now there are some additional ways to create virtual machines in Azure using things like APIs, but those are out of scope of this course as well. So we are going to focus only on Azure portal, Azure CLI, Azure PowerShell with Azure module and Azure template. So let's continue. So now creating a virtual machine in Azure portal.
Okay, I'm here in my Azure portal, and as you can see,
As I
I'm
show you
just
in
at
the portal
the start
itself.
phase, and
Let's go.
I will just say create a resource, and I will look for the virtual machine, and this is the first one option. I will just say virtual machine, and then it just asks me which resource group I want to use. So I will use the existing resource virtual machine name, and you see virtual machine Virtual machines in Azure have two distinct names: virtual machine name used as the Azure resource identifier and guest host name. When you create a VM in the portal, the same name is used for both virtual machine name and host name. The virtual machine name cannot be changed after the VM is created. You can change the host name when you log into the virtual machine. So keep it in mind, very important factor. Virtual machine host name and the virtual machine name. So first time I will create um, AZ-204 and VM, and that is all right. Okay, this is going to create virtual machine, so the name of the virtual machine and the host name will stay the same. And then I choose, by default it gave me North Europe availability zones and zone 1 standard. A lot of things are here to understand. Region you already know. Availability options. Azure offers a range of options for maintaining availability and resilience of your application. Architect your solution to use replicated VMs in availability zones or availability set to protect your apps and data from data centers. So if you have done already Azure 900, you already are aware about these things. What is availability zone, what is availability set, what is resiliency. You should know these things. If you don't know, I would simply suggest to go through these terms, because I don't want to cover them here, because these should be covered in the Azure 900, which is basic. But in case if you haven't appeared in the Azure 900, then I would suggest you to go through them on internet or Microsoft Learn. You will find a lot of solutions there. But I will go with the default options, and here you see security type, and it offers a lot of security. um, trust Trusted launch virtual machines, confidential virtual machines, and this is the standard virtual machine. Images, very interesting one. You see here a lot of images are there. You see Ubuntu, Red Hat, Linux, Windows Server, Windows. I would go with the 19 Windows Server, and you see, and then it asks me which size I want to go with, and by default it selected the standard one, but I can see all the sizes here, and I can choose cheapest one or expensive, whatever I want according to my requirements. So how many virtual CPUs you need, how many RAM, how many data disks, and how many max IO apps you need, and according to your requirements you can make the decision. But also if only the cost is your requirement, and then I will just simply select the cheapest one. So for now it's just selected, let's select this one, and this is just 9.42 month per month. Now it asks me to create a username for my application. AZ-204 user. I just created a nice user, and it is just suggesting me the password. A password is pre-written for my previous virtual machine, but I will say test is a 204 user. Okay, it is not fulfilling one condition, which is one uppercase character and one number and one special character. I have to write down again. It is good to know that your password should have one of three of the following. So it has the number and everything. So let's say age at 204. Then it's a user, and still the password is not good because it should be 12 and 123 characters. User 1. No, not still. So user pack of the day. Very long password, and I'm not sure if I'm going to remember this, but doesn't matter. Age at 204 user pack of the day. Oh, it matches. Okay, so I have the username and password. For later on I need to configure the inbound and outbound rules. Public inbound ports none, allow selected ports this. This is very important if you want to use your virtual machine for RDP, but you can also say SSH, HTTPS, and HTTP, but then it gives you some warnings. But I can just disable HTTP, SSH, and HTTPS. I will just say RDP, and then this will allow all IP addresses using your access to your virtual machine. And then that's it. And then if you would like to save on licensing because you might want to use some hybrid benefits, you can select this option, and then I can confirm, and then it will cost you very less. But I will not select this, and I will not select this option. And next is disk, so I don't want to save. And next is disk, and this is again by default it gives you premium SSD, but you can just go down and you can go standard HDD because the premium SSD is expensive. Again, that cost you a lot. And I can continue, create and attach a new disk if you want, and attach an existing disk if you want. Then I want for the networking part, I want to create a VNet virtual network, and with subnet ID, with public IP this and NIC blah blah blah, everything is there, and then I can continue. So this is basically setting up my virtual network part. And then I can go for the management, um, everything. How do you want to log in? Auto shutdown, you see enable auto shutdown between some time, uh, after some specific time, after a specific time. If you want to backup, how do you want to backup the virtual machine guest OS, and patching. So enable host patch up, so guest update the OS you are going to use beneath the virtual machine. So basically you are um, having some automation in here. And then I go forward and I create the virtual machine, and that's it. I can add the tags. Next I can review and create. So for now it is just validating the virtual machine and my script, and then it will say if the script is validated, then it will create. Basically this is not a script, this is simply an ARM template. So till now we have created an ARM template via uh, Azure portal basically, and that's really interesting. And then I can just click create because it was already validated, so I should not have generally any problem until unless I do not have things like creation rights, or I do not have the subscription which supports it, or maybe some policies are there. So runtime validations are not done. When it does the validation, it only validates your template. So if I just go here, you see it's a template, and now a deployment was created for that template, and you see a lot of resources are being created. You see IP, public IP address, NSG, VNet, and zone, and then the real virtual machine is being created. And you see it has created an ARM template. We will talk about it later on during this course, because yeah, as I shown you for how to create app service using ARM template, I will also show you how to create virtual machine using ARM template. Let's wait for this. This will take some time because yeah, it is heavy work. We are kind of creating a machine, right? So yeah, it is some heavy work. Let's continue to the course, and I hope it is clear for you.
As a developer, you are used to write code to build applications. Well, in Azure, you will have the ability to create virtual machines and infrastructure using code. And deploying infrastructure like virtual machines with code provides your organization a lot of value. Let's walk through some of the key reasons why you would reasons for deploying virtual machines using code. First, deploying virtual machine with code adds consistency to your deployments. As I have said previously as well, deploying via code always increase consistency. virtual machine creation so that you can create 1, 10, or 100 virtual machines the same way every time. No difference. And like any other code, you can have other that code and take the deployment code and check into source control. Next time any production system should be implemented using automation, primarily because you can build repeatable source control processes that can be used to deploy your environment. And last but not least, with your deployments in code, you can take that code to construct similar down level environments such as dev test. And this can add consistency to your to development and testing cycles. Since you are able to replicate your production configurations easily and consistency in non-production scenarios, your app is genius. So now that I have convinced you that you should be implementing your Azure development deployments in code, let's look at the tools that we are going to focus on in this course to help you do just that. And those tools are Azure CLI, Azure PowerShell with AZ module, and ARM templates. Whether you are creating virtual machines using Azure CLI or Azure PowerShell with the AZ module, the high level process to create a virtual machine in code consists of the same steps. First, you create a resource group in region if you already don't have one. Then next you execute the command needed to create the virtual machine. In PowerShell, that's new AZVM, and in Azure CLI, that's AZVM create, and then specify appropriate parameters for those commands to create the virtual machine. And we will get into the code for the upcoming sessions. Now, if you need remote access to the virtual machines over the internet, you need to ensure the appropriate remote access ports are open on the network. Security group securing your virtual machine and its interfaces. The ports that needs to be open depend on the remote access method for your virtual machines operating systems. For Windows, that's TCP port 3389, and for RDP, and for Linux, TCP port 22 for SSH. In addition to the remote access ports, you can also specify if your application ports such as 80 for HTTP, 443 for HTTPS, and so on. As I have already shown you while I was creating the virtual machine on Azure portal, you could select HTTP, HTTPS, SSH, or RDP. You can also add rules to the network security group directly to control access to this virtual machine based on the port's IP address, and doing so is recommended, but it's of course out of the scope for this course. Lastly, to access this virtual machine from outside of Azure, you will want to retrieve the public IP address from the virtual machine itself. Once you have the public IP address, you can connect to the virtual machine remotely and begin working on that VM. We will look closely at the techniques for doing this in both PowerShell, Azure CLI in the upcoming demo. Now this course is certification focused. If you want to deep dive in the programmatic deployment of virtual machine inside of Azure, be sure to check my other videos how to create virtual machines using different options. So let's walk through the code needed to create a virtual machine with the Azure CLI. The first thing needed when creating a virtual machine in the code is to create a resource group. We can create a resource group with the Azure CLI command az group create. We give that resource group a name. We give that resource group a name, and then we choose the location that we want to create the resource group in. I have already shown you how to do that because we did that for the app creating app service. You can of course deploy a virtual machine into an already existing resource group, and then the next step is creating virtual machine, and then you can do that with AZVM create, and then you pass in the resource group name that you want to create the virtual machine in, and then you give the virtual machine a name. So so what I'm doing here is AZVM create in the resource group tag of the day RG with the name this one. So this is the name of the virtual machine, and then the image Windows 2019 data center, admin name, admin username, demo admin password 123 star blah blah blah. And then there is another way. If you have AZVM create Azure resource group this, name tag of the day Linux, image Ubuntu, admin user this, authentication type SSH because it is Linux, and then SSH key value is this one. So you see, for two different types of image, we have two different types of things here, the parameters. So simply you can do this. I would not do this demo myself because I have already shown you how to do that. This is pretty forward, pretty straightforward, pretty easy. I will put these commands in the no, I will not put it in the description, but I will put or I would suggest you to go to this resource actually, because there you will have a lot of commands there. You can easily get the one which is useful for you. Why I'm not doing this as demo? Because then you will not be able to learn. I want you to do it yourself so that you can understand what I'm talking about. And let's continue. Enabling remote access. So now once that virtual machine is finished deploying, we can move on to the next step, which is to open up the RDP for access, remote access into this virtual machine.
Remote
We can do
access
that
into
with the
this
code
virtual
here
machine.
on
We can do that
line,
with the code here on
which
line,
says AZVM
which
open
says
port in this resource group,
AZVM
name
open
of the
port in
resource
this
group,
resource
name of
group,
the
name of
virtual
the
machine,
resource
and then
group,
it
name
says
of
this
the
port. So it
virtual
is
machine,
simply
and
saying
then it
create
says
a rule
this
to
port. So
open
it
the
is simply
virtual
saying
machine
create a rule to
on
open
this
the
virtual
virtual
machine,
machine
and then say
on
open
this
this
virtual
resource group,
machine, and then say
which
open
is
this
with the
resource group,
parameter 3389. So let's
which
go
is
ahead
with the
and run
parameter
that code to
3389.
open
So
up
let's
that
go
port
ahead and
for
run
remote access
that
into the
code
virtual
to open
machine
up that
from
port
IP
for remote
address.
access
Once the
into the virtual
X
machine
process is
from IP
finished,
address. Once the X process
I
is
would say
finished,
I would really suggest you to do
I
that.
would say I
And
would
I hope you're
really
following
suggest
till
you to
now
do
with
that.
me. I
And
want
I
you to do
hope you're
that
following
with
till
me,
now with me.
and
I want you to do
I
this
want you to
that with me,
execute.
and I
Once
want
it
you
is
to
finished,
execute. Once it is
and then you
finished,
can open up the
um,
open
and
up
then you
that
can
port for
open up
remote
the
access. Once it is finished,
open up that port for
then you
remote
can
access. Once it is
access.
finished,
I would definitely
then you
want you
can
to access
access. I
RDP
would definitely want
for
you to
accessing
access
the
RDP
virtual machine.
for accessing the virtual machine.
Then, so here we have the
Then,
command
so
AZVM
here
list
we
IP
have the
addresses,
command
which
AZVM
lists
list
the
IP
IP
addresses,
addresses,
which lists the IP
and we
addresses,
specify the resource group and the
and we
resource group name
specify the
and the name
resource
of the
group
VM,
and the
and
resource group name
we
and the name of the VM,
say list IP
and
addresses.
we say list
It
IP
will list
addresses.
all the IP addresses.
It will list all the IP addresses.
Um, what public IP addresses of this
Um,
virtual machine is.
what public
So
IP
my
addresses
public
of this
IP
virtual
address for
machine
this
is.
virtual
So
machine
my
will
public
be
IP address for this virtual
xyz.
machine
Let's
will
say
be
x.y.z.z.
let's say
A
x.y.z.
because it is for
A
things.
because
Yours
it is
will be most
for
likely different.
things.
In addition
Yours
to
will
the
be most
public IP
likely
address, the
different.
virtual
In
machine is
addition to
also
the
having
public IP
private IP
address, the
address.
virtual machine is
In my
also
case,
having
it
private
will
IP
be, let's
address.
say,
In my
blah
case,
blah blah
it will be, let's say, blah
172.16.1.4,
blah blah
and that will be used for applications and
172.16.1.4,
services
and
either
that will be
inside
used
of the
for
Azure
applications
or
and
that
services
have some sort
either
of private
inside of the
connectivity
Azure
into
or
our VNet.
that have some sort
Now
of
for
private
this
connectivity
demonstration, I'm
into
not
our
going to
VNet.
log into
Now
this
for
Windows
this
virtual
demonstration,
machine
I'm
with
not
a
going to log
RDP
into
on
this
public
Windows
IP
virtual
address.
machine with a
We
RDP
saw that how
on
to
public
do that
IP
in the
address.
previous demo,
We
because
saw that
that
how
is
to do
time
that in the
consuming and
previous
this
demo
video will
because
become
that
too
is
long.
time
But
consuming and this
I
video
want
will
you to do
become too
that
long.
because
But
this is
I
not
want you to do
difficult.
that
You just
because
go to the
this
portal
is
and
not
select
difficult. You
connect
just go
part,
to the portal
and then you select
select
how do you want
connect
to
part,
connect, and it will download
and then you select how
one
do you want to connect,
RDP
and it
file.
will
You just
download
click on the file,
one
you enter the
RDP
username,
file.
you
You
enter
just
the
click on the
password,
file,
and you
you
are
enter
in
the
the VM.
username, you enter the password, and you are in the
Let's
VM.
continue.
Um, let's continue.
So as I said, I want you to do that. I will not be doing this myself, but I want you to creating VM with Azure CLI, enable remote access using Azure CLI. As we have already all these things in place, I want you to use that and mm, uh, do that yourself. Again, then once you have done the Azure CLI, I want you to continue doing that with PowerShell as well if you are interested, because yeah, you might have the same thing in exam. In exam, they might ask you with the Azure CLI or Azure PowerShell. So for exam perspective, you have to do that for both CLI and PowerShell. For your interest perspective, you can ignore it. So, so to understand this, we have a PowerShell script which says username is this, password is this, and Windows credential, which is creating new Windows credential using this. So we have created Windows credentials using username and password. This is simply a PowerShell command. If you don't know, please look at new object. It is simply creating new object using this PS credential. Then we continue. What we are doing here is simple. We are creating a new Azure VM. If we already have this source resource group, if we don't have this, we will create the resource group as well in the location of the VM. Here we are simply saying name of the virtual machine is this, image is this. We should know exact name of the image because we have the predefined images, so we have to choose the name of the image from the existing images only. And then for the credential part, you see I'm using Windows credential which I created here. This is simply a variable. And then open ports 3389. I'm already telling the VM the command to execute to include this in the script itself to open the port 3389 for RDP connection at already, right? So I already have the RDP connection here. And the previous one, we opened it ourselves. And while I was creating the VM using portal, I added this as well. So generally you have this option already, so you don't have to open and run the previous command we ran previously, but sometimes you might. And then if you just want to get the public IP address of this virtual machine, then you have to specify the resource group name and the name of the virtual machine, and then you need to filter the select object IP address. Simple, right? Pretty straightforward. So I would like to urge you to go to Azure portal, select the cloud shell, and run these commands using PowerShell. I hope you know this already, but I have explained this in the video as well previously, that you can just execute these commands. If you want to learn more, you can go to Azure Virtual Machines Linux create quick PowerShell. You can go to this URL, pause the video, and just search for quick create PowerShell. Uh, quickly create for virtual machines, and then it will take you to this, or you can manually type it. I will also put a link. There is this guy Sean Bart who has added useful links to his website, and I think I will put his link because I feel that is interesting, so I will add him there as well. Okay, let's continue. So I guess I have explained you the PowerShell command. Now I want you to do that in the demo. Um, so I hope you will pause this video and do a PowerShell creating virtual machine using PowerShell. I have already explained it. For your sake, I would show it again. So pause the video. I will not highlight with the yellow color and just do it. Let's continue. And then I hope you will do that. So this is simply a demo which I'm skipping. I'm not doing demo using PowerShell and enabling remote access using PowerShell, which I could do, but I want you to do that as well, because yeah, that's simply the thing we want to do here. And I also want you to see later on, verify, get the public IP address, and also check what is your public IP address and what is your private IP address, because private IP address is used for internal communication, public IP address is used for external communication over the internet. Let's move moving along in our journey of learning how to deploy virtual machines in code Azure. Let's talk about ARM templates. An ARM template is JSON formatted file that is configuration document that defines what resources you want to deploy in Azure with their configurations. You can create any resource with ARM template. In this course, we are going to focus on virtual machines, but I have already talked about what is ARM template, its structure and everything. If you want to learn more about ARM templates, I will be creating a specific video about infrastructure as code, and I will suggest you to watch that. But for AZ-204 perspective, you can continue doing this course. ARM templates are building block for deployment automation. Using ARM templates, you can just deploy your application, parameterize configuration elements for your resource defined in ARM template. You can use parameters for commonly changed configuration elements such as virtual machine names, virtual machine storage account name, and more. You can use that same ARM template repeatedly to deploy the environment defined in the template, but using different parameters to customize each environment as deployment time. So the examples of having one set of parameters for production, another for QA, and another for dev, still using the same ARM template but with different parameters, providing consistency to your deployments. From a process standpoint, you create an ARM template, and then an ARM template is submitted to Azure Resource Manager for deployment using the tools that we focus on in this module, and the Azure portal, Azure CLI, and Azure PowerShell. Once the ARM template is deployed, it affects the changes defined inside the ARM template. In Azure, changes such as creating the resource, edit existing resources or their properties, or even deleting resource. So basically, every so when I show you the demo in Azure portal, you saw in the end it created a template, and then it created a deployment, and that deployment was actually creating different resources for that virtual machine. So like it was creating NSG settings, it was creating NIC, it was creating VNet, and then in the end it was creating virtual machine. So let's continue. um, Simply have already explained this, what is ARM template, but let's talk about it again. ARM template format, if you know it, you can skip this part. Yeah, first we have some header information schema in the location of the JSON schema file that describes the template language. Then the content version of the is the version of the template which is defined by you, the user. Control of your template. Next is API profile, which allows you to for the versioning of the resources and the defined in the template. Then next we have parameters, which is used to provide values during the deployment of that deployment, so the same template can be reused for multiple deployments. This is where you will define your deployment specific configuration parameters, and this is very useful when you want to be able to use the same template over and over again, but changing out the parameters for specific deployments, as we said, for test prod and staging. So things like resource group, regions, resource names, and network configuration are common parameters. Variable define values that are used in your template and are often constructed from the parameter values. User-defined functions allow you to create customized functions that simplify your templates and help enable reuse of template. A common use for function is generating resource name based on the environment that it is being deployed to. So with the functions, you can just create deployment specific resource names. And then you have resources. A common, sorry, the based resource is where you will specify the things that you want to deploy. So virtual machines, storage accounts, networking elements, and so on. Outputs are typically return values from the resources being deployed. This allows you to inspect and use the output in systems that are driving the deployment. So things like scripts and other deployments tool. Now, in addition to user defined functions, there are also a collection of predefined ARM template functions available to help you manage your deployments. So for example, there is function to look up the Azure resource ID for resources given its string name. For more operations, more things like that, I would highly urge you to go to this website from Microsoft Learn and check for Azure Resource Manager and then templates and then template functions. It is simple and straightforward. It looks difficult, but as I would say, it is really easy. Just go through this. So, time for a demo. Let's go to Azure portal.
So while I was creating a VM using Azure portal, I was having this thing here. I was here and it created actually a deployment. It created a deployment simply for below resources like Azure VM, IP, NSG, VNet, and this was networking. NIC, yes, and this is VM, and then shutdown compute VM resource also because we configured automation to shut it down every at 7 p.m. So it simply created a schedule for shutting down the VM. Anyway, so what it did, it actually created the ARM template. Now we have this ARM template, and in this ARM template, you see inputs. Inputs are the inputs we put from the while I was creating the VM using Azure portal. Then you have some outputs, which is AZ user and the template. Inside the template, you have parameters. It is like this. So you have parameters, variables, and resources. It created 6 resources in total. You see here network interface, NSG, virtual network, public IP address, virtual machine, and it also created a schedule for to shut down the virtual machine. So in simple, it has created a an ARM template, and now what I want to do is I can simply go ahead and download this ARM template, and I can show you here. So I downloaded this ARM template, which is basically the same thing which we just saw, and it has output. So we just saw this part, right? So I can download this virtual machine and I can add it to my source control, and I can also um, send the values for these parameters. So let's say depending on my environment, depending on my requirements, I can change the values. Like I can change the location if I want to deploy different another virtual machine. I can have a different virtual network related configuration here, so which will be different for different environments, and then I can have different username, password, mechanism for login, patch mode for these things as well, I can have different options. So basically what I want to say is, as I said in the beginning, that if you automate your deployment, which is like CI/CD, when you use it in your deployments, you are simply taking the overhead of doing everything manual, first of all, but you are also increasing the consistency. Your production environment will be the same as your dev environment or the vice versa. So when you face any problem in production environment, you will be able to solve the problem quickly and easily, because you know both environments are same, so it will be easy to reproduce the same error or problem in your dev environment. Second thing is, you are not dependent on human, right? So next day if your developer leaves the team, you are gone, right? Because the information is also going to leave from your team, because that specific developer did some manual changes in the Azure portal, and then okay, you are no more able to do that because he just changed something in the Azure portal. So basically, your knowledge is still staying if you keep your code, if you do the deployment using the code. So I hope it's clear. And to deploy the same thing after the changes, I can just simply deploy like here. I can just say deploy, and it will create a deployment. So it is a custom deployment, and it took the values already provided from the ARM template, but I can also modify them. You see, I can modify these values myself and change them. Basically it is simply creating a deployment. It is not creating a specific um, resource. It is creating a deployment, and that deployment itself will contain 6 resources, you see. So it's a custom template, and it will create 6 resources. If you want to see them in the visualizer, you will see it has 6 resources and how they are related. Oops, it is so fast. So basically you are creating a Azure virtual machine, and for that you are creating NIC, network interface, and for that NIC you are creating NSG, virtual network, and then also you are creating public IP address. Simple, right? So this is basically it. So if you go back to template, and you can also deploy the template, if you don't want to do it like this, you can also, so this was one of the ways. You could also do it from a custom deployment. You could just go to custom deployment like this, custom deploy a custom template. And here you have many options. So build your own template in the editor, which will give you option to upload it. And you can also do custom template, common templates which are already there. You can use pre-existing ARM template, which is for Linux virtual machine, Windows, creating web app, SQL, whatever. So but the basic idea is you can build your own, and you can load a file which you already have, let's say in your Visual Studio Code, and then you can upload that file and then save it, and then go back to custom deployment, and then continue from there. So basically you can deploy any ARM template like this. I hope it's clear. Let's continue.
Creating and running containers in Azure. Hello, this is Nitesh Sharma, your host. Welcome to my course, Microsoft Azure Developer Implement IaaS Solutions. This module is about creating, managing, and running containers in Azure, and I have broken it into 3 major sections based on the requirements for the AZ-204 exam. We are going to start off by learning how to use Docker tools to create container images. We will look at what a container is, the process for building a container image for simple .NET Core applications, and then learn how to run that container locally on our local workstation. Next, we will
take that container
Next, we
image
will
and push that
take
container image
that
into
container
Azure
image
Container
and push
Registry.
that container
Azure
image
Container
into
Registry
Azure
is
Container
managed
Registry.
container
Azure
registry
Container
service based
Registry
on
is
the open
managed
source
container
Docker
registry
registry,
service based
allowing
on the
you
open
to
source
build,
Docker
store,
registry,
and manage container
allowing
images
you
for your
to build,
container-based
store, and manage
application
container
deployments.
images for your
Then
container-based application
we
deployments.
will take that
Then
container image and run
we
it
will
as
take
container
that
in
container
Azure
image
Container
and run
Instances.
it as container
Azure
in
Container
Azure Container
Instance is
Instances. Azure Container Instance
an
is
Azure service that allows us to run
an Azure
one or
service that
more
allows
containers
us
in
to run
Azure with no
one or
server
more containers in
or
Azure with
infrastructure to
no
manage.
server
We are going to
or
start off with some
infrastructure to
container
manage. We are going
fundamentals.
to start off with some container fundamentals. Containerization of applications allows you to package up your programs, binary libraries, and other required components into a single deployable binary package called a container image. A running instance of a container image is called a container, and inside that container is your running application. And so your application up and running and able to consume the resources provided by the operating system. Generally speaking, you will run one application inside of a container as the container image become the deployment mechanism for your application. And so container image are generally going to be very small and portable. And the key what that container image become portable is via container registries, which allows for container image to be easily shared and used. Let's look at the comparison of virtual machines and containers. With virtual machine, for years you have been buying and deploying physical servers and installing hypervisors on top of that hardware. And we then created virtual machines and installed full operating systems on those virtual machines and then deployed our applications on top of each of those virtual machines. This model was great for increasing hardware utilization by increasing the density in which applications were deployed. But this model left us with maintenance tasks for each of these guest operating systems, and deployment times for VMs and apps was very slow and often manual. You still have a foundational compute component, and this can be either a physical or virtual machine. You then install an operating system on top of that. From there you deploy a container runtime which enables you to virtualize the OS, and then each container deployed has an isolated view of the underlying operating system, and from each other. The application running these containers through can communicate with each other over the network. Since the entire application is contained within that container image, this dramatically simplifies the application. Since the entire application is contained within that container image, this dramatically simplifies application deployments to just setting up your container from container image. In this module, we are going to focus on Azure Container Instances, which gives you underlying compute platform as service, so that you can deploy containers without having to worry about any infrastructure servers or even the underlying host operating systems. You can focus solely on your applications, how they are built, configured, and deployed. Let's look at the build and deployment process for these containers now. So with fundamentals behind us, the next thing that I want to introduce you to is process of building a container image, storing a container image in a container registry, and running a container image as container in Azure Container Instances. So it sounds a bit confusing. So this is the whole process. If I can just make it like this, nice design. It's like your Google specs. Container and so on development. And so on a development workstation, we will use locally installed Docker tools to build a container image. And to do that, we will write a Docker file. In the most basic form, a Docker file is a sequence of commands or instructions used to build a container image. Common instruction in the Docker file includes copying a compiled application binary into the container image and also defining which binary or scripts run when a container is started from a container image. Additionally, a Docker file is used to craft the environment inside the container for your application. So perhaps copying configuration files or even setting environment variables. We will look at the details of the Docker file in the moment. Once the Docker file is written, you execute the docker build command, and that will create a binary container image stored on that local workstation. Inside that container image would be application binaries and configuration needed to run that application inside a container. Understand, right? So you have binaries, libraries, you have image, and then to build, and you build it and you have it on your development workstation. And now you need to push it. So once it is done, once the Docker file is written, you execute the command build, right? And then that will create a binary container image. And then, as I said, the inside that container would be the application binaries and configuration needed to run that application inside that container. Essentially, anything defined inside a Docker file will be affected inside the container image. With that container image created, it can then be run locally as a container to test out our application. Once you have a functioning container image, you can then push the container image into a container registry, which is Azure Container Registry. Once the container image is pushed to really uploaded to the container registry, it can then be shared with the other users or container orchestrator to pull that image down and run that image as container in that environment. In the course, in this course, we are going to work with Azure Container Instance, and you can create a running container in ACI using many of the standard deployment tools for Azure. So the Azure portal, Azure CLI, Azure PowerShell, and so on will be the mode of creation of Azure ACI, Azure Container Instance. And so once we request the container to start by specifying the container image that we want to run, the container image will be pulled down to ACI and started up. Once that container is up and running, user can start using our container based application. So once it is pushed to Azure Container Registry and then it is pulled by the Azure Container Instance, then our app is up and running. It can be usable. So as I promised, we have the Docker file, example of Docker file, and this is how it looks like. From mcr.microsoft.com.net core ASP.NET Core 3.1. So what we are saying here, I want to use the ASP.NET Core 3.1 from this location. Okay, and then what I want to do is I want to create a folder in my container, then copy the the web app bin release from the publish folder to config.sh, and then run bash config.sh, expose it to 80 and the end entry point of .NET web app.dll, and that's it. Looks simply high level commands, right? We are saying pretty high level things we are doing. So time to dive into our Docker file. For our container based application here, we are going to package into container image a simple C# based hello world container web app. This example Docker file will show you how to build a container image for this. I will also show you some common instructions used to configure the environment inside the container image for an application. Most Docker files will start with a from instruction. This defines our base container image used for subsequent instructions in the Docker file. This is the foundation of which you are installing your application. Here we are using ASP.NET Core 3.1 image from the container registry mcr.microsoft.com. This is an official container image from Microsoft, providing the core things needed to run a .NET Core web application. Inside of the container, anything we do from here inside of our Docker file will be built onto this base image. We now want to configure the environment inside the container image to run our application. The next instruction that we'll use is the run instruction. The run instruction will execute a command inside the container for a command that exists inside the container. And so here you can see run mkdir/app. This will create a directory named /app inside container image. Now another common instruction that you may use when building container image is work directory. This sets the working directory for any subsequent instructions in the Docker file. Now with the environment laid out, we can use the copy instructions to copy our application binaries into the container. And so here I'm copying my compiled application from local directory on my development workstation into the container image. The binary are in the relative path ending in the publish, and they are being copied onto container image into the current working directory, which is /this dot is actually the app. This is actually the app directory which we set the working directory in the previous instruction. Now let's see, we needed to copy another file into the container, perhaps a script that needs to be run inside the container. Here I'm using copy instruction to copy config.sh into the directory, which is actually the app directory, since that's the current working directory. Now that the script is inside the container, we can execute the script with the run instruction. We define which cell we want to run the script in and then pass the script name as parameter. So here we see run bash config.sh. If this was another shell like jar shell or even PowerShell, I would specify the shell binary here and then the parameters needed to call the script that we want to launch. And of course, those binaries and scripts would need to be available inside the container, the expose container. The expose instructions tell the container's runtime which port the application running in the container is listening on, and in this case this is 80. And the final instruction is entry point. The entry point instruction is used to define which script or binary we want to start when the container is started from this container image. And so inside the square brackets we will define the command that we want to run and then its parameters. And so we are going to launch the .NET command with the parameter of our compiled application binary, which is webapp.dll. This DLL was copied into the container image during that first copy instruction that we executed. Also important to call out is that we don't have to specify the full path to the DLL since we set the working directory using the work directory instruction. In some application scenarios, the CMD or the command instructions is used to start the application in container image, and so you will see that sometimes entry instead of entry point with this Docker file return, we execute the Docker build command with the parameters -t web app image /v1, and So a name is human readable string to help us reference a container image by name. And so here we use web app image to help describe our application. The tag v1 is used to help version control our image over the time. As newer images are produced, we can increment this value to match new version of our application, and then we can differentiate between versions as well. Time to get into our demo. Let's create a container image for simple .NET Core web application together using Docker. So here we are with Visual Studio launched on our development workstation. Let's do a demo.
Okay,
Time to get
so
into our demo. Let's create
we have this
time
demo.
to get
So
into our demo. Let's create
we have this demo,
and
we have some prerequisites for this demo.
actually
What you have to do
initially
is what you have to do is we just want to publish a web app. So to do that, we need to install the Docker. Okay, so to do that, we need to install the Docker. If you already have a .NET Core SDK, if you already have these things, perfect. And the step one will be I am already in this folder. And the step one will be I am already in this folder. It contains demos, few PowerShell scripts, Docker file. It contains a few PowerShell scripts, Docker file, we saw, which is simply then we have the one we saw, and then we have container registry. Okay, and this is create local container registry. Okay, in this one, this is PowerShell script. In this one, what we are going to do is we are going to execute few commands, right? These commands are .NET build. So just to test if your web .NET build. So just to test if your web app terminal actually builds, and then run. Okay, so this is just test to test, and then your application. Okay, so this is just to test if your application is actually working, and then you publish with the release version, and then you build time to build the container build tag and image and tag it with the build tag. Okay, and then in order to with the v1 by default output, and then in order to by default output from the command run in the container during the build, you need to add the console progress plane to see output from the commands running. Progress plane to see output from the commands running. And if you already built the image, you will need to delete the image. If you already built the image, you will need to delete the image. If so, for Docker cache, new layers are built. Image, so Docker remove web Docker image web app image v1 and Docker builder prune force. Anyway, okay. Let's get started. I'm already. Anyway, I have already built my let's get started. So I have already. I have already built my application. So I have already. So my app run these commands good and working. I need to publish my app well and good and working. And I need to publish my app. Okay, let's continue. Let's publish the app then. In the release folder. Let's continue. Let's publish the app in the release folder. So if I just copy this and run it, okay, it has published in the it has published in the web app in the it will publish folder in the web app, and it has created a release folder and it is in there, and it has created a release folder and it is I want to okay, and now I want to let's take it image the Docker build now we are actually building the Docker image. Now we are actually building the Docker image, creating and wow, it is creating a build from here. Build from here. It is really interesting to see how they. It is really interesting to see how nice. They and then work. Nice. Okay. Now I want to run. And then so I have already built the image. Now I want to run. So I have already built the image from Docker file. And now next step is simply this Docker file. And now next step is simply run the image locally. So run Docker the image locally. Allow access. So Docker run because this is allow access. Docker is trying to because this is someone is trying to connect. Docker is trying to. Someone is trying to connect and it's done. Okay, so now I just need to curl and it's done. Okay, so now I just need to curl to this. See if the app is running. Let's see if the app is running, and you see when I
in
curve
the
it
docker,
output hello
and you
world
see
version
when I
1 and
curve
host
it
name is
output hello
you
world
see.
version
So
1 and
but the
host name
actual
is
host
blah blah
name
blah.
of
You see, so but the
my
actual
laptop
host
is
name of
the laptop
my
name, but here you see the
my
host
laptop
name is
is
different,
the laptop
and
name,
that's
but
how
here
I
you see
know
the
it is
host name is
running
different,
from
and
Docker. Of
that's
course
how
I
I know
know
it is
because I deployed
running
it
from
to
Docker. Of course
Docker,
I
of
know
course.
because I deployed it to
But another way to
Docker,
know
of
is
course.
the host name is different,
But another
right?
way to know
If you
is
will
the
test,
host name is
if you
different,
will run this
right?
app
If you
locally,
will
you
test,
will see the host
if you
name
will run
is
this app locally, you will see
is
the
different.
host name is
And I can
is different.
if I just run this part and
I can
check, host
if
name
I
is
just run
different.
this part and
Anyways,
check, host
so
name
this
is
part
different.
is done.
Anyways,
And then
so this part is
um,
done.
we need to delete the
And
app
then
because we
yeah,
need to delete the app.
we don't want
Because
yeah,
we don't want
we don't
to
want
keep it running. So I will
we
run
don't
all
want
these
to
commands
keep it
all
running.
together
So I will run all
and
these commands all together.
okay
So you see
run.
web app image v1.
Okay,
So you see
image
web
ID
app
this
image
about a minute
v1
ago was
image id this about a
created.
minute ago was created.
So let's hold on to this, and because we
So
wanted to
let's
create
hold
the
on to
image,
this, and
and
because
we
we
will use
wanted to
this in the
create the
next demo.
image,
Thanks for
and
watching.
we
I
will
hope
use
you
this in
liked.
the next demo.
This
Thanks
is
for
just the
watching.
beginning. I
I
hope you
hope you
liked it.
liked
Let's continue.
this is just the beginning. I hope you liked it. Let's continue.
Now that we have a container image to be
Now
able to
that we
deploy or
have a
share it
container
easily, we
image to
need a
be able
container
to
registry.
deploy or share
And in
it
this
easily, we
course,
need a
we
container
are
registry.
going to
And
focus
in
on
this
Azure
course,
Container Registry.
we are
Azure
going
Container
to
Registry
focus on
is a
Azure
managed
Container
Docker
Registry. Azure
registry
Container
service
Registry is a
based on the
managed
open
Docker
source Docker
registry
registry,
service
allowing
based
you to
on the
build,
open
store,
source
and
Docker
manage
registry,
container
allowing
images
you to
for
build,
container
store, and manage
deployments.
container
Azure
images for
Container
container
Registry or ACR
deployments.
can be
Azure
a core
Container
component
Registry
of a
or
CI/CD
ACR
pipeline.
can be a
It
core
can be
component of a
integrated into your
CI/CD
source
pipeline.
control systems
It
and
can
build
be
container
integrated into your
images
source
when
control
code
systems
is
and build
committed for
container
the container
images when code
orchestrators
is committed
such as
for the container
Kubernetes and serverless
orchestrators
platforms like Azure
such as
Container
Kubernetes
Instances
and
can be
serverless
configured to
platforms like
pull
Azure
images
Container
from those
Instances
container
can be
image
configured to pull
container
images
registries.
from those
Further,
container
you can
image
use the
container
Azure
registries.
Container Registry
Further, you
task
can
to
use the
streamline
Azure Container Registry task to
building, testing,
streamline
pushing, and deploying images in Azure.
building, testing,
ACR
pushing, and
tasks
deploying images in
offloads
Azure.
the build process
ACR
of your
tasks
application into
offloads
Azure
the build
Container
process
Registry
of your
and can be
application
triggered to
into
build a
Azure
container
Container
image when your
Registry
team
and can
commits
be
code
triggered to build a
into source
container
control.
image when your team
And
commits code
then
into
that
source
image will
control.
be automatically
And
pushed into
then
container
that
registry
image will
when
be
the task is
automatically pushed
complete.
into
The last
container
concept
registry when the task is
of
complete.
ACR
The
that
last concept
I want to
of
introduce here
ACR
is that
that I want to introduce here is
there are
that
several service tiers: basic, standard, and
there are several
premium
service
are the
tiers:
current
basic,
service tiers.
standard, and premium
As you
are the
move
current
up in the
service
service
tiers.
tier, you will gain
As you move up
more
in the service tier,
performance,
you will
image
gain
throughput,
more
storage capacity, and
performance,
also
image
security
throughput,
and
storage capacity,
replication
and also
features. For
security,
more
and
information on ACR
replication
service
features.
tiers, check
For
out
more
this
information on
link.
ACR service tiers,
Check
check
out
out
here
this link.
because yeah,
I have it here
the
because
SQs part is really interesting to know.
the SQs part is
Although
really
they only
interesting to
have
know.
basic, standard, and premium
Although
service
they only have basic,
tiers,
standard, and
but
premium service
the difference between
tiers,
them
but
is really
the
interesting.
difference between
Let's continue.
them is really interesting. Let's continue. Azure Container Registry requires authentication for all operations, which is normal, right? Azure Container Registry supports two types of identities for logging in: Azure Active Directory identities, including both user and service principals, and a service-specific ACR admin account. This is an administrative account which is disabled by default and is only needed in some scenarios. When building pipelines and automation container orchestrators, the tools and applications should use what's called headless authentication for their unattended logins into ACR. Headless authentication is only supported using Azure Active Directory identities, and we are going to focus on service principals in this module. You should not use ACR admin account for headless authentication by tools or containers orchestrators. From a user developer perspective standpoint, at the command line, you can use Azure AZ-ACR login or Docker login. Log into Azure Container Registry, you will be challenged for username and password, and then you will be able to log into ACR and perform operations. And for CI/CD pipeline, we will need service principal, which will be used for login for authentication purpose. Right? I think it's clear, right? If you want to do it via command line, then you can simply do like this. And if you do it via pipeline, you have to follow this way. Okay, I hope it's clear. Let's continue. The credential that you will use is your Azure Active Directory identity. When it comes to which operations you can perform, that's where role-based access control come into play, and we are going to look into those in more details in a moment. For deeper dive into ACR, security, and the various supported authentication scenarios, check out this link here. Access to Azure Container Registry using an Azure Active Directory. Azure Active Directory identity is role-based, and identities can be assigned one of several predefined roles, and if needed, you can create custom roles. This is a listing of predefined role RBAC roles in Azure Container Registry. The roles there can be grouped into two use cases: role assigned to people and role assigned to tools. Azure Container Registry as an Azure resource and can administer or access its configuration using Azure tools. These roles also have access to content of the container registry itself, such as image stored in it. The role ACR push, ACR pull, and ACR delete are roles that you will want to assign to service principals when using headless authentication for tools or container orchestrators. These roles have access to the container registry data such as image, but do not have access to Azure Resource Manager. So they don't have access with Azure tools such as the Azure Portal, Azure CLI, and Azure PowerShell. Important, very important to focus here, these things. The primary example of the right role for headless authentication for a container orchestrator or with Azure Container Instance is Azure's ACR pull. This role gives those services the right to pull an image but no other access to the container registry or the data in it. So if you just want to provide this role, which will only give related required permissions for ACR pull, same for push if you just give push, and the same for delete. But if you want to give other rights, then you have to give other roles like owner, contributor, or reader. Let's continue. To create an Azure Container Registry, we can use all of our normal Azure Container Registry. We can use all of our normal deployment tools. Let's walk through Azure PowerShell, Azure example to see this in action. Let's walk through an Azure CLI example to see this in action. First, to make our code more usable, I'm going to set an environment variable. More usable, I'm going to set an environment variable ACR name with tech of the day demos. This will be our Azure Container Registry name. Our Azure Container Registry name, and this name needs to be globally unique inside of this name Azure, needs to be globally unique inside of part of the fully Azure, qualified domain name, because it becomes part of the fully qualified domain name Azure Container Registry. To create an Azure Container Registry, Azure Container Registry. To create an Azure Container Registry, use of command AZ-ACR resource group name, create, and here we are going then to you specify resource group name, and here we are going to take off the day with the demo RG and then you
tech of the
specify
day,
the name, and
demo
then you
RG,
specify
and then you
SKU,
specify the
which is
name, and then
standard
you
here.
specify
Now,
SKU,
to
which is standard
log
here.
into the container
Now,
registry that we just
to
deployed, we can
log
use
into the container registry that
Azure
we just
ACR
deployed, we
login,
can
and then
use
specify the name,
Azure ACR login,
parameter,
and
and
then
then the
specify the
ACR
name,
name itself.
parameter, and
And
then the
again, I'm
ACR
using the
name
environment
itself.
variable here.
And again,
There,
I'm using the
so this
environment
will log
variable
you
here.
in
There,
with your current
so
Azure
this
CLI
will log you
credentials.
in with your current Azure CLI credentials.
In your current session, we will have
In your
administrative
current
access to the
session, which
container
we will
registry
have the
since you just
administrative
created it.
access to the
You
container
so
registry
now
since
that
you
we
just
have a
created it.
container image built
So
on our
now that
local
we have a
development
container image
workstation
built
and a
on
container
our
registry
local
deployed in
development
Azure, it's
workstation
time to
and a
push
container
that
registry
container
deployed in
image onto
Azure,
container
it's time to
registry,
push
and
that
we
container
going to
image
use
onto
two
container
different methods
registry,
here. We
and
first
we
using
going to
Docker
use
tools,
two
and
different
then
methods
second
here.
using
First
Azure
using Docker tools,
ACR.
and then second using Azure ACR. Then next we need to get the login server for our Azure Container Registry. The login server is public DNS name specifying the network location of our Azure Container Registry. We can get this in the Azure portal by looking at the properties for our Azure Container Registry, but we can also retrieve it at the command line with the Azure AZ-ACR. So, and specifying the container registry name, and then we can use the query parameter to extract the login server field. That value will be then stored in the environment variable ACR login server. The current value for the login server in our example is going to be a tag of the day demo acr.azure cr.io, and so that's a combination of our Azure Container Registry name, which is tag of the day demo acr, and the domain suffix azure cr.io, which is the domain suffix for all Azure Container Registries. Next, we need to add alias to our local container image using this login server and a new name and tag. This additional tag tells Docker where it needs to send the image when we execute a Docker push and create an alias. We can do that with Docker tag. And so let's walk through this command together. And so here we have Docker tag, and then for source image we have web app image v1. That's our local container image that we built earlier in this module. For the target image, for the alias, we are referencing ACR login server variable again, and then appending an image name and tag. And so in our example here, that's going to be tag of the day demo acr.azure cr.io slash web app image colon v1. Docker tag just tags the image with an alias. Now we need to push the image into ACR, and we do that with Docker push and then specify the image alias that we just created together. When this is executed, it will then upload or push the image into ACR, and it will be available to be pulled down by authenticated users or services. What we just covered so far in this way. To build and push an image to Docker tools, we can build and push an image another way, which is ACR task. Using an ACR task to build our container image, will read the Docker file into the current working directory and then zip up all the resources and code, and then upload that into ACR to build our container image in Azure Container Registry. Once the build is finished, it will then be pushed into ACR for us to use. Let's look at how to do that in code. We can use the command ACR build with the parameter image
This is what image will be named and tagged with the Azure Container Registry. And so here we have web API, web app image as colon v1 ACR task. Okay, and I choose to tag to identify that this was built inside of Azure Container Registry using a task. We then specify the name of the registry that we want to push the image to when the build is finished with the dash registry parameter, and then specify the ACR name. We see the space and then a dot, right? This is going to reference a local Docker file in that current working directory. So this part, it's really important, and please pay attention to this as well. um, so basically, to summarize, what we did is we created ACR name, we created ACR login server, and then we created a Docker tag for this with this web app image. We created ACR login server, and we did the Docker push, and then we build. If we want to do the same thing using Azure ACR task, then we can do the same thing using Azure ACR build, right? I hope it's clear. Let's continue. So creating an Azure container registry, time for demo. Let's create an Azure container registry together and post our newly created container image into Azure container registry. We will then also look at we can use ACR task to build an image inside of Azure and post it onto container registry. Let's get started. All right, so let's go to Visual Studio Code and get started.
Okay, so I have already done the Azure login part, and I have already default subscription set. Now the thing is, let's create another Azure group, which is with the just create Azure group, create dash name with this name and location Central US. Okay, and what I'm going to do is I'm going to change the central location here, because Central US, my subscription is free tier and I'm not allowed to use this location. So I'll just change it and be right back. So okay, let's continue. I set the location to this one. Now I'll just execute this and let's see. Okay. uh, okay, it is not understanding this thing. Anyways, I'll do like this. Okay, and now I can just copy paste it. And it will create a resource group for me. And now I have the resource group. Now I can log into, sorry, too fast. Now I need to create ACR name, which will be ACR this one, and it should be globally unique. And then I can create Azure ACR with this name. So ACR name, it is being used here. Basically it is a PowerShell script which I should execute separately, but anyways I'm not going to do that, so I'll just do like this. Okay, and then need to move this as well. Oh, and same for SKU. And now you have your command for doing the Azure ACR. So it will what it is doing, it is creating ACR in this resource group, and the name is this one, and SKU is standard. Okay, and then what we will do is we will simply log into ACR to post containers, and this will use the current Azure CLI login context which we just did. So I'll use this and replace this name with this. Same here. It is taking some time. Let's wait for it. All right, so the Azure ACR command succeeded. Actually, it did not succeed in the beginning. It's thrown some error here. It said this already exists, so it should be unique globally, and it already existed. AZ-204 demo ACR. So for that, I added a tag of the day in it, and it was fine. It went fine, and now I have created a ACR with this name, and now I can log into it. And so let's say Azure AZ login to this, and it will use my existing context. So I'm logging, the login is succeeded, and now what I'm doing is creating login server, and then I will use this login server uh, to display for the Docker tag part. Okay, let's continue. So I executed these 5 lines actually. So these 5 lines I executed, and then we see here, you see I created, so I tried from here, reference is not valid, repository blah blah blah. Okay, this was a successful execution, and here you see the output. It tagged web image with this name, and then image is this, and then to list the images, you see these are the images we have. So one is AZ-204 demo ACR tag of the day dot Azure Azure CR.io repository. Then another one is with the v1 tag, and these are the image ID. 2 images are there. So one image is there actually with the same image IDs. Okay, so now the thing is to push it to Docker. So to push it to ACR. So if you remember exactly what we have done till now, we have we built. If we go back from the step 1, what we did, we created a local image, Docker image, and now what we are doing, we created ACR, and then now we just listed if there is any image existing with this tag, and then now we want to push Docker push to this Azure ACR login server, and with this image tag, and then we can just list these images if they are successful there or not. So let's continue. So as I executed these 3 commands, Docker push, it has pushed all the web images there. Then I'm executing this list with this name, and then it has listed web app image result v1 to show the tag on it, and which is v1, and now I'm back. So what we have done, now we have pushed the Docker push command, which will push the image to the ACR, and now I can I can ACR build to build our image in Azure, and then push it into ACR to use ACR build task, and you can also do the same thing with this part. So I'm not going to do this part here. That's it, because I just wanted to create an ACR, and then push an image to ACR. Okay, that's it, and let's continue.
Along in our Azure container journey. It's time
along
now to
in
learn
our
how
Azure
to run
container journey.
container-based
It's
application
time
in
now to learn
Azure
how to run
using Azure
container-based
Container
application in
Instance. Azure
Azure.
Container Instance
Using
gives
Azure
you a
Container
serverless
Instance. Azure
platform
Container
as a
Instance
service
gives you
offering,
a
enabling
serverless
you to
platform
run
as a
containers in
service
Azure
offering,
without having to
enabling you
set up
to
any
run
virtual
containers
machine
in
or
Azure
other
without having to
infrastructure
set up any
service.
virtual
It's
machine or
most
other
effectively used for
infrastructure
simple
service. It's
applications,
most
task
effectively
automation,
used
and
for
also
simple
build jobs.
applications, task
When you need
automation, and
full
also
container
build jobs.
orchestrations,
When you
you
need
should
full
look
container
towards Azure Kubernetes
orchestrations,
services.
you should look
When you
towards
deploy
Azure
containers in
Kubernetes
Azure
services.
Container Instance, you
When
can
you deploy
access your
containers in Azure
applications
Container
over the
Instance, you
internet
can
via an
access your
automatically
applications
provisioned,
over the
fully
internet
qualified
via an
domain name or
automatically
optionally.
provisioned,
Uh,
fully
containers
qualified
deployed
domain
in
name or
ACI can
optionally.
be connected directly to
Containers
an
deployed
Azure
in
virtual
ACI
network
can be
for
connected
private
directly
secure
to an Azure
communication.
virtual
This can
network
be
for
combined with
private secure
express routes
communication. This can be combined with
or
express
VPN
routes or VPN,
gateway for access from other network outside of
gateway
Azure.
for access from other
You can run
network
both
outside
Windows
of
or
Azure.
Linux containers in
You can
Azure
run
Container
both Windows
Instance,
or
but
Linux
in
containers
this
in Azure
course, we
Container
are going to
Instance,
focus
but
on building
in
running
this
Linux
course we
containers.
are going to
When
focus on
defining your
building
containers
running
in ACI,
Linux
you can
containers.
specify
When
an
defining
amount
your
of
containers in
CPU
ACI,
or
you can
memory needed to
specify
run your
an amount of
application.
CPU
This
or
default
memory
is 1
needed to
core
run
and
your
1.5
application.
GB of RAM.
This default
If
is
your
1
ACI
core and
deployed containers
1.5
need
GB of RAM.
persistent data
If your
for data
ACI
files
deployed
or even
containers need
databases,
persistent data for
containers
data
can
files
directly
or even
mount Azure
databases,
files shares
containers can directly
backed by
mount
Azure
Azure
Storage.
files
Azure
shares
containers
backed by
container
Azure Storage.
instances also
Azure
support scheduling of multi-group
instances also
containers
support
that share
scheduling
a
of
host machine,
multi-group containers
local
that
network
share
storage,
a
and
host
lifecycle.
machine, local
This
network
enables you to
storage, and
combine your
lifecycle.
main application container
This
with
enables you to
other
combine
supporting
your main
containers such as
application
logging,
container with other
side
supporting containers
sidecars
such as logging,
to construct a more complex application
sidecars,
scenarios.
to
The final
construct a
feature that
more
I want to
complex
call out
application
about
scenarios.
ACI
The
is
final
that
feature that I want to
you
call
can
out
define
about
a
ACI
container
is that
restart
you
policy.
can
Container
define a
restart policy
restart policy.
tells
Container
ACI
restart policy
what to do if an
tells
application
ACI
running
what
inside
to do
of
if
the
an
container
application
stops,
running
and
inside
your
of
options
the
are
container
restart
stops
always,
and
restart on
your
failure,
options
and
are
restart
restart
never.
always, restart on
Always will
failure, and
restart the
restart
container if the
never.
application running inside
Always will
container
restart the
stops for
container if the
whatever
application running
reason,
inside
and
container
this is its
stops for
default option. If
whatever
you don't
reason.
specify a restart
And this is
policy
a
when you
default option
deploy
if you
your
don't
container.
specify
The
a
next
restart
option is
policy
on
when you
failure,
deploy your container. The
which
next
if
option
the
is on
application running
failure,
inside the container
which
fails,
if the
then it will
application running
automatically
inside the
restart by
container
ACI.
fails, then it will
However, if the
automatically
application
restart by ACI.
exits
However, if the
gracefully, then the
application
container will stop and not be
exits
restarted.
gracefully, then the container
And the
will
final
stop and not be
option
restarted.
is never,
And
which
the
when
final
the application container
option is
stops,
never,
regardless of
which
how it
when the
stopped,
application container
gracefully or
stops, regardless
ungracefully,
of
the
how it
container
stopped,
will not
gracefully
be
or
restarted.
ungracefully, the container
Now that we
will
know that
not
what
be restarted.
Azure Container
Now
Instance
that
is,
we
let's
know
see
that
how
what
we can
Azure Container
deploy
Instance is, let's see how
containers
we
into
can
ACI
deploy
from various container
containers
registries.
into
First,
ACI
and the
from
focus
various
of this
container
course
registries.
is
First,
we
and the focus
can
of
deploy
this
containers
course
from
is
Azure Container
we
Registries,
can deploy
and we will
containers
see
from
how
Azure
that
Container
works in the
Registries,
upcoming code
and we will
samples
see
and
how
demos.
that works
Additionally,
in the
we can also
upcoming
deploy
code samples
containers
and demos.
into
Additionally,
ACI
we
from
can
any
also
Docker
deploy containers
compliant
into
container
ACI
registry,
from
including
any
Docker
Docker
Hub. So
compliant
there is no
container
hard
registry,
dependency
including
on
Docker Hub.
using
So there
Azure
is
Container
no hard
Registries. You
dependency
can
on
use
using
any
Azure
container
Container Registry.
registries.
You can use
But
any
as in the
container
previous
registry.
example, we already
But
did that.
as in the
So
previous
yeah, we
example,
will
we
continue
already
using
did that.
Azure Container
So yeah,
Registries.
we will continue using Azure Container Registries.
Now, when deploying containers,
Now,
you
when
can
deploying
use
containers,
both public or private
you
container
can
registries.
use
When I say
both
public, I
public
mean
or
registries that you
private
can
container
pull
registries. When I
containers
say
from
public, I
anonymously
mean
without
registries
having
that
to
you can
log in.
pull
A
containers from
private container
anonymously
registry
without
is one
having
that
to log in.
requires
A
authentication,
private
like we did
container
in the
registry is
demo.
one that
First, we
requires
have to log into
authentication,
the
like we did in the
ACR.
demo. First, we
In
have
fact,
to
the
log
Azure
into the
container registry that we
ACR.
just deployed,
In fact,
right?
the Azure
And
container registry
image into
that we just
requires
deployed, right?
authentication by
And
default.
image into
To
requires
authenticate
authentication by default.
to
To
authenticate to
authenticate
our Azure container registry, we need to tell
to our
Azure Azure contains a registry we need to
key
tell
elements
Azure
when we
Container
deploy the
Instance
network location of the
two key
login
elements
server
when we
for our
deploy the
container
network
registry,
location of
which
the
we
login
learned
server
how
for
to
our container
find
registry,
when we
which we
deployed
learned
our
how to
Azure Container
find
Registry
when
earlier
we
in this module.
deployed our
And the
Azure
second
Container
element that
Registry
we
earlier
need
in this
is
module. And the
authentication
second element that we
credentials,
need is
specifically
authentication
a username and
credentials,
password that has the
specifically
appropriate
a
role-based
username and
access
password
control
that
rights to
has
pull
the
an
appropriate
image from
role-based
our
access control rights
container
to pull
registry.
an
And
image
in
from
our
our
upcoming code
container
sample and
registry.
demos, we will
And
learn how
in
to
our
create a service
upcoming code
principal
sample
and
and demos, we will
configure it
learn
with
how to
the
create a
correct
service
role-based
principal
access
and
control to do
configure it
just
with
that.
the correct
I
role-based
do
access
want to
control to
reiterate
do
that
just
we
that.
can deploy
I do
containers into
want to
ACI
reiterate
from
that
any
we
container
can
registry.
deploy
In our
containers
course
into
here, we are
ACI
going
from
to
any
focus on
container
running
registry. In
containers
our
from
course
Azure
here,
Container
we are
Registry
going
in
to focus on
Azure
running
Container
containers from Azure Container
instances.
Registry in Azure Container instances. So creating a service principal for ACI to pull from ACR. Let's walk through the code needed to create a service principal that will have access to pull images from our Azure Container Registry. We will then use this service principal in Azure Container Instance so that it can authenticate against our container registry and then pull the image for the container that we want to deploy. And so let's start off with setting some environment variables. First up, we will define ACR name, and that's the actual name of our container registry. And I'm using tech of the day demo ACR, which is the name of the container registry, and we will that we deployed earlier. Update this to your container registry when needed. Now the next variable, we have the get actual resource ID of our container registry. Resource ID of container registry. And next we will define a variable for service principal name and then use AZ-AD SP create for RBAC to create the service principal and then retrieve the password and store that in the variable SP password. And then going through the parameters for command, first up we have the name, which is going to be the name of our service principal. And then we have the scope, which is ACR registry ID, which we recovered here. Role is ACR pull, query, password, output to the TCV. So, and then we have saved it to SP password ID. All right. Then this will be required to pull our image from the container. Now we need to create SP app ID. Again, app ID will be used as username when authenticating to our Azure Container Registry. Now we are using environment variables here in our script for deployment. If needed, the service principal app ID and password can be stored in Azure Key Vault as secret for secure access and reuse. So we are just recovering them here like this, but we can also store them. So ACR login, and with the appropriate security laid out, allowing Azure Container Instance to pull from Azure Container Registry, we can now tell Azure Container Instance how to deploy a container from Azure Container Registry using authentication. First, we will set the environment variable for our login server. This will be used to tell Azure Container Instance the network location of where our container images are stored, and also used in conjunction with the service principal ID and password to authenticate to our Azure Container Registry. Now, to create a container in ACI, we use AZ container create. So basically what is happening now, we are creating a container inside the Azure Container Instance. So we will then specify the resource group, then name of the container, then the DNS name label, then port, image which we will get which is from the ACR login server, this, and then registry login server, which is which is ACR login server, which we did here, and then registry username and SP app ID and password, which is we just did in the previous slide. So basically, we are telling to create Azure ACR to create a container. Okay. All right. Deploying container.
What I did
Deploying a
here
container
is
using Azure
simply
portal.
I'm in my Azure
Deploying a
Studio Code
container
again,
using Azure
and
portal. This one.
what I'm trying to do is I'm
That
creating
this
one
one
Azure container.
because and
I've
then
already done these
let's
steps in
deploy
the
some
previous one, so I
container
don't have to
and
do it
then
again.
let's
And
deploy
then
some
I'm just
container
creating a
together in
CLI,
Azure container instance using
Azure
Azure
container,
CLI. I don't want to do it with the portal. It will be slow.
Azure container
To do
create
it
in
with
this
the
resource
portal.
group with this name and this
And
DNS
continue. So let's
with
go
this
ahead
image and on this port.
and continue.
Okay. And so what it did is the resource provider for Microsoft Container instance was not registered, which is generally the case for some of the subscriptions. So what it is doing is registering it for me, and registration succeeded. Now it is creating the container for me. So I'll pause for a while because it will take some time, and I will resume. All right, so it is created, and it shows me when I executed list, it shows me all these properties on this and a lot of information. Well, I cannot go through all this. And then let's continue. I will continue doing it, and so these are the further to execute. So as I shown you, I needed to get the password, I need to get the app ID, and then I will use all this information in the AZ container create. So I will execute um, this part before executing this, but I will just show you only this part because yeah, this is we have already discussed how to create SP password, service principal, app ID, echo. This will be printing all this, and then I'm creating getting the ACR registry ID, blah blah. So anyway, I will continue from here on, and I'll just show you after the pause. All right, I just created I just executed all this bunch of code, and I put the URL like this, and then just printed it what it is. Then I created changed the name of ACR name, which was like this, and then I got the registry ID using this query and login server. Then I print the login server, then get the SP password, SP app ID, and then create the container. I'll continue doing it 1 second. It has an error. Argument registry username expected 1 argument. So 1 second, I will continue. Okay, now I'm running all this set of commands, which is initially getting the URL and then creating the ACR name, getting the ACR registry ID and login server, then password for service principal, along with creating the service principal, and then creating the container in the ACR, and then showing the container. All right. So and this is successful execution here, you see. And if I go to my resource group here, and if I refresh, if I go to container instance, and if I see here containers, I see tech of the day demo CLI container is created and running, and you see here the events which were started, pulled, and pulling. So you see the time and dates here, and this demo concludes here. So I hope you understood how to configure, how to create local container, and then how to push the container image to using Docker. Creating image using Docker, and then creating ACR container, Azure Container Registry, and then pushing the image to this registry, and then creating a container inside Azure container instance, and then finally, so we are done till here. I can just container delete it, and then I can delete everything else. But I will keep it for now in my Azure portal for now, to keep it for other things. But you can continue and delete your instances. So that's it for now, and I hope you understood.
All right, that's a wrap for this course,
All
Microsoft Azure
right,
Developer Implement
that's a
IaaS
wrap for this
Solutions,
course, Microsoft
where
Azure Developer
we
Implement
focused
IaaS
on deploying
Solutions,
virtual
where
machines and
we
containers.
focused on
With
deploying
this
virtual
course, you
machines
should be
and
prepared
containers.
for the
With this
implementing
course, you
IaaS,
should be
IaaS
prepared for
solutions
the
objective for your
implementing IaaS,
A204
IaaS
AZ-204
solutions
exam.
objective for your
In this course, we covered
A204
how to provision
AZ-204
virtual
exam.
machines,
In this course, we covered how to provision virtual
how to
machines,
configure VMs and remote access, create ARM
how to
templates, create
configure
container
VMs and
images for
remote
your
access,
solutions
create
by
ARM
using
templates,
Docker,
create container
publish an
images
image
for
to
your
Azure
solutions by
Container
using
Registry, and
Docker,
then run
publish
those
an image to Azure
containers by
Container
using Azure
Registry, and
Container
then run those
instances.
containers by using Azure Container
We
instances.
then learned how to publish images
We then
into
learned how
Azure
to
Container
publish
Registry, and then also how
images
to
into
run
Azure
containers
Container
by
Registry,
using
and then
Azure Container
also how
instances,
to
and deploying
run
containers with
containers by
Azure
using
Portal
Azure
and Azure
Container
CLI.
instances, and
So
deploying
here is
containers
the
with
end of
Azure
this
Portal
course,
and
and I
Azure
really
CLI.
hope you
So
enjoyed
here is
listening
the
to
end of
this,
this course,
and
and I
that
really
we have
hope you
laid a
enjoyed
prepared
listening to
foundation
this,
for your
and
Azure
that we have laid a
AZ-204
prepared
studies.
foundation
We have
for
covered a
your
lot of
Azure
ground so far
AZ-204
together,
studies. We have
discussing how
covered
to
a lot
deploy
of
virtual
ground so
machines and
far
container
together,
in
discussing how
containers
to
in
deploy
Azure.
virtual machines and
It's truly
container
been
in
pleasure recording
containers in
this
Azure.
course, and
It's
I
truly been a
thank you
pleasure
for your
recording
listening,
this
and
course, and I
most
thank you for your
importantly learning
listening,
with me.
and most
Thank you, and
importantly
let's
learning with
continue
me.
to the
Thank
next
you, and
part of
let's
this
continue to
certification.
the next part of this certification. Hi, my name is Nitish Sharma, and welcome back to Microsoft Azure Developer Implement Azure Functions course. This is third part of the part one, and we have already discussed Azure app services, Azure virtual machines, and we have also discussed containers. And now we are going to discuss Azure functions. In this course, I will be teaching you the essentials that you need to know about Azure functions in order to meet the objective of your exam AZ-204. Started. In particular, there are three skills listed under the implement Azure functions exam objective, and these are implement as function triggers by using data operations, timers, and webhooks, implement input and output bindings for functions, and implement durable functions. We will talk about all of them one by one in next slides. Let's continue. In we will tackle each of these skills in
We will
next
tackle
three
each of
modules
these
of the
skills
course.
in but to get started, I
Next
will
three
explain
modules of
what
the course. But to get started, I
Azure
will
functions
explain
are.
what Azure functions are.
Introduce some key terminology such as serverless
Introduce
and
some key
function app, and I'll
terminology
show
such
you
as
how to
serverless and
use
function
these,
app,
and
Azure
I'll show you
them
how to
on
use
in
these
Azure
portal to
Azure
create an Azure
them
function
on
application.
in Azure portal to create an Azure function
So we will
application.
demo on Azure portal as well.
So we will demo on Azure portal as well.
Let's start by quickly introducing Azure functions.
Let's
Azure
start by
function
quickly
is a
introducing Azure
serverless
functions. Azure
application
function
platform which
is a
provides a
serverless
simple way
application
to run
platform
a small
which
piece of
provides a
code
simple
or
way to run a
functions
small
in the
piece of
cloud. You
code
might hear
or
it
functions
referred
in
to
the
as a
cloud. You
function.
might hear it
As service
referred to
platform,
as a
serverless
function
means that
as a service
rather
platform.
than
Serverless
having to
means that
provision
rather
um,
than having to
and
provision
maintaining server
um,
ourselves,
and maintaining server
we delegate
ourselves
that responsibility we
the
delegate
cloud
that
provider. We simply
responsibility
provide our
to
code,
the cloud provider. We
and
simply
serverless
provide our
platforms also
code,
support automatic
and
scaling to meet
serverless
demand
platforms
and
also
offer
support
billing
automatic
modules
scaling to meet
models
demand and
where
offer
you
billing
only pay for your
models
code while it's
where you
running.
only pay
So
for
while
the
you are
for your
using
code
it,
while
so
it's running.
Azure
So
function
while
are
you are
cooked
using it,
into
so
Azure Functions
Azure
app,
function
which
are
is a
cooked
collection of
into
one or
Azure
more
Functions
related Azure
app,
functions
which is a
that are
collection of
developed,
one or
deployed,
more
and
related
hosted
Azure
as a
functions
group
that are developed,
on
deployed, and
that
hosted
same
as a group
specific Azure
on that
application.
same
So Azure App
specific
Service.
Azure
So let's say
application.
in
So
Azure
Azure
App
App
Service,
Service.
in
So
Azure
let's
App
say
Service,
in
you
Azure
had
App
one
Service,
single Azure App
in
Service
Azure App
plan, and you
Service, you
hosted
had one single Azure App Service
one or
plan
two
and
Azure
you
App
hosted
Services on that. Here
one
you
or
are
two
all
Azure App
still having
services
the
on
same
that.
Azure App Service plan,
Here you are
but you
all
are
still
paying for
having the
what you
same
are
Azure App
using,
Service plan,
only for what you
but
are
you are
using.
paying
Let's
for
say your
what you are
function is
using
being used
only for
only
what you are
once or
using.
twice a
Let's say
day.
your
It
function
doesn't
is being
make
used
sense to
only
keep it
once or twice a
alive
day.
all the
It
time, first
doesn't
of all, and
make
then
sense to keep it
second, you don't
alive
need
all the
to
time, first
pay
of all,
for a
and then
whole day then,
second, you
right?
don't need
So you
to
can make
pay
use of
for a
that,
whole day then, right? So you
that
can make use of
ability
that
from cloud.
that ability from cloud.
We have three things. We
We
are going to
have
talk about programming
three
languages,
things. We
hosting,
are
and
going to talk
development
about
environment.
programming languages,
In
hosting, and development
this course,
environment.
we are going to talk about first is
In this
programming
course, we
languages.
are
So
going to talk about first is programming languages. So you can use Azure Functions offers a lot of choices and flexibility. First, it offers a choice of programming languages. You can create Azure Functions in C Sharp, Java, JavaScript, Python, PowerShell, and many other programming languages are also available. In this course, we will see demos that use JavaScript and C Sharp. I prefer mostly C Sharp, which are which is most commonly used with Microsoft products, commonly used with Azure Functions as well. And then we have second, you have a choice of hosting environment. Azure Functions are usually hosted in service plan or Azure App Service. So there is a consumption plan, which is a serverless pricing plan, which bills you only while your functions are running and automatically scales out to meet your demand. This is the most commonly used service plan for hosting Azure Functions. One limitation it does have it is that there is a time limit of 5 minutes for each function invocation. There is also App Service Plan, which doesn't have this time limit and uses a more traditional pricing model where you pay monthly for the compute resources you are reserving. And there is also a premium plan which offers faster performance, enhanced security options, and reserved instance which are always ready to run your functions, but does also offer serverless automatic scaling capabilities. Alternatively, you can also run Azure Functions in Docker container, and we have already talked about Docker possibilities, and but uh, Docker container allowing you to benefit from the Azure Function programming model on premises or in any cloud provider. And you can run Azure Functions locally, which is great for development and testing. In this course, I will show you example of running Azure Functions in the consumption plan and locally. So let's get started. And then the third one, finally, the Azure Functions gives you choice of development environments. You can develop directly in the Azure portal, and this is great for learning and quick experiments. But for most applications, you will either want to use Visual Studio, which is practically good choice if you are using C Sharp and running on Windows. And you can use alternatively, you can use these Azure Functions core tools, which are cross-platform command line tools, and you typically use these in conjunction with other editor like Visual Studio Code. We will see three of these development environments in action in this course. Let's so let me show you how to create an Azure Function app in Azure portal. You can do this by clicking a create resource in the portal, and I will take you there in a moment. Let's go there.
So here I am in my Azure portal, and here you see I created few resources yesterday, but I deleted them, so you don't see them here anymore. I have a subscription called Azure Subscription 1, and it just gives me direct option to create a resource. Here you in the left side of the portal, you have you can click on the frequently used things, and function app is one of them, and you can just click on this and start from here, or you can also click on create a resource, which will give you a search option. So you can many ways. I will just click here function app, and it just shows me how many function apps I have, and I don't have any here. I will just click create, and it will take me to the plain where it asks me for a few more details, and here it by default selects my subscription, and then it asks me to get a resource group, which I don't have for moment any. So I will say tech of the day 204, and there is no resource group like this, so it will I will say create new. I'll add this and okay, and it will create this resource group. Then we go ahead and it asks for the function app name. Let me see if it is available. It is available. Tech of the day. If I try to remove it and then test it, yeah, it is also available. So I'm going to create a function app name tech of the day dot azure websites dot net. So as you can see, this is a domain name, and then that means that this name function app name should be unique on Azure Websites.net, right? So this is, you can say this is the subdomain and this is the main domain name. So it should be unique on this one. So within Azure Websites, this name should be unique. Then if you go further, you have two options, and if you want to deploy via code or with the Docker container. We said if you select a Docker container, it just asks you for the region, and then it asks you for the operating system you have underneath you want. And if you select code, it just asks you for the runtime stack and which version of that runtime stack, and then region. So region is in a region is required for everything, but these two things changes. So runtime stack and version, if you select via code, and if you just change it to Docker, then you need to say only the region. So I'll go with the code, and let's say you have multiple options here for the runtime stack: .NET, Node.js, Python, Java, PowerShell, Core, custom handlers. I'll go with the .NET, and then it asks me to select a version of .NET framework. It has multiple frameworks, and okay, for the function app, there is difference to note here. For the function app, you see only two options available: 3.1, which is Core .NET Core 3.1, and 6 .NET 6. Um, but for the function app, for the normal app service, it gives you more options, many more options. Like it even gives you a .NET 7 preview now, because while I was doing it yesterday and creating a function app service, it was giving me option for .NET 7 preview. But yeah, it depends on the time of the year. And now we are in end of August 2022, almost September. So the .NET 7 preview is available already. And yeah, so let's continue. I selected .NET 6, Windows, operating system Windows, and it is asking me to select the plan billing. As I discussed, you have three plans now. So consumption plan, which is serverless, function premium, and app service plan. So app service plan is the same like you have for your app services, and it's you can reuse that plan as well, but that is like you are paying for the fixed compute price for 1 month, right? So but the benefit is you can host multiple function apps in this using the same app service plan. Or if you go with the consumption plan, which might be cheaper, because you will be paying only for the consumption you are doing. That means the function app for the time your function app is active, but it might be expensive if your function app is running 24 hours. So then better option is to use app service plan. Anyway, let's continue with the consumption plan. Then I go with the hosting, and when creating function app, you must create a link or general purpose Azure storage account that supports blob, queue, and table storage. Because you need one storage account for the function app here. And then you go with the networking. I don't want any networking here, so I am not using any VNet or anything, but as I'm not allowed as well, is only available in function premium and basic, standard premium, premium v2, premium v3, dedicated app service plans. So because I used use the consumption plan, I don't have this option available. So if I want to use, if I want to integrate virtual networking, VNet integration, then I need to be either on the premium uh, and basic, standard premium, premium v2, premium v3. So either I should be on the premium, or I should be having app service plan, which is basically the requirement for this. Okay, and then I go with the monitoring. I don't want for now actually to have any application insights, but if I want, I can simply have application insights. That means my anything, any problem, error, logs, everything will be logged into application insights. I think I would do that, because the benefit is, if I want to debug my Azure function, it will log everything here. One thing I want to change here is the region, because by default it's selected Central US, but I want to do it in the North Europe. I will change it in a while. So region I want is North Europe, because my subscription plan is basic and it doesn't allow multiple regions. So but that is only to me. And now my function app is almost ready. What happened just now is it just validated my selections, and now if I click create, it will create. And now I already have the ARM template. I have been repeating this during the last videos as well. While you are on the portal, and when you are trying to create a resource, by this step you already have the template here. So if you want to download this ARM template and then use it for your code integration, so if you don't want to do it manually via portal, and for the next time you want to keep it in your repository, so source code, then you, if you want to deploy or create Azure function app using CI/CD pipelines, you can do that as well. And that is ARM template. You can download it here. So I will just go ahead and create it, and now the function app is being created. Now I already have the function app, not yet. And what happens is, I just created a deployment. I want you to pay attention here. You created a deployment. So deployment means multiple resources might be created, right? Because I selected many things. I asked to create a resource group. I asked to create a storage account. I asked to create also for log analytics. So you see a lot of things are created. You see Microsoft Insight. So log analytics is created, and then you have storage account, you have server forms, you have another storage account. So you see multiple things are being created here, if you want to pay attention. And now we want to go to our resource. So go to resource. The deployment is completed, and now we are in our Azure function app. For now, this function app might not be having anything. You see your function app 4.0 app is up and running, and that's it. You see, nice. Oh yeah, okay. A nice But anyway, this is up and running. And you see, if I go back here, I don't have any functions in here. If I go here, you see I have no function. So I have just created a function app for now. And if I want to add functions, so I just want you to differentiate. I just created a function app, and now I need to create a function in it, because I might have multiple functions, right? So let's create a function. This time I'm going to create a function via using the portal itself, development portal. You can also have VS Code. You can have other tool like PowerShell or Azure CLI. For now, I'm going to do it in the portal, and then I'm going to select a trigger. What type of trigger I want to use. I will explain in a while what are the triggers, what are these things. For now, I'll just select HTTP trigger, and then I'll just say create. So it is going to create a Azure function based on HTTP trigger. Okay. Okay. Now I have it, and it just gives me option to code and create test my Azure function. And you see, I have this code. This is the code I have, and yeah, simply connected. You are now viewing logs of function runs in the current code plus test panel. To see all the logs of this function, please go to monitor from the function app menu. So if I go to monitor here, and I can in the real time I can also debug the problems I might have or requests I'm receiving here. Anyway, we'll talk about it later. So first of all, I just want to just change a little bit in the code itself, and I just want to test it. So response message is this, but I also want to add here uh, tup, 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 request, and now in here I want to return something. Let's say this is HTTP trigger function executed successfully. uh, and I will say, and it was added for testing AZ-204. Let's save and test. So this is actually a simple post request to this method, and I will just say I'm sending name Azure and run, and I should receive a response now. 200 output is hello Azure. This is uh, this HTTP trigger function executed successfully. Oh yeah, okay, and here uh, here you see other logs. um okay, anyway, let's continue, and I hope you understand. This was just a basic explanation about function app, and you have many other things. I will talk about them in a while. These are almost like app service things you have, um, and you should know them by now, but yeah, I hope it is clear. Let's continue.
Implementing function triggers. Introducing triggers. Okay. Hi, my name is Nitish Sharma here, and in this module we are going to learn about how to implement function triggers. Triggers are what causes an Azure function to be executed, in simple words, right? As I just shown you in the exam in the portal how to create an Azure function, and while I was creating in the portal, you had a lot of Azure function triggers which were there, and we wanted to see them here. So if you see them here, you see you have few of them are here. There are many more triggers you might have. So in this module we will look at three examples of triggers. We will create an HTTP request trigger function, which is how you implement webhooks, we will create a scheduled task which uses a time trigger, and we will use a blob storage trigger, which is an example of basic data operation, and we will implement all of these in the Azure portal using the function app that we created in the previous module. So let's continue. Every Azure function has exactly one trigger. The trigger is event that causes the function to run, because as you know, the concept of function app is serverless function app. That means it is not running continuously, but it is running on a trigger. Okay, so Azure functions support many types of triggers, and we only have time to see a few of them in action in the course. But let me tell you about some of the most commonly used Azure function triggers. An HTTP request trigger allows us to create an Azure function that runs in response to a web request. This allows us to implement webhooks or to create RESTful APIs using Azure functions. So it is similar to REST is APIs, because it will execute when you call this endpoint, let's say. So basically it's similar like REST APIs. A queue trigger, sorry, I forgot, a time trigger allows us to create scheduled tasks such as function that needs to run at midnight every night. A queue trigger allows us to run a function in response to a message on a queue, which could be Azure Storage Queue or Azure Service Bus Queue. A Cosmos DB trigger allows us to run a function in response to a new document being created or updated in the Cosmos DB database. A blob trigger allows us to run a function in response to a new file being uploaded into Azure Blob storage, and there are many other triggers types, including event grid or Microsoft graph. Actually, you can create triggers on many resources which are, so basically if there is any change on any resource, Azure resource, you might create a trigger. This is to explore actually. So HTTP request triggers are one of the most commonly used triggers types, as they are useful for implementing APIs and responding to webhooks for external systems. When you use an HTTP request trigger, Azure function lets you customize which HTTP methods such as GET or POST and can be used to call your function. You can also customize the route to control the URL of your function, and HTTP triggers can be secured by requiring an authorization key. There are three authorization levels. Anonymous level means your function doesn't require a key, or function level requires callers to provide a key that's specific to just that function, and the admin level requires a key that can be used for all the functions in the function app. Let's create a function that uses HTTP request trigger. Here we are. So I will go back to the Azure portal, and I will explain you how to create I have already done that. Actually, I have already created HTTP based trigger, and but there was no authorization level on the function, which means that the call to that function um, doesn't need any authorization code. So I will do something with the authorization as well. I will change the authorization, and we will try to call that endpoint and see if it reacts. Okay, let's continue. Let's go to the demo.
Okay, we are back in the Azure portal, and as you saw in the previous demo, we created a function app, which is tech of the day. And if I just go to this app directly, I can just go like this, and the app was running up and running. And then we created a function which is called HTTP trigger 1, and I just deployed it, and I just created the first function but I did not show you many other things like authentication, keys, and everything. We are going to talk about that in this demo now. So you see here, I'm in this function we created, HTTP trigger one. I did not rename it or did anything with it. I just created it, and then what you can do, you can still change its name, of course. If you go to code and test, you can do a lot of things with it. You see here, you are passing a request, HTTP request, and a logger, iLogger will be used for logging, log analytics, and every error, status of the application, everything about the application into log analytics, which we can later on check. And then this request is containing the user input, which we can use, send some information to it, and then that thing can be used in the program itself, in your function app itself, and then it does something with that, and you can use that. So that's a simple app here. If I go to further things like what is the definition of this function, what are other settings. So you see here, auth level is function level, which means at function level you have the authentication level. You might have anonymous, or you might have function level. Then the name of the request is request, then type is HTTP trigger, direction in method get or post method, and then the response is type of HTTP as well. So that's it about and then you have readme, and then it just talks about yeah, something about the function. Pay attention to it. It might looks a bit different what you have in your Visual Studio Code, because, or in your portal, because I selected here .NET 6, which .NET 6 gives you a lot of flexibility, and writing the syntax is a little bit different. So you might have different styling of different syntax of your code, but nevertheless, don't worry about it. Let's continue. Then I want to and then okay, then you have function key at the function level. So this is I'm specifically inside the function, and then I have the function keys inside the function level, and then I can get the keys. It is so slow, I just hate it. I don't know why. Anyway, it's here, and I should have. So you have one function key which you can hide and use it. And then you go here, sorry, in the overview, and if you want to check, get the URL, get the function URL, copy it, and I just go to this part and you see it. So you see here, this function, HTTP trigger function executed successfully, pass a name in the query string or in the request body for a personalized response. And I passed this code. So I used because here you see we saw the default key, which is function level key, and then that key is passed in the request itself with this code, and I used it and it is successful. And if I remove it, then I get 401. You see error, HTTP error 401. That means that it doesn't work, because the authentication doesn't work, because it needs a code to access this function app, sorry, this function. And then it says if you pass a variable called name, which is simply tech of the day, and I will pass, and then you see it is working, hello tech of the day. That means, because in the code here you see I'm using the name passed in the query that is being used here, so it will display the name. So basically that's what it is doing here. So basically yeah, that's it about the creating the HTTP triggered function app. I hope you understood and enjoyed it. Let's continue.
We are again with the triggers. So now recently we talked about HTTP trigger. Now we want to talk about time trigger. Time triggers are a simple but powerful way to run scheduled tasks in the cloud. When you use a time trigger, you provide a cron expression that determines when your code function should execute. So I'm gonna create a time trigger and see how it is going to execute, and then we will see it will actually it should execute on its own, and then we'll see what it does. Let's go to the Azure portal.
Okay, so after HTTP triggered function, we want to create time trigger function. And when I click create function, deploy develop in Azure portal, and you see here you have a lot of options, many triggers. Then the second most important and most used is time trigger, actually, which you see here, time trigger. And I selected this and I say create, and it is going to create a time trigger function for me. And you see it just created a time trigger function named time trigger 1. And if I go to code plus test, and if I see the code, it just have this time trigger my timer ilog as input, and it just does this part. So it just displays what it is doing. If I see the function.json, which is actually the bindings for this function, and you see the name my timer, which is it is sending, type time trigger, and then direction is it's an input, and then schedule is cron expression. If I go to this Chrome expression, this means that it's every 5 minutes. So basically, this we have created a time trigger for 5 minutes, but I will change it to 1 minute to um, to just see it in action. And we go to monitor here, so that to see if it is actually working. And you see it, the last one it executed was um, 25 of August 11:34. But yeah, I'm expecting another run here. So basically, it should execute again. I will pause the video and wait for 1 minute. So when we are seeing this live, in monitors tab, you have option to invocations, and you can also look into logs. When you go to logs part, you are connected to the monitor part of the application, and you are actually seeing the live logging here. And this is really good for debugging any problem. And you see it is active for 2 hours, and I would highly recommend you to use this when you are developing your function app. Yeah, so it is supposed to be running every minute, as we changed the logging part, the cron example. So we changed it, and you see it is triggered within 1 minute, and it says executing function time trigger 1, time fired at this, and C# timer executed at this. You see, so basically it will trigger every minute. If I continue looking at it, it will keep doing the same thing. It will keep publishing this. So that means, like, what I have done here is actually working. Okay, so um, you see here. Okay, right, and then if you go to uh, overview and try to get the function URL, you don't have it because it's a time triggered. It's not a webhook. You cannot call this function yourself. It will be triggered automatically, and that is the main advantage or disadvantage sometimes. So yeah, let's see. Let's continue. I hope it is clear.
Another important trigger is blob trigger. As an example of data driven trigger, we are going to trigger a function where whenever a new blob is uploaded into blob storage. Once again, when I click to add the function and create the blob trigger, this is the third most important or third most used trigger. So I will just go to the portal and I will explain it to you. See you there.
Okay, again we are on our Azure portal, and we are in the function of tech of the day, and in the function part, I'm just gonna click create function, and same way I'm gonna select a trigger. So here you have multiple triggers: Azure Queue Storage trigger, Azure Service Bus Queue trigger, Azure Service Bus Topic trigger, Azure Blob Storage trigger, Azure Event Hub trigger. We want to add Azure Blob Storage trigger, and that means it will trigger when when on a specific storage account and a blob is added. So let's go to the function itself, and let's see what it created by default, because we just clicked and added it. So by default it might have things. So you see stream blob, which it is, that means it is sending the blob to it, name of the blob, and then logs. And if I go to function.json, and I see here I have input as my blob trigger direction is in, and then you see it is pointing towards sample work items slash name. So if I just go to another tab here, okay, so as you see, we created blob trigger 1, and this was actually here in the test trigger container, which is I uploaded a demos.txt file using upload here, and this is a container within this storage account. And if you go here, you see when I uploaded demo.txt, it detected the blob and it triggered the function app. So basically, if I go back to this code and test, what was happening, what we created, actually it was, if we go to function, it was checking for the past test trigger, and slash dash name is, this is the name of the file. So basically it is waiting for this, and then if I just go here, it triggers with the stream itself. So I have the blob, and if I want to do something with the blob, I can still do something. I mean, I have whole information about blob as a stream, so I can use that, and the name is the parameter we passed from there, which we displayed in the if I go to monitor, and you will see here it was triggered 2 times. And if we check the last one, this one, you see executed the blob and details were this. So uh, it was triggered by the blob change, right? So you have all the information here. Function processed blob name demo.txt size blah blah blah, because it knows the information about the blob. So I hope it is clear that we can create blob trigger, HTTP trigger, and time trigger on the Azure portal. You can change their names. If I just go here and I want to change its name, I can change it, and I can do it other way. I hope it is clear. With that, let's continue. Let's continue.
Hi, it's Nitesh Sharma here again, and in this
Hi,
module, we will learn how to
it's Nitesh Sharma here
implement
again,
input and
and in this
output
module,
bindings
we will learn
for
how to
an Azure
implement
function. We will
input and
learn
output
about the
bindings
various
for
types of
an
input
Azure
bindings,
function. We
which
will learn
simplify the
about the
process of
various
getting
types of
data into
input
our
bindings,
function from
which
int
simplify the
external
process of
systems,
getting
and
data into our
we will look
function from
at
external
output
systems,
bindings,
and
which
we will look
allows
at
us to do things like
output
sending a
bindings, which
message to a queue
allows us to do things like
or
sending a
adding a
message
new
to a queue
document to the database.
or
We will
adding a
be
new
using Azure Functions
document to the
core tool in
database.
this module
We will
demonstrate the
be
process
using
of
Azure
developing Azure
Functions core
Functions
tool in
locally.
this module,
A
demonstrate the
binding
process
is
of
a
developing
connection
Azure Functions
actually to
locally.
the data
A binding
within
is a
your
connection
function.
actually
Binding
to the
are
data
optional and can be
within
input
your
or output.
function. Binding
Input
are
bindings
optional
are
and can
used
be
when we
input or
want to read
output.
access.
Input bindings
We
are
want
used when
read
we want
access
to
to the
read
data from
access.
the external service
We want
within our
read
function, and
access to the
output
data
bindings are
from the
used
external
when we
service
want to
within our
write data
function,
to
and
the
output
external
bindings are
service.
used when we want to write data to the external service. So, so a function can have multiple input and output bindings. Some examples of available input bindings are blob storage binding, which can read the contents of a blob. When you upload a blob, when you have blob trigger, you have the possibility to read the blob stream, as I shown you in the previous example. And same way, also you can have from Cosmos DB binding, which can look up a document in the Cosmos DB database, and several other input bindings are available, such as Microsoft Graph, which you could use to read a document from the OneDrive. For example, Azure Functions also provide many output bindings. Example include Azure Blob Storage, which would allow you to create a new file in the blob storage. Azure Key Storage, which allows you to post a message to a queue, and Cosmos DB, which allows you to create a new document in the Cosmos DB database. And there are many other, including Event Hub, Service Bus, and even connectors to third-party services like SendGrid for sending emails to Trello, for sending text messages, yeah, many more. So you have many more third-party as well. Let's continue. Let's do the demo. In this demo, I'm going to create HTTP request trigger uh, using JavaScript function and use a Cosmos DB input binding to read a document from Cosmos DB. Let me quickly tell you the tools I have got installed. The Azure Function core tools, which are cross-platform command line tools for working with Azure Functions app locally, Visual Studio Code, which I'm using as my code editor, and I have got the Azure Functions Visual Studio Code extension installed, which will simplify creating the bindings. I have also got the Azure Storage Emulator and Azure Cosmos DB Emulator installed locally, which means I don't need to create a storage account and a Cosmos DB database in the cloud. To create a new Azure function project, you just use the function init command in a new folder, and this project is going to use JavaScript. So I will select node, then JavaScript, and I will open this folder in Visual Studio Code, and then I will start. So let's do the real demo. Okay, we are here in my Visual Studio Code, as I told you, and I have a Node.js function app, which is simply getting the context, request, and input document. And input document is a type of, if I go to, I can check what type of input document is. And in the bindings here, you see it's a list, and in the list itself, you see the bindings like auth level is function level, type is HTTP trigger, direction in, and name is request. So if you connect them with the function itself, you see here request, and here it's the type. It's so the input parameter here is request, which is type of HTTP trigger, and it's an input, and method used are get and post. Then you have type of output direction, which is output binding, and you simply saying it's an HTTP output binding, and this is the response. So if you go back to the function itself, and here in the context.response you are saying body.document.desk whatever, but you are sending a changing the response here, and which is by default will be responded back. If I go back here, and then we see the type of Cosmos DB, it's an import document, and database name demo, collection name to do, connection string Cosmos DB connection, and then ID is query ID, and this. So basically you are putting an input type of input document which with this query, and to connect it with this local Cosmos DB. For clarity purpose, I have this Azure Storage Explorer, which by default gives me possibility to create an emulator. I have a storage account emulator, and I also have Cosmos DB emulator, so I can just use this. And I also have data lake storage generation 1 preview. This is with old version, and you see here I have Cosmos DB, and which is running on localhost. So I don't really have to create a Cosmos DB in my Azure portal to test it. Simply I can supply the connection to this Cosmos DB, and this will work. Next to it we have queue, which is a type of queue, and direction is output queue item, and it's a web job storage. Let's go to index.js, what it is doing actually. So if you see here, I'm checking if the document input document, if it's not null, then let to do item run query ID blah blah blah, which is a request. In the request itself you have this value, and then context.response, you set the response with 404 and the message, and you set the output by queue item with this message. So you see context.bindings.output queue item. If you go back here in the function, and if you see output queue item here, which is being set, so basically we are setting back the context.bindings, and then you have this parameter output queue item, and you are setting this with this message, basically which we need to send because it's an output binding. So I hope it is clear for you to understand input bindings and output bindings. It is very important to understand. And then I can go here, and you see I have added the Cosmos DB connection, Azure Web Job Storage, function worker, and I added the local connection string like this, what I have in my data in my Azure Explorer, which is a local Cosmos DB, kind of a fake DB you can say, not real in Azure, and but it doesn't matter, right? It's kind of an actual DB, Cosmos DB. And then in the host settings, you see here in the host settings, it's not really doing anything different. Just setting the extension function bundle, this one, and then yeah, not really much doing here. Local setting and packages, no, not really anything special, and yeah, that's it. So I hope it is clear. To run this message, I just have to do function.start, and it will execute. To do that, I can just go here and run function.start, function start, and then it will execute it, and wait for any context document in the Cosmos DB uploaded here, and respond accordingly. So if I add any document to this, and then to this database, I need to create a database, the one which we are looking for, and then I can upload a document. So basically that's it. I hope it is clear to you how the input and output bindings works. You just need to understand that it's a simple way of input and output fields actually to a function, which we have in general in C# or any other language, as well as parameters are the inputs, and the outputs are the output we send back to the caller of that function. And same thing is happening here. So basically the caller of the function is someone from the internet, and that is sending a request, and request is actually input to our function, and the output is same response. So we change the context, HTTP context. Basically, that's it. So I hope it is clear. Let's continue.
Nitish Sharma here again, and in this module, let's
Nitish
learn how
Sharma
to
here
implement
again,
Azure
and
Durable
in this
functions.
module,
Azure
let's learn
Durable
how to
function is
implement
an
Azure
extension
Durable
to Azure
functions.
functions that
Azure Durable
enable
function is
you
an
to create
extension to Azure
stateful
functions that enable
serverless
you to
workflows.
create
These
stateful
workflows are referred
serverless
to as
workflows.
orchestrations by
These
durable
workflows are
functions.
referred to
Let's
as
continue.
orchestrations by durable functions. Let's continue. So, the programming model consists of three types of functions. First is client or a starter function. This is an Azure function that indicates a new orchestration. It can use on any of the Azure function triggers we have already looked at. Second is orchestrator function. This is the function that defines the steps in the workflow and what order they are performed in. The orchestrator function can also handle errors that happen at any point in the workflow. However, the orchestrator function doesn't perform any of the actual steps in the workflow. That's the responsibility of activity function. We will explain that in a while. An orchestration consists of multiple activities that can be performed in sequence or in parallel activity functions. And activity functions can use any of the input or output bindings we have looked at earlier in this course. And orchestrator function do have to adhere to some quite rigid guidelines. And at the moment, it's recommended that you create your durable functions either in C# or JavaScript. For this demo, in this module, I'm going to use Visual Studio Code, Visual Studio, and C#. Let's continue. You have orchestration pattern. Let's review some of the orchestration pattern that durable functions make possible. Function chaining is where we want to execute a sequence of activities and functions in a specified order. The orchestrator function keeps track of where we are in the sequence. So let's say we first execute activity 1 on Azure function, then we go to the next activity, then the orchestrator, and then activity 3. So in whole flow from here till here, the orchestrator function will keep track of these activities. This is simple chaining. And then we go to next one, which is
It is a pattern that runs multiple
fan
activity
out.
functions in parallel
It
and
is a
then
pattern
waits
that
for
runs
all the
multiple
activities to
activity
finish.
functions in
Results
parallel
of the
and then
parallel
waits for
executions
all the
can
activities
be
to finish.
aggregated
Results of the parallel executions
and
can be aggregated
and used to
and
compute the final final
used to
results.
compute the
And this pattern is very hard to achieve
final
without the use of
results, and
a
this pattern
framework
is very
like
hard to
durable
achieve
functions.
without the
So
use of
basically,
a
you
framework like
start your
durable
activity one
functions.
and then
So
you do
basically
activity two, which
you
is a
start
parallel
your
execution of
activity 1
multiple
and then you
functions,
do
and then
activity
in
2,
the
which
end you
is a
wait for
parallel
all of them to
execution of
execute
multiple functions,
here,
and then in
and
the end
then
you wait for
once
all
they
of them to
execute, you
execute
go to the
here,
next
and
activity.
then once they execute you go to
Then
the
next
next
pattern
activity. The next
asynchronous
pattern
HTTP APIs. This pattern
is
is useful when
asynchronous
you have an
HTTP
API that
APIs.
you
This
need
pattern
to
is useful
repeatedly
when you
pull
have an
for
API that
progress. You
you
start
need
off a
to
long
repeatedly
running
pull for
orchestration, and then
progress. You start off a
your
long running
orchestrator function can
orchestration,
manage the
and then
pulling until the
your
operation has
orchestrator
completed or
function can
timed out.
manage the pulling until the
So
operation has completed or
um,
timed out.
you start
So
a process, and then
you
you
start a
do the work,
process,
then you
and
wait
then
for it,
you
and then you need
do
to
the
get the
work,
status continuously from
then
this.
you wait
So
for it,
you
and
keep
then you need to get the
getting the
status
status,
continuously from this. So
and
you
you
keep
keep waiting. So
getting the
basically it's
status,
asynchronous execution,
and you
because
keep
here
waiting.
this
So
do
basically it's
work is doing
asynchronous
a lot of
execution,
magic
because
work.
here this
So
do
you need to
work
get the
is
status
doing
of
a
it.
lot of magic
Next
work.
is monitor.
So you need to get the status of it. Next is monitor. The monitor pattern implements a recurring process in a workflow, possibly looking for a change in state. You could use this pattern to repeatedly call an activity function that's checking to see if certain conditions are met.
So you have a work in progress, and you keep checking if something is changed, and for that you just poll and sleep, and you keep checking. So it's kind of a monitoring for a specific thing. And then you have human interaction. It's very common in business, very
Human
common
interaction,
workflow
it's very common in
which
business,
require a
very
manual
common
approval, where the
workflow
workflow must
which
pause until
require
a
a
human
manual
has
approval,
interacted in
where the
some way.
workflow must
This
pause
pattern
until a
allows
human has
workflows
interacted
to
in some
wait
way.
for certain
This
events
pattern
to be
allows
raised and then
workflows
optionally
to
perform
wait for
mitigating
certain events to
actions
be
if
raised
there
and
is
then
any
optionally perform
timeout waiting
mitigating
for human
actions
interaction.
if
So
there is
you
any
continue
timeout waiting for human interaction. So
you make
you
a request
continue
approval to human interaction, and
you
this
make a
human comes
request
in,
approval
and if
to human
he
interaction, and
approves it
this human
over the
comes
time
in,
or not
and if he
within a time frame,
approves it
and then
over the
you
time or
continue
not
with the
within a
process
time
approval.
frame, and
And
then
if there is
you
anything
continue
he
with the
can or she
process
can
approval, and if
escalate the
there is
matter.
anything he can or she can
Then let's
escalate the
create a
matter. Then let's create a durable function um, functions workflow using Visual Studio. I will start by creating new Azure C# function, and I will select the function app project type and call it durable function app. Let's go to Visual Studio Code. Okay, I have created a function app in my local Visual Studio, which has these two things: function one and my orchestration.cs. In function one, I have a function uh, which is called function one, and the authorization is at function level, and the inputs are request only, and then in the request I can get the name. It's the same function which we created in the beginning, and it's HTTP trigger. And then second is my orchestration. So my orchestration function, which is we just talked about, so which is the type of durable icon orchestration trigger. So this is a type of durable function, and inside this, so we have output, and then in the output I have added three activities which are simply calling three functions in parallel. So you see it is calling say hello, and these are calling in asynchronous. It is important to see you are adding await call activity async, and you are adding these three activities. So we called activity named my orchestration hello, this one, and then second one my orchestration hello, again the same activity, and third activity with the same, and then we return the output to this. So and then you see here I'm just passing some very values: Tokyo, Seattle, London, because this activity accepts an input which is string type. I could pass an object or anything. Later on, this is simple function app. Later on, you could also add a dependency injection where um, you don't have to pass things like this, but you will have a proper dependency injection with the startup class, which is a bit more in detail and deep with Azure functions. So it can be same as you have normal apps REST APIs in your in C Sharp with the dependency injections. Here you don't see that here yet, but you could achieve that. But that's a bit more in detail. I would like to do that in a separate video, not in the context of this certification. So let's continue here. Here you and then you see so this is hello, and there is another one which is my orchestration HTTP start, and it can be with the authorization level anonymous, and with the durable function starter. Okay, so then it is just printing the instance ID here and check status response. So let's go ahead and execute this function. So build this, and it will build it, and yeah, run it. so that there are a few errors, and no error, gone now. um, let's, because it is, okay. So you see here, we have launched our function app, and you have function one, which is simply calling the API, this one. And you have other my orchestrations. You have orchestration trigger and activity trigger. These two can be triggered with the orchestration. So below, this app is up and running and working. For your learning purpose, I would suggest you to go through it and look for it. You could also find latest examples in Azure samples. I would suggest you to do that, because this might be a bit old by the time you watch this video. I would suggest you to do your own research and do it yourself. It's nothing difficult. Um, it's not really that difficult. I think just get started. I would just ask you to get started. I hope you liked it, and let's continue.
Nitesh Sharma here, and in this module you will learn about custom handlers. By now you should already know that you can create Azure functions in several different languages, including C#, Java, JavaScript, Python, PowerShell, and many more. But what if you would like to create Azure functions using languages that's not currently supported, such as Rust or Go? So, or maybe you would like to use a runtime that isn't currently supported, such as Deno, which is an alternative JavaScript runtime. And this is where custom handlers comes in. Custom handler allow you to implement Azure function using your language or runtime of your choice. And of course, for the majority of situations, it still makes sense to build Azure functions using one of the built-in languages. So quite possibly you won't ever need to use custom handlers, but it is worth being aware that this option is available to you for those scenarios in which you do have a need to make use of different languages or runtime. In this diagram, we can see an overview of how custom handlers work. Just like with regular Azure functions, a trigger such as HTTP request or a message appearing on a queue is what causes the function to execute. And it's the Azure Functions host that receives this trigger along with any associated payload data. However, to execute your custom handler, it makes an ongoing HTTP request to web server that's running your custom handler code. Any data associated with the trigger or input bindings of your function is passed on to the custom handler via the request payload. And the custom handler can also return data to the function host in the response payload. If your function has an output binding, the function's host can use the response data from your custom handler and pass it on to the binding target. And this means that so long as your language of choice support running a basic web server to receive the requests from the function host, you can implement a custom handler in that language. So here you were triggered, if a call was triggered via any of the trigger, and then your function internally it calls a custom handler, and then with its request payload it returns a response, and then it prepares the output bindings. So same way, it's kind of in between. Let's continue. So let's discuss the main steps involved in creating custom handler. First, we need to create a new Azure function app, which I recommend to do using the Azure Functions core tool with the funcs in it command inside an empty folder, and when it prompts you for which language you want to use, you need to select custom. And this will add a section called custom handler in your host.json file. The second, you need to create an Azure function again. Again, the tooling can do this for you, and you can choose whatever trigger and type you like. For example, you might choose a HTTP trigger, and this will create a function.json file defining the triggers and bindings for your functions, and this is exactly the same as already you have regular functions. Third, you need to create the executable that implements the web server in your language of choice, and the official Azure Functions documentation helpfully provides a quick start example which shows you how you can do this in both other languages like Go or Rust. And because that's executable, which we don't want to talk about because that's what it can be, whatever, and all. And then you have which has handler or something, and yeah, that's it. Pretty straightforward. And in the function app. And finally, you should also be aware of the purpose of the extension bundles. These are needed to support the bindings and triggers that you use. And this in this section, which is host.js, JSON file defines the extension bundles that are available and gets auto-generated for you when you create your function app. So like this, you could get started with your creating the custom handler. So the first part is over, and I hope you enjoyed it. The first part we covered was web apps, creating web apps, creating virtual machines, creating containers, creating function apps. And now we are on the second part, which is develop for Azure storage. This section of the path covers the objective found in the Develop for Azure Storage section of the exam guide, including develop solutions that use Cosmos DB data storage, develop solutions that use blob storage. So we talk about the first part, which is creating Cosmos DB containers. Hello and welcome to the course Microsoft Azure Developer Developing Solutions with Azure Cosmos DB Storage. Now this course is designed to help you on your path to gain your AZ-204 certifications, and this is going to cover the concepts around Cosmos DB. Now, my name is Nitesh Sharma, and I'm your host of this channel. And yeah, so first of all, we are going to be selecting the appropriate API SDK for the solution, as well as we are going to be performing operations on data and Cosmos DB containers, and these two items will be covered here within this initial module of the course. And then we have set up appropriate consistency level for operations and implement partitioning schemas and partition keys, and these will be covered within the second module here within this course. And finally, with the third module, we will be managing change feed notification and reviewing that server-side execution that we have with Cosmos DB. So let's jump in. So there is a concept that we need to cover before we dive into working with the Cosmos DB, and that's understanding the concept of NoSQL database. So let's look at the things historically. For past many decades, we have seen the database space be dominated by one type of the database, and those are relational database. So think here, and that is SQL Server, MySQL, Postgres, and the like. Now these dominated the space. However, what we saw was as internet grew, And as we were creating more and more data, we now have the things like IoT sensors that are pumping out massive amount of data. We have social networks that are dealing with massive amounts of data. There were challenges in making relational database scale, so we saw the emergence of another type of database, and that would be NoSQL database. So no and these type of databases tended to be very well suited for working in a distributed manner in the cloud. So let's quickly look at some differences that exist between relational database uh, and NoSQL databases. First of all, when we are looking at the relational database, we have a fixed schema. That means we think about our schema ahead of time, and we actually comment we create that schema, and if we are going to change our schema, we would need to alter it and potentially have to do some type of data migration. So we also generally have table based structure. Now when we are talking about scalability, when we are looking at relational databases, we historically needed to do vertical scaling or potentially look at some manual sharing to get that scalability that we needed. And here is where we hit some limits. However, when working with relational databases, we had the normal ACID guarantee. So atomicity, consistency, isolation, and durability. This meant that we could make sure that whatever we were getting from the database was the latest and greatest. We had our state firmly cemented in the database, and then with that we also had data normalization. So we worked with in relational databases to make sure that our data didn't have to repeat itself. We didn't have to store data in multiple places. Now things totally shifted when we started looking at NoSQL databases. First of all, we now have a fluid schema, um, which is opposed to a fixed schema, which we know in advance. And um, we also now have multiple structures. So as opposed to just having a table based structure, we have key value stores, and we have graph databases, documents, stores, and wide column, really, which is two-dimensional. Key value store. So with this, these multiple structures have served specific needs. For example, we saw graph database really helping out things like product recommendations, engineers, engines, and social networking relationship mapping. And now we have here with NoSQL database the ability to have horizontal scaling as opposed to just vertical scaling. And we did this by having data partitioning and really having that baked into the platform as a whole. Now, but what we have here is opposed to ACID is we have base. So basically available, soft state, and eventual consistency. What this means is we have to account for the fact that the data is going to be distributed. That means that when we are performing an operation against our data, it is going to first commit to the specific node that we are working with, and then it will distribute out to all other nodes. This means that we have soft state that we don't know if what we are seeing is the most recent version or potentially just a version that is waiting to be updated. Now with NoSQL databases, we also have non-normalized data. So in many ways, with NoSQL databases, we don't optimize our data based on how it's stored, and to prevent repeating, we optimize our data based on how it's going to be read, and that is part of what enables it to scale to a level that we can't with traditional relational databases. Now, I should mention here both relational databases and NoSQL databases have changed dramatically over the past few years, and so some of the limitations that plagued each of them have been partially eliminated with some of these updates. But if we look at Microsoft recommendations, they say if your transactional volumes are reaching extreme levels, such as many thousands of transactions per second, you should consider a distributed NoSQL database. And this is what brings us to Cosmos DB. So now that we have got some background material in working with NoSQL databases, let's look at capabilities of Azure Cosmos DB. So Azure Cosmos DB is Microsoft globally distributed multi-model database service. And let's examine some of its highlight services. First of all, it provides extremely low latency. In this case, we are talking about single digit millisecond latency. It also provides an SLA for throughput, latency, availability, and consistency. So you can see because of that, this service has been built around optimizing each of these four elements so that they can stay within that SLA. Now it supports multi-region replication at any point. This means that even if you have already launched your database and you want to add this later, that is something that you can do. It does provide 5.9 of high availability for both reads and write. And one of the great things about it is it does enable elastic scalability. We don't have to make all of these decisions ahead of time, and we can let the database scale based on demand that it's receiving. Now the pricing is for the throughput that you provisioned. Now I have included an asterisk here because there is an new mode currently in preview. With the but the traditional approach in working with Cosmos DB is that you do select an amount of throughput. And that is what you are going to be paying for, and it supports multiple consistency options. So if you remember when we talked about ACID versus base in the previous clip, we are dealing here with something called consistency, meaning that in most NoSQL databases, especially the early ones, you had to deal with what was called eventual consistency, meaning that when you wrote something, it would need to then be distributed out to all of the other read nodes, and what you got back might or might not be the most recent version. But Cosmos DB has multiple approaches for consistency, and we will cover those later within this course. But for now you should just remember these fast 5 things about Cosmos DB. So pricing for the throughput you provision supports multiple consistency options, provides SLA for throughput, latency, availability, and consistency, supports multiple regions at any replication point, provides 5.9 of high availability for both reads and writes, enables elastic scalability. So just remember these things. Additional Cosmos DB features. Now let's look at some of these features that set apart. First of all, it has integrated analytics. So Spark is actually included in Cosmos DB. So you have the ability to run some low latency analytics against your data. Next, it has region support. So even every Azure region has their Cosmos DB. Next, it has schema agnostic. It also has automatic indexing baked in and supports multiple SDKs, which we are going to cover in the next slide. So it has integrated analytics, region support, it is schema agnostic, it has automatic indexing, supports multiple SDKs. Now look at the Cosmos DB and its organization of data. Now I know we haven't covered the different APIs yet. As mentioned, we are going to be covering that within the next clip, but here I'm just going to say that this organization holds true in working with SQL API, and we will cover this how this varies with other APIs in the next clip. So first of all, we start off by with the Cosmos DB. This is high level container that must be created first. You will select an API at the account level. In this case, I have chosen, let's say, SQL API. Now, within your Cosmos DB account, you are going to have a database. In this case, I have in this case, let's say we have an app that we are maintaining for our organization, and we need to store some data for it. We are going to then have database dedicated for the application, and then we might have another application that we also maintain, and we are choosing to separate those by having separate database. Within the databases, we are going to have container, and you can think of this in a similar way to tables within traditional relational databases. And you might have multiple containers within database, and then inside of those containers you are going to have items, and here you might even have another container within your other databases. So now we are going to move on to look at different APIs that supported within Cosmos DB. So one of the things that truly sets Cosmos DB apart is that it can act like multiple different types of databases. So when we look here at Cosmos DB, it supports 5 different APIs. The first API is SQL. It enables you to use SQL-like query syntax for querying your data. Then we have Cassandra, MongoDB, Gremlin, and Azure Table. So let's look at each of them and see why we might select those particular APIs. API. First of all, we have Cassandra, and this API makes sense if you are familiar with the Cassandra query language, SQL, for querying your data. Also, maybe your organization already has a lot of different tools they leverage that work with Cassandra. And one of the great things that about using Cassandra with Cosmos DB is all of these solutions will still work when you are using Cosmos DB. In most cases, you will simply need to change your connection string. Now, if you already have existing Cassandra database that you want to migrate to cloud, this becomes another great API to choose. Now Now you also might want to store data in the wide column format, which again is the two-dimensional key value store. Now in reality, it's going to be stored a little bit differently in Cosmos DB. But if you are used to working in this format, when you are working with API, it will appear just like you are working with data stored in way that Cassandra would store it. So, and the next is Azure Table API. Now, also we have the Azure Table API. Now, the Azure Table Storage is part of Azure Storage, and so you have experience in using Azure Table Storage. This can be a great way to simply leverage Cosmos DB and some of the additional capabilities. Now, I should mention here, there are some differences between Azure Table Storage and Cosmos DB's Azure Table API. Be sure to read the documentation to understand how these differences could affect your application. Now, if you have existing application in that the data that you want to migrate from Azure Table Storage, this can be a great solution. And also, if you're familiar with querying data using OData and link, this becomes a great choice because it supports link and OData. SQL API. Then you have we have the SQL API, and this in reality is the core API, and in this in reality is the core API. And if you want to leverage SQL like language to query your data, this is great choice. It's also going to be storing data as JSON document, and truthfully, if no other use case fit, or if choose the SQL API. Now, when we looked at our previous examples, choose the SQL API. Now, when we looked at our previous examples, where we showcase the different entities within Cosmos DB. So going from account to a database to container to an item, the database entity is different depending on the API you're choosing. So as we mentioned, the SQL API has a database. This is key space this entity, but in Cassandra, this is key space with MongoDB. This is also database. And is Azure Table, this is as it is with Gremlin. Now, and with Azure Table, this isn't the reason I have applicable. Now, truthfully, and the reason I have so when we are working with SQL, this is a container. When we are working with SQL, this is a container. But when we are working with Cassandra, this is a table. When you are working with MongoDB, this represents a graph collection. When we are working with Gremlin, this represents a graph. To no surprise, and we are working with the Azure Table probably. To no surprise, this remember the differences. So, to just summarize, remember the differences. To summarize everything, when we are working with Gremlin, this represents a graph. When we are working with Gremlin, this represents a graph. When we are working with Azure Table, it represents a collection. When we are working with MongoDB, it represents a collection. When we are working with Cassandra, when we are working with SQL, this container, this is a container. And when we are working with SQL, this container, this is a container, but this represents a container. So I hope it is clear. This represents a container. So I hope it is clear. Let's continue. So now we are actually going to go through the process of creating a Cosmos DB container. Now we are going to be doing this within the portal. However, I quickly wanted to review how you would like to do the exact same thing utilizing the CLI, and these commands are beneficial to know before you take your Azure AZ-204 exam. First of all, the first step is creating an account with the Cosmos DB, and in this case you need to select the API when you are creating your
Okay, when I am in my Azure portal, and you see when I try to create Azure Cosmos DB, it gives me options with multiple APIs, right? I will show you again. So I'm here, I selected Azure Cosmos DB, which is still in preview here, and but when I try to click on create, it asks me what do you want to create, which API which suits you best. And with that, Cosmos DB is fully managed NoSQL database service for building a scalable high performance application. You see here I have option Core SQL, Azure Cosmos DB API for MongoDB, Cassandra, Azure Table, and Graph, Gremlin. So Gremlin, Azure Table, Cassandra, and Azure Cosmos DB API for MongoDB, and then you have Azure SQL Core. So let's say, and it is the recommended one as well. So I will just go and create with this one, and now I am creating Azure Cosmos DB account for Core SQL. Okay, and then I need to select the resource group as all of them as all the resources needed to be reside in a resource group, of course. And then I need to select an account name. Let's say AZ-204, and name is not available. It should be unique. So tag of the day, it must be unique. I don't think anyone else is existing with this name. Um, and then I will select the location North Europe. And then we talked about the throughput, and here you see it is asking for capacity. Choose the capacity mode for your database operations. Do you want to go with provisioned throughput, or do you want to go with serverless? If I select serverless, it doesn't ask me for other options, but if I select provisioned throughput, then it asks me with Cosmos DB free tier, you will get first 1000 RUs and 25 GB of storage for free in an account. You can enable free tier for tier on up to one account per subscription. Estimated $64 per month discount per account. So apply free tier discount or limit total account throughput. So in case when you have provision throughput, it will ask you for this part. And if you go with the serverless, yeah, you don't have to answer these things. Then we go with, I will go with the serverless, and then we go with the global distribution. Configure global distribution and regional settings for your account. You can also change the settings after the account is created. So if you want it with the availability zone or not, I will enable an availability zone, because that's the advantage of having Cosmos DB, right? Well, or you can disable as well. I will enable. Then we go to networking, and if I want to work with the VNet, and yeah, then I can have private endpoints, VNets, or I will say all networks. Then I will go with the backup policy. It is asking me if I want periodic backup or continuous backup. Continuous backup is doing the backup all the time. We can read it here. It says continuous backup with point in time restore in Azure Cosmos DB. It's almost real time. So if you see recovering from an accidental write or delete operation within a container, restoring a deleted account, database, or container, restoring into any region where backups existed at the restore point in time. So it will do the continuous backup. Then I go to the encryption. Azure DB encryption protects your data at rest. Pay attention here, because you might have questions in your exam. Azure Cosmos DB encryption protects your data at rest by seamlessly encrypting your data as it's written in our data centers and automatically decrypting it for you as you access it. So by default, data encryption is there. But there are things you can either leave it to Microsoft and they use their server managed key to encrypt and decrypt it. You can also have your own key with the link to your key vault where you store the key, and that key will be used for encryption decryption. All right. This way, Microsoft is handling the encryption, and here you are doing the part of the job, and Microsoft will be doing the part of the job. Next is, then if you want to add any tag, and then next I can just review and create. So by now validation successful, and I have the template. I can just go and create the Cosmos DB, and meanwhile I'm enjoying my tea. It's too difficult to keep speaking all the time, and then your mouth is like somebody took out all the water from your mouth, and when you are speaking it feels like, yeah, really bad sound. Anyway, let's continue. Yeah, it will take some time because it is going to create Cosmos DB with global distribution and all those resources I selected. So let's pause the video for now and resume in a while. All right, the deployment is successful, and we now have a Azure Cosmos DB account. Okay, so till now, to understand it clearly, we only have an account. We don't have anything else yet. Congratulations, your Azure Cosmos DB account was created. Then it gives me options in the kickstart: add a container, download and run your .NET app. Very easy, right? Very easy to get started. Let's do the same way, because this is how you can continue learning it, and you can reproduce the same thing. So I will say create items, container, and it will take some time. And if I go to what it is doing, actually I will explain it here for concepts purpose. Um Here you have containers. Let me find them. Where are they? Up, 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 up. Okay, if I go to overview, and if I see here, it says looks like you don't have any containers yet. And if I go to Data Explorer, before going to the Data Explorer, by default the location I left West US. Okay, anyway, it was not letting me create other resources in other regions, but now it let me. So, somehow I didn't understand. Anyway, let's go to Data Explorer. In the Data Explorer, you see it has created in the SQL API, which was our API before while we were creating the Azure Cosmos DB account. And in the API itself, you see it has created data and to-do list, which is welcome to the Cosmos DB, globally distributed. And you see here you have new container options, blah blah, other options as well. So it is just it's very slow and I don't like it. Anyway, you can also create a new container, you can create new database. So if I click on new container, yeah, it opened by that time. So here you have create new container. You currently has at least one database or container with provision. The RU billing will apply to this container if the RU in total account exceeds more than this. So this is just a warning. Then you create database ID. You say something test 204. Same share throughput across containers, auto scale. Your account is currently configured with a total throughput limit of 1000 RU, so I will say 100, doesn't matter, 10% of the maximum. Then container ID, so it's important to differentiate, and I will say container, let's say container 2 just for and I'm just letting the indexing automatic partition keys /id. We will learn about these things in a while. what is partition key, and then you can also add unique key. If you go in advanced, you just have my partition key is less than 100 bytes. Anyway, you go okay. Max RU throughput must be more than, doesn't matter, let's continue. Okay, it is giving me warning because I already have. Anyway, with this type of tier you cannot, with this type of subscription you cannot do a lot of things anyway. But anyway, this is how you create a new container. And then once you are done, you created a container, you are having something like this. Sorry, I don't want to go in the query explorer, I want to go data explorer. So here in the data explorer, it's so slow, as I just want to, maybe I'm not patient, I don't have patience. But in meanwhile, if you see here, it gives a lot of possibilities. So we were talking about integration with Power BI, Azure Synapse, add Azure Cognitive Services, search, add, you can add Azure function, of course. Then you can have in the containers part, you can browse container, scale, document explorer, query explorer, script explorer. In the monitoring, you have all the monitoring. This is normal, except webhooks. It is not in all the resources. Automation, you have the same thing in other resources as well. But the interesting part is you have these integrations which are from Power BI, Azure Synapse, and Cognitive Search, and Azure Function as well. So this is really interesting. This is taking too long. Alright, I am in the SQL API in the Data Explorer part, you see, as you can see here. And I just went through the to-do list database which it created in the items, and in the items you have other things like items, scale and settings, blah blah blah. Anyway, you can just go through it, and I think you will like it. And here you see interesting thing is launch quick start, new container, you can create new container, and connect. If you go to connect, you see here read write keys, and these keys I will anyway delete the Cosmos DB, so it doesn't matter if you copy or if you use this key. Yeah, so these are the keys you can use as connection string from your project itself, and then it will be fun working with Cosmos DB. And then what interesting thing I just shown you in the beginning, that once I create items, it's done. And then you can continue with the .NET app. So let's continue.
I just shown you how to create Cosmos DB
I
account
just shown you
using
how to
Azure
create
Portal,
Cosmos
and
DB
now let's see how to
account
create a
using
Cosmos
Azure
DB
Portal,
container
and
using
now let's see how
Azure
to create
CLI.
Cosmos
Okay,
DB container
so
using
here we are first
Azure
what we are
CLI.
creating, create
Okay,
SQL
so
API
here
Cosmos DB
we are first
account,
what we are
and
creating,
it's
create
very simple.
SQL
Azure
API
Cosmos
Cosmos DB
DB,
account,
which is
and
Azure
it's very
CLI command
simple.
for
Azure
Cosmos DB.
Cosmos DB,
Then we
which
say
is
verb
Azure CLI
create,
command for
and the name
Cosmos
of
DB.
the
Then we say
account
verb
in
create,
the resource
and the
scope
name of
this
the
one. Then I
account
say create
in the
SQL
resource scope
database
this
in the
one.
Cosmos
Then I
DB.
say
So
create
Azure
SQL
Cosmos
database
DB
in the
SQL
Cosmos
database
DB. So
create
Azure Cosmos
with
DB SQL
account name
database
is this one, tag
create
of the day,
with
and name of the
account name
DB
is
is
this one, tag of
sample
the day,
DB.
and
And
name of
then
the
I'm
DB
just
is
saying Azure
sample
Cosmos
DB.
DB SQL
And
container
then I'm
create,
just saying
resource
Azure
scope is
Cosmos
this
DB
one,
SQL container
account name is
create,
this one,
resource
database
scope
name
is
is
this
this
one,
one which we just
account name
created,
is this
and
one,
the name of the
database name is
container
this
is
one which we just created,
sample
and the
container,
name of the
and
container
then the
is
partition key path is
sample
employee ID.
container, and then
Very
the
simple, right?
partition key path
Very
is
simple.
employee
So
ID. This
Very
part
simple,
we
right?
have already
Very,
done.
very simple.
This
So
part I just
this
shown you
part we have already
in the
done.
portal
This
itself.
part I
But
just shown
I
you
would I would
in
really
the
want
portal
you to
itself.
do that
But
at your
I would really
at
want
your
you to
point,
do that
because it is really
at your point.
easy, as I shown you
At
that
your
in the
point,
portal
because
itself you
it
can
is
just
really
click on the
easy, as I shown you that in the
as
portal itself you can just click
CLI
on the
and then run
um,
these commands
as
there.
CLI and
You
then
can
run
easily
these commands
find
there.
these commands.
Um, you can easily
I will not be
find
putting
these
them in a
commands.
GitHub repository because I
Um,
don't think
I will
it's
not be putting them in a
that
GitHub
important. But
repository because I
if
don't
you
think
guys
it's
comment and
that
say we
important.
really
But
need them, then I
if
will
you
be
guys
putting them in the
comment
GitHub
and say
repository as
we
well.
really need them, then I will be putting
But
them in the GitHub
for now,
repository as
I will
well.
just keep them like this. So
But
if you need
for
them,
now,
you can just
I will
ask me
just
in the
keep them
comments and
like
I
this.
will put
So
these
if you
commands
need
in
them,
the
you can just ask
GitHub
me in the
repository
comments
where you
and I
can
will
just
put
go and
these commands
use
in the
them.
GitHub
Let's
repository where you
continue.
can just go and
So
use them. Let's continue. So now, the last thing we need to cover in this module is knowing how to select the proper SDK for your Cosmos DB project. So there are a few things that you need to consider. First of all, if you are using SQL API, which again is the core API for Cosmos DB, you should utilize the latest Cosmos DB SDK for your platform. Microsoft has provided those SDKs across a wide array of platforms, and you can get the latest information on those, including different versions and what type supported and which within each version of documentation. So when you are using MongoDB, Cassandra, Gremlin, you should utilize the current SDKs for those APIs. So as you mentioned, mentioned previously, you can use the current MongoDB, Cassandra, Gremlin tools to interact with your Cosmos DB databases. But if you are using Azure Table API, you can also leverage the current table storage SDK to interact with your Cosmos DB Azure Table database. But note, as mentioned earlier, there are some differences between Azure Table Storage and using Cosmos DB's Table Storage API. So make sure that you understand the impact of those. And let's continue. Throughput and scaling. As we all have already seen, and while I was creating Cosmos DB on Azure portal, you saw that there was an option to select throughput scaling. So now that we have reviewed and different APIs that are supported by Cosmos DB and how we can interact with Cosmos DB, now we are going to look at Cosmos DB in real world by talking about concepts that affect performance, and we are going to start off by looking at concept of throughput. You and how you are charged for using Cosmos DB. First, let's look at traditional databases and how we could scale it once demand grew. One of the approaches that we could take is vertical scaling, which we talked in previous slides already, that for the traditional, we could just vertically scale it, and where we could simply add more resources, CPU, memory, even better drives, where the data could be added to the server to help it handle more demand. Or we could take horizontal scaling approach, meaning we are adding more servers to the mix. And if we are looking at traditional databases, this is where we would start to look at concept like read replicas, where we would be able to spread out the demand across multiple servers. But Cosmos DB doesn't work this way. We don't manage the underlying infrastructure. It is managed service. So with Cosmos DB, when we are talking about scaling, we are going to talk about this concept of a request unit, RU, which you will commonly see as abbreviated as RU. Now a request unit within Cosmos DB takes all of these things that we looked at with vertical scaling, and it consolidates it into a single unit. So we want to scale any of those resources, we would simply increase the request unit for our database. So we simply increase the RU request unit for our database. Let's continue. Resources. Now, as a baseline, one RU is equal to 1 KB item read operation from a Cosmos DB container. So if you need to read more data than that, maybe the items in the database for you that you are fetching are going to be much larger than 1 KB. And if that's the case for you, that means you are going to need more requests RU for a single read operation. Now, as I mentioned, this encapsulates several different resources for the server that are running your database, and this includes your processing power as well as the memory and the IOPS or input output operations per second for your database. Now there are some different approaches to managing your requests units, which we will call the throughput for your Cosmos DB. So I hope this concept of RU is clear, and how these are calculated, how these are determined, and how this affects your input output operations, IOPS, processing unit, memory, IOPS, and throughput. Then the first approach that we have is provisioned throughput. That means that you set a specific amount of throughput that is needed. There is also a new approach that is currently in preview called serverless, and that is not anymore preview now by the time I am doing this video. But let's look first provision throughput. Now, provision throughput is ideal for an always on production. We saw this while we were creating Azure Cosmos DB account, that we had option for provisioned, and this means that your throughput is idle for provision throughput is idle for always on production implementations. And if you are doing a production application, you probably need to go ahead and go with this approach. Now you can configure provision throughput at either the database or the container level, and later with this later we will talk about best practices. We'll cover which way you should do this. There is a best scenario you can follow. Now throughput is evenly distributed to partitions, and later within this module we will talk about your partition key strategy and why this matters so much. Now another thing about your provision throughput, there is limit to the amount of RUs you have to have related to the amount of storage you have. So you do need to have at least 10 request unit per gigabyte of storage. You couldn't have, for example, one request unit and then have 20 giga of storage. So there are some limitations you need to work with. But once we see that our request unit are consumed for a partition, future requests will be rate limited, because we saw this while we were creating our container, and you saw that I couldn't create another container because my RUs were gone, because those were used by the previous container I created. Next, provision throughput. That means we can make a request, it will not complete and will not let us know in the response that we don't have any more resources available at the point in time. So this brings up an important question: how do we handle scaling? Well, by default, if you are doing provisioned throughput, it requires a manual scaling approach to get more RU. So you could have something trigger an alert when you start getting rate limit, and you could increase the RU. But this is really manual approach, and there is another approach that is quite bit better, and that approach is called auto scaling. Now this is auto scaling for provisioned throughput. So with this approach you can specify a maximum RU throughput amount, and Cosmos DB will take the work of going through and making sure that it has the correct amount of provision based on the demand that you are seeing. But it's important to know here that the minimum throughput is going to be 10% of the maximum. So if you specify 1500 RUs as your maximum and you are leveraging provision throughput with auto scaling, that means the lowest it will ever be going to be is 150 RU. And while this is probably fine for the production application, if you are doing development workloads, this might seem a bit cumbersome because there is going to be times when it is not used at all. And this helps to highlight one of the benefits that we have with Cosmos DB serverless. So with this approach, you pay only for the request unit that you consume and the storage that you use. Now, this makes this ideal for on and off workloads, especially development workloads where maybe you spend a couple of hours in a day working on something, and maybe at that point in time you need 600 RUs, but then you are not going to touch it again for 2 days, in which case you would rather not pay for that period of time. Now, Cosmos DB serverless is currently in serving that problem. For example, there is a maximum of 5000 request unit and it does require a new account type. So you have to actually create an account that supports this serverless model, and currently it only supports the SQL, which is the core API. But in case when you need to decide Cosmos DBs that you don't want to pay for the time you're not using it, then yeah, serverless might be a good option. So let's talk about the best practices when looking at the throughput. First, you need to use partition strategy to evenly spread throughput on partitions, and we will talk more about that later within this module. Also, we want to provision throughput at container for predictable performance. So you can actually put your throughput and provision it at the database level. But that is going to spread it out across the different containers, and that's going to mean you don't always have a predictable amount of throughput available for a specific container. So because of this, it is best for you to go through and actually provision that throughput at the container level. Next, you can use a serverless account type for your development workloads, but as mentioned, right now this is limited only to SQL API. Maybe in few days it will have other APIs as well. Next, you need to understand the link between consistency types and the amount of request units that are consumed. And since we haven't fully covered consistency types yet, that's what we are going to learn in the next slide. So next we are going to discuss the concept of data consistency levels on Cosmos DB. And this is one of the biggest changes that developers will have to get used to when working with the platform. So Microsoft says that distributed databases that rely on replication for high availability, low latency, or both must make a fundamental trade-off between the read consistency, availability, latency, and the throughput. So to know more about this, this is what from the Microsoft Cosmos DB documentation. Then now we are going to talk here especially about the read consistency, and what we mean here is when we make a write operation to the database, what value do we get back if we immediately try to read that value, right? So now let's look at this way and explain it in terms of consistency level spectrum. So over on the far left, we have the concept of eventual consistency. So since we are talking here about read consistency, let's say that we have an employee database, and let's say that I am in North America and go through the update one of the employees email address. Well, immediately after I write that to the database, let's say somebody over in Asia queries for that value. What value are they going to see? Well, when we are dealing with the eventual consistency, what would happen is I would write to the node I'm connected to in North America, and if somebody immediately query from Asia, chances are that the value hasn't made it all the way there yet. So they are going to see the previous value for the email address, but over the time that data will get replicated out to all the different nodes and replica sets, and eventually things will be consistent, hence the term eventual consistency. But there are other options that Cosmos DB prevent us with, options that really weren't available in the first generation of NoSQL databases. So we have, in addition to eventual consistency, we have consistent prefix. We also have session bounded stateless, and now we are going to talk about each of these and explain what these provide. But first, this is a spectrum, and that means that the position of items here from left to right matters. So here in this case, when we are looking on the far left, we have eventual consistency. One of the benefits that we get is extremely low latency. So if we make a write or if we have a read, we are going to get data back very quickly. But on the far right, if we want to have strong consistency, and we will talk about more what that means in just a minute, we are going to have higher latency. On the left, we are going to be able to have higher throughput with our databases, and on the right, we are going to have lower throughput. Also on the left, we will have the higher availability, but on the right, we will have lower availability. And initially it sounds like, well, of course we want low latency and high throughput and high availability, so we will just choose eventual consistency. But in doing so, you are going to have to deal with the fact that the data that you are reading might not be the most recent version of the data within the database. So let's begin to look at the different consistency levels and understand what they provide. So first, we have a strong consistency, and this is what we would expect when we are working with traditional databases. And this guarantees that the reads are going to get the most recent version of an item, and this one is pretty easy to understand. But if we go from this side to this side, then we have some trade-offs. So let's continue and look at the consistency.
Next, we have bounded stillness. Next,
And what
we
this
have
means is
bounded stillness.
you are not guaranteeing
And
that
what
you are
this
going
means
to get
is
the most recent version.
you are
but
not
we
guaranteeing
also
that you are going to get the most recent version,
fairly
but we
recent
are
version,
also
either in
guaranteeing
terms of
that we
number
are
of
going to get a
versions
fairly recent
or an
version,
amount
either
of
in
time
terms of
that
number of
that's elapsed.
versions
This
or
way there
an
is
amount of
bound
time
to the
that's
staleness of
elapsed.
the data.
This way
Hence
there
the
is
name
bound
bounded
to the
staleness.
staleness
Next
of
we
the
have
data, hence
session
the name bounded staleness.
consistency.
Next we have
And with session consistency, what you can make sure of is
and with session
that you
consistency,
have
what
a
you can
session
make
with
sure of
Cosmos
is
DB, and the
that
client
you have a
has to work
session
with
with
Cosmos DB to
DB,
put
and the
some type
client
of session
has to
identifier.
work with Cosmos DB to
But
put
that's
some
handled
type
in
of
the most
session
cases by
identifier.
SDK for you. but this handled in the most cases by SDK for you. But this says some consistency you are going to guarantee that the client session will read it its own rights. This way, you don't have the problem that can sometimes happen with NoSQL databases, where as a client you can go out and query the database and you are going to get back different data than the data you just wrote. Now, next we have consistent prefix consistency, and this deals with a very special scenario. And this deals with a very special scenario. And that scenario is when you need to be sure that the updates are going to be read in order. So if order matters, then you need to look at consistent prefix consistency or strong consistency. For example, and then we have the one that we have already discussed, and then we have eventual consistency, have the one that we have already discussed, which is eventual consistency, which provides no guarantee for, and you are not sure that you are even for the order of data, and you are not sure that you are even going to be able to read your clear rights. And the difference from going so I hope it is clear, and the difference from going from here to here. Let's continue. And now next let's talk about how consistency levels work if you are using the SQL API Cosmos for Cosmos DB. So there is really two ways that you can interact with the different consistency levels. First, you can set an account default. So at the account level within Cosmos DB, you can set a consistency level, and then every operation will follow that consistency level unless you specify a different consistency level when you are making a request. And the SQL API has this support, so you can choose to override that default if you need it for a specific operation. But let's talk for a minute about the other APIs that are supported by Cosmos DB. So first, for Gremlin and for Azure Table, Cosmos DB is going to use that account default consistency level. So whatever you have set it at, it's going to use that level for both reads and writes. Now for Cassandra writes, it will also use the account default consistency level, but for reads, it will map the client consistency to a Cosmos DB level. Now that's based on a predefined mapping that has been defined by Microsoft, and you can look in the documentation to see what that mapping is. Now for MongoDB, the written concern is going to use the count default consistency level, but just like with Cassandra, we are going to see the read concern is going to use mapping to specific Cosmos DB consistency level. And that also in documentation if you want more information. Now, there is one really big consideration that you need to understand when we are considering throughput and the different consistency levels. If we are looking at both strong and bounded stillness, the reads are going to consume twice the normal amount of request units for a request, because Cosmos DB is going to have query two different replicas to meet the criteria of consistency level. So if you are using those specific consistency levels, you need to understand how that will affect the throughput of your container. So I hope this is clear for each API, the different type of consistency levels, default consistency levels for read and writes, the differences and why they are different. Let's continue with partitioning data in Cosmos DB. That we are going to cover is to do how we partition our data within Cosmos DB. So first of all, let's just get some high level understanding of concept that we need to understand before we can fully understand how partitions work on Cosmos DB. And don't worry, we will take time defining each of these. So the first concept is logical partition. And in addition to that, we also have the concept of physical partition. We have then the concept that we have briefly covered, and that is the concept of partition key. And then we have a concept called replica set. Let's continue. So let's start off by looking here at the logical partition. So a logical partition is a set of items within a container that share the same partition key. Now we can have as many as logical partition as we need, but each partition is going to be limited to 20 gigabytes of storage. But these logical partitions are managed by Cosmos DB. So however, how we use them is going to be governed by our partition key. I hope it's clear, but it's very important information here. So a logical partner is a set of items within a container that share the same partition key. This is the key to understand. And now let's talk about physical partition. So here the Microsoft says that container is scaled by distributing data and throughput across physical partitions. Now internally, one or more logical partitions are going to be mapped to a single physical partitions. Now they are entirely managed by Azure Cosmos DB. So physical partition includes logical partitions. Then let's continue to the replica set. Now the next concept that we have here is the concept of a replica set. So physical partition is going to contain multiple replicas of data, which is known as replica set. Now by having this data replicated, we are going to be able to have durable data and fault tolerant data. And these replica sets are also managed by Cosmos DB. So we are talking here about a lot of things that are managed by Cosmos DB. But what do you manage? Let's see. Well, you manage the partition key and the strategy around how you manage the partition key and the strategy around how you use the partition key. So a partition key serves your request as to the correct partition. The means of routing your request to the correct partition. This is how NoSQL databases work. In essence, this is how NoSQL databases work. A request should be routed. A partition key will determine where a request should be routed to get the right data, and it's going to be made up in this case of partition key. So let's say, for example, that you have defined partition items in e-commerce. So let's say, for example, that you have a product items in e-commerce database, and key which you have a product ID, and then you have the value which is key which is whatever the value is, and then you have the value which is whatever the value is for the specific product, and now it should those things together make does not change partition key. Now it should be a value that does not change for the item here, so that you shouldn't go choose back and actually value update. Here that you also should have go back and actually values that it also should have many different values that is absolutely are represented within the container, and this is absolutely critical because this is going to determine how things are routed. Now at high level, I also want to give you that you have how you now at high level. I also want to give you information how you this is how this partition key is used. Documentation. So this is Azure this also comes from the documentation. So the Azure Cosmos DB uses high. So the Azure hash-based but no. Uses so the Azure Cosmos DB hash-based partitioning to spread logical partitions. Hash-based partitioning to spread logical partitions across. I will repeat it again. So Azure Cosmos DB uses. I will repeat it again. So Azure Cosmos DB uses hash-based partitioning to spread logical partitions across physical partitions. Cosmos DB hashes the partition key. Now Azure Cosmos DB hashes the partition key value of an item, and then going to allocate the key space of the partition key hashes evenly across the physical partitions. Basically, Now that might seem really confusing, but basically you just need to understand that it's going to take a hash of that value and then use that value, and you are going to have a specific address space that's mapped to that value, and that will determine how it gets to the correct partition. Now, with that being said, that we need to keep in mind. There is some strategy considerations that we need to keep in mind. First of all, throughput is distributed evenly across all of your physical partitions. And this is huge. You need to understand this is because, let's say, for example, for one reason or another, our partition key has us storing 95% of our time in a single partition, and then the other 5% gets stored in another partition. Well, let's say we have allocated 20,000 request units for our database. Well, in this case, each partition is going to get 10,000 request units, even though 95% of requests are going to be to one partition. That's going to mean that we are going to be limited to 10,000 request units. That means we are going to have to pay for that, and we want to actually scale it up. We are going to have to scale it well beyond 20,000 if we wanted to be able to have access to more. That means there is a bunch of request units we are not using, but we are still having to pay for. This concept is called hard partition, and our partition key strategy should be designed in such a way that we minimize this. So next, if you need multi-item transactions, you are going to need to look at triggers or stored procedures, and we are going to be covering both of those concepts within next module. So next we are going to want minimize cross-partition queries for heavier workloads. So if you are either in a scenario where you are dealing with large amount of storage, or you need large amount of throughputs, you will probably need to put even more thought into your partition key strategy to make sure that it's going to meet the demands that you have. And you really need to decide on your initial partition key strategy before you create any container. Let's look at the sample scenario. Let's say here that we have an employee database, several values. Here we have that are associated with our employee. Now you might look at that are associated with our employee now, and you think you might look at this we could use something like email address for our partition key, because we could use something like email address for our partition key, because we are going to have a lot of different values. We are not going to have the same value for two different individuals, and that actually might seem like a great idea, but here is the problem: this value can't change. So in this case, an email is not a great choice, because for one or another reason in this case, need to change an employee's email address. So in this case, that's not a great fit for a partition key. Now, next we could say, well, we could use office identifier. That way, we could spread out our employees to different partitions by using the office identifier. We have two offices, and one of them is company. We have two offices, and one of them is here in the United States, identifier US, Europe, and we have this identifier US and one blah blah, and the other say, let's say, that has 90% of employees, and well, if other 10% are in Asia. Well, if that's the case, we are going to use this office identifier as partition key, and we are going to run into the same problem that mentioned earlier. We are going to have a hot partition, and we are not going to be able to spread the traffic out evenly. So we are going to have acquire a higher number of request units simply to satisfy the demand, and we have next something like department, but yet we could also look next something like department, but yet again we need to be sure that this value doesn't change, and it is possible for an employee to change departments. We are going to have also, we can't be sure that we are going to have things
we
spread
do
out
run
relatively
the risk
even.
here if
So
we
we do not
had, let's
we
say,
do run
huge development
the risk here if we
department or
had,
huge
let's say,
marketing department,
huge development
that we might run into a
department or
scenario
huge
where we
marketing
could have
department
hot partition.
that we
But
might
if
run
we
into
look
a scenario
at a
where we
value
could
like
have
employee
hot
ID,
partition.
this
But
becomes an
if we
ideal
look
choice.
at
Number
a
one,
value
because
like
we
employee
won't need to
ID, this
change it.
becomes an
We are
ideal
also
choice.
going to
Number
have a
one, because
wide
we won't
variety
need
in
to
the
change it.
IDs
We are
that are
also going to
chosen.
have a
It's going
wide
to
variety in
enable
the
to
IDs
give that
that are
proper key
chosen.
space
It's
by
going to
hashing the
enable
values
to give
to
that
several
proper
different
key
partitions.
space by hashing the
Now,
values
Cosmos DB will
to
handle
several
splitting
different
of
partitions.
partitions to
Now, Cosmos
manage
DB will
that, but you
handle
need
splitting of
to be
partitions
sure
to
that there is enough
manage
difference
that,
in the
but you
values
need to be
so you
sure
don't
that
end
there
up
is enough
with a hot
difference in the
partition.
values so you don't end up with a hot partition. So next we are going to talk about the server side aspect of interacting with Cosmos DB, and here Cosmos DB does provide a robust approach for you for how you can execute code in response to actions taken on the data stored within Cosmos DB. Now, in some cases, these terms we use like stored procedures, triggers, these are going to mirror traditional database constructs, but you need to know that they are fundamentally different in how they are implemented and they do have some unique limitations. So what we are talking about here when we are talking about server side concept? Well, here we are really talking about four different things. First of all, we have stored procedures, we have triggers, we have user defined functions, UDFs, and we have change feed. Now these are three happen in now these three happen internal to database engine, and then we have another one which is change feed, and this execution happens external to the database engine. So server side execution. So let's talk first about server side execution environment. So as mentioned, stored procedures, triggers, and UDFs are executed within the database engine. Now, as of time this publication, these are supported when you are using SQL API, but not supported with other. Maybe within few months or days it will be supporting, so please check it before saying that. Now this server-side execution environment supports JavaScript, so no matter what language you are using to work with, no matter what language you are using to interact with Cosmos DB, if you are writing a stored procedure triggers or UDF, it will need to be written in JavaScript, and it can be created and managed via portal and via SDK. Now, at each of these in turn. So first let's look at stored procedures. So as mentioned, a stored procedure must be defined in JavaScript. Now here is one of the things you need to know, understand. It executes on a single logical partition and it only has access to that partition. Now what this means is you cannot create a stored procedure that interacts with items that span multiple logical partitions. So if they don't have the same partition key, you can't interact with them, and if you try, it will actually throw an error. And you must provide the partition key with your request to execute. That means you need to know the partition key of the item that you are working with before you execute your stored procedure. So you couldn't use, for example, your stored procedure to auto generate a partition key value. In this case, you have to know it ahead of the time, and the reason is because this is how Cosmos DB is going to know which logical partition it needs to call on to execute this stored procedure. Now it does support as transaction model because If something fails in your stored procedure, all of the changes will be rolled back. However, remember what I mentioned earlier, all of the items have to have the same partition key. Then next, let's talk about triggers. So triggers also must be defined within JavaScript, and they can be either executing before, which is a pre-trigger, or after, which would be a post-trigger. The data is returned to the database, so you can use pre-triggers to handle things like data transformation and validation, and you can use post triggers to handle things like aggregation and change notifications. Now with this, it is important to remember this also execute on a single logical partition, so some of those limitations still do occur. Now triggers are not guaranteed to execute as they have to be specified in a request. Now most people that are used to working with traditional databases bark at this statement. It seems too strange to them because they are used to triggers being guaranteed to execute. But in this case, when you are working with Cosmos DB, let's say you are creating a new item, you need to pass in an array of the trigger that you wanted to execute. Now errors in either the pre or post trigger will cause the data that was inserted into the database to be rolled back. So if in a pre-trigger, it just won't ever get inserted into the database, but if it's in a post trigger, then it would cause the data to be rolled back. Then user defined functions. So next, we have user defined functions, and just like the others, this needs to be defined in JavaScript. And it enables you to define a custom function that can be leveraged within a query, and you can use this to encapsulate some common logic that you have in query conditions. So change feed processing, now as mentioned, all other server-side approaches enable execution on the Cosmos DB engine. However, with change feed processing, you can react to data changes using server-side code outside of the Cosmos DB engine. So let's talk about the change feed. First, it enables you to be able to notify for any insert or update actions taken on your data. And what that means is that deletes are not directly supported, but you can leverage a soft delete flag. So what this means is you could have a field, for example, within your data that says is deleted, and you could set that to be true. When you set that to be true, that's when then going to be an update to the data, and that could enable you to then receive a change feed notification. Now the other side of this is you would set a TTL, time to live, or time to life on your data to be really low value. So you would go get the change notification that the delete flag was changed true, and then the item would delete itself. So there is a way you can still support deletes. Now a change will appear exactly once in the change feed and reading data from the database. So the actions taken to get the data out of your database to be put into the change feed, that will consume your throughput. So you do need to understand the impact of using change feed for your provisioned throughput. Now partition updates will be in order, but between partitions there is no guarantee. So if you are working within a single partition, you will get those things back in the order that they were executed in. But if you are using mixed partitions, again there is no predicting the exact order that will be. Now change feed is not supported for Azure Table API, but is supported for the other APIs for majority of the SDKs. You do need to review the documentation before you start on a project to be sure to understand which SDKs are supported. The first approach and the easiest approach is use Azure functions. You can simply set up a trigger to be tied to Cosmos DB, and we will do that later within this module. The other approach is change feed processor that is supported on some of the SDKs, and this enables you to run this on whatever infrastructure you want, but it's going to handle the heavy lifting here of going through the making sure that it manages the checkpoint of your interaction with Cosmos DB, so that you can make sure you are not losing any data in process. And while I mentioned that there are really two different approaches, really these are the same approaches, except the Azure function, it's got change feed processor built in, and you don't have to manage provisioning the of workers to go out and deal with the changes in that role. So now we are going to move forward and actually use change feed processing notification with Azure functions. So here within this demo, we are going to do a few things. First of all, we will be creating Azure function app for use with change feed notification, and we will then be creating a function utilizing the change feed, utilizing the template for change feed notification. So let's dive in. So let's go to Azure portal. So I'm here in my Azure portal, and as you can see, I previously created this to-do list from the kickstart. I just clicked and it created for me this item container as well, and there is another one, scale and settings. So if I just click on here, I have multiple options: new SQL query, new open query, and then here new stored procedures, new UDF, or new trigger. And then I can create a trigger here, and I can create a trigger which says trigger ID, type, and function trigger body, so which is simply creating a new trigger here. And we'll just close them. Okay, and same way, if I just go here, I have the same options here. I can create new SQL query, new stored procedure, new UDF, and new trigger. If I click on the trigger again, I have to enter the same thing, same detail, and it will say like trigger operation, what type of trigger operation, delete or replace. So basically this is about getting triggers on them. As we are already here, I would also show you how the default consistency works. For now, we are in the session consistency. You see, session consistency is most widely used consistency level both for single region as well as globally distributed applications. So you see here, what it is doing is, so if anything is written, it will write down to these three west use central US, then slowly it will do other as well. So you see the pattern here, and if you check this one, you see consistency prefix, and you see the difference. And eventual consistency is like you write here already 3 4 5 written here, only 2 3 written, and only 1 is written here. And if so, you see the difference. And then if you go with the strong consistency,
everything is written at the same time, you see. And bounded stillness, okay, you see, kind of is consistent. So what I want to say is, just wanted to go through it as well while I'm on the portal. And then to for the backup, let's go through all of them all together. So the backup options, we have geo-redundant backup storage or locally redundant backup storage. For networking, you already know. Course, you already know. Dedicated gateways, we don't care for now because we will talk about them later. Power BI integrations, you see here, you can visualize your Cosmos DB in Power BI and you can integrate with it. So this can result into a lot of things like nice graphs, reports, user reports. So that can give you a lot of strength. Same way with Azure Synapse, you can do wonders because Synapse provide you a lot of other analytic features. If you go with Azure Cognitive Search, that again gives you a lot of strength. And then you can simply add Azure function. So you see, item, name of your Azure function. You can create an Azure function which for any DB triggers that listen to the change feed of a container. So this is what we were just talking about, to create a change feed using Azure container, sorry, Azure function. So what it does, it just gets the container from there, and then it gets the Azure function, select the function existing app, and name of the Azure function is item triggers, and then C#. And then if I save it, it is just going to create an Azure function which will listen to the change feed to this container which is in items. So if I just go to this app, you see it is creating um, it is just creating this function app. And now we have functions. Let's look at it. It will take some time. So I'm here in my function app, and you see one item trigger is created from the Cosmos DB. So that's it about change trigger. Basically, you need to create in Azure. So sorry, in Cosmos DB. So we go back here, and we go back here. So which was from the change feed trigger. I hope it is clear. Let's continue.
Welcome to the course Microsoft Developer Develop Solutions with Blob Storage. My name is Nitish Sharma. In this module that is called Understanding Azure Blob Storage, you will learn about the core concepts of blob storage. Before we start, let me show you how this course is structured. This course helps you to learn for the exam AZ-204 solutions, developing solutions for Microsoft. When you look at the AZ-204 exam objectives, you find there is a section called Develop Solutions that use blob storage. That section has these 5 exam objectives that are covered in this course. So when you look at the course structure, there is the first module that helps you to understand the core concepts of Azure Blob Storage, like storage accounts, container blob types, replication strategies. In the next module, you will learn how to interact with the data using Azure SDK .NET. Then you will learn how to set retrieve properties and metadata, how to implement data archiving and retention, including hot, cool, archive, storage, and finally how to move items between storage accounts and containers. So here you see which modules cover which exam objective. Now let's ensure you understand the core concepts of Azure Blob Storage, which is foundation that you need for the exam. Azure Blob Storage is Microsoft's massively scalable object storage for cloud. In that object storage, you store unstructured data like text file, binary files. Besides storing plain data, uh, besides storing plain text files like HTML, JSON, or text files, you can also store log files. Binary files are, for example, images, videos, zip file, PDF files, and also virtual disks for virtual machines. You can access the data in blob storage via Azure Storage, Azure Storage REST API or HTTP, HTTPS. HTTPS is the recommended options. One of the recommended options. This REST API means that you can access blob storage from any device that can make HTTP requests. You can access blob storage from the Azure portal and from command line, CLI, PowerShell. To access blob storage from your applications, you can use an Azure Storage Client library that wraps the REST API calls. Client libraries exist for several platforms like .NET, Java, Python, Node.js. Azure Blob Storage with storage account, containers, and blobs. Use blob storage. You have to create an Azure storage account. For the storage account, you have to define a name like, for example, storage tag of the day. The storage account name must be unique across all storage accounts because the storage account name is part of the URL for your storage service. Here you see in the example that the name of the storage account, if it's tag of the day, then it is tag of the day, name of the storage account. Then the URL is .blob.core.windows.net. So your name of the storage account should be unique, and it must be between 3 to 24 characters long and must contain only lowercase letters and numbers. So I hope and this must be unique across all storage accounts, as I already said. Let's continue. The blob container is like a root folder for your blobs, and you can create as many containers as you want. To access, for example, the image container via URL append dash image. So we will have a blob container which is like this, image blob container, and you have videos blob container. Image blob container contains two blobs, thomas.jpg, and then you have design/logo.png. That means you have inside a blob container you have a folder, and that folder has a logo.png. So to access logo.png and thomas.jpg, how do you type, how your URL becomes? So HTTPS, because we are accessing over the HTTPS, and then name of your storage account .blob.core.windows.net slash name of your container images, then slash design slash logo. Simple, right? It's very simple. And then to format the to get the list, you can say compt list. So it's very easy to form the. Now you have so-called virtual directory and the URL to access the design logo files that uses its full blob name. You can also use REST APIs with this URL to list all the blobs of the image container. Now let's create a storage account and blob container, and let's upload some blobs. Let's go to demo. So in this demo, we are going to create a storage account, and then we will upload some blobs. And let's go to our Azure portal.
Now I am in my Azure portal here, as you can see, and let's create a resource. I will say storage account, and it is already visible here. Let's go. I got good. Okay, and then I don't have any storage resource group ready because I deleted all of them yesterday. So I will create a new one, tag of the day 204. and I will say storage account. So I'll say tech of the day. Let's hope it's unique. And the region I will region I am in North. Let's say so. I'll say North Europe. And it says standard recommended for most scenarios, general purpose v2 account. We will talk about these two things in a while because this is really important and it decides a lot of things for your storage account. Same with redundancy, we will talk about it in a while. You have multiple options: locally redundant, geo redundant, zone redundant storage. So geo zone redundant, sorry. So geo zone and geo zone. Okay, so I will leave it locally redundant, and let's continue. And then I have configure security settings that impact your storage account. Require secure transfer for REST API operations. Enable blob public access. Enable storage account key access. Default to Azure directory. And I leave it as it is, default. Yes. So I will discuss about these options as well in the next slides. Blob storage. So data lake storage gen 2. The storage hierarchical namespace accelerated big data analytics workloads and enable file level access control. It's a bit extra functionality if you want to use it for data lake storage gen 2. And then you have blob storage, enable SFTP preview, allow cross-tenant replication. We will talk about all of this in a while. And then it also asks if you want to enable large file share. I'll continue. Then enable public access from all network. Okay, I allow it. Microsoft network routing, internet routing. Determine network routing, how you route your traffic as it travels from source to Azure endpoint. Microsoft network routing is recommended for most customers. We will also talk about it, but it's out of AZ-204, so maybe I might skip it, but let's continue. Enable soft delete for blob. These are the default automation you have. And enable soft delete for containers, enable soft delete for file share, tracking, access control. A lot of options are there now. Encryption, customer managed key, or Microsoft managed key, blob, files only. Let's continue with the default settings, and here we are with the final validation. It's valid, and let's create. And it is going to deploy my first storage account. As you can see here, it created a deployment. As I always talk about it, that it simply creates an ARM template, and behind the scene it is executing that ARM template as a deployment. So basically it's not one resource you are creating, you might be creating multiple resources at once. And let's wait for it. Oh, it is created. So let's go to the resource. Now inside the tech of the day storage account, you see I have containers and I have no container except logs, which is by default created for this container, which might contain nothing for now, but it might contain something later on. And let's go back. If I go back to overview, here you see whatever the uh, settings I selected, like it is locally redundant storage, it is account type is storage v2, general purpose v2. It is important to remember, and you might have question on based on this what type of storage account you need to do certain operations. And the provisioning state, it's of course done. Other properties you can see here: hierarchical namespace disabled, default, blob, public access enabled. Everything is here, whatever you just set during the creation. So share capacity is 5 terabyte for the file service. It gives a lot of flexible um, opportunities. Now you see here also
So let's talk about access control. Maybe we'll talk about it in the topic itself about the access control. But let's say containers, we talked about file shares. If you have file share, then you can have them here. Queues, tables, Azure table, networking, really important. If you are using VNet, then your storage account will be available only via VNet, and then you need to add the VNet here. Or if you want to add access via public IP address, sorry, you're only for a special IP address range, then you can also say that. You can also create private endpoints. You can also have custom domain for because you might deploy a website here, static website. You can deploy via storage account, and for that you can also add it, use it as a custom domain. So custom domain, creating custom domain is really good. So you see here, is verify tech of the day, that Z16 web core windows.net. This is another, or this one for working with my custom domain. Anyway, let's continue. I don't want to spend much time on this. And then you have access keys, which is really important. You have access keys, and that you can use for your connection to the storage account. And then you can also use as connection string, which you might use in .NET SDK applications, or you can use directly the custom key. Also, you have other things like shared access signature, which is like you create a specific kind of token or code which allows you to do certain operations only. So you can say only read, and I don't want them to write, or I want to give them read, write, but not delete. List is by default, then you have to give, because if someone wants to read, then they need list. They cannot add, maybe they cannot create, update, process, whatever. You put the permissions, and then you can generate a key. Then you have encryption. Here you see encryption is enabled. Encryption support for customer managed keys, blobs, and files only. Infrastructure encryption disabled. Encryption type is via Microsoft, and you can also have your own key and then add the micro. So there are two types of encryption, which is storage encryption. Protects your data at rest, because your data is staying inside the storage account, and that means it is there. And then if you want it to be encrypted, it will be called data at rest, and that is encrypted. Another type of encryption is data in transfer, and that is while on the network, downloading or uploading. Then you have replication. So you have we will talk about it in a while. What is redundancy? You have data protection, object replication for your again for your data redundancy, high availability, also blob inventory, static website. I talked about it already. So many things. And then you also have, for the monitoring purpose, you have insights, alerts, metrics, webhooks. We will talk about them in monitoring chapter, but this is, as for each resource, you have these default options. You can also have automation here. Automation is simply you create a specific runbooks, and then those tasks are run on a schedule. So you can add a task, set monthly cost for resource. This is simple an example, but you can have your own tasks as well. Or if you go here inside the keys, let's go to the keys. Here you see set rotation reminder and enable rotation, custom rotation and remind. This is also part type of automation, but you can also schedule key rotation using automation. Anyway, this was it about storage account. Let's continue. want you to do this for me. Actually, I have already created the storage account using portal, and I want you to do this exercise for me. If you can do, is you need to create a storage account and with the Azure CLI. So you're gonna create a storage account using Azure CLI. What command you're going to type is AZ storage account create. Very simple, right? First you are telling AZ storage account create. Then you're telling name of the storage account. So storage tech of the day 01. Then you're telling resource group. If you don't have a resource group, you have to have the command before this for creating the resource group. And then you saying these are the parameters like location, SKU, and type of storage account, which is kind storage v2. You have to keep them specific. I mean, you have to type them exactly same. And the same way you can also do for the Azure PowerShell. Using Azure PowerShell, you have to change the command a little bit like this. So new AZ storage account, instead of AZ storage account create, you say new. You start with the verb new and then say AZ, then you say add storage account. Then you tell name and storage and the name of the storage account, resource group name, tag of the day, location, SKU name, standard raggers, and kind is storage v2. Pay attention to this dash, it is only one, whereas in Azure CLI you have two dashes, dash. I expect you to do that, and I hope you will be able to execute this. I will continue. Authorize requests to blob storage. There are different options available to authorize requests to blob storage. You can use shared key, which is your storage account key, also known as access key. Where you develop an application, you really use a connection string to access blob storage, and that connection string contains the shared key for your storage account, as I shown you while I was creating the storage account. And you can also you can authorize storage authorize requests to blob storage with shared access signature. And shared access signatures, as I shown you while I was creating the demo, are just token that you append to blob URLs. That gives you fine granular control over how your data can be accessed. You can also use Azure Active Directory to authorize requests to blob storage, and you can even configure anonymous public read access at the blob container level. So I hope nothing is new here. I have already told you everything about this. So to authorize request to blob storage, now let's go to Azure portal and let me show you how to authorize requests with a shared access signature and how to configure anonymous public read access on the blob container. And in the previous clips, we tried to access a photo, PNG. I just shown you how to access it, and you might get a few exceptions if you are not allowed to get it. And then if you are allowed to get it, then you will get it, or you will get like page not found. Let's go to Azure portal. Okay, back to my Azure portal. Here you can see I have a container called test, and in this test container I have a text file demos.txt. And this file, if I want to get this file, I go here and get the URL, I copy it, I put it here, and it says resource not found. As expected, the specified resource does not exist, because you see here the access to this is private. You can't see it here because the access is set on the container level. So container is private, and
if it is private, you cannot access it. So first let me make the change access level to public. You can set blob anonymous read access for blob only, or you can say container anonymous read access for containers and blobs. So I will change it to container level, and it is giving me warning, although I will explain you because this is not good idea to change the access level at container level. But anyway, it is now at container level access, and I go inside the demo, and if I copy and paste it here, I see the content in here. So simply by setting the access level on the container level, I could just get the demo.txt. But what I could do also, I could also change at the blob level, and you see I could do a lot. I could generate SAS for this blob especially, and then I could also access with this SAS token. So let's just go back and change the access level to private. Okay, and now I go to this blob and I say generate SAS for this blob, and then I can just using that SAS token I can access. Meanwhile, I will just show you if I can access it. No, it is again the source not found while it is generating SAS token. So you see the power of SAS token, access control. Okay, so here you see it is asking me signing key 1, stored access policy none, permission read only. I can give other permissions as well, but not more than that. It is also asking me the time, when do I want it to start, and the expiry date is 26 today, within I think 8 hours. Yeah, and then you can also specify special IP addresses, or you can just say okay, no, it's okay, you know what, it's fine. And it's SAS token is generated. You have a SAS token itself, you have a blob SAS URI. I will copy the blob SAS URL because then I don't have to copy paste the whole thing. And here we are again back access with the access to this file with the SAS token. So you see the power of generating SAS token. I hope it is clear, and I hope you liked it. Let's continue.
Know already the structure of blob storage with storage accounts, blob containers, and blobs. Now let's look at the different blob types. When you store files in blob storage like images, videos, you want to replace the whole file when you update it. This means you upload a complete new binary object exactly for this scenario, and these kind of files like images, video, text file, PDF, document, blob storage has a blob type that is called blob. The blob stores its contents in a separate blocks. That's why it is called blob. Now let's assume you want to store a log file in blob storage. Instead of replacing this file with a brand new file like you would do it for the blob, you want to append some lines of text and end of your log file. For log files where append operations are required, there is a blob type called append blob. So apart from blob, you have append blob, and um, beside images, videos, and log files, you might also want to store Azure Virtual Machine disks in blob storage. When you use disks, you need to be able to read and write at any position within the blob. So you need random read-write access for this random read-write scenario, which is required for Azure Virtual Machine disks. This is the third blob type, which is called page blob. So these are the three blob types. Now let's look at different storage account types, because I hope this is clear. The page blob is used for scenarios like disk storage. Append blob is used for the scenarios like logs. Block blobs are used for when you want to store something in entirety of it. Let's continue and know the storage account kinds. There are different kinds of storage accounts. The most common and also default storage account is storage v2 account. As while I was creating the storage account, I told you that this is really important to understand, and you need to know the differences. So I'll explain that here in a while. The most common used, also the default account type is storage v2. This is so-called general purpose account. That means it supports not only blob storage but also file, queue and table storage. There is also version 1 of this account kind that is just called storage or general purpose version 1. Beside that, there is account kind blob storage that only supports the blob service. These two account kinds are legacy accounts. They are still supported, but new storage accounts, storage v2 is recommended. You can upgrade these legacy storage accounts to storage v2 account. This is permanent change and you cannot revert after upgrading. I could show you this in the Azure portal, but it's not a big deal. Just go to the storage account and then you can change the type. In the configuration section you can just change it, but for legacy account only, you are not able to change it back to legacy. So when you omit the legacy accounts, you have only the storage v2 account kind. It look like this when you use it with the storage standard performance, which means magnetic drives. The blob service supports the 3 blob type: block, append and page blob. We'll talk about it in few slides. It is getting a bit complicated if I talk everything in the same thing. Know the storage account kinds. Besides standard performance, you can also select premium performance when creating a storage account. This means your data is stored on solid state drive SSD, but when you create a storage v2 account with premium performance, it does not support file, queue and table storage. It does also not support the blob types, block and append. It only supports the page blobs. This means that a premium storage v2 account is only for virtual hard disks. So we have the premium performance with SSD drives. This is magnetic drive and it supports all of them: block, append and page, and it only supports page. Block blob storage, it supports block, blob, append, and file storage only file. This account kind supports to use block blob with premium performance. You create a block blob storage account. This account kind supports the blob service with block blobs and also append the blobs. There is also the file storage account that supports the file service with premium performance. Important to understand is that a storage v2 account with standard performance is great for high throughput of data, and it is recommended option for most scenarios. That is the reason why this account kind is default account kind. Block blob storage on the other side is great if you have a lot of transactions with small objects. The data of your storage account is always replicated to ensure durability. When you create a storage account, you can choose a replication strategy. Locally redundant storage is cheapest replication strategy. It creates 3 copies of your data in the selected region of your storage account, like For example, West Europe, the copies are created in a single data center, which is also known as availability zone or just zone. If a disk failure occurs, your data is still available, but if the data center level disaster occurs, like for your example, fire or flooding, all copies of data may be lost, and that is unrecoverable. So zone redundant storage in this next level, it distributes your data across 3 data centers in the same region. So this was in the same data center, this is in the same zone, so it distributes your data across 3 data centers in the same region. This means that your data is still there if the data center is destroyed or not available. Note that this replication strategy is not supported in all regions. It is only supported in those regions that have 3 separate data centers. Now with these 2 replication strategies, you will lose your data if the whole region becomes unavailable. For example, because of massive natural disaster, for both replication strategies, there are alternative replication strategies that copy your data to a secondary region. For locally redundant storage, there is geo-redundant storage that stores 3 copies of your data in the primary region, and it asynchronously writes the data to a single data center in secondary region where 3 copies are stored. The same exists for zone redundant storage, and it's called geo zone redundant storage. It's was 3 and the same 3 copies of your data in the primary region in 3 data centers, and it asynchronously writes the data to a single data center in the secondary. So as I have already talked about it, but to understand it, let's say you want to access the data from secondary option. So this is your primary region, geo redundant storage, and from the primary region you are copying data synchronously to secondary region, and the same way for the geo zone redundant, you are copying 3 copies from your primary region to secondary region with 3 copies. And to access from the secondary region, your storage account name dash, you just add a secondary here and you will get the copy from there in case you need to access it. Generally you don't need to access it. Storage, now let's look at the storage accounts and replication strategies. The storage v2 account supports all 6 replication strategies. The legacy accounts storage and blob storage supports only the 3 strategies, LRS, GRS, and RAGRS. So with the general purpose v2, it supports all of them, and also with the premium, it only supports LRS, ZRS, zone redundant, storage and local redundant, and the legacy one supports LRS, GRS, RAGRS, and legacy doesn't support zone redundant, but this one supports zone redundant. Now, understanding the Azure SDK for .NET. Welcome to the module interacting with data using the Azure SDK for .NET. My name is Nitesh Sharma. To access Azure services like blob storage from your application, you can use an Azure SDK. Azure SDK exists for different platforms like .NET, Java, JavaScript, Python, C++, and Android and iOS. And to use, you can read more about Azure SDK on Azure github.io/Azure AD SDK, or you just search online and you can also find Azure SDK for .NET. yeah, collection of client libraries are there, and it is pretty simple to understand it. It is like Azure dot storage, so service category and then service name. So Azure dot storage dot blobs, which is the nugget package, and then same way Azure dot storage dot queue, which is again a nugget package. And it is pretty simple. And if you want to have a look at the code of Azure SDK for your .NET, you can do this as it is open source and available on GitHub. In this module, we used use the client library Azure storage blobs to get the access to the blobs. Now let's ensure that you understand this .NET client library, the Azure storage.blobs, which is coming with the nugget package. The Azure.storage blobs nugget package contains three important classes: Azure Blob Service Client, Blob Service Client, Blob Container Client, and Blob Client. So you have Blob Service Client, Blob Container Client, and Blob Client. Blob Service Client is used to reference the blob service of the storage account. Use this class, for example, to list all the containers of your storage account. The blob container client class is used to interact with the specific blob container. You can use it to, for example, to create a container or list the blob of a container. The blob client class is used to interact with blob. So you see the hierarchy. You are in the first, you are in the blob service, you are then in the container, and then you are in the blob itself. So at the storage account level, blob container level, and blobs. So now let's see this in action, and let me show you how to use the azure.storage.blobs client library in .NET. In this demo, you will learn how to use .NET Client Library for blobs container and to upload list and download blobs. Let's switch to Visual Studio, and I will show you how to do it.
Okay, here I am in my demo application which I created using using the examples we have on the GitHub. This is just a copy paste from there, and you see here I have program.cs, which has the main entry point, and then I have a file to upload, which is nothing, just an HTML document, and we will copy this content and we will write this content to a file we want to upload. So here let's go through it, what we are doing here. If you see step by step, I am create container and upload blob, then I will list the blob in the container, and then I will download a blob, and then I will delete the container. So I will create a container if it's not there, and then I will download it. And let's go and see our existing container. What do we have? So here I'm here. If you see, I do have a container, and I will delete this because we are going to create it. So refresh. I don't have any other container except logs. So let's continue, and go through the code first. So if I go to the first function, what I'm doing is I'm creating a blob service client using the connection string I provided, and connection string I shown you how to get it from the access keys. So this is connection string, and once I get this blob service client, then I get the container with the container name I precisely say so. And then once I got the blob container client, I check if it does not exist, create it. So create if not exist, and public access level the access level is public on the blob container level. So you see we also have other options, blob or blob container level or none. So I said blob container level, so a whole container is public. Then I upload. To upload, what I do is I create a blob client using this blob name, which is the name of the file we want to upload. And then you see I say console, this is just console. Later on I create a file stream to read from the file to upload from this one, and add this content to this blob, which is the blob client I just created here. So I upload to this blob client this file stream, and I say content type is text HTML, and that's it. So we are done with the upload. Let's do it one by one. I will debug with you and do one by one. So let's continue. Let's run the first. I will go here first. Created the blob service client, created the blob container, and creating blob container, then it created. So let's say it just passed this create if does not exist, and let's see if it created uh, the container. Let's refresh. It created the container. So let's continue now, and now let's create the blob client, and it created the blob client with the blob name. The blob, just pay attention, this blob does not exist yet. This part, it says test slash demo.txt, does not exist yet. If I go to container, there is nothing here. But let's continue. And because I haven't uploaded anything, I just have created a reference to that blob which does not exist in the Azure yet. I have just created a reference in my local, and I just opened the file to upload HTML, and then now I will upload to this blob client this file stream, and I will say the content type. So now I should have the blob here. Yeah, you see I have the blob. So I continue now. Now I want to list. So if you see here, it listed all the demo.txt, and if we go to the function itself, it just creates a blob service client, and then um, displays the name of the account, and then get the blob containers async, you see here, and then you just print the name of the container, and then inside the container itself, you see blob container client, it's inside the blob container itself, it gets the blob items inside the blob container. So that's how it printed like this dash arrow container name, and then it printed space blob item. You see the display like this. Okay, I hope it is clear. Let's continue now, and downloading the blob, and it is done. So I should have downloaded the blob, but so, and then it is done. Okay, before deleting, I'm just saying enter anything, but I don't want to delete it. I just want to show you what we had, something like this here. And if I just go to the file, which is this one, demo txt, and I copy the URL, I go here, and I see the text which was here. You see the HTML is translated to, I mean, to display with the browser. Your browser already translates it. So I hope it is clear how to create a container, how to create a blob, how to download, how to list, how to delete. I displayed you everything. Let's continue.
To the module setting and retrieving properties and metadata. My name is Nitesh Sharma. Properties and metadata exist on blob containers and on blobs. The blob containers has so-called system properties, and one of them is etag, which stands for entity tag. This is a string identifier that changes every time the blob container was updated. The last modified property tells you when the container was updated. The blob has also the system properties etag and last modified. It also has several other properties like content type, content length, blob type, which can be block blob, append blob, page blob, and I have explained all of them previously. And you also have properties like etag or last modified are read only, and then there are properties like content type that you can set on a blob. Beside properties, a blob container can contain user defined metadata, and those metadatas are string based key value pairs that you can store on a container. That same concept of metadata exists also on a blob. Properties and metadata are set and retrieved via HTTP headers. Now in this demo, let's look at here properties and the metadata in Azure portal, where HTTP response header of the blob. So let's go to the portal.
So here on blob demo.txt, we have metadata, which is metadata key value pair, as I said. And then if I go back to container and if I check on the container level, the properties, container properties, and you also have edit metadata, where you also can store them with the key value pair. And if you go to container properties, you have name, last modified, etag, lead status, lead duration, and encryption scope, version level disability. So, and then um, you have another tab which is like you can just set multiple metadata here as key value pair.
So in this demo,
Let's continue.
you will learn how to set and retrieve properties.
Okay, we are back to our container here, and you see there is no container.
Studio and
Let's go to our
portal. Let's switch to Visual Studio. I have already
code.
shown you in
Here I already
portal,
have
but
the
let's go
connection
to
string.
Visual
What I
Studio
did,
and
I
let's check
commented
it
out
out.
the previous code, and I added more code, which is like creating container, which will simply return a blob client, and then I will set the properties on the blob client, get the properties, set the metadata on blob client, get the metadata on the blob client. I guess it's clear, right? And let's see how it does it. So I go to set blob properties, and in this one what I'm doing is getting the properties from blob client using get properties async, and then you just set the things on it, and you set HTTP headers async, and then that's it. So we will do it. Let's look at it one by one. I'll run it, and okay, so let's see here one by one step. We uploaded the blob, this one demo, then we set the properties, then we got the properties, and while we got the properties, it said content type text HTML blob block creation on this one, last modified this one, set blob metadata, then we got blob metadata. So if I go back here, and if I just refresh it, and if I properties, sorry, it is test, but I will go demo properties, and in here you see here full name, tech of the category, author profile. I added these two metadata, and it is there. So I hope it is clear how to do it, and it's not a magic, it's just a C#.NET SDK which has pre-built, sorry for that noise, which has pre-built clients. And let's continue
To the module implementing data archiving and retention. My name is Nitesh Sharma. When it comes to data archiving, you need to understand the access tiers for blobs. On the blob, you can set the access tiers to hot, cool, or archive, and you can always change this access tier. Let's understand it more in detail. So you have hot is the default access tier of a blob, and it is recommended for frequently accessed data. The cool access tier is for infrequently accessed data that you store for at least 30 days. The archive tier access tier is for the data that can be archived for at least 180 days. This means that you don't plan to read the data in the next 180 days. Setting a block blob to one of these access tier is important for your cost of the storage account. The access and transaction costs are low with the hot tier, and they are very high with the archive tier. On the other side, the storage cost per gigabyte are low for archive here and high for hot tier. The costs for the cool access tier are between hot and archive. So if you go from here to this side, access and transaction costs, and if you go from this to this side, storage costs are high. And this is how you decide which one to use, archive or cool or hot tier, and you will get a question at least in from this part in the exam. Now on your storage account you can set a default access tier for blobs of the storage account. Hot is default as mentioned, and you can also select cool as default access tier. The blob access tier is inferred from the default access tier defined on the storage account, but on each blob you can set the access tier individually. At the blob level you can set it to hot, cool or archive. So you can see the archive access tier is only available at the blob level but not at the storage account level, sorry. The reason for that is that the access tiers hot and cool are online tiers, while the access tier archive is offline tier. That means that you cannot access a blob after you have set the access tier to archive, because then the blob is offline. You still read its properties and its metadata but not the content of the blob. To read an archive blob you have to set the access tier back to online tier. This process is known as rehydrating and may take several hours to complete. Once completed, you can read the blob again. And so, all right, so far to access tiers, important to know is that access tiers for blob are not supported by all storage kinds. So to summarize, I hope it's clear what it is, hot, cool, and what is rehydrating, online, what is offline. Let's continue. Only the storage account kind v2 and blob storage support access tier. If you have, for example, a legacy storage v2 account, you need to upgrade it to v2 from v1 to v2 account to use access tiers. The premium performance account kind blob storage does not support access tiers, and file storage kind does not support the blob service. All right, because for the premium you don't really need it, right? That's why you are paying high price. So let's continue. In this demo you will learn how to set access tier of a blob in And so let's go to Azure portal. In this demo, you will learn how to set access tier of a blob.
Back again,
You will
I'm
learn
here
how to
in my
set
Azure
access
portal,
tier
and you
of
see
a
I'm on
blob. And
my
so let's go to
same
Azure portal.
container, and then
And so
same
let's
blob
go to Azure portal.
demo.txt, where I will go to the properties and I will change the access tier. It just by default it was set to hot. Then you can set to cool or archive, and here it gives me warning: setting the access tier to archive will make your blob inaccessible until it rehydrates back to hot or cool, which may take several hours, which we just discussed. If I just set it to cool and save, it is quick, and then I can change it back. Access tier last modified this, and I can change it back to hot, and it is successfully changed. Let's continue.
So I gave you an example of how to set access tier in Azure portal. Now I want you to do one more exercise yourself. What you do is you just use this command to set the access tier for storage blob. So here I'm missing one thing, which is AZ storage blob set tier, and then you just say account key, account name, account container name, and the tier, and you put the properties to them here. So I want you to do this exercise for me and let me know. Also, if you want to do it with .NET SDK, it is very simple. You just get the blob client first. So you have the blob client, and then now you can just do set access tier async and then access tier dot cool, right? Or archive, and then it will be done asynchronously. So I want you to do this yourself, and I hope you like it. Let's continue. Manage. In this demo, you will learn how to manage the blob lifecycle with rules. And let's go to portal again.
Okay, back to the portal, and if I go here, I have everything with me. Here you see properties. In the properties I have blob service, I have networking, I have file service, I have queue service, I have table service. And for if I talk about blob service, and if I go here, it takes me to the blob containers. If I go back, and if I just want to change the default access tier for blob service, I can just change it to different one. You see here, secure transfer disabled, allow public access, blah blah blah. And here I can set it to cool default one, or and default is LRS. Here as well I can go back here, and I can also change the public access blob. So I can also change the container soft delete, blob soft delete. Mind the difference, please. You can soft delete a container, you can soft delete a blob, and I can change it. I can say this, I can remove it, I can add it, I can change the value in days, let's say 1 day, let's say 80 days, whatever. You see it is in days. And same way I can enable soft delete for containers. I can remove it, I can add it, and enable permanent delete for soft deleted item, which is again interesting. Permanent delete enables you to permanently delete a soft deleted snapshot or blob version before the retention period ends. So once you have deleted a blob, it is stored in the soft delete, and then once the soft delete time passes, it stores it in a snapshot for some retention period, and then once the retention period passes, it deletes it permanently. So and it is really important to know, because for big companies retention is really important. For some companies Archiving is important because you need to keep sometimes records for 7 years. Um, so I have covered most of the things here about data protection. So the data retention, enable operation backup recovery with Azure Backup. So Azure Backup can help you protect your blobs in storage account and manage the protection at scale. You have enable point in time restore for containers. So you have, that means they keep copy of your containers with timestamps, so you can go back and get a copy of your container and for a particular point in time. What else? Yeah, versioning and tracking. So you can also enable versioning. So use versioning to automatically maintain previous version of your blobs. So when you modify, you update it to a different version, and then you can use it for consider your workloads, their impact on the number of versions created, and the resulting cost. Optimize cost by automatically managing data lifecycle. Yeah, so this is basically the life cycle of your uh, blob service. Let's go back and go back to blob service. Here we have talked about blob service. I haven't talked about file service. We will talk about in a while. And let's go back.
Soft delete for blobs. As in the previous demo, I have already shown you how you can turn on soft delete and how you can work with it. So how many days you can set for soft delete and then archiving. So we have already discussed this. Let's continue. Then there is understanding snapshots and versions. This is also discussed, um, and the versioning is also been discussed. Versioning being also shown to you. So let's continue. And working with leases, it's an important concept, and for to do that we have to go to the Azure portal. So let's go.
Okay, so I'm back here in my portal again, and you see I'm in the containers part. If I go here and I go to this container, and if I check, there is um, this blob demo.txt, and I can say I acquire lease, and that means I have acquired the lease for successfully, and then successfully acquire lease for following blob with this lease. While the lease is active, you must include the lease ID with any request to write the blob or renew, change or release the lease. If I want to communicate with this with this demo.txt, I should communicate with this lease ID, and I will copy this. And now you see, for this blob, particularly for this blob, uh, the delete option is gone. You see, I cannot delete it, and so and I can refresh it as well to show you properly. Yes, so I don't have the delete option because I took the lease. So the blob is in my control, and then no one else, if someone else access it from somewhere else, let's say another user want to access it, they cannot uh, use it. So I have to go back and say break lease, and then I'm breaking it. Or if I want to do it programmatically, then I have to use the lease ID to break it. So that's it. I hope it is clear. So working with immutable blob storage. If you, I am here in my test container, and in the access policy, I will show you back. I clicked on this one container, and then I went to access policies. And in access policies, I have two types of policies: stored access policy and immutable blob storage. And that means user defined policies applied to a container for retaining the data in all blobs in the container in non-modifiable and delete protected states. So choose one policy at time. Retention policy changes may require some time to take effect. So if I just say add policy, and it has two types of policies, legal hold or time-based retention. If I say time-based retention, and it is for days, so I said 10 days, and then enable version level immutability, and it is not active for me, because in order to enable version level immutability support, your storage account must have versioning turned on, because I did not turn on the versioning. So I don't have version immutability here, but allow protected append rights to none, append blobs none. So I can still allow them to append the blob, or say no, it is not allowed, and that means I have the time-based lease, time-based policy for retention period for 10 days. And if I just say save, cancel, that means I'm kind of creating a policy for immutable blob storage. Same way I can say for stored access policy, and then say identifiers, and then I set permissions, start time, end time, and OK. I hope it is clear, and let's continue.
Moving items between storage accounts and containers. My name is Nitesh Sharma. To move items in blob storage, you copy the items from the source to the target, and after the copy operation, you delete the source. So let's continue how you can do that. Now let's look at the tools to copy data in blob storage. You can use Azure CLI, copy blobs and containers. You can also use Azure copy command line utility from Microsoft. It allows you to copy blobs between containers, storage accounts, and local directories. You can of course also use the .NET Client library for blob storage to copy blobs, but this would mean that you have to write code to copy your blobs. So now let's look at the Azure CLI and AZ copy. To copy a blob with the Azure CLI, you use AZ storage blob copy start command. Like here you see. As you can see here, I have defined the source first, which is a JPG file, and then the account name. The destination or the target is after that. So destination container, destination blob name, and yeah, so that is how you continue. And then you have another way. You copy a directory and not a single blob. You specify in addition the recursive flag that you set to true. To upload a local folder, you specify the local folder directory as a source and the URL to the container as target. When you specify the directory like this, AZ copy, and after that you prefixes the blobs with the directory name. In this case, you documents. So if you use star here, you can use a star, and then AZ copy does not prefix the blob with the directory names. So that is why we have used star here. That means that does not prefix blobs with the document. So when you upload it to this container, the URL for or the blobs will not be prefixed with the slash document, so the directory structure will not be copied on the server itself. Copy blobs between containers. So previously we shown you that how can you do that from local folder to storage account. Now you want to do it between storage accounts. So it's simple. Here you just say AZ copy and then the source and then the destination, and you again say recursive equals to true, because you want to copy all the blobs within the container itself. So for that you need to specify recursive equals to true. I would want you to do that actually. So I would like you to do a test or an exercise to check your knowledge, and that is simply the blobs you have created within the Azure. I want you to do I want you to use AZ copy command and copy blobs from one storage account to another storage account. And it's simple, we have already talked about it, but I want you to do that so that you remember it and learn it. Let's continue. So next, congratulations, you finished this course. You learn how to develop solutions that use blob storage and covered the corresponding exam objectives. You learn how to interact with data using appropriate SDK, how to set and retrieve properties and metadata, how to implement data archiving and retention, how to implement hot cool archive storage, and how to move items in envelope storage between storage accounts or containers. And the next step for you to take the next courses or the next keep watching actually this video series and go take other remaining videos. My name is Nitesh Sharma and thank you for watching this course. If you have any questions, you can leave your comments in the comment section. I hope you are enjoying this course and I wish you good luck for your exam. Let's continue. So third part is implement Azure security. We have till now covered two parts and this is the third part. Welcome to the course Microsoft Azure Developer Implement Security. My name is Nitesh Sharma. This section is of the This section of the path covers the objectives found in the Implement Azure Security section of the exam guide, which include implement user authentication and authorization, implement Azure Security Cloud Solutions. This course will help you to learn for the exam AZ-204 Developing Solutions for Microsoft Azure. Let's continue. So the part 1 in the part 3 of overall series is implement user authentication and authorization. This course is part of develop solutions for Microsoft Azure AZ-204 and we are going to cover this topic with 3 topics itself, like secure Azure storage, authenticate using Azure AD, authenticate using authorize using Azure AD. I was also surprised, why do I have 2 times authenticate? So authenticate and authorize using Azure AD and secure Azure storage. Let's continue. Secure Azure storage. Let's start by talking securing Azure storage. What are we going to talk about in this module? First, we will understand the different ways you have to secure your Azure storage. Then we will talk about RBAC and Azure storage. And finally, we will understand shared access signature and stored policies. So let's continue. So how can you secure Azure storage? Let's find out. When we talk about securing Azure storage, you need to think in 3 dimensions. First of the management plane, then data plane, and then encryption. Management plane is, well, as the name suggests, management to the storage account. So who can access the storage account, who can manage the storage account, who can change permissions, who can add more users so they can manage other things, so and so forth. But managing users and their permissions isn't only the thing. Of course, a storage account holds data. So do we need to secure access to the data? In other words, I know I have a document stored in blob. Can I access it? Order the different mechanism. I have to allow my application to access it or not access it. And yes, another relevant concept that I actually won't have chance to dive deeper into this course, which is encryption. So yes, Azure Storage supports encryption both through Microsoft managed key or you bring your own key. I have shown you this while I was creating a storage account. So there is a way you can encrypt storage, Azure storage, but I won't be talking about this in this course. But you can look for it when you if you want more about if you want to know more about encryption online. And but this is out of this course for now. Let's continue. So what is RBAC? Understand management plane RBAC. Let's start by getting deeper understanding into management plane and specifically with Azure storage is uses. Like many other Azure resources, is a concept called role-based and access control RBAC. Let's understand what this means. At the very heart of this, of the three things, starting with security principle, you want to keep the concept in mind as I explain RBAC. Security principle. The first part of RBAC is security principle. Security principle is somebody or something you want to grant access to. In Azure, that could be a user. This particular user is security principle. That user is a different security principle. Groups of users can also be security principles, and users are people that sign in interactively, that provide a username password. It's a person sitting on a computer, but sometimes you may need a headless process. This would be a service principle. Well, at the end of the day, it's like username password, but it's intended to work like an automated headless process that can run behind the scene. So a user don't need to sign in or do MFA or anything like that. And then you have another thing called managed identity. So you have a headless service or managed identity, but this is something you don't need to worry about managing credentials of. So for these two things, Microsoft provides you way to manage credentials, and Microsoft will manage that. So for a user, a group, a service principal, or a managed identity, this is what you want to grant: some access or to remove some access from, and that is role definition. So what type of access you want to grant, what are you granting actually, and what it can do. So basically you are just saying some basically you are telling that this is what your security principle can do. And in that you have description which talk about this specific role definition, then you have ID of that role, name, and then you have permissions. And permissions is a simple list of objects, and in this example we see actions and then data actions and then not actions and not data actions. It is very interesting to see that actions are the permissions you have, so things you can perform. So here you see Microsoft Authorization star read, that means everything it can read everything. And then so on, based on the resources, you see for insights alert rule star, insights diagnostics and settings star. So like that you provide some actions it can do. And then you have data actions, what it can do, can it read the data, delete the data, modify the data. Then not actions, what it cannot do, and same what it cannot do with the data. So storage account contributor is a built-in role, and it has some these are the things by default it has, but you can same way you can also create your own role definition and create your own actions, data actions, not actions, and not data actions. So this is, so if we continue on the third part, so we provide these roles to this security principle, and then so there should be a limit, right? Providing to a service principal to do these things on what. So sometimes you say I'm providing it at management level, and I'm providing it at subscription level, I'm providing it at resource group level, I'm providing it at resource level, because you want to limit your permissions as the least as possible, because you want to secure your application. And there comes the scope into picture, because you don't want to give it to anyone except to this resource, or except onto this resource group, depending on your requirement. So as if I call it all together, what is RBAC? RBAC is simply providing a role definition to a service principal on a scope is RBAC. And these are the three pillars of RBAC. Let's continue. Understand it more in detail. You see here, role assignment basically is well, you attach a role definition to a security principal on a scope, and this grants access to something. Removing that role assignment will remove that access. Let's understand that this with an example. Tech of the day. The security principal is a user is attached, and storage account contributor, which is a role definition, to a certain storage account, which is a resource here, a scope. So see, this will allow tech of the day to be a storage account contributor on tech of the day storage 123. And you can imagine that this concept applies to so many things in Azure. You will see it, RBAC appears over and over again. And a couple of more things I want to mention before we move along. What if I have multiple role assignments assigned to me? Well, they are additive. For example, if I have owner and contributor, and owner is contributor plus a few things, then my overall permissions are owner plus contributor. Okay, however, there is an interesting concept called as a deny assignment, and a deny assignment takes the precedence over everything else. So I may have owner or contributor, but if there is a deny assignment that blocks access, then my access is blocked. Simple, right? So after the management plane, let's understand the data plane. When it comes to managing access or securing access to Azure storage, well, there are three ways to secure access to Azure storage when data plane is concerned, or Azure AD. For the first is keys. When you provision a new storage account, Azure will generate two 512-bit storage account access keys. These are basically long string that an application can use to access Azure storage. But you do need to take some steps to protect the keys, and these keys, these access keys, because they are equivalent of a root password. And in fact, you should not be embedding these keys directly into your application and that you distribute to all your clients. Plus, you should have ability to rotate keys. You can do that manually, or you can use a keyvault to do that automatically. And you should prefer to use products like shared access signature authentication, and certainly using keyvault to rotate keys. The second mechanism is shared access signature, as we have already talked. This is I have already shown you this on the portal. How can you generate shared access signature, which is basically like a least privilege mechanism when compared to Azure storage key, although they are built on top of storage keys internally, but they allow you to trim things down and allow you to access something without sharing the storage key. And you can still rotate the storage key to invalidate these shared access signatures. But shared access signatures are attached to a certain URL, some specific permissions, maybe even a range of time. So they give you a lot of flexibility when it comes to granting access to Azure storage account. And finally, another way is Azure AD. So Azure Active Directory is a premier part of the Microsoft Identity Platform, and when you access Azure storage using Azure AD, you will access it using standard OpenID Connect mechanism, and that really opens a lot of possibilities for us. For instance, there is no dependence on a key. You use something called an access token, the duration of which is customizable, but it's done. It's 1 hour by default. Well, it's technically 1 hour, 5 minutes, because they give you 5 minutes extra grace period to renew it. So there is a lot of details under Azure AD, and while I will talk about Azure AD in this course, I will also create separate videos on my channel to talk about Azure AD, because this is a big topic. Let's talk a little bit about storage account access keys. When you create a storage account, you are going to get two storage account access keys. They are equivalent. They are 512-bit, and these are long strings for you, and they are equivalent. And the reason they give you two is if you want to rotate one, you can still keep using the other one for continuity purpose. These keys are effectively root level access, so if the key is compromised, you are not going to get any notification except perhaps a rude surprise in the form of data leakage or huge bill. Therefore, you must secure these keys, preferably not embed them directly into your application, and use SaaS signatures or use Azure AD based authentication. And yes, you should rotate these keys frequently as well. So Microsoft recommends that you use a product called Azure Key Vault to manage access keys, and then you should regularly rotate and regenerate your keys. And Key Vault just makes this really easy. Of course, you can manually rotate the keys, but they can be automated using Azure Key Vault. So two things: you get a pair of keys, and it has access rights on the root level, and then you should rotate them. Let's continue. RBAC in storage. With that, let's dive into our first demo where I get to talk about RBAC in Azure storage. And let's go to Azure portal for that matter.
So I'm back in my Azure portal, and here you see I'm in my storage account, tech of the day. And in that storage account, I have my fifth option is access control IAM, which is called IAM these days. You also call it RBAC actually. And here you see a lot of things. You see check access, role assignments, roles, deny assignments, and classic administrators. So in my check assignment tab, I see view my access, so I can check what is my access on this storage account. So if I talk about in RBAC terms, what roles I have as a service principal on this scope, which is tech of the day. I will say check my access, and here you see I am as a service administrator, so which means I have full access to all resources in this subscription, and that is why I also have role on this storage account. And then I can also create, so I can directly click here, add role assignment, or add a code administrator. I can say add role assignment and then say owner, next, or I could choose another one, contributor, next, and then I need to select user group or service principal from my Azure AD. For now I have no one, and only this one is created for me, so which can be added, but yeah, I have to create some users for that, matter of the fact. And then you have roles. So you see this is just talking about what are the built-in roles you already have in Azure, and these roles, you can make use of these role definitions for your application, or you can create your own. But these are the basically rules which are required. Let's say for storage blob data owner, storage blob data reader, or contributor for that matter, you have specific role which is storage account key operator service role, which is only for the keys. Because sometimes you want to give rights to someone who can manage the keys, but you don't want him or her to see the keys, see the data in it. So you have many built-in rules here, and you can explore that. And if I just go back to I am here, I also have deny assignments, and for that matter I don't have any for now, but you can add again. And same classic administrator where you just see the administrators. So very interesting, and you can do everything here. Yeah, I hope it is clear, and let's continue.
Let's talk about shared access signatures. We have already talked about a lot about this topic, but let's dig a little bit more. Or SAS for short is a secure delegated access without sharing the key. See, the thing is, a key is too much power, as you already know, and so they have given us shared access signature, which is sort of trimmed down the power a little bit, a lot more manageability. And how do they work? Let's figure it out. Well, we need to know that there are three different kind of SAS. The first is a user delegation SAS. Basically, this is when you use Azure AD and you use a specific scope called user impersonation, so that users permission matter when you try to access storage. And second is a service SAS. A service SAS is secured with the storage account key. A service SAS delegates access to a resource in only one of the Azure storage service, either a blob storage or a queue storage, table storage, or Azure files. Then you have account SAS. An account SAS is secured with the storage account key. An account SAS delegates access to resources in one or more of the storage services when it comes to operations, and all the operations available via a service or user delegation SAS are also available via account SAS. Additionally, with the account SAS, you can delegate access to operations that apply directly at the level of services such as get, set, service properties, get services, start operations, etc. And you can also delegate access to read, write, delete operations on container tables, queues, file shares that are not permitted with a service SAS. So what does a typically SAS token look like? Let's figure it out. Well, it looks like this. So this is not all the parameters you can pass, but this is an example SAS token. You see there are a lot of parameters here and they all have meanings, and these are the meanings. Now there is a link where you can you can establish between them. So let's see here. This is the URL until here, and then you are signed version, signed services, signed version and signed services, signed resource types, signed permissions, RWD, LACUPX. We will talk about them in a while. What are these? And then signed expiry and signed start. So signed expiry and signed start, signed protocol, HTTPS, signature. So these are the things you have in a simple SAS token. So let's talk about them. So this service token we will talk about some of the things like signed services, BFQT, that sounds for blob, file, queue, and table. Signed version is the storage service version used to authorize requests made with the shared access signature, and service version to use when handling requests made with the shared access signature. And let's look at for example signed permission, which has read, write, delete, list, which means RWDLA. So they all have meanings. And how do these get created? It will become very clear when you see the demo, or I have already shown you actually this while I was creating the storage account, but I will do it again, and you will understand this how it is created. And then in the end you also, and the signature is HMAC computed over, yes, it is HMAC computed over the string to sign, and the key using the SHA-256 algorithm, and then encoded using base 64. So the key that is part of this entire equation, so rotating the key, for example, well, will invalidate your SAS token because the signature will no longer match. So this will change because our key is rotated. So there, another way to distribute or categorize SAS tokens are ad hoc SAS, which is everything you need, as in all the information that you need is available in the token itself. What permissions, what time starts, what expiration, all of them are in the SAS URI. The SAS URI you saw um, is an example of ad hoc SAS. So let's go to the portal and look at it.
So here I am back again in the Azure portal, and here I am in the security plus networking, and where I clicked shared access signature. And here you see I am looking at few things and options. Here I can select which is allowed services, which services I want my SAS token to be allowed on, allowed resource types, so service, container, object, or none of them, or whatever, two of them or all of them. And then you have what type of permissions I'm allowing: read, write, delete, list, add, create, update, process, immutable storage, permanent delete. So these are the permissions I am assigning. And then you have blob versioning permissions, allowed blob index permissions. These are a bit different. And permissions for viewing, creating, and filtering blob indexes. And then I set start and expiry time, which we talked about. And then you can also add specific IP address range. You can also add allowed protocols. You have basic routing tier, which is by default basic. You can also select Microsoft networking routing or internet routing, and then signing key, which key you want to use for signing purpose. And once you get this token, and once the key you use to sign this, as we talked uh, in the previous slide, we talked if this key one is rotated, then your SAS token is no longer valid. So you see here, let's go and generate, and in a while it will generate. Okay, I have the connection string now, and it generated the SAS token, and this is the SAS token. You see clearly here the things we talked about are here. And you see here this is the signature, and this signature key will change once we change our access key. We rotate our access key. So that will be it.
You see, I have faded out access SAS access token, and after that I have this new, which is just nothing but just a new representation of the previous SAS token, SAS token. So here you see in here in basically I have a my policy, which is SI my policy, and my policy is nothing but having a simple these things already used. So this is nothing but just making um, the other properties, these properties set into my policy. Why do I, why, what is the advantage is simply I can keep the consistency everywhere. So let's say I want to give specific permissions for a specific time and rights to certain users, and using certain key, and then every day I have automation which rotate my key one. That means my SaaS token is valid for that specific time, for that specific period and date, and that means I have the consistency, and next day I can again provide a new SaaS token for that specific group. And yeah, so and dates and everything I don't have to worry about. Also the read write list or delete rights you want to give them. So basically, to keep add consistency, you use stored access policies. I hope it's clear. Next, we have already done that, but I want you to manage SaaS-based security for Azure. In this demo, I want you to manage SaaS-based security for Azure storage, and where you will generate a SaaS token, and in attempt to generate one, you have to customize few settings, and then you also need to select for services which service you want to allow. So BQT, blob, queue, or table, and let's say not other or one or all of them, and then you need to verify which services you can access with this SaaS or not. So I want you to do this yourself. I hope you will be able to do that, and it will be fun. Let's continue to the next topic. Authenticate using Azure AD. In this module, we are going to talk about a very exciting topic, which is authenticating using Azure Active Directory. Starting with an overview. First, I would like to introduce you to the main character of the movie, which is Microsoft Identity Platform. Then there is this word being thrown around a lot, which is called as modern authentication. Let's understand what that means. We will dive into a few demos. We will see what it means to register an application in Active Directory, and we will see how you can do that. Then we will authenticate using that app registration. Of course, the platform matters. It could be JavaScript, Node.js, or .NET application. We will see all of that in a moment. A topic as this cannot be covered in a single module, so I will create different videos which are not part of this certification course, but are good to go or good to learn. So I will do that. Let's continue. Microsoft Identity Platform. What is it? Well, there is a definition for it. I will let you read the definition for the three main parts: authentication service, open source library, and application management tools. Collectively, I like to think of in the Microsoft ecosystem, if we are talking about identity, authentication, authorization, that sort of stuff, then we are talking about Microsoft Identity Platform. Let's dive a little bit deeper. When we talk about authentication service, there is something called Azure Active Directory and few others related products. When we talk about open source libraries, there are things like ADAL, MSAL, and more. And when we talk about application management tools, there are so many. For example, threat protection, for example, being able to manage single tenant or multi-tenant applications and logs, so on, so forth. The Microsoft Identity Platform is the Microsoft Identity Platform in these three parts: authentication service, then divided in these three and application authentication service, open source libraries, and application management tools. Okay, let's continue. Let's dive a little bit deeper into each one of them. These three starts with the authentication service. Starting with the authentication service, at the heart of it is a product called Azure Active Directory. Have you ever logged on to Office 365? then congratulations, you have already logged into Azure Active Directory. Chances are that your organization in one way or another already uses Azure AD or is going to use it sometime in the near future. Perhaps you interact with the partner who has invited you to OneDrive file when you log in, or you are logging in using Azure AD. Azure AD doesn't just exist in a vacuum. There are a bunch of other products that support it. For example, if you are on premise and you use Active Directory on premises, then chances are that you have used something called Azure AD Connect to synchronize these on-premises identities into cloud. So for that purpose, you have Azure AD. As a developer, you don't have to worry about this, but your IT pros, chances are they have set this up for you. But as a developer, this is completely transparent to you. Maybe you have used a product such as ADFS when Azure Active Directory wishes to authenticate you to an on-premise AD. It can choose to federate authentication to a product called ADFS. Actually, to be precise, this federation mechanism is on open standards. So yes, you can federate to anything as long as it understands those standards. Purely in Microsoft world, there is another authentication mechanism that is Azure AD can use, which is pass-through, which works through Azure AD Connect. We won't dive into that because yeah, they are not outside of this developer needs to worry about. Um, I think it's clear that there is so much more here, but as a developer, I think you need to consider that your interaction is going to be Azure Active Directory, and that's the main character we need to worry about only. So let's continue. There are a number of open source libraries. So when we write all this authentication code without libraries, it will become very difficult. These are standards you need to follow. It's easy to make mistakes, so it's good thing that Microsoft has given us a library called MSAL, Microsoft Authentication Library, a precursor to use this used to be called ADAL. ADAL is one of the deprecation, but it still works, but the recommended path going forward is MSAL because it is OpenID Connect compliant. What does that mean? Well, we will get to that in a second, but MSAL, to be precise, is not a single library. It is family of libraries for different platforms that they support. For example, MSAL for .NET, there is MSAL for Node.js, MSAL for Python, and so on and so forth. Then there is another library called Microsoft.identity.pap, currently available in .NET Core and other .NET frameworks, which makes it very easy for you to target common authentication scenarios. But there are platforms that Microsoft doesn't provide in MSAL for. The good news is Azure Active Directory is OpenID Connect compliant, which means if Microsoft doesn't provide a library for certain platforms, let's say Ruby, Rails, for example, is a particular popular platform. Microsoft doesn't currently have an MSAL for Ruby on Rails, but there are open source or OpenID Connect certified libraries available for Ruby on Rails, and you are welcome to use them. So you can still make use of other platforms that are not supported yet by Microsoft. So then there is this whole concept of application management that is again part of the Microsoft Identity platform. There is a thing called gallery and non-gallery applications. Very prominent common applications that you may have already heard of, things like Dropbox, Cisco, WebEx, Google Apps. All of these can work with Azure AD. So they are called as gallery apps. Administrators can just research for them, point and click at them to their tenant, and ready to go. What about applications that are not as famous but they support a standard protocol? That would be non-gallery application. As long as they support something like SAML or OpenID Connect, they are welcome to be used in Azure AD tenant as long as the administrator allows it. Then there is a concept of single tenant and a multi-tenant application. Single tenant applications are designed to be used in your organization. Multi-tenant applications are applications that your organization writes that many other can use. Do you have an Android or iOS phone? Is there a mail app or on those? Can the mail app show emails from Office online? That mail app is a perfect example of multi-tenant app. It's been written by Apple or Google, but it can be downloaded from an app store and it can be used to talk to your email. Authentication is who you are. But what can you do? That is the authorization. All of that is also part of the Microsoft Identity Platform. Then there is concept called consent. Okay, this is app you are interested in, and this app wishes to read your mail. Do you allow that? Does your administrator allow you to allow that? All the management comes under the big bucket of consent. Then logging. Who was using this application at a certain time? When was the last token issued? All of that rich information logs. That's important, right? I could go on. There is a very long list of what Microsoft Identity Platform has when it comes to application management. So there is much more to it. But in a nutshell, I would talk only about these 5 things. So now let's talk about modern authentication when we talk about identity. Let's draw a line in the sand. What does that mean? Let me start with a little preface before I dive into what these mean. Modern authentication doesn't actually have an industry standard definition. So for the purpose of our discussion here, I will choose to draw this line in the sand based on what I think modern authentication is. So what is this? Legacy authentication? You know, a long time ago, there was something called a basic authentication. You literally just pass the username password in the header. Not so good idea, right? And so when we started encrypting it in one way or another, that was anti-LM. And then that was good, but it wasn't perfect. So we came up with something called Kerberos, where you had something like domain controller issuing tickets, and then the resource servers like your Exchange server on premises would give you a session granting ticket based on a ticket granting session. This stuff worked very nicely on premises, but it didn't scale to the cloud world, because of which we needed to think beyond these protocols. And these protocols, they are still here, they are still good, and they are still serving a purpose on premises and similar scenarios. But when we talk about identity at the scale of internet, cross-platform etc., then we need to talk about modern authentication. And when we talk about modern authentication, there are some protocols here. WS federated SML, which are based on redirects and HTTP posts, designed very much for web browsers, but have been armed twisted to fit in native apps or mobile apps. I won't get a chance to dive deep too much in WS and SML in this particular module, but I have covered this in alternative courses on my YouTube channel. Um, they then you have something called OAuth, which wasn't the authentication protocol. It was more like delegation protocol, which was like, hey, I am allowing XYZ application to do something on my behalf, but it was used as pseudo authentication protocol. So the world got together and established a more formalized origin of that included the user's identity in a standard format which is we call today as OpenID Connect. So after OAuth we formalized few things and we went to OpenID Connect. OpenID Connect is where we spend most of our mind shares on these days. I'm not saying that SML doesn't exist, it sure does. there are a lot of applications that still use SAML, but OpenID Connect by far is the most flexible, and going forward there will be something called as distributed identity. Note, not out there in the world yet, but that's the next upcoming thing in the modern authentication. So let's talk about OpenID Connect. When you think of any application, what do you think? What does that application look like? Hey, it's a user that wants to log into application. Now, I know in the back of your mind you are thinking, well, this could be a different kind of user. What if it's a robot identity? What if the application is a web app or native app? Or do these details even matter? Yes, these details matter. But I will get to those in a moment. But just stay with me here. You have a user logging into an application. Maybe there is no user. Okay, a user log into an application. Now this user logs into an app. The app knows who you are, the user, but now this app wishes to call an API. Now these arrows are blue for your purpose, because here thing becomes interesting. When you're calling an API, maybe you want to call not just under the user's identity, but maybe you want to use the application's identity to call an API. For example, if a user wants to read their own mail, then the user's identity is important. Well, when the user wishes to read all users' profile, then maybe the application's identity matters. Then maybe this API wishes to call another downstream API. So that is why when you log into an app, the app tries to call an API, and later on maybe that API itself is trying to call downstream API. What you do in this case, let's think a bit more. But now let's dive a little deeper into this. So when we talk about the application inside of OpenID Connect, there are many kind of applications. You can have SPA, JavaScript single page application. You can have native application, something written in WPF or Windows form, or maybe iOS mail application on your end or on your iOS mobile device, and on so on and so forth. Something that's natively installed on your machine. It's a thick client application. Perhaps a web application, a website you are logging into. Hey, maybe it's a daemon, a service, something like that doesn't have a user interface. It just needs to run in the background. Or maybe it's something with a very limited user interface, like a new IoT device, or maybe a fancy new hard disk you bought, but hard disk needs to talk to a web service for some reason. Maybe it connects to OneDrive. I'm just making things up, but it's possible, right? Each one of these different kinds of application and more have been thought through in OpenID Connect. We call these flows. For example, single page applications classically have used implicit flow, but browsers have progressed. The recommended use forward is to use alternate flow for SPAs called PKSE. Now, Azure AD supports both, but PKSE is recommended. Then you might have a native or web application. They use auth code flow. But there is a big difference. A web application is out of reach of the user, so it can securely store secrets, whereas a native application cannot. So a native application sometimes is also called as a public client, and a web application is sometimes called as confidential client. To be precise, a native and a SPA would be a public client. Anything that cannot be trusted with the secret is a public client, and anything that can be trusted with the secret would be confidential client. Both of these use auth code flow as the native and web both use auth code flows, but one uses it without a secret and one uses it with a secret. I'll show you what a secret means, but when I actually show you in the demo, But why is this matter to us? Because its confidential client is slightly more trustable. So refresh tokens issued are little more liberal in duration, but for most part, you don't have to worry about it. MSAL takes care of it. And then you have got daemons. Daemons are another flow called as a client credential flow. Client credential flow, well, they just say, hey, I'm XYZ app, here are my credentials, give me token for such or such scopes. Now Azure AD will give you a token because there is no opportunity to pick up and choose scopes, because there is no user interface. It will give you an access token for all the scopes that the daemon has been pre-consented to. What does consent mean? I will show you this in a demo as well, but at the high level it's thing, you can do things your application is allowed to do. What about applications with a limited user interface? They use something called device code flow. Device code flow is something like you are given little secret that you type into a user interface on a browser on an alternate machine, something like with a non-limited user interface, and then the limited UI device polls and says, hey, do I have a token yet? Have you finished authentication on that other fancy device you have? And if you have, then go ahead and log in. You understand? So I want you to understand the difference between these 5 types of application you might have for you, and the different type of authentication mechanism you might be following for these specific applications. Let's continue. All of those applications, when they wish to call an API, they present something called as an access token. An access token is set as header, authorization header in your HTTP request. When an API receives an access token, it needs to validate that access token. It validates it with the help of Azure AD. So you got that access token, then you call the API. API validate it using Azure AD, and Azure AD returns back. And now this diagram might be a little misleading because it's very simplistic. It doesn't actually send the token to Azure AD, although there are identity providers that support that as well. It is something called as introspection endpoint, which currently Azure AD doesn't have. There are some scenarios where you may want an introspection endpoint, but validating those tokens essentially relies on certificates. The access token has a signature part of it. Azure AD will provide a public portion of certificate, so you are able to validate that this access token is not being tampered with. And yes, all this communication must be on HTTPS. So you want to make sure that this access token is not stolen. Access token is like a cash. If you drop it $10 bill on the ground and pick it, it's mine. There is no way to know that it doesn't belong to you. Now again, if there are standards like proof of possession that get around this problem as well, but we are talking about basic OpenID Connect, where a simple access token, there is no way to know who it belongs to. And then yes, API can call another downstream API, and that process it can request Azure AD to give another token. Now when you ask for another token, if this API is calling downstream API using application identity, it may use client credential flow or something like that. But when it is using the user's identity, so the second token that you get, you should possess a user identity. Then it uses a specific flow called on behalf of flow. On behalf of flow, well, actually behind the scene looks very similar to client credential flow, but I think we are getting way beyond of level of details that want to cover in this course. But just understand that there is something called on behalf of flow that allows me to get a token for an API on behalf of a user. Well, I have mentioned this word token a lot, so let's cover this as well. But I hope this is clear to you how this flow works. So all these type of applications request using this access token in their header to an API. API validates with Azure AD, and then it says it is validated. The thing in reality doesn't happen like this, but it's a verification, which is a process. And then with this access token, it can call another downstream API, and this access token can be the same, or it can generate a new access token and then call the API. There are many multiple scenarios based on the requirements. In OpenID Connect, you mainly have three kinds of token. First is an access token. An access token is what you present to an API. It has got enough information that allows the API to know who you are and what you wish to do and whether you are authorized to do that. The API is expected to look at the token, validate it, unpack it as long as the token is intended for the API, and then make decisions based on it. An ID token, on the other hand, is the user's identity, the logged in user. This is intended for your application. If you log into website and the website wishes to know who you are, it bases the decision on the ID token that it received from Azure AD, and then if it trusts the ID token, it will establish a web-based session between the server and browser, and the browser meaning the user. Now, of course, a native application is slightly different, but they use ID tokens too. And then finally, you have got something called refresh token. Refresh token is something that you can use to get new access tokens. One of the scenario you may want a new access token is when the old access token is about to expire, but there could be other scenarios as well. So I hope it is clear the difference between access token, ID token, and refresh token. A lot of interesting talk. Let's solidify our knowledge with a demo. Let me show you how to register an app. Let's solidify our knowledge with a demo. Let me show you how to register an app in Azure and Active Directory. For that, and I will walk you through our basics of this. And for that, let's go to our Azure portal.
So now I'm back in my Azure portal, and as you can see, I'm on my home screen, and so for app registrations, I need to go to Azure Active Directory as it's part of the Azure Active Directory. Then in this side pane, left side, you see here I have multiple things. I have users, groups, external identities, role and administrators, administrative units, enterprise applications, devices, app registrations. This is what we need to work on. And I need to create a new app registration here. Here you see it is giving me also a warning that EDAL, which was old way of connecting with the Azure Active Directory, authentication library for Azure Active Directory is no longer supported. Anyways, we are not going to use it, but this is just extra information you see here. All applications will need to be upgraded to Microsoft Authentication Library (MSAL) and Microsoft Graph. We'll talk about it later when we use it in .NET SDK. So let's continue. When I click on this app registrations, it takes me to my own applications, and here I don't have any application. And if I click on this one, all applications, these are the applications I have in my subscription, and these were created by either by me or by deploying a resource using some automation. So for using CLI commands, and like last week we did some deployment using Docker containers, and for that purpose we created some service principles for demo ACR like this. If you watch previous videos, you will see them. So yeah, these were created by some commands. Anyways, we go here and I see I have no application here. And you can also check your deleted applications. So let's go to own application. And here you also see endpoints, and endpoints are really interesting thing to know actually, because you will get a lot of confusion here. I will go here. I'll go for the new app registration, the user facing display name of the app, and let's say test AZ-204. Accounts in this organizational directory only. So this is single tenant application. You can also select multi-tenant. I'll just go with the account single tenant. Then if it's an application which is which is a web application using web browser, then you can also use redirect URI, which is optional. You see here, you don't have to have it, but you can also use it. And you see here, you have a web, you have a SPA, you have public client native mobile and desktop app. So you can choose web, and then you provide a valid redirect URI, and sometimes you don't need it. um, and as I don't have any redirect URI, I'm not going to use this part. This is optional as well. So it is just simple as it is. You see, it is just created now, and I have my test AZ-204 app registration ready, and I can use it. View API permissions. It has already user.read on my Microsoft graph, which is by default provided, and I can also grant. You see here, I have options which we have already talked about. Grant admin consent for default directory, and I just granted it. I have the grant consent. So that's it. So my app registration is ready. If I go back uh, to my app registrations, and you see I have an app here. And if I go to details here, that's the client ID or app ID which I will need. Pay attention, I don't have any of these settings, which are also really important, because yeah, I need a client certificate or secret for headless authentication. I need redirect URI if I'm using the web part. So if it is from device or from browser, um, and then you also need an application ID URI, which is also not added. um, I just created this application, that's it. There are a lot of other things to do here, but I haven't done. Endpoints, you can uh, use it, and you see for different type of authorization, you have different options. I guess it's clear. Let's continue.
I would like to talk about authorization using Azure Active Directory as applied to both apps and users. So first, an overview of what we wish to talk about. Well, I think it's important to introduce the main character of this module, which is authorization. So let's understand what this means, what is authorization, and then through the demos, we will learn how the authorization applies to apps and users. And in each of one of these, I will show you 3 different ways. Therefore, there will be 6 demos in total, and then we will end up with a little summary. So, what can you do? So, what is authorization? Well, the definition for authorization is very plain and simple. What you can do, simple as that. Authentication is who you are. So, we have already have established through the authentication who you are. The next obvious question is, what can you do in my application? Are you an administrator? Are you reader? Are you writer? That sort of things. Here is a little advice from me. Do not over engineer authorization. It is very tempting. I have seen this mistake over and over again, and just because a platform allows you to do a lot of frequently, developers and architects will over engineer authorization, and then it becomes very hard to know what a certain piece of code might do at certain point, and it is hard for you to understand that. Imagine how hard it is for users to understand it. So keep it simple as you can explain it on a single sheet of paper in 2 minutes. Then, so when we talk about entities inside of Azure Active Directory as in things that can authenticate, I like think of them as two halves. First are apps, like service principal or managed identity, which are also service principal of whom credentials are managed by Azure Active Directory and they don't have a backing up app registration. So certainly an app can authenticate, an app can ask for an access token. The second main entity is user, a user logging or through their browser, iOS, WPF app, whatever mechanism they may use. But here an active user is signing in and providing their credentials, maybe doing MFA and things like that. So these two entities, the way they do authorization is very similar to each other, except remember, in the app there is no user, therefore there is no ID token. So when it comes to authorization, there are three different ways that Active Directory can help you do authorization. And undoubtedly, this list will increase over time. And this will increase over time, of course. First is group. This is pretty logical, right? Isn't it? I have a number of groups I can create in Azure Active Directory, and inside of that group, I can put my service principal and then the apps, or I can put users in those groups. And then depending on the fact that whatever you are in group 1 versus group 2, I would like to draw some authorization decisions based on that. The second are custom claims. Custom claims are information that you can put on ID token and access token based on which you can drive authorization decisions. For example, I would like to have a custom claim for user where I want to know what country they logged in from, and based on the country of origin, I may want to drive authorization decisions. And finally, you have something called app roles. App roles are something you define at app level, and then those roles can be assigned to a user or an app, and they surface up the necessary tokens. So let's understand these three multiplied by 2 as an apps and users. So 6 possible ways of doing authorization. So this is the first demo, and I would like to see how we can do group-based authorization for apps. In this demo, I'm going to show you how group-based authorization works for apps. Apps as in a user is logging in and application is requesting for an access token. So I want you to quickly walk you through this setup over here, and let's go to my Visual Studio. Okay, back to Azure portal. I am in my Azure portal and I am in my Azure Active Directory. There I am going to go to app registrations. I have already created two apps, and I will explain why too. So as I have already said, that what we are going to do is request token from an app for an API to call for that API. So what actually is happening is we are calling from this app, AZ-204 test app, um, Azure Active Directory, and get the tokens from that for this scope, right? To access other functions or services inside this API. So basically, this is the case where you call you from SPA or from other web application, you call your own app which is
where you are authenticated, and then the app decides if you can access the other service or not, and then on based on that the app itself act as user and it requests test API AZ-204 test API. So for this API it requests an access token to the um, Azure AD. Okay, so let's continue. And what else I have done is, if I go to AZ-204 test app, I have created it, and you see I have already one secret for this, because this is the base app which is going to make token request. So it also has secret because we need to use that secret to request the token. And then it also has things like API permissions. We will talk about what API permissions are, and it doesn't have any it doesn't expose any API. It doesn't need to, because we are not requesting token for this, but from this to API. Okay, let's go back to app registrations and go to test API, and here you see I don't have any client credentials because I'm not going to request any token from this API. So please note the difference, and I'm saying this again and again because I want you to understand this. I'm not making any call from this API. I'm making calls for this scope to work in future, and to consume this resource, so this API. Okay, let's go to API permissions, and here you only have user.read because I don't need to add any, but it exposes an API, because this is how I can use. So this expose an API which says it exposes an API like this for this scope, and the scope is for the user. So to give the access to the uh, app itself. So when I expose this API, and when I go back and go to my app here, and here I configure the permissions. Here you see I have added this. I just remove it. I will show you again. Add a permission, and in here if I go and my APIs, I see the exposed API here because I have exposed an API from this, and now I can select this as my uh, API, and I can just add this. So now I have added, and now I need to do one more thing: grant admin consent for the default directory, and then I say yes. So to revise, I guess it's clear. I hope it's clear, because what I'm doing here, I want to request an access token from this app for the scope of this app from the Active Directory, right? So let's go to our Postman, and here I have already created something called, let me make it a bit bigger. And here you see in my collection that I have a body, and inside the body, let me make it a bit bigger. Yeah, I have body where I have put my client secret, because I need client secret, because I'm doing a call for OAuth call to this OAuth call to get the token with a shared secret, and that's why I need the client secret. And then the scope is the API. The API, for that API I want to request a token which is coming from, so I'm requesting to Microsoft Online, saying that my credentials are these are my credentials, my client ID is this and client secret is this. That means I, as an app, requesting to the Microsoft Online to get the token like this. I hope it's clear. And then when I say send, when I say send and I go here and I get a token back, you see here, and this is a token which is simply, which can be read from jout. I can just post it here. So you see, these are my information on this token, and we have already talked about all this stuff, like audience is this app, and issuer is this, all these information we have talked about, and yeah, so you already know about this. And then if I go back here, you please note, pay attention here in the payload data, you don't have any information about, basically no information is there, not much information is there, and that is because we have not added any information. So to do that, I go back to my app registrations, I go here, and in the token configuration, because this is what is going to request token configuration, and I say add group claims, because we are talking about group in this demo. I'm going to going to say what properties I want to be displayed there, and so what I want to be displayed there. So I just say security groups, directory groups, now group assigned to the applications, like that. Okay, I add it, and now I have token configuration as group. So if I go back here, and maybe it might take some time, but let's see, we'll keep trying, and if it is refreshed or not, let's see what did we get. And this time I don't have any information about group yet, so you see there is nothing, and it takes some time. So as I said, it might take 30 seconds to be active, because another thing is this is cached here and might not be making I remove the cookies. Now if I do the request again, I might get it. Let's see. Okay, I see something different here this time. Still I don't see anything in here. Let me pause for a bit, maybe it is possible that, okay, and I waited a little bit and I did the same thing, I requested again, and then I got this JWT token, and now you see in my groups I have this ID, which is ID of that specific group I have claims on. So you see in the AZ-204 test API, I have token configuration for this group. One more thing I did was, if I go back to app registrations here in the group, this is another important part. So I created a group called AZ-204, and in this group I created a member, I added a member which is AZ-204 test app as service principal. So pay attention. Now what I did is I added this service principal to be part of the group itself, AZ-204, and then I go back here, and I go back here, and in the apps itself, I go here, and I added token configuration and added groups which are part of this app. So now I kind of added groups to be part of that that uh, token. So I hope it is clear. Let's continue and let's continue the next demo. Okay, so back to our Azure portal. Here I am in test API, and what we have already done is app requesting access token for for an API and uh, for this specific group. And now group-based authentication is done, and based on the response we can also do the authorization, but we want some extra claims. So I'm here in the API itself, and in the token configuration I have already configured group claims, and I want to do optional claims. And here you see three types of token type. One is ID, access token, and SML. Access to ID token is for user based login. Here we are doing app based login, so our app is trying to log in, not the user itself. So we are interested in access token, and in access token itself you have many properties, and you can add these extra claims in the token so that you can identify, or you can do extra steps in your so tenant country, in your in your application. So if I do these two things and add them, some of the claims require OpenID current scopes to be configured through API permissions page or by checking the box below. Okay, so they are added now. So now I should get these three things in my access token. As I said, this might take few seconds, but let's try again, and let's see what do we have in the access token. Nothing yet. It is only giving me the groups, but let's wait for few more seconds maybe. But as I'm recording this live, I will keep trying. First I will also remove the cookies. Okay, and then send the request again. This time it took some time, maybe did some magic, and it has the information we are looking for, and still not yet. I will pause for a few seconds. Let's wait. Okay, and this time I see something here which is tenant country and all. Okay, one more thing to notice here. What we did was we added email as property as well, which is an option here in the access token, but as I am requesting it as an app, I don't have an email address, right? It's a service principal. It's an app registration, so I am not really having an email address. So it is just registered in the Azure Active Directory as an identity, but it is not having any email. So I don't have any information about email here. You see, I only got the tenant country. So that was it. I hope you understood how to do and how to do claim based authorization. Okay, I'm back in my Azure portal, and in my Azure Active Directory. Here you see I have two apps which I registered. I created two app registrations, and I was consuming API test API from test app. That means I was requesting access token for this app, for this app registration or API from this app. What we have done till now is we requested as a group, we requested as claims, and now we are going to request as app roles. What I have already done is I have gone here, API permissions, expose an API, and I have removed that scope I created here earlier, and this stays here as it is. And then I go back here, app registrations, and if I go to app, also I don't have any API permissions here. These are removed, I removed them. So now what we need to do is we are going to um, authorize using app roles. So we go to app roles in the test API, which is the API for which we request access token. I go to app roles. I have already created an app role for admin. You can do like this, just add and both and do like this. I have already created this. And now if I go back in my app registration and go to my app, and here I add API permissions the same way like before. I go to request API permissions and go to my APIs. Here I should see AZ-204 test API, and here in the permissions part I should see admin. So I add this as permission, and um, you see the warning here: you are editing permissions to your application. Users will have to consent if they have already done so previously. So because we have changed, so they have to do it again, and I can grant it from my end like this. It's done. So now I go, so it's done from here. Now as it should take some time, if I request the same thing and if I do the same thing here, it will take some time. Let's see if it has updated. Yeah, it is updated, and you see here I have roles as admin. I still have the groups because I did not remove it. I forgot to remove. I still have the claims as NL. So you see in the final um, authorization for app, you have three ways, as I talked: group based, role based, and claim based. So I hope it is clear and you learned something here. Let's continue for the user. All right, I'm here in my SDL Studio, and I just wanna show you that I have an app, I have a client app, I have a service. You can consider them, this is like app and this is the app service API. And from this I was requesting tokens for this, and now we are on the second part. So we flipped the switch and now we are on the second part, which is we gonna request ID tokens for user specific and then do the authorization based on that part. So let's continue. I'm not gonna go in details here, but I will go to my Azure portal here, and I'm back to my app registrations. So up, if I go here, I have the same apps, but I have changed few things, and things are that I have, if I go to app itself, and in the API permissions, you see I have added this admin, and inside the admin it is just simple. You can just create new admin like this, and or you can add a permission. You say my APIs, click here, and you will see delegated permissions for the admin. Anyways, this time what we are going to do is go back here. Okay, this time what we are going to do is, as previously what we did was we requested token, access token from this app for this app, but this time we are going to request ID tokens, and for that part we need to work on the app itself. And if I go to app and API permissions, uh, sorry, oh, if I go to API, and if I go to API expose and API, here I have already exposed this API, and I go back here, and I need to
register the I need to register the redirect URLs, which is important part here. So here, instead of registering for ID tokens, I have registered for access tokens, and that's the main logic here. If you are requesting for user specific, then you need to register for ID tokens. If you are requesting for app, then you are requesting register. You should register this platform as access tokens, and that's the only difference. And let's just run. I just run this Visual Studio, and I just go to the page where I just see this page here, and I modified that a little bit, and here you can see it displays my name, my preferred username, and yeah, other things as well. And that is because I have selected here in the, if I go back in token configuration, I have selected family name, email, and these are the claims I have selected. So in the token type ID, I have selected these things, and that is why I am able to see them there. And how did I get started, or how did I get this whole application? It's very simple. I just went down here, quick start, and I'm going to look for the web application. I say, and what type of application I want to start with. I say app ASP.NET, and it's very simple. Now I have almost everything ready, and it even suggests me to make these changes for me. Then I can download the sample code, and then I just configure it. It is very simple, and I'm done. As we are here, uh, it is it is nice to understand things. So you are from web browser, you are requesting, you are being redirected, and it sends your web app sends back a redirect, and with that redirect goes to Microsoft Identity, which forms or does other things depending on your configuration. And in the back, in the response back, it turns you access token, and with that access token you can access the web API you want to access. So it's very simple, very nice, very easy, and then you can. It's really easy to get started with, but I don't want to go in details with this code. It is you who gonna do that. Yeah, it's because it's very easy, very easy to start. I will do another video on that. So let's continue from here. Same way, as we requested claims for user-based authorization, we can now add more claims to it, and it is the same thing actually. Uh, where I'm in token configuration, I can add more optional claims for ID token type. I have already added them, but you can add more things like um, given name or tenant country, things like that. Add them, and you should see them in the application itself. So I just gonna stop it and start the application again, and let's see. So you see here, I should have more things. Group name. So it's still not updated. It will take some time. Let's wait and watch. Sometimes it is just cache which is returning same thing, but in the end I should see these things. um yeah, I think it is fine. If you believe me, we can continue, because it will be bit of waste of time. And the last one is then app roles. I don't have any app role yet, and the same way as we did it for the application, we're gonna add app roles for this as well. So let's continue. Okay, this one is a little bit extra and interesting one.
user authorization using app roles. And here in the test app, as we are on the same Azure portal and Azure Active Directory, in the app registrations, we have two app registrations to revise you. And I'm in the test app. I go to in the test app, and here in test app I have created two app roles in the app roles. Just create two roles like that. And once I have created in the app two roles in the app registry in this app, now I need to do one more thing. That is, I need to go to um, enterprise applications. And this is a bit strange. You will say, okay, you are working in app registrations and now you're going back to enterprise applications, and this is a bit confusing, but don't worry. This is how in the beginning it was set up. If your application is having user interface, you are or you need to work most of the time in the enterprise application instead of app registration. So this is basically how it was designed, and that is basically you have more power, more things you can do in the enterprise application. So I'm in the enterprise application on this app on this app, and here I need to add users, and I already have a user called Nitesh Sharma. With this default access I can add more, and the same guy, select role, select assign. So this was default access, but now I have reader access, and I can provide another the remaining role as well, which is admin. I select admin, I assign. So I have all the access now. So that means, so now I, as a user, I have these roles. Okay, now if I go back to the application and if I do the same thing, if I run the application, now I should receive these roles in my response, and that means I can simply, and here I am, and okay, it has not, is it, no, not yet. I don't have the updated version yet. It will take some time. Okay, and you see here are a lot of identity claims, and those claims are under object identifier. You have other claims as well. These are tenant ID and name identifier. So this is how you get the claims, email address, whatever we have selected in the in the application itself. So I'll show you that thing here. Whatever you have requested added in token configuration, you should see that there. So that's it for now, and I hope you learned a lot, and let's continue.
Okay, let's end with a little summary. In this module, I talked about what is authorization, which was the main focus of this module. Then through the 6 demos focused on apps and users, I showed you the different ways the Azure Active Directory or Microsoft Identity Platform allows you to do authorization. Now I would like to end this with a little summary here. This is the end of this course, and I'm sure this course showed you some new concepts. I hope you learned something out of it, but I'm sure you have a lot more questions because Azure Active Directory and the Azure Microsoft Identity Platform is pretty big topic. There is a lot to learn here, so I hope you will continue your journey of learning beyond here and reach out to me if for anything you may need. Thanks for watching this course. Let's continue the journey and next part. You can leverage several services in Microsoft Azure to improve the security of your cloud applications. In this course, Microsoft Azure Developer implements secure cloud solutions. You will learn about security requirements for Microsoft exam AZ-204. First, You will explore Microsoft Graph to securely access Microsoft 365 services. Next, you will discover how to use Azure Key Vault to protect your keys, secrets, and certificates. Finally, you will learn how to use Key Vault reference for app services and Azure Function apps configuration settings. When you are finished with the course, you will have the skills and knowledge of secure cloud solutions needed to take the Microsoft exam AZ-204 developing solutions. So let's get started. In this clip of the module, we will show you how to use Microsoft Graph. We are going to talk about RESTful APIs as well as the SDKs. No learning experience is complete without a demonstration, of course. So in the first demo of the module, we will work with Graph Explorer. This is a great tool provided by Microsoft, and you can use it to get familiar with the available APIs in the Microsoft Graph. You can even call the APIs from within the portal. And finally, in the last demo of the module, we will use Microsoft.NET application, and we are going to use the Microsoft Graph SDK to do that. So Microsoft Graph is a great feature and it's here to stay. I'm so excited to share this module with you. So without further delay, let's get started. You have probably heard about Microsoft Graph here and there. So what is Microsoft Graph? According to Microsoft, the Microsoft Graph is a gateway to the data and intelligence in Microsoft 365, Windows 10, Enterprise Mobility Plus, Security, and as you know, Microsoft rebranded Office 365 to Microsoft 365 some time ago. For example, here are a few applications that you can work with using Microsoft Graph. The list includes Office 365, Windows 10, Enterprise, Mobility plus Security, Excel, Calendar, Mail, and many more. You can also use Microsoft Graph to query Windows 10. More on that later. You can work with the calendar. You can manage security incidents in Enterprise plus Mobility plus Security, or you can work with the user's mail. So Microsoft Graph provides a unified programming model that you can use to access data in mentioned products. As you probably remember, each of the products mentioned have their own set of APIs. For example, you could use the Excel API to work with Excel. You could use Calendar API to work with mails, calendar and mails, and so on. Now you have the single API called Microsoft Graph, which can significantly make your life easier. In even simpler words, using Microsoft Graph, you can treat the information in the Office 365 as data. This means you can query them and write to them. If you need more information on all the supported applications in Graph, take a look at this documentation where you can see that you have a lot of things. I will share that link in a while, because there you can see all the mentioned APIs and a lot more information about Microsoft Graph. And let's continue here. When it comes to Enterprise Mobility plus Security, you can work with Advanced Threat Analytics, Advanced Threat Protection, and even Azure Active Directory Identity Manager and Microsoft Intune. All of that through a single graph.microsoft.com API. When it comes to use Windows 10, you use Microsoft Graph to work with operating activities, devices, operating system notifications, or even universal print functionality. And finally, the last category is Dynamics 365 Business Central. You can use Microsoft Graph for management of financial data of the management of the project. So Microsoft Graph giving you a lot of flexibility, and this is the overview of small overview, I would say, not covering everything, but giving you what you can do with Microsoft Graph. A lot of things. teams, groups, calendar, files, messages, meetings, people, devices, user, coworkers, insights, tasks. You have a lot. So that's how you could use the power of Microsoft Graph. Let's continue. Now it's time to use Microsoft Graph in our application. To be able to call these APIs, you should have Microsoft account. You will use this account to obtain access tokens and call these APIs. Some Microsoft Graph APIs are only available with work or school or developer accounts. However, you can still test a subset of Microsoft APIs using free Microsoft Azure accounts such as MSN, Outlook, or your own. So, as you remember, we talked about two methods to integrate Microsoft Graph into your application, and you can directly call the good old REST APIs, or you can use the SDKs of your platform. So let's continue, and this is how you can work with Microsoft Graph. I will go to this Graph Explorer in a while. You should note this, and let's just do a demo. Just copy this this link and stay with me to do the demo with me. developer.microsoft.com en-us/graph/graph explorer.
So I'm here in the Graph Explorer, and you see I can request. I have at my hand I have a lot of getting started, applications, patching, Excel, extensions, group, identity and access, insights, Microsoft Teams. A lot of options available here, and I can use those options and make a run query and get the response back here. Like, so this is basically a sample, tenant sample, and I can use it. I'll talk about it more in detail later. Let's continue. All right, I am here in the section which is developer.microsoft.com and slash an slash us graph, and then I just clicked on quick start, and here in the API section I like this, I clicked quick start and I'm here. Okay, very easy and very good one. This is pretty simple, pretty straightforward. I'm not going to run any program here, but I want you to do this demo as well along with me. So what we're gonna do is, we are here on Microsoft Graph, quick start, Graph API. Then I just say, okay, I'm gonna work with C#, get a client ID. This will get me a client ID, automatically register new application in Microsoft registration portal, and embed the client ID, also known as app ID, which is simply basically it is going to just create an app registration here. Okay, so if I just refresh it, you see here I have only two, and I will just say get client ID, and this is gonna sign in, and it is just going to create a client ID here. And by the time, okay, just created client ID here. If I refresh, okay, it is taking app name. Thanks for registering. You configure client ID in the code sample. It created this graph.net quick start app name, and if I go here and I just select app registrations, I still don't have them here. Okay, anyway, it created the client ID, and now I can just simply download the code sample and run it. So I just download it and I'm ready. So this is what I want you to do, and continue doing that. So once I downloaded the app, and you see here I need to add few options, and these are client ID, client secret, tenant ID, auth, which is common. So I need to modify these things, and then I can just run this console application which I just downloaded. So basically what I want to say is, to get started with .NET SDK, you don't have to do much. It is just that you need to install a few things. You need to use Azure.core, Azure.identity, and Microsoft Graph, and that's it. You are ready to do anything now. And you see here you can do app only calls, user auth calls, so a lot of things you see in this example. I'm not going to go through all of this, but I just want you to know that you can just do it. So let's look here, and I'm ready. You see you are on your way to building app and can to continue following steps. You to manage and configure your apps, create a new one, or go to the Active Directory Admin Center, explore tutorials, more tutorials about graph tutorials, you explore SDKs and so on. So let's continue. Okay, after clicking on the running the app, what I have just downloaded, you see here I am in my portal, and how I arrived here is because it asked me to sign in, use web browser to open the page https microsoft.com device login, and then enter this code, and I did the same thing, and now it is asking me to grant access, so I give yes, and now it should you're gonna sign into a graph.net kickstart, and you can now safely close this window. So I'm signed in, and here I should continue, and I can continue working on it. So you see here I do have access token. If I want to continue, if I want to do something else, I can do list my inbox, and I don't have anything in my inbox. List users, make a graph call, I can say 5, and I can make a graph call. So basically what I wanted to say is use this tutorial to just to get started with it, and you will see a lot of things. For now I don't have anything in my calendar as well, not in my email address, because I'm not using this as my main address. So this is not the account I'm logged in with is not my um, Microsoft account where I have emails. So let's stop with it, and let's continue with the rest of the tutorials.
Everyone, I am Nitesh Sharma and welcome to this module. In this module, we are going to talk about managing keys, secrets, and certificates using Azure Key Vault. We will see how to implement and configure Azure Key Vault service. We will also learn about soft delete, purge protection features. You can move configuration settings for function app services to Azure Key Vault without any code change. And this feature is called Azure Key Vault references. And we will take a look at this as well. And finally, in the modules demo, we will use Azure Key Vault. So let's get started, and let's start by quick introduction on Microsoft Azure Key Vault. Azure Key Vault is an Azure service which allows you to securely store and access secrets. Imagine you have secrets such as connection strings. You can store them in this service and access them at runtime, and this is going to protect your secrets from accidentally checked into the source control or compromised by hackers. There are three types of secrets you can store in Azure Key Vault. The first one is keys. These are cryptographic keys which are used by other Azure services such as Azure Disk Encryption, Azure Storage Account Encryption at Rest, or SSE. The other types of entities you can store in Azure Key Vault are called secrets. And these are any sensitive information, including database connection strings and service passwords. And finally, you store certificates in Key Vault. And these certificates for Azure, for example, can be used to authenticate your service into target services or to secure HTTP calls. So let's continue. And similar to other Azure services, there are multiple pricing tiers that you can choose from when provisioning Azure Key Vault. The first tier is called standard tier, and the second is premium. The first tier called standard, and if you choose this tier, all your secrets will be protected by software. You can also go ahead and choose the premium tier. This is going to give you all the features of a standard tier, and also on top of that you have the option to store and protect your keys in hardware security modules or HSMs. Obviously the premium tier is more expensive. You can easily provision an instance of Azure Key Vault in the Azure portal or programmatically using PowerShell, Azure CLI REST APIs, and ARM templates. Here is how you can provision an Azure Key Vault in Azure portal. Simply, let's go to Azure portal and I will show you how to do that.
We are back here in our Azure portal, and you can see I have selected and looked for the source key vault, and here I am going to create key vault. So here, if you can see, it is asking me simply for a resource group where I want to store it. So I will say AZ-204 and then key vault name. And if I just go ahead say test, it is going to check if this is available or not, because still being reserved by vault which was previously soft deleted, please use a different name. And you see, if I just say test AZ-204, it is again looking for if it is available, and to verify must contain alphanumeric character and dashes and cannot start with number. So AZ-204 test tag of the day, and this must be available, and the reason is North Europe, let's say pricing tier standard or premium, as we talked about it already, standard, and it is asking me soft delete, and which is by default enabled, you see here, and um, days to return deleted vaults is saying 90 days, you see here, and I can say purge protection, so allows key vault and object to be purged during retention period, enable purge protection, enforce a mandatory retention period for deleted vaults and vault objects. So here by default it is disabled. You can enable it as well. Once enabled, this cannot be disabled, so you see, and the vice versa is possible. So it has just verified, or it is still verifying if the values I have provided are correct or not, and then I can just go ahead and create. So it has validated, and now I can just create, and it is creating the key vault. Let's wait a little bit. Oh, okay, it must be quick. So here I am, and it has created the key vault. If I go to this key vault, you see here it has created a vault URI, which is very important thing. Where we were selecting the key vault name, it should be unique. That is why it was not accepting, because it should be unique within this domain, and that means it should be unique key vault name on Azure itself globally. So that is why it wasn't accepting it. And if I go through this key vault here, you see here you have keys which we talked about, and these are the keys that you can use for some encryption purpose. You have secrets. We don't have any secret created yet, but you can create a secret. I go back. Okay, you have certificates, you have access policies, which you can specify who can access this. For now only admin is allowed, but the networking, if it is under a VNet or not. If it is under a VNet, then I need to add the VNet here, or IP address and all that thing. So for now it is just all networks. And then you have other things like for the security purpose, you have things like Microsoft Defender for cloud monitoring, automation, everything. Automation is really interesting in Azure Key Vault as well. So that's how you can create. If you just want to generate a secret, name blah blah blah, and the content type optional, and you can just create it. You see, you have one secret now, and I can check this its value. It is by default it is like dot dot dot, but you can show the secret value and you can just go back. Yeah. Then I can just go back here. I can go to secrets. I can even delete this, and I can delete it. So now that's it. Let's continue.
So we already saw how you can provision key vault on Azure portal. Now we are going to look at how you can provision key vault using Azure PowerShell, and same way Azure CLI. It is simple. It is very simple. You just have to say new AZ key vault, then key vault name, resource group where you want to create, and the location, and that's it. And by default it will take it as standard, so and you can create it. Next is creating Azure key vault using ARM template, provisioning Azure key vault using ARM template. And if you go to Microsoft documentation for creating Microsoft.key vaults, this is the resource type, and if you check it, it is very simple. You just have to um, give few values here, and key secrets if you have any, if you want to add them here, and that's how you can just simply create a key vault. I would suggest you to go to Microsoft website and to this documentation page where you can find microsoft.keyvaults/vaults, and there you will see this structure for Microsoft. Let's continue. The next step is to access it. There are three options that you can use to authenticate to Azure Key Vault. The first option is to go ahead and use the Active Directory app registration. Using this option, you need to go ahead and register an application in Azure Active Directory. After that, you need to assign permissions to this app registration service principal in the Azure Key Vault, and after that, any application using the app registration service principal can go ahead and access the key vault. The other option is using managed identity. This is preferred option over option 1, because as you saw in the previous module, using managed identity, you don't need to store key vault credentials in your case, client ID, and client secrets in the application registration file. And Microsoft also recommends using managed identity. The third option, which is also the newest option, is to use Azure Key Vault reference. And this option is only available if you intend to access Azure Key Vault from Azure Functions or App Services. And we are going to take a look at option 2 and 3 in the module demo. I'm going to provide links. Actually, not the links, but maybe I will do some videos where you can create the app registration, or I have already talked about how to create app registrations actually, and then you can access any resource because you have the access token, and then you just need to call the Azure Key Vault using that access token, as we did in the previous examples. So let's continue. So in this demo, we are going to provision an Azure Key Vault, which we already did both in Azure Portal and using Azure CLI, which Azure PowerShell, sorry, and that we already did, and then we continue, and then we are going to configure client application to use Azure Key Vault. So in this demo, we will configure a client application to use Azure Key Vault. We are going to do it using managed identity. So let's get started, and I will start my Visual Studio and create an app which you can easily find on sample Azure samples. I will provide you more details.
Access to that app registration, the contributor or other providing access to that app registration and your key vault, which is an app registration old way access. Then you have key vault, which is a normal old way, and
Then you
third
have
one is and then
access the key
referencing
vault
the
using
keyboard.
managed
Here
identity,
we are talking
and
about
third one is
using
then
managed identity,
referencing the
and
key
in
vault.
here
Here we are talking
this one
about
is simple, very
using
simple
managed
actually. So
identity, and
what I'm
in
doing
here
here is I'm
this
creating
one is
keyboard
simple,
URI,
very
which is
simple
simply
actually.
your
So
name,
what I'm
the
doing
name
here
of the
is I'm
key vault,
creating key
which
vault
we
URI,
created in
which
the
is simply
previous
your name,
demo,
the name of the key
and
vault,
here I'm
which we
creating
created
a
in the
client
previous
certificate client
demo.
using the
And
name of
here
the
I'm creating a
using the
client,
key vault
certificate
name
client
and the
using the
credentials,
name
and
of the
I'm providing here
using
default
the
credentials.
key vault
And
name
default
and the
credentials
credentials,
means
and I'm
um,
providing here default
to
credentials.
go a
And
little
default
bit in
credentials
detail
means
here, default credentials are the one
to
just try
go a
to get
little bit in
your
detail here, default credentials
current
are the
signed
one
in
just try
credentials.
to get
So
you
basically it will try
um,
to get you
current
log
signed in
into
credentials. So basically it will try to
indirectly
get you
logged in if you have
log in
already
through
previously signed in, and that is what I have
indirectly
done
logged in if
previously,
you
and
have
that's
already
why
previously
it will
signed in,
take my current
and that is what I have
credentials.
done
That means
previously,
I
and that's
as a
why
user,
it will take my
and then
current
you can simply get
credentials.
the
That means
certificate from
I
this
as a
client,
user,
and
and
that's it.
then
You
you
see,
can simply
I'm
get
getting
the
the
certificate
certificate
from
from
this
this
client,
client using the
and
certificate
that's
name.
it. You
So
see,
let's go
I'm
ahead
getting the
and execute
certificate
this.
from this client using the certificate name.
Um,
So let's go
I
ahead
hope it
and
will
execute
work.
this.
So I
um,
have breakpoint.
I hope it
I
will
don't
work.
need it, and
So
that's
I
it. It
have
is
breakpoint.
now
I
fetching the
don't need it,
certificate from the
and
from
that's
the
it.
key
It
vault,
is
and
now
it
fetching
should
the
give
certificate
me it gave me the
from the key
certificate
vault,
which I have
and
created
it
in
should
my
give
Azure
me
portal.
it gave
And
me the
if I
certificate
go
which I
here,
have
I can show
created
you
in
it.
my
This
Azure
one here,
portal, and if I go here,
refresh,
I can show
and this
you
is
it.
my
This
certificate,
one here,
and you see this
um,
certificate is
refresh,
like that.
and this is my
Okay, so
certificate,
we are kind
and
of
you see this
fine with it.
certificate is
Let's
like that.
continue.
Okay, so we are kind of fine with it. Let's continue. And another way is referencing key vault from your application itself. And how do you do that? We will see in a while. This is how we just got the first way of getting the key vault secrets like this, and we just created a client, secret client, and then you can just request get secret from this. But the second way is you can reference it, and you can say kv and the kv reference, and then you can reference it from your app settings, and you can just say secret URI is this one, um, and that's it. You will get the access to the keyboard secret. um, I'm not going into the details of it because it is very easy. You can just get a demo from the key vault. I'll put a link there, and you can easily find it. This whole you can easily find this whole web app demo app for key vault referencing. I hope it is clear, and let's continue. Okay, to give you basic idea about how referencing of key vault in Azure works is simply I'm here in Microsoft Learn documentation, where I'm just going to go through this article, use key vault references for app service and Azure functions. And this is very easy. How you can do this is you have to follow these 3 steps, and to do that is create a key vault, which we already did. Then you need to create a managed identity for your application, which means for our app service or for Azure function we create a managed identity. And key vault references will use this app system assigned identity by default, but you can specify a user assigned identity as well. So then create access policy in Azure Key Vault. For application identity, you can create um, which one, the one you created here, and then enable the get permissions for this policy, and do not configure authorized application or application ID settings, as this is not compatible with managed identity. Then you need to also think about network restrictions on the vault, which you can configure yourself, and make sure your application can access the key vault from the VNet if there is any VNet configuration. And then you can do these things by just configuring assign the application
assign the identity to your application. If you haven't already, then you can configure using key vault references in that. I want to quickly go to the reference syntax. So this is how the reference syntax is. At Microsoft.keyvault, and then you specify the reference string, and reference string is simply my like this, my vault.azure.net secrets, and then my secret or the ID of that secret, and that's it. So this is how you can add a reference to your secret in your application. And later on it talks about rotation, but this is not important for now. Yeah, so I would just continue like this, and then if you want to do more, this is how you can do later. Okay, I hope it is clear. Let's continue.
Okay, so far we created an Azure Key Vault resource and created secrets, keys, certificates inside it. These entities are important. There could be SSL certificate you just purchased or encryption keys for your virtual machine in Azure. There could be database connection strings and storage connection strings and so on. So what happens if any of these entities or even the vault itself get deleted? You are going to lose all that information, right? In the case of encryption keys, that could even result in your virtual machine in becoming unusable. So what do you do? So there is a way to protect these entities inside Azure Key Vault. Yes, the answer is yes. You can use Azure Key Vault Soft Delete, which allows recovery or of the deleted vaults and key vaults objects, which we just when we were creating the key vault, uh, I shown you the option. There was option for soft delete. So these objects include keys, secrets, and certificates. So recently Microsoft has made a change to Microsoft Azure Key Vault. So soft delete feature is automatically enabled for any new vault that you are creating. Also for existing vaults, you need to go ahead and enable soft delete because soon all key vault resources should have soft delete enabled. So I have added the link for the documentation page in the description below, where you can go ahead and look for Azure Key Vault soft delete. And first, you need to enable soft delete for your key vault. At some point in the future, a key certificate or secret or even vault itself get deleted. So simply go ahead on recover and deleted entities if you are still within the retention period. And the retention period is here. It might be 7 days or 90 days. And 90 is the default. When you are creating a key vault, you have the option to change the soft delete retention value. So when the soft delete retention entities will be permanently deleted, you can either wait for the retention period to end. In that case, the soft deleted entities will be deleted, and you can go ahead and permanently delete the soft deleted entities by performing the purge operation. To be able to run the purge operation, your user should have elevated permissions, and we are going to see that in this module and demo. What is Azure Key Vault Purge Protection? So when the purge protection is enabled, a vault or an object in the deleted state cannot be purged until retention period has passed. It also means that you go ahead and purge a soft deleted key. That key is permanently lost and you cannot recover it. So is there a way to prevent purge operation on a key vault? The answer is yes. You can go ahead and use the key vault purge protection. So when your purge protection is enabled, a vault run object in the deleted state cannot be purged until the retention period has passed. So you can use Azure Portal or PowerShell or Azure CLI and ARM template to enable soft delete and purge protection. This is how you do it. So you go in the Azure portal when you are creating the key vault, and make sure to specify the retention period for the soft delete. The default value is 90, and you can also go ahead and enable purge protection by simply selecting the appropriate option. Right, we have already seen this while we were creating the Azure key vault. can also use PowerShell to enable soft delete for existing vault. And yes, as you can see, this is the PowerShell command you need to use. In the first command, you get the reference to your key vault here, and then you just set the, using this resource ID, you just set the properties, and you get a reference to your key vault by specifying the name of it. After that, you just set the enable soft delete here. You can also enable soft delete at the point you are creating the vault, and the same goes for the purge protection. To do so, you need to use new AZ key vault command and pass enable soft delete parameter to it. And here you can see the PowerShell script to enable purge protection for your vault, and this is very similar to the command we saw previously to enable soft delete, where here you getting the reference to it and then you just setting the properties. Okay, time for another demo. Let's go ahead and work with Azure Key Vault, soft delete and purge protection using Azure Portal. And the second one, Azure PowerShell, you are going to do that. So let's go to my Azure Portal.
Okay, I'm here in my Azure portal again, and the previously created Azure Key Vault is here. If I go to overview of this Key Vault, and I see here in here I have soft delete enabled and purge protection disabled. So if I click on this one, I see that we had a soft delete enabled, and the in period was 90 days, but the purge protection was disabled. So if I go to secrets here and manage deleted secrets, I see an option here. The operation purge is not enabled in the access policy of the secret, so I cannot recover the purge protection here. If I go to certificates and same way manage certificates, I cannot do that. So if I go back here, overview, and in the purge protection, if I do enable purge protection, once enabled, this operation cannot be disabled. So if I save it and then I go to secrets, manage deleted secrets, operation purge is not enabled and access policy of this protection is enabled. So let's refresh it and let's try and create a secret. And refresh it. You see, okay, we have two secrets now. I think there was some problem, and I delete this. I delete this one as well, and it deleted. So now refresh. I don't have any secrets. I go here and I have option to recover the deleted secret, and I can just recover it. So if I go here back, take some time, there is some problem, but the thing is, I can, as the purge protection is enabled, I can simply
In these
import the
demos, we
secrets.
used
So
Azure
I
Key
hope it
Vault
is clear.
secrets.
Let's
You
continue.
can
In
also
these
store
demos,
keys
we
and
used
certificates
Azure
in
Key
the
Vault secrets.
Azure
You can
Key Vault
also store
resources,
keys and certificates
and
in the Azure
as I
Key
have
Vault
already done
resources.
that, I have
And
used Azure Key Vault
as
keys,
I have already done that,
which can be
I
then
have
used
used
for
Azure Key
Azure
Vault
storage
keys,
service for encryption
which
purpose.
can be then used for Azure storage service for encryption purpose.
So if I just create, if I just want to use
if
that
I just create
key vault keys
if I just
to
want to use that key vault
key to
keys
use for
to
storage service
key vault key
encryption
to use for
SSC, I can
storage
simply create a key in the Azure
service
Key Vault
encryption
and
SSC. I can
then
simply
name it
create a key in the Azure
something
Key
related
Vault
to Azure
and
Services
then
encryption,
name it
and I
something
can
related to
use
Azure
choose some
Services
algorithm
encryption,
encryption
and
algorithms,
I can
and
choose some
which is
algorithm
beyond
encryption
this exam,
algorithms,
but
and
you can
which is
finally
beyond this
create the
exam,
keys,
but
and if the key
but
is
you can
created,
finally create the
then
keys,
in the storage
and if the
account
key is created,
we just choose
then
that
in the
key
storage account
for your
we
encryption, and
just
then
choose that
your
key
storage account term
for
here
your
is that
encryption,
your
and then
storage account should
your
have
storage
access on
account
this key vault.
term here is that your
And
storage
then
account
storage
should have
account can use
access
that
on this
key
key
for
vault,
encryption purpose.
and then storage account can use that key for encryption purpose. So and we have already done this demo that how you can make use of Azure Key Vault for keys and certificates, like I shown you in the console application, that you can just reference to the certificate by creating certificate secret client, and that secret client can get any certificate or keys. So I hope it is clear, and let's continue to the summary what we have learned in this one. So we started this module with a brief introduction on Azure Key Vault. You can use this service to protect your secrets and access them at runtime. We saw how to implement and configure Azure Key Vault in the Azure portal and programmatically. We also talked about soft delete, purge protection. Use this feature to protect your secrets against being accidentally deleted. We also talked about Azure Key Vault references. You can use this feature to move up settings from function apps and app services to Azure Key Vault and reference them at runtime with no code change. In the few modules and demos, we also saw how to access Azure Key Vault using managed identity, how to work with Azure Key Vault references, and how to enable soft delete and purge protection on a Key Vault. So I hope it is clear, and let's continue. This part is over. This was the part 3 of the Azure 204, and we are moving ahead with the part 4. So this section of the path covers the objectives found in the monitor, troubleshoot, and optimize Azure solution sections of the exam guide, which include integrate caching and content delivery within solutions, instrument solutions to support monitoring and logging. Hi, my name is Nitesh Sharma. In this course, we are going to cover the integrate caching and content delivery within solutions element of the Microsoft Azure 204 certification. Especially, we are going to cover how to develop code to implement CDN, how to configure caching, expiration policies for front door CDNs, Redis cache, and how to store and retrieve data in Azure Redis cache. So let's continue. So with that, let's dive straight in. We are going to go straight into demo and start by deploying a simple web app before switching over to Azure and configure an Azure CDN endpoint. So let's get started and go to our Visual Studio. Okay, I'm back in my Azure portal here, and here you see I have created a web app which is named as CDN app, and I have a URL which is called cdnapp.azurewebsites.net. It is in resource group AZ-204, and I have FTP hosts, and yeah, that's it. So what I want to do is now use this web app and add CDN to it. So simply what you can do here is by going to networking, and there in the networking itself you can add CDN. So let's do that. I go to networking, and in the networking itself you see it is talking about inbound traffic, if I have any access restrictions, if I have any assigned addresses, private endpoints. And the second thing is it is talking about Azure CDN and Azure Front Door. We will talk about Azure Front Door later on. For now, we are only going to focus on Azure CDN. So let's go to Azure CDN, and here As you all know, it says content delivery network is designed to send audio, video, images, and other files faster and more reliable to customer using servers that are closest to users. So basically you put the content close to user, and that is why you have content delivery network. And here in the endpoints you have no endpoint. um, you and it is giving me option to create new CDN endpoint, and it is also talking about migrate custom domains to CDN. So it is asking me if I want to migrate any custom existing domain to CDN, and how can I do that. And there are three situations you might have. If I go to this, if you don't have an existing custom domain mapping to your origin, you can add a custom domain directly to your CDN endpoint. If you are having an existing custom domain mapping to your origin, you need to update this DNS mapping to the CDN endpoint. And if you have a custom domain and custom SSL mapping to your origin, you need to update this DNS mapping and enable custom SSL on CDN. So these are the three cases you might have, and here are the solutions for them. And it is talking about step by steps you need to take, you need to do in order to do a specific case, in order to resolve a specific case. So depending on your situation, you can go there and you can check which one applies to you. I'm not going to do that. I'm not going to go there in detail, but I'm just going to create Azure CDN here, and it is going to create a CDN endpoint for me now. And let's wait for a while. One more thing it is talking about is in order to create a CDN profile, you need to make sure that you have registered Microsoft.cdn in your registered resource provider. And to verify that, you need to go to your subscription, and then you need to go to resource providers. Here I'm in my subscription, Azure subscription 1, and then I go to resource providers in the settings, and here I look for Microsoft.cdn, and it's registered. And here it is talking about API versions. It is registered with these are the APIs I can use. And it is important if you are working with ARM templates, using uh, these specific API is really important there. So make sure you have registered Azure CDN, Microsoft.cdn there. And let's start. Need to create an endpoint. um, then continue. Another way of creating CDN is using this front door and CDN profiles. If you go to all services and you search for web, and then you search for CDN, before you used to have one more thing in CDN. Before you used to have two different things, CDN profiles and front door. Now they are combined and together, and if you go to front door and CDN profiles, previously these were two different things, two different separate done separately. So CDN profiles and front door. Now it is a single thing. And if you go to create here, it is asking you Azure Front Door is a secure cloud CDN, you see, which provides static and dynamic content accelerations, global load balancing, and protection of your apps, APIs, and websites with intelligent threat protection. And here it is giving you another option, which is custom create or quick create. You can say custom create, then design an endpoint with multiple domains, add endpoints to scale your deployments, leverage powerful configuration options to deploy custom. You have another option which is which gives you option to explore more about it, and then you go here. You see Azure CDN standard from Microsoft Classic, Azure CDN Premium, Azure CDN standard from Akamai. So you just go with the Classic here, and then you go continue, create one, and then you select the resource group and name of the profile. Just say
um, tech of the day, and it's global. CDN profiles are global resources that works across regions, and then create new CDN endpoint, which then will give you tech AZ-204. I hope it is available. Origin type is web app, and then origin host name. You get this one because this is the only web app I have in my resources, so it is giving this option. So next I go here, no tags to add. I go again here, and now my profile is being validated. It is validated now, and I can go and create CDN profile. So it is very different now what it used to be before, because these two things are combined together to eliminate the confusion between different options available to create a CDN. So I will show you once this deployment is done, because I have already created another front door as well, and I will show you how they appear here. So let's wait for it. So this is our deployed tech tech AZ-204 CDN endpoint, and you see here I can if I go origin app is this one, and if I go to endpoint, this is also page not found. Oops, your CDN endpoint can't find if anything new endpoint. So you need to still modify the CDN. Let's go here. Um, we will talk about it in a while, because why it's not displaying the one I expect. But before that, what I wanted to show you is we are here, all services, and here in what I have created is I have already created Microsoft CDN. I have created front door. Both are having same logo. You see, the service type is same. You see, this one is also displaying the same way. Uh, so basically, what Microsoft wants to uh, show you here is that they consider front door and CDN profiles kind of same service. Well, they are kind of same service because they are serving the same kind of purpose. So here in tech of the day, which is front door and CDN profiles, and it is on tech AZ 204. And if I go back, and this is front door, and if I go here, if I you see I have already configured this one, which is similar to this app. So the front door is working, because what I did is if I go to front door designer, you see here I set test is at 204.azurefrontdoor.net is pointing towards backend pools and routing rules, and backend pool is the test AZ, which is our web app here. So enough. I didn't want to talk about front door, but yeah, this in this topic I had to talk about it. But let's continue with the CDN. So if I go back to my CDN here, and you see what type of opportunities I see here, it is having this endpoint here. If I go to overview, it is having this endpoint here. I can add one more endpoint, um, and say blah blah blah. Origin path is that, no origin host name, where I will be able to select after web app is selected, I will be able to, and then I can add an endpoint. So my web app, okay, it is available. Add, and it is creating a CDN endpoint for me. uh, and now once it is done, it should be available.
And one more thing I want you to focus on is you can add custom domain to this endpoint which I just created, which is tag AZ-204. If I go back to the front door CDN, you see I have added two endpoints, and these two endpoints are serving origin hostname, which is this one, and then I can still add custom domain to it. That means this, when I say test azure204.com, let's say this is the custom domain, let's say, and then you can add it. But before doing that, as you need to do some steps which are like you need to create a DNS record for this that points towards this, and that you can do actually yourself, which is a very simple process, which is and then you can just add it here. So and then your custom domain will be available via CDN profile. So I hope it is clear, but before that, let's talk a little bit about origin. Here you see you have origin, which is created CDN Azure Websites Net, which is simply name CDN app Azure Websites.net, blah blah blah. Then you have custom domains, which I just talked about. Compression, which is you want few files to be compressed, and that is because you want them to be downloaded quickly, and that you can choose here. Caching rules, you want caching for your CDN content, then you can bypass caching for query strings, cache every unique URL, ignore query strings. So you have three options here. Geo filtering, then you have you want to allow geofiltering, allow, and then you say which country in geofiltering you want. So there are many things. So you see, manage geofiltering on your endpoint to block or allow content in selected countries. So I say allow here, but you can also block or not set. Optimization, and optimization you have enhances content delivery for your delivery scenarios. So use general web delivery for your regular static content and media streaming, and large web file download for optimization of specific types of static content. So you have general delivery. Use dynamic site accelerator to deliver dynamic content using advanced routing technology. So and then you have rule engine. You can create rules, you can add conditions here, blah blah blah. You can create multiple rules. We'll talk about it. And then you have locks. A lot of possibility. This is going to be a bit longer, so I will stop here and continue the course.
So we have seen how to deploy a simple application in Azure CDN endpoint. So it's probably a good idea now to get an architectural overview to show how a CDN actually works and its relationship with our web application, specifically the request and response cycle. So let's start with the basics. What exactly is a content delivery network? Well, a CDN is a globally distributed network. Think of it as a collection of geographically created servers, located servers actually, that help you deliver internet content faster to your users. It achieves this because the content in your web application is physically closer to the user. Therefore, download and latency is vastly reduced. A CDN doesn't help your web application load faster either. There are other benefits, but CDN can help reduce the bandwidth costs of your hosting provider by reducing the amount of content that the origin server has to handle. CDN can also increase availability and redundancy. Large volumes of traffic or hardware failures can cause problems for any websites. But distributed nature of the CDN means it's capable of handling significantly more traffic and deals well with network failures. So there are also some security benefits too, as CDN offers some protections against distributed denial of service attacks. So in total, there are 5 major benefits of using CDN: globally distributed network, reduced asset load times, reduced hosting bandwidth, increased availability and redundancy, protection from DDoS attacks. But now, any web application that you create is going to contain 2 types of content. Firstly, you can have static content. Now, static content is essentially things like images, CSS files, JavaScript files, anything that isn't created as part of the user interaction. And you have dynamic content. Now, dynamic content is anything that changes in response to a user's interaction. Imagine a dashboard with graphs or tables or some data that is generated as part of the search query. Now, content delivery networks are designed to deliver this static content, and these are the files that don't change between one user visit and another. So let's say we have an application deployed to our web host and it's accessed by user across the world. Now we can improve our application performance by delivering our static content through a content delivery network. Static content is essentially copied to different CDN servers across the globe, and these are known as point of presence servers. When the user accesses your site, they retrieve the static content from their nearest point of presence server. Because it's geographically closer to them, it has reduced latency, which improves the performance of your application. Let's look now at how CDN distributes our content by exploring the request response lifecycle. Now, when you first deploy Azure CDN, it doesn't contain any content at all. None of your files are distributed or available at any of the endpoints. So how do you make your files available? Well, it all comes down to request response lifecycle. Imagine a user makes a request for a file. Now, currently the CDN endpoint doesn't have copy of that file. So what does it do? Well, it goes to the origin web server or web host and retrieves it. The file is cached and remains cached on the edge server until the time to live specified by HTTP headers expires. If the origin server doesn't specify TTL, then the default of 7 days is used. Now, if another user makes a request for that file, then the CDN does now have a copy of that, and it can return this, and it's time. It doesn't need to round trip to the web server. So once this user requested, let's say this JPEG, this will request to the web server, and here it knows that it is already there. So a copy is created, and then if the next second user is ask for this, it gets in response from the cached results. Then it doesn't have to do this. Let's look now at the different techniques that we have for controlling Azure CDN. Let's look now at the different techniques that we have for controlling Azure CDN. Remember that your typical web application is made up of lots of different types of content, and why you want tabs or perhaps to apply different rules for certain areas of file tabs, or perhaps even different rules for certain areas of your application. And to do this, we need to use caching rules. But be aware these are within Azure CDN. But be aware these are only available with Azure CDN standard from Verizon and Azure CDN standard from Akamai profiles. If you're using Azure CDN from Microsoft profile, then you must use the standard rules engine. And if you are using CDN Premium from Verizon engine in the managed, then you have to use the Verizon Premium rules engine in the managed profile for the purpose of the exam and you should
apply your caching rule
focus
for the
on
purpose
using
of
the
the
exam,
exam from a
and
standard
you
query
should
zone or
focus
Akamai
on using the
profiles.
Azure CDN from a standard query
So
zone
you have
or
different types
Akamai
of providers
profiles.
as we saw while we were trying to
So you
create
have different
Azure
types of
CDN
providers as we
profiles.
saw while we were trying to
And I
create
explained
Azure
you we have
CDN profiles.
multiple providers,
And
multiple
I
things,
explained you we
and
have
those are
multiple
combined
providers,
together
multiple
in
things,
one part,
and those are
and you
combined
have
together
option to
in
choose.
one part, and you have option to choose which one you want to create. So with that cleared up, let's look at the rules themselves. First up with we have global caching rules, and now you can only set one global caching rules for each CDN endpoint, and this rule is applied to all requests that the endpoint receives. So you can use a global rule like this to override any HTTP cache directive headers that may have been sent to the clients. We then have custom caching rules. You can create as many as custom caching rules as you like, and these allow you to specify caching behavior for a particular file extension or a particular path within your application. Now, one thing to bear in mind here is that these custom rules are applied in order, and they will also override any global caching rule that you may have defined. Imagine if you wanted to set an explicit cache duration for 30 minutes of JavaScript files, then you would create custom caching rules to do this. Finally, we have a query string caching. This offers you a way to control how requests that contain query strings are dealt with. The query string is portion of URL that contains value in the form of key value pairs. Now there are three different modes that you can choose from to tell Azure CDN how to deal with query strings. The default behavior is to simply ignore them. In this scenario, the CDN passes the query string from requesting client through the origin server on the first request and caches the assets that returned. All subsequent requests for that asset are served from the CDN, and it ignores the query string until cached asset expires. So you can also bypass query string. If you choose this option, then requests containing query strings are not cached at all by the CDN. So the final option is to cache every unique URL. In this mode, every request with a unique URL, including the query string, is treated as unique asset with its own cache and its own time to live. Now, it's important to point out here that you shouldn't use this mode if your URLs contain query string values that change the every request. Doing so will result in a very low cache hit ratio and give you your app very poor performance. So we have already done a long demo in Azure portal, and but there were few things remaining for the caching and for custom query part. So I will go through this once more and just give you a little hint or examples in Azure portal. Let's go.
So back here in my Azure portal, and I am in the endpoint. Discard, I will discard and go back here. Um, in my Azure profile front end, I'll go back even one more further. So I'm here in my Azure CDN profile, and then I am in here. You see I have created endpoints, and I'm talking about these endpoints. So let's go one of them, and then in the endpoint itself you have multiple options. You have origin, which is just simply about and you can configure the origin itself, and create you can create another origin group. Other options are custom domain. We have already talked. Compression, which is you can set compression of the resources you want to compress because those doesn't change, and then you can just zip them to nearby server. Caching rules. Caching rules are three types of rules: query strings, ignore query strings, bypass caching for query strings, cache every unique URL, and you can just save it and say saved, and then it will save it. It will update the endpoint. You also have other things which we talked about. It is taking some time. Okay, it's saved. And then you have geo filtering, and then in geo filtering you have two part things: action and country or region code. So in the action, if you select allow, and then you say select some of the countries which you don't, sorry, if you say block, I want to show you, and you block someone from Afghanistan, and then maybe other countries who cannot see this, maybe from Pakistan or any other country. I'm just saying it's not something I want, right? So and then you save, then people from these two countries will not be able to browse anything using this endpoint. Cancel, it is still saving. So and then I geofiltering is done, and then optimization. So for optimization purpose, it says general purpose, optimized for general purpose, which we already talked about. You have also have used dynamic site accelerator, which is additional cost, and it is using some additional advanced routing technology. Then you have rule engine, which is very interesting. Use this global rule to configure actions that will always trigger, for example, cache TTL settings. Later rules with scooped match conditions will take priority. So you can add a rule here, name it test blah blah, add condition request body, and if request body, and then say contains, and then say um, and then say blah blah, if request body contains blah blah, and then yeah, and then your case transform, and you say to lowercase, and you save it. Sorry, you also need to add action. So this is the condition, then you need to add condition action. So you say URL redirect and contains blah blah blah, then URL redirect and permanent redirect moved to found blah blah blah, temporary redirect, and you say protocol https hostname blah 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 .com, and then you just say you provide a specific path, and that's it, and now you can save it. So you created a condition. A rule engine is simply a rule which says if this is true then do this, and in the if condition you have multiple options. And if here if I create another rule as I show you, you can create, and in the condition itself you can track multiple things, right? Device type, http version, request cookies, post argument, query strings, remote address, request body, request header, request method, request protocol, request url file extension, multiple things, right? Based on these things you can make some decisions, and then you can add some action to it. So I hope it is clear. And I'm back. So let's go back to rule engine we were talking about, and that's it. So and then you have logs. Log is simple. You can create a log test, and then log type read only nodes, and okay. So this is the log for this scope that you can create. I will delete it, and because I don't want any logs, And that's it. So I hope it is clear, and let's continue.
Azure Redis Cache is a Microsoft maintained implementation of the popular open source caching system Redis Cache. Redis Cache is popular because not only it can operate like as in-memory database, it can also work as database cache and even a message broker. Azure Redis Cache has 5 pricing tiers that provide you with different features, and 3 of them are. Let's take a look now. There are 3 standard pricing tiers that will likely be referenced in the exam, plus 2 advanced tiers, which we will briefly look in a moment. First, we will have the basic tier. Now, as you would expect, this tier has a minimal amount of features, support less throughput, and has a high latency. There is no service level agreement with the basic tier. It shouldn't be used in any production environment. In fact, Microsoft recommends that this is only used for testing and development purpose. You do get up to 53 giga of memory capacity through uh, and can have up to 20,000 connected clients. The standard tier gives you 2 nodes, a primary and secondary replicated node, and has SLA of 99.9% availability. And again, you get up to 53 giga of memory with 20,000 of clients connected to it. The premium tier enterprise grade Redis cluster that offers a complete feature set with high throughput and low latency, as well as 99.95% availability. With premium, you get up to 100 giga of memory, 40,000 clients, connected clients, and that's it. In addition to these 3 tiers, there are also 2 enterprise tiers, enterprise and enterprise flash. These tiers are for all of the functionality of the premium tier plus powerful enterprise ready features such as Redis module. They have 99.99% availability and are designed for massive yet cost-effective cache implementations. Enterprise Flash has the addition of fast, non-volatile flash storage. Now, within each pricing tier, there are several different skill levels, and you can scale up and down within your current tier. However, it's important to point out that while you can scale up a Redis cache, say from basic to standard, it isn't possible to scale down your current tier to a lower one. So, one of the things that you will need to understand for the exam is the impact that a caching policy can have on performance and integrity of an application. Typically, developers incorporate caching into their system architecture in order to improve performance and scalability of a system. When we talk about caching, what we are really talking about is temporarily copying some frequently accessed data to fast storage that's located close to the application. If the cached data is closer physically to the main application, then we will see significantly improved response time. So what sort of data should we cache? Well, caching is at its most effective when client application is repeatedly reading the same data, especially if that data generally remains unchanged. You also need to consider the performance of the main data source. Querying a SQL database considerably slower than retrieving data from Redis cache. Data contention is also a consideration. If you have multiple processes within your application, all competing for access to the same data, then you should definitely consider the data for caching. And finally, you should consider the location of the data. If your database is in another region or perhaps located on premises, then using a Redis cache can significantly reduce network latency. So I would suggest these 4 things to take into consideration when should we cache. Let's continue. So Once we have identified data suitable for caching, the next question is how long do we cache it for? Out of the box, when you add an item to Redis cache, it doesn't have an expiry time. That means it will exist within the cache until it's forcibly removed. Now, in some standard that might be fine, but typically you want your content to expire after a certain period of time. Now we can control expiration in Redis cache by setting a time to live TTL or expiration policy. That's the time period such as 30 minutes after which the item will be removed from the cache. And now there are no right or wrong answers here, but there are two guiding principles that you can use to help you determine what this expiration time should be. Firstly, there is a rate of change of underlying data. A list of countries is very unlikely to change and could be considered almost static data. This can be stored for a long time, whereas a currency exchange rate is more volatile and might change several times a day. And this kind of data needs to be cached for shorter duration. Secondly, you need to think about risk of using outdated data. What I mean by this is impact. What impact will it have on your application if your data returned from the cache is out of date, even if just for a moment? With dynamic data that changes often, you might want to apply lower time to live values that expire the data at the rate of change that matches that of the primary data source. This lowers the risk of returning outdated data while it's still providing buffer to offload database requests. So it's also important to recognize that even if you are only caching data for minutes or seconds, you can still greatly improve the performance of your application, resulting in a much improved user experience. Now, in order to set an expiry time for a value, you provide a TTL value in the string set method. And in this example, you can see that we are setting TTL for 3 hours, after which time this key will be removed from the cache. So let's do a demo. In this demo, we are going to look at how we can connect a web application to Azure Redis cache. And for this, we are going to be using Stack Exchange.redis client, and we are going to focus on how we can store and retrieve data as well as run simple commands. So here we are going to use Visual Studio, and let's go.
Okay, we are back in our Visual Studio, and here is a simple example. Actually, I don't want to go through the whole process. It's just an application web app. You can just create a web app, or you can get a lot of source code examples on while you create Redis cache. What I want to show you here is just simply how you can use Redis cache using Stack Exchange Redis, which is simply a library, and it comes with some models from Redis cache. Um, for the sake of injection, we haven't done much. It is just a logger and configuration injection, so DI injection. And here you see one important thing is I'm using a lazy uh, initialization of a type connection multiplexer. Okay, and here inside this I'm saying get me connect cache connection string, and then I connect to it. So I have a connection to the um, cache connection, and then here I get the cache value dot get databases. I create a cache model. I add some execute some commands. So builder, it's a string builder which is just used in the end to a string with the cache log. So if I start here, there's nothing happening. It's cache, which is a simple reference to the databases, and then it has some commands. so it can execute, and then you inside you put the command. So ping flushal, and then message. So it's a string get message, get the key, and then get set a key with the value hello from ASP.NET. So cache string set message, which is you are getting it here, and hello from ASP.NET, and you just say save it, and then get the key again, the same message, and then expiring message. So you say cache dot string get and get message, and then here you set the string set, uh, which is expiring message. uh, so wait for 30 seconds and get the key with the expired message. So simply we are playing with the cache here, and then you can execute cache clients model dot cache log, and then cache clients cache dot execute and clients and list with these execute commands with this parameters, and the parameters are simply these values. So what we are doing, what I want to say here is simply we have created a connection with the cache, Redis cache, and that's how you can use in your application, and it's pretty easy, straightforward, right? I don't want to execute this app because I have to go through all the things, setting up connection string here, which I don't want to set up, um, but I just need to add the connection string here. But you can do this, and it's a simple example which you will see in your any Azure samples, or if you don't find it, comment in the comment box below. I will make sure you get it. Yeah, I hope you like it, and let's continue.
Let's finish this module by looking at some best practices guidance for Redis cache. Now there is a lot of guidance available, but I only want to focus on things that might be relevant for the exam. So let's take a look. So firstly, you should always remember that Redis cache is an in-memory data store, and while it's highly available, it's possible for data loss to occur. You should never rely on a key being present. It may have expired or been evicted. We typically use Redis in between our application and our primary database. So this shouldn't ever be a problem if your system is designed correctly. If the key doesn't exist, then retrieve the data from the database and then cache it. Next, you should always set an expiry time on your cached objects. Now, as a rule, if you don't set an expiry time, those cached objects will live forever, with one exception. If the server runs low or on resources, in particular low on memory, then Redis can forcibly evict cached objects in order to free up some memory. However, this is something that you never that you never really want to happen. And setting sensible time to live values for your cached entries will help avoid this. So you should also look at introducing jitter into your expiry times. What you don't want is all of your objects expiring at the same time, as this will lead to an increased load on your primary data store. By adding jitter, that is varying the expiry time, you can spread the load over a longer period. You should also avoid caching large objects in the cache. If you need to cache large complex objects, then you should consider breaking them down into smaller separate objects and caching them individually. The reason for this is that storing and retrieving large objects can lead to timeouts. Finally, it's really important to make sure that your Redis cache is deployed to the same region as your application. Remember, you are using Redis to increase performance of your application, and this is typically achieved through reduced latency. So having your cache in a different region only serves to increase latency, negating the benefits of caching in the first place. If your application is deployed in multiple regions, then you should consider having separate caches in each region that your application serves in the Next module, implementing application caching patterns. We are going to explore the common caching patterns and how Redis can be configured for optimal performance. Welcome back. So in this module, we are going to be focusing on common caching patterns that you can use to increase your application's performance and scalability and resilience. There is a big emphasis in this exam on the architectural aspect of caching. So we are going to focus in on that here. Let's start by thinking about what people are trying to achieve by incorporating caching into their application. Now, here we are talking about caching in general. So that could be the use of SCDN or indeed the addition of Azure Cache for Redis. The underlying cache technology really doesn't matter here. Application performance is often something that drives people towards caching. Perhaps reducing the load time of a web application or reducing the number of round trips to a database cache can also make our application more scalable. They reduce the load on the key component in your application, such as web servers and databases, and make it much easier to scale out your application or services to more users. Caching can also make your application more resilient. If you have a read-only copy of your data in your Redis cache instance, then your application may be able to remain stable and responsive if your database server becomes unavailable. So let's take a look at some common caching patterns that you are likely to see in the exam. So consider this typical scenario. You have an application that reads and writes data to a database, perhaps a SQL database or some other data store. Now reading and writing to a database is typically a slow operation because the data store has to access physical disk to retrieve data. Now one solution here might be load the database into memory, but this approach is costly. In most cases, the database just wouldn't fit in the available memory. Now, this is the problem that the cache aside pattern solves. With cache aside, you store the most frequently accessed data in Redis cache so that it's quickly available without first having to query the database. First, you check to see if the cache already contains the data that you need. Now, if it does, then you use the data without having to query the database at all. If the cache doesn't contain the data that you need to have, then that you need, you don't have to query the data as normal and use that in data in the application. So you store a copy of that data in cache, so that's readily available for the next query. Now there are some things you need to consider here, some as lifetime of the cached data and how you maintain consistency. But generally this pattern will greatly increase application performance by reducing round trips to your database. Then there is content caching pattern. Allows you to use Redis cache a little like a content delivery network. To cache static content, that's the image, style, sheet, and web templates that rarely change in your web application. Using content caching reduces the load on your server, thereby increasing your application's performance. If you want to use content caching in ASP.NET applications, you can use this Redis output cache provider for ASP.NET. And then the third is user session caching pattern. They use a session caching pattern that allows you to use Redis cache for session storage within your application. Often when building a web app, developers need to maintain some form of application state between sessions. A shopping cart is a typical example of this. You want the user's cart to persist even if they close the browser, so that when they return to the site, they can continue with their purchase. Traditionally, this is done within session cookie or HTML local storage API, both of which have their limitations. Storing too much information in the session cookie hurts the performance of your application, and even the local storage API limits the amount of data you can store. A solution to this is store the data itself in a database and then only store a pointer to a key or a key to that data in the session cookie itself. But rather than use a traditional data store for this, we can use Redis cache so that we benefit from the faster access time to the stored data. So we have a session and a pointer to that session is stored in the session, and that whole data is stored in the Redis cache. So one of the things that likely to come up in the exam is configuring Redis cache for optimal size and performance. Why this is important? Well, it's important because when we create a resource in Azure, we never want to over provision. That is, create a resource that exceed our needs. If we do that, we end up with higher cost, which is something we always want to avoid. So now I'm not going to go through all the different pricing tiers and performance statistics, but you should at least familiarize yourself with these before the exam. Now, overall, there are currently 12 different tiers available within the Azure cache for Redis. But which one do you need? Well, for this, you are going to do a little bit of investigation first. You need to think about the number of objects that you're going to have coexisting within the cache. Now, this is going to be entirely dependent on your application that you are going to that you are working with. So only you are going to know the answer to this. Next, you're going to need to think about the size of those objects. Small, simple strings obviously take up much less space than large complex objects with lots of properties. Next, you should factor in the number of requests that you expect your application to make to Redis cache. Redis runs entirely in memory, and an empty instance typically uses about 3 MB of RAM. But obviously, this memory footprint increases as items are added to the cache. Now, a standard C3 Redis cache can process approximately 100k requests a second, but this will drop to around 90k requests a second over an SSL connection. Finally, you need to consider cache expiration. If the cache expiration policy isn't set correctly, you won't have a very good cache hit ratio. The cache hit ratio is the number of cache requests that return a result. If items expire too quickly, they won't be available when required, which just puts unnecessarily load on the cache instance without delivering any benefit. So now it's difficult to calculate these numbers accurately, but can make some estimations based on the size and the number of objects that you need to cache, as well as the number of requests you believe your application will make. Once you have selected and deployed your Redis cache, you can even test it using Redis benchmark utility.
So
So
in
in
my
this
Visual
demo,
Studio,
we are
you
going to
see
take a look.
I am
So in this
using
demo,
set
we are going to
SDK
take
into
a look
Redis,
and
and
how you
here
create
it's
resilient
simply
to Redis cache and
static
performance
control
connection
application which
to
will
Redis
look
cache.
simply
We are also
retry
going to
example,
take
save data,
a
and
look
do
how
those
you can
connections. So
control
save
the
data function
retry
is
behavior
caching some
for those
data.
connections.
Here
So we are
vehicle
going to
count
go
is
again to the
1000
Visual
random,
Studio. We are going to
and
go
this is
again to the
getting
Visual
a
Studio.
connection, cache connection from this. Here it's an interesting fact there. This part is static. So I have created a Redis connection helper which gives me static connection. So this is a same connection which will be used throughout the application. So here what I'm doing is simply setting vehicle for each loop in the vehicle count. So for 1000 vehicles I'm setting some speed and with this limit. So string dot set and with this expiry from minutes 10. Okay, so I'm setting for vehicle I, which is 1 2 3 4 5 until 1000, and setting the speed limit, sorry, the speed okay. And then I read the data. The second function, which is reading some cached data, I get the connection from the same Redis connection helper, which is if I go here, you will see it's a connection is a static value which returns the lazy connection, which is again a static dot value. So it's the same connection every time. Here then cache, so I have the cache and then string, and then I am printing the value. So it is perfect. I think it will just get the value from there. But um, here I'm also setting few things. Redis connection helper, is connection string, configuration options, and in the retry option I can set um, retry policy, which is simply a exponential retry 5000 back of milliseconds, and then connection timeout is 15,000 milliseconds. And with this policy I can set the connection policies, and then I'm just connecting this lazy connection. Simple, right? So and then here you see a random value between 5000 5500, retry reconnect after times in millisecond, and then I can reconnect, change the reconnect policy with these values. So in all, what I wanted to say is this is how you can simply connect with your database, Redis database.
Your application data in caching service such as Redis cache can raise concerns around security. Let's look now at what options we have for securing data within Redis cache. Firstly, let's talk about encryption in transit. That is one security of the message sent between your application and the cache itself. So transport layer security is provided by TLS. Out of the box, Redis uses TLS 1.2. Now, Redis does support actions over an HTTP connection that isn't secured, but that's not recommended for production environments, and you have to manually enable that within Azure portal. Securing the communication with TLS protects the messages traveling between your client and Redis cache, providing strong authentication, message privacy, and integrity. So, what about once the data arrives on Redis cache? Is it secure there? Well, we call this data at rest. Now, as a rule, all of your data remains in memory all of the time. That means that encrypting and decrypting data on the server side will put great strain on the memory consumption of the cache. For this reason, Redis encryption is not implemented and not supported on Azure, but the story doesn't quite end up here. You see, within premium pricing tier, you have the option to enable data persistence. Data persistence allows you to essentially keep your cache backed up to Azure storage account. Now we might then consider this data truly at rest once it's returned to a storage account. For this, data encryption is enabled and by default uses Microsoft managed key to do this. But you can provide your own encryption keys if required. So there is encryption. And welcome to the course Microsoft Azure Developer Instrument Solutions for Monitoring and Logging. And this first module, Introduction to Azure Monitor and Application Insights. Okay, so now let's discover the topics we are going to talk about in this course, in this part. So first of all, we will understand Azure Monitor structure, Azure Application Insight capabilities. We will discover service available in Azure Cloud and that help us track issues and detect bugs quickly. Then we will see how to configure instrumentation with Azure Application Insight in the ASP.NET Core Web Application. And then we will learn how to implement Application Insights, web test, and alert to receive automatic notifications when there is an issue detected in our solution. And at the end, we will see how to implement source code that handles transit transient faults. So in this case, we are going to talk about poly library, and we will implement retry pattern and circuit breaker. At the end, we will summarize the whole course. So the first module, in this module we are going to talk so the first module is specifically, so as I mentioned, we are going to understand Azure Monitor structure together with application insights capabilities to enable monitoring our solutions built on Azure cloud. Then we will configure Azure application insights resource in the Azure portal. We will configure instrumentation with this in Azure application insights resource in the ASP.NET web application, and then we are going to analyze log data and troubleshoot solutions. At the end of the course, we will summarize the whole module. Great. So let's get started. Before we jump onto the Azure Application Insights resource, we will discover how to monitor solutions. It's worth to zoom out and understand Azure Monitor structure. So let's go. At the center of the diagram, there are data stores for matrices and logs, which are two fundamental types of data used by the Azure Monitor. On the left side, there are sources of monitoring data that populates these datas. On the right side, there are different functions that Azure Monitor performs on this collected data, such as analysis, alerting, streaming, and to the external systems. I mentioned that there are two fundamental types of data used by Azure Monitor, so metrics and logs. So this is the external who consume the data. This is Azure Monitor using the data in the form of metrics and logs, and these are the resources. So metrics. Now let's discuss them briefly. Metrics are numerical values that describe some aspect of a system at a particular time. Example of metrics can be CPU or memory usage value. Logs, then there are logs, and logs are events that occur within the system. They can contain different kinds of data and may be structured or free-form text with a timestamp. Example of the logs can be information about the exception that was from within application during the execution. Now let's discuss Azure Monitor capabilities. With Azure Monitor, we can correlate infrastructure issues. So we can try to imagine that we have a solution built with Azure, the virtual machines. For instance, we can easily detect that there is not enough memory with Azure Monitor. We can also detect and diagnose issues across applications and their dependencies. So it doesn't matter which kind of language we use to write our application, still with Azure Monitor we can detect issues. Azure Monitor also provides support for the operations with smart alert and automated actions. So once there is an issue detected, we can easily receive email notification, and of course with Azure Monitor we can create visualizations with Azure dashboards and workbooks. So there are basically four capabilities described. There are many more, but these are basically four grouped together. So correlated infrastructure issues, detect diagnose issues across application and dependencies, support operations with smart alert and automated actions, create visualizations with dashboards and workbooks. What kind of data does Azure Monitor collect? It's a quite large volume. With Azure Monitor, we can collect data about the performance and the functionality of the application's source code. So it's very important because we can integrate Azure Monitor SDK with our application and the exceptions quickly, and also some bugs within our code. With Azure Monitor, we can also collect data about the operating systems on which our application is running. We can extend the data volume and collect data about the operations of Azure resources. So we can collect data about the performance of the Azure web app or Azure SQL database, and of course we can collect data about the operations of tenant level Azure services such as Azure Active Directory. At the end, there is one more important fact. Azure Monitor can collect log data from any REST client that allows to create custom monitoring scenarios, including on-premises solutions. So, first of all, let's answer the question, what is Azure Application Insight? Azure Application Insights service available in the Azure Cloud is an extensible application performance management service for developers and DevOps professionals. And as I mentioned in the previous clip, Azure Application Insight is part of Azure Monitor. So now let's discuss a simple solution built on Azure Cloud. So let's try to imagine that we have a web application that is integrated with Web API component, and this Web API component is integrated with the database. And of course, there can be some external systems integrated with this Web API. But in general, this is our whole solution, and of course inside those different applications like Web API or Web App, there can be some potential issues. So to detect them easier and detect them quickly is worth to integrate those components with Azure Application Insights. And once the data is collected by Azure Application Insights, we can access this data either by using visualization tools like Power BI, or we can use direct REST APIs or Visual Studio integrated development environment. So basically you have resources, you have application insight which use or these resources, and then these are the tools or systems that can be used to display that information. Then application insight capabilities. Perfect. So once we know that Azure Application Insight can help us detect issues quickly, it's worth to discuss Azure Application Insight capabilities in detail. With Azure Application Insights, we can check performance of server machines like CPU or memory users. So if we host our instance, if we host, for instance, our web application on the Azure Web Apps service, we can check whether applied service plan is enough, because maybe it should be increased. With Azure Application Insights, we can detect thrown exceptions in the application's source code. It is very important because we can detect bugs quickly. With Azure Application Insights, it's possible to add custom events and metrics in the client or server code to track business events. So in this case, if we have a web application and we would like to track user behavior with Application Insights, we can do so. This is not enough, because with Application Insights, we can collect request rates, response times, and failure rates. And of course, with Application Insights, we can collect page views, load performance reported by the user's browser. As you can see, Azure Application Insights is quite powerful tool. Now it comes to the Application Insights integration with the application's source code. There is quite large volume of SDK available for the different language and frameworks. Let's take that out. We can use Azure Application Insight SDK with ASP.NET, ASP.NET Core, Java, Node.js, React, Python. But then you can ask, that's fine, and it is, but this is for the web application. But what about desktop and mobile apps? For those kind of applications, there is a separate service called Visual Studio App Center that enables you to collect data from mobile and desktop apps and then export this data to Azure Application Insights. So you have App Center, Visual Studio App Center, which is used to send the data from WPF, Android, iOS device apps, and then that can be collected in the App Center diagnostic UI. There is another question. How can I see collected telemetry from my applications? There are a few ways and features available in Azure Application Insights to do this, and let's discuss them. First of them is smart detection. Smart detection automatically warns you to potential performance problems and failure anomalies in your web application, so we can access the list with potential issues detected in our web solution. So this is provided by Microsoft itself, Azure itself, and it's a smart detection. That's why it's called a smart detection. Then you have application. Another feature is called application map. Application map helps spot performance bottleneck or failure hotspots across all components of the distributed application. It's great because we can visualize what happened when the request was sent from one component to another in our Azure solution. So you basically know the flow. So then you can derive some solution from it. Another great feature of Azure Application Insight is called Live Metrics. Live Metrics tab, we can access real-time information about application performance, so we can see incoming requests, outgoing requests, overall health, CPU usage, memory usage, exceptions rates, and some other interesting details. And that is live metrics. Then once we discover that there are some issues and failures inside our application, it's good to read about details. And in this case, failures tab is the way to go. It provides details about issues detected inside your applications, like exceptions and server errors. And great. So you understand what Azure Application Insight is and what are capabilities. So now it's time to create your own Azure Application Insights resource inside your Azure portal, and this is we are going to do in the next step. Just try. Let's continue. So in this demo we are going to learn how to create Azure Application Insight resource in the Azure portal. Then we will overview the application insight tab and access instrumentation key that we will use in the .NET application. And let's go.
Okay, I'm back here in my Azure portal. I am in the CDN app which we previously created, and yeah, I'm not just gonna create new web app. Actually, I'm just gonna use the same. And well, when I clicked on my configuration, here you see App Insights instrumentation key, and I see many more things here, and which are Application Insights connection string, Application Insights agent extension version, and these three things are added when I created this app and I selected the option to create application insight. So by default this application insight was created with while I created this app. And if I go to the tab application insights, which is in preview, I see here it is enabled, and collect application monitoring data using application insights. Here you see the app is connected to the insight resource which is also named as CDN app. And here you see instrument your application, and here you can see you have some examples, um, and some suggestions here you can use, basically. And so that's about connection from the web app to this application insights. um, if I want to see application insight, I'm here in the application insight itself, and here you see I see all the things which are related to application insight. Let's go through one by one what we just talked about. So you see here two things you see here in the application insight app which are really important for your application. First is instrumentation key, second is connection string to this instrumentation key, and these two things are used in your .NET Core app. I'm not going to create an app and use it, because there are a lot of examples on Azure samples where you just have to use um, that as connection string and your app is ready to be used. Even if you just add this instrumentation key in your config, as I just shown you in my previous while I was showing you the app itself, that's enough. It will automatically collect the failure errors, many errors, and which are automatically collected. So apart from that, you see one more thing, which is workspace. This is the workspace which is by default created because I created it, but this is the log analytics workspace. So application insight uses a workspace, because that workspace is where you are holding all your data, all your logs. Basically, this can be shared workspace, which then can be used by multiple other applications and share across your application inside as well. So basically, that's it. These are the three main important top things I wanted to talk about, and then let's go through the application map. In the application map, it's loading actually, because the app is not being used a lot, so no data. You can add the intelligent view, but doesn't matter because there is not much data, but you can see the uh, memorial view of your data. This is smart detection, which we talked, and there is no data, so you don't see much here, but yeah. And then you have live metrics, which we also talked about, which shows you the live data to your application. Then you have transaction search, you have availability, and this shows your overall availability of your resources using it. And then you have failures. So this is especially in the default data reported or logged from your app while while user perform any queries to your app. Performance, then again performance is shown here, how your app reacts to any request. So basically this is it about application insights. I hope it is clear, and let's continue.
Basically, this is for you to do actually, because I am not going to do the demo here. But what you can do is easy to get some examples from Azure sample GitHub repository and just go for it. The main key point here is instrumentation key, which you need to create your application insight, or you might have created it while you were creating a web app. So just pay attention to it, and by default your SDK reports all your failures, exceptions, user requests to the application insight. Let's check it out. I want you to check it out actually. So good luck with that. Then you have second part. After you have integrated application insights, you need to analyze logs and solve issues. To analyze logs, you need to check for the exceptions, and those exceptions are really easy to find out, because once you go to the application insights, you see all the requests there. You can then go to that particular request which failed, and then in that request you will see the log, and logs are so much detailed that it will give you stack trace of exception, so you can easily go to your source code and fix the problem. So this is another challenge for you to do. You just simply have to uh, yeah your app must run for some time, and then it will automatically cause some failures, and then it will log ultimately, and then you can check it out. Really good example for practice. So summary, what we did, um, We learned about Azure Monitor as a tool to monitor performance and issue related to application and services hosted on the Azure cloud. We learned how to create and use Azure Application Insight resource as an extensible application performance management service available in Azure cloud. Then we saw how to analyze data and troubleshoot solutions with Azure Application Insight. I hope you enjoyed this module and you will stay with me to learn how to implement alerts and handle transient faults in the next module. So, welcome to the second module, Implement Alerts and Handle Transient Faults. My name is Nitesh Sharma and I have the pleasure to guide you through this course. In the previous module, we talked about Azure Monitor structure and we learned how to create Azure Application Insights resource in the Azure portal and how to integrate it with existing ASP.NET Core or ASP.NET application. How to collect elementary data. Let's see the topics we are going to talk about in this module. First, we are going to talk about availability tests and how to check responsiveness of your web application. Then we will learn how to receive automatic alerts when your app is not available. And in the end, we will see how to react on the transient failures in the application source code to make your solution more resilient. So let's get started. And in this clip specifically, we are going to talk about how to monitor availability with Azure Application Insight Web Test Alerts. With Azure Application Insight Web Tests, you can set up recurring tests to monitor availability and responsiveness of your web application and web services. And this is very important because you can try to imagine that your solution has many different web APIs. For instance, you would like to automatically check whether each endpoint is available and can return data. So now when we when talking about tests, there are different types of them. So there is a single URL test that you can create in the Azure portal, and with this test you can check availability of a single endpoint of your web API. But you can also use custom track of availability tests. So type of tests. So those send information about availability of an application using track availability method from SDK that we used in the previous module. And of course, also multi-step web test, a recording of sequence of web requests, which can be played back to the test more complex scenarios. And of course, one of the endpoint is available. We can automatically be notified. Azure Application Insight can alert you if your application isn't responding, if it responds too slowly during the availability test. Now, let's look at the simple diagram. There is this web application and web API. And now we would like to run a availability test for all the application endpoints available in this API. And once one of the endpoint is unavailable, we will be automatically notified by the Azure Application Insights. When talking about alerts, it's also important to mention about an action group. So yeah, we will discuss this bit more detail in the next one. But Application Insight then can alert, say, 404. But an action group, what is an action group? Because when you are talking about alerts, you need to talk about action group. An action group is a collection of notification preferences defined by the owner of Azure subscription. Azure Monitor and Service Health alerts use action groups to notify users that an alert has been triggered, and each action is made up of following properties: type, so notification or an action performed; name, unique identifier of the group; and action, so for instance a webhook. In the end, once there is a failure, new alert is sent to the target group. So in the next demo, we are going to learn how to set up availability tests and alerts. In this demo, we will learn how to configure application insights, availability tests, and alerts, and To be more specific, how to set up availability tests, how to create an action group, and how to receive and investigate alerts. Here I'm going to Azure portal and let's check out.
So here I am back in my application insights, and inside the application insight I see in the investigate I am in the availability, and in the availability sorry, in the availability I have the two possibilities to create test, and you see here add classic test, which gives me the test name, test 1, and then there are two things, URL ping or multi-step. And the multi-step you upload a web test, and the URL ping you just ping the URL and then you say google.com. I'm just typing anything. Okay, you should start with HTTPS. Okay, and then that's it, and then you say test locations, success criteria, alerts, and the alerts, in the alerts you have enabled. So create. So now the availability test is created, test 1, and you see it will start performing. And then you also have a standard test which you test to, where you give the URL, you say parts dependent request, enable retries for availability test, proactive lifetime checks, test frequency at which test will be executed periodically, and test locations. And then you can simply create a URL. I will say again HTTPS, although I shouldn't do like this, but I'm just google.com. Basically you understand what I mean is. So, and then I created a second test, and we have to come back here after some time to have real, you see, okay, the availability test, and it was successful, 5 successful calls. So if I go back here, and you see here the first test was successful and then done successfully. So that's about it. I can delete them because I don't need so yeah. Yes, one more thing I forgot. Then you have open alert rules. So one, the uh, the app is that the test is created, as we talked, we need to create alert rule as well. So here in the alert rule I can say custom log search, all administrative, blah blah blah, web test, right? So let's say this one, and then over the last 6 hours, I say event selected, critical error warning. I don't say warning, I don't want informational verbose, I want only critical and error status, failed started and round one succeeded, and then event, all services and users, and I can just say review and create. But one thing you see, you need to, I think we are missing one thing, which is actions as well. So we need to create an action group to create an action, because you create alert, but what type of action group you need. So you select this, you have the action group smart detection here, which sends 2 email to Azure resources, and which is email Azure resource manager role, and you email Azure resource manager, which is a type of here email, yeah. And in the details, alert rule name, email alert. Okay, and that's it. So I am going to create an alert as well. So basically what we did now is we created a test, and if test fails, it is, you see, it is doing from multiple servers, and then if a test fails, it just sends alert. And alerts are what you need to specify those alerts. So you need to go here and in the alerts part, sorry, and here we created alert rules for this specific test, and that is target group is CDN test1 CDN app and test CDN app, which is availability test, and this one is application insights. Okay, so I hope it's clear, and let's continue.
Implement code that handles transient faults. We are going to talk about handling transient faults, but before that, it's good to answer that question. What transient faults are? Transient faults include the momentary loss of network connectivity to components and services, the temporary unavailability of a service, or timeouts that arise when the service is busy. Let's put some examples here. In the previous module, we saw cars. We created a test in the portal application that enables checking all the that was pinging Google, let's say, and if the Google is not able to communicate or respond, let's say it was behind the scene, Google is doing some other calls, and if it is not able to do that call, let's say, and it is communicating with an API, and let's say it is not able to communicate with that API and retrieve all the available data, but after trying a few times the endpoint can be available again. So that is transient fault, and this is related with the transient faults because maybe there was some network issue, and after another attempt all available um, data will be retrieved successfully. Of course, there are some challenges related to transient fault. Transient faults can have a huge effect on perceived availability of an application, even if it has been fully tested under all foreseeable circumstances. To ensure that cloud-hosted applications operate reliably, they must be able to respond to the following challenges. Application must be able to detect faults when they occur and determine if these faults are likely to be transient. The application must be able to retry the operation if it determines that the fault is likely to be transient. And if the application, of course, must use an appropriate strategy for the retries, because you cannot keep trying. This strategy specifies the number of times you should try. Now, to make our application more resilient, we have to apply some changes in the application source code. Of course, doing it manually can be time consuming and challenging, and that is why it's better to use great library called Poly. It's on open source library that provides retry pattern implementation, timeouts, and circuit breakers. So that can be used for deciding what retry policies you use. So let's start with the retry policy. Retry enables repeating the same operation again X number of times before giving up. In this case, we can send the request to the specific service again after some time. Then we can wait before sending the next request. We can configure retry times and retry intervals between requests. And then we can also add the circuit breaker policy. If something goes wrong, hit the panic button that prevents any further attempts to repeat the operation. So in this case, service is unavailable and cannot respond to our request. We want to avoid sending requests for some time. When the circuit breaker is open, no request is sent until it is closed again. In the next demo. I'm not going to show you how to incorporate poly library. It is pretty simple. It's open source library and it's available in the market. It's out of this course, but if you want to get familiar with it, it's better to use it's using a specific syntax, and you just need to use it from your nugget package. So, and then you can get familiar with retry policy and circuit breaker policy. So we have learned a lot in this module, and it's time to summarize it. We have learned how to set up availability tests with the Azure Application Insight and how to configure application groups, action groups, to receive email notifications once there is an issue with our application. We saw how to make application more resilient using retry and circuit breaker patterns. You integrated poly libraries with existing ASP.NET Core Web application or .NET Framework, any recent 6 or whatever you used. And thank you so much for watching this course. I hope you enjoyed it as much as I did, and thank you once again and good luck. So we have completed till now 4 parts, and this is the last part of the series, developer solutions, AZ-204 certification exam. And if you have made it till now, I really want to congratulate you. You are almost done. So Azure API management enables publishing APIs to external partners and internal developers. It is a way to create consistent and modern API gateways for backend services. In this course, Microsoft Azure Developer Implement API Management, you will learn about Azure API management capabilities and how to interact with how to architect API integration in Azure. And first, you will gain understanding about the components of Azure API management and how to create Azure API management instance in the Azure portal, of course. And then you will discover how to protect your APIs from unauthorized use with API keys and client certificate authentication. And finally, we will explore how to implement policies to improve the performance of an API by adding a caching policy and implement throttling to prevent resource exhaustion. By the end of this course, you will have the clear overview of how Azure API management is structured and how to provide secure, scalable API access to your applications. And if I talk about this module, first we will learn how to architect API integration in the Azure cloud, and we are going to discuss why it's important to use API management in some scenarios when building cloud solutions. And then we will understand the components that are part of Azure API management service in Azure cloud. And of course, we will do some demos, including creating Azure API management instance in the Azure portal. And of course, we will see how to implement policies like throttling and caching. And let's get started. Before we start, it's worth to answer question, what is API management? Azure API management. It's Azure service to create consistent and modern API gateways for existing backend services. It provides secure, scalable API access for your applications. Azure API management consists of 3 main components. And these 3 main components are API gateway, which accepts API calls and routes them to your backends. You have Azure portal, the administrative interface where you set up your API program, developer portal where web user interface for developers where they can read API documentation. Gateway that accepts API calls and routes them to your backends. Azure portal that is administrative interface where you can set up your API program, and developer portal where web user interface for the developers where you can read the documentation. Now Let's look at the diagram. There is a web application that communicates with many different web APIs and the backend services. In some scenarios, it's better to hide those web APIs behind the API gateway to provide a single surface of communication for the client applications. So in this scenario, web application sends a request to to the API gateway, and API gateway forwards those requests to the specific backend services. Once we understand API gateway component, we can discuss its capabilities. As I mentioned before, API gateway accepts API calls and routes them to your backend services. And that's not the end, because API gateway we can verify API keys, JWT tokens, certificates, and other credentials. This can be really helpful because, for instance, instead of verifying certificates on the application side, you can hide it behind the API gateway, and verifying the certificate will be API gateway's responsibility. With API gateway, you can also enforce users quotas. So and rate limits, and this can be really helpful because you can limit the number of requests that are sent to your specific backend services. API gateway can also cache backend responses. So now let's talk about Azure portal capabilities. When it comes to Azure portal management, once you create Azure API management instance, you can access its settings, and yeah, you can also package APIs into products that we are going to discuss later in this course. And of course, you can manage users that have access to your APIs. So to summarize, API gateway can act in between as a broker for your web APIs and your web app. So to discuss capabilities, developer portal is a place where developers can read API documentation, create an account, and subscribe to get API keys to access specific backend services. Developer portal is also a place where developers can try out an API via interactive console. And the third part is versions and revisions. Of course, there is also access to analytics data. Now, when we are talking about APIs, it's good to talk about the concept of versions and revisions. Inside the API management service, versions allow to present group of relevant APIs to the developers. You can use versions to handle breaking changes in your APIs safely. And below you can see example of different versions of so basically, if you have different versions of an API, and revisions allow you to make changes to the API in a controlled and safe way without disturbing your API consumers. And again, now it's worth to mention two important facts. Each version can have multiple revisions, just like a non-versioned API, and you can use revisions without using versions, or the other way around. Typically, versions are used to separate API versions with breaking changes, while revisions can be used for minor and non-breaking changes to the API. So versions are for big changes, and revisions are for minor changes. So typically versions are used to separate API versions with breaking changes, as we said, and the revisions are for minor changes. We are going to talk about managing APIs with products and groups. Before we start, you should understand that APIs are the foundation of an Azure API management service. Each API represents a set of operations available for developers. Each API contains a reference to the backend service that implements the API, and its operations map to the operations implemented by the backend services. So operations in API management are highly configurable. with control over URL mapping, query and path parameters, request and response content, and operations response caching, rate limit quotas, and API restrictions. To summarize, each API in the Azure Management Service contains a reference to the backend service that implements the API and its operations. Now, when we're talking about API access, there is a concept of products and groups in the Azure Management Service. So products are how APIs are surfaced to developers and have one or more APIs, title, description, and terms of use. On the other hand, we have groups that are used to manage the visibility of products to the developers. So the products are how APIs surface to developers, and groups are that used to manage the visibility of the products to the developers. So let's discuss products in detail first. Product can be open or protected. Protected products must be subscribed to before they can be used. It means that developer has to first subscribe, get API key, and then with the API key, developer can access a specific API. When a product is ready for use by developers, it can be published for the developers to use it. Subscription approval is configured at the product level. Developers need this subscription to access the product. And now when it comes to groups in the Azure API management services, there are administrators that manage API management service instance, creating the API operations and products. There are also developers that are granted access to the developer portal and build applications that call the operations of an API. And the third group, guest unauthenticated developer parts portal users with a certain read-only access, such as ability to view APIs but not call them. There can be one, of course, custom groups. Administrators can also create custom groups or leverage external groups in associated Azure Active Directory tenants. Now when it comes to the developers, they can be created or invited to join by administrators, or they can sign up from the developer portal. Each developer is a member of one or more groups and can subscribe to the products and can subscribe to the products that grant visibility to those groups. It's a long sentence, please grasp it. If you have, then great. So now it's time to create your own API management instance in the Azure portal, and this is what we are going to do in the next demo. So in this demo, we will learn how to set up Azure API management service. We will create an API management in the Azure portal. We will integrate in existing API application with API management, and we will set up access for developers. And let's go to the portal.
So back here on our Azure portal, we are here in my dashboard, and I have already searched for API management, and I just selected create resource, and then I selected API management, and here I click create. That's it. And then it asks for a resource group I want to create it in, region, and region of course will be North Europe. Oops, Europe, France, France Central, Europe, Switzerland North. Okay. Resource name is at 204 API management test. Administrator email. Let's enter this. Pricing tier developer no SLA, so it's a developer version, developer tier, and it doesn't have any SLA. Next is monitoring, and I want application insights. I already have application insight created. Then in the scale are not supported for the consumption tier, no problem. System assigned managed identity enables system to grant access to resources for existing. Very nice one. And we will talk about yeah, we have already talked, so let's cover this a little bit here. So what happened is, you system assigned and user assigned, there are two types of managed identities. And user assigned is like can be used for multiple resources to distinguish, and system assigned is for a specific resource there is that identity, and these identities are registered in the Azure Active Directory. And when you want service to service communication or access, you assign some rights to that specific identity. That means, let's say keyvault has access over storage account, then it can rotate access keys of storage account and store them back in the Azure key vault. So for that purpose, Azure key vault should have some rights, and for that we create a system assigned identity of Azure key vault that can access the storage account. Let's continue here, and let's go to virtual network. We don't have any protocol setting. What type of protocol settings we want? HTTP, TLS, we can select any of them, and I'm not going to select any, and let's continue. Then we are install API management gateway, and here sorry, review and install, and this is going to validate the properties and things I created, and then I can just create. It is initializing, deploying, and let's hope it is creating quickly. Okay, looks like it is quick. It has created. Let's pause a little bit. The operation is still running, and let's see how long it takes. I'll again pause for a few seconds. It is taking a lot of time. Let's reconvene again. Okay, the service is still in process. It's just still creating, and deployment is still in progress. And till then, we will see what has been created. So here you see we are in the resource group. This blah 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 gateway URL is this one. That means when we are going to connect to this API management, we are going to connect via this gateway URL, and developer no SLA, virtual IP is not given it. And you see here in the pricing tier, we are on the developer SLA no 1 unit, delegation disabled, identities no identities for now. And you can see here external cache none, APIs total APIs none, virtual network none, gateway URL none, because we don't have any yet. Subscriptions undefined, so yeah, still being deployed. But you see in the API section, as the service is still being deployed, it's getting ready. But yeah, you see here in, you see you have settings in the APIs, you have products, you have subscriptions. And subscriptions are not like other subscription, but subscriptions by the developers or other people, named values. Then you have backends, you have policy fragments, API tags, schemas, authorization, which is in preview, and power platform, just for creating interactive applications. So that's it. One more interesting thing I see here is OpenID in the developer portal. So you have a special API, and then you have a developer portal separately. And in the portal overview, you see all the operations you can have related to developer. AD's provider is already configured in your payment. You can manage it in identity. You can enable it. Enable user sign in with Azure Active Directory. You have portal settings, which is not yet there. Users, you might have users, you have groups, then you can add identities, managed identity, all that what we talked recently. And yeah, that's it. Let's see if it is deployed yet or not yet. Then you have notifications, custom domains, which we can add custom domains. You have managed identity, which we just talked about, and in managed identity we can turn on the managed identity for this one, or we can add a user identity, user assigned identity. Certificates, no certificate is certificates are there. So we will revisit this portal again and we will have some more information, but till then we can get started via APIs. So we can add more APIs, existing APIs, and apply runtime policies. In the portal overview, you have resolve common issues with your developer portal. You have analytics, you have named values, which we have here. So APIs, in the APIs, you have developer portal and you have monitoring. So let's go back to our learnings and we will be back to this portal again.
To the second module of the course, Azure Developer Implement API Management. In this module, we are going to talk about how to protect APIs and improve their performance with API management. My name is Nitesh Sharma and I have pleasure to guide you through this course. Let's see the topics we are going to talk about here. First of all, we will talk about protecting APIs from unauthorized access with access keys and client certificates. Then we will learn how to use policies to change the behavior of the API through the configuration. Next, we will be implementing throttling to prevent resource exhaustion. And at the end, we will improve performance of our API using a caching policy. A lot of stuff to learn. Let's get started. So we are going to talk about in this clip about the concept of Azure API management, security, and policy. So first of all, we have to describe what is policy. Policies are a powerful capability of Azure API management that allow changing the behavior of API through configuration. Policies are a collection of statements that are executed subsequently on the requests or responses of an API. Let's put some an example of Azure API management policies. They can be used to change the format of the data. So for instance, if the response from the API is returned in XML format, we can just transform the response to JSON. So we can also restrict the amount of incoming calls. As you remember from the previous module, we used start product where 5 calls per minute were allowed. With policies, we can also enforce existence of a value for a specific HTTP header. With the policies, we can also cache specific response from the APIs according to the specified control cache configuration. So remember these 4 tasks out of many which we can do with the API, Azure API management policies. So format conversion from XML to JSON, we can bound restrict amount of incoming calls, enforce existence and or value of HTTP headers, cache response according to the specified cache control configuration. Then now it's time to discover different categories of policies available in the Azure API management service. Let's start with the access restriction policies. We can limit call rate by the key. This prevents API users by limiting calls rate on per day basis. So as you remember in the previous module, for the starter product there was a limit 5 calls per minute. We can also use access restriction policies to validate JWT token. So we can check whether the token is passed in header or query parameter. We can also set users quota. We can also set users quota by key. So what does this mean? We can also set users quota by key. This enforces our renewable or lifetime call volume or bandwidth quota. Maybe in some scenarios we want to use some custom HTTP header. With this access restrictions policy, we can check its presence. So we can check if a specific HTTP header is present or not. With this access restriction policy, we can also limit call rate by subscription. This prevents API users by limiting call rate on the per subscription basis. We can also use some advanced policies, but remember these 5, which are limit rate by subscription, set users quota by key, validate JWT tokens, limit call rate by key. So differentiate limit call rate by key, limit call rate by subscription, check HTTP header presence. And these are some of the advanced policy. What is possible with advanced policy? We can return a mocked response directly to the caller. Mock response. We can also forward the request to the backend services with the advanced policies, and we can retry exhaustion of our request at the specified time intervals. We can also set request methods. This allows changing the HTTP methods. We can also add tracing. This adds custom traces into the API inspector output or application insight. So there can be scenarios where we would like to transform our data. In this case, transformation policies can help. We can convert XML to JSON. This applies to the request or response body. And another way around, we can convert JSON to XML. There can be also scenario where we want to find and replace a string in a body. With the transformation policies, we can find a request or response substream and replace it with the different substream. We can also set backend services. This policy changes the backend services for an incoming request. In the end, we can also set a query string parameter. So we can convert to XML to JSON, JSON to XML, find replace string body, set backend services, and set query string parameters. So this is transformation policies. Then we have caching policies, which is another very helpful category. We can cache a response according to the specified configuration, cache control configuration. We can perform cache lookup and return a valid cache response when available. And of course, we can remove value from the cache. So we can remove value from the cache using a specific key. These are only some example of the policies. And policy scope. We can apply policy at a global scope. This will affect all APIs within the instance of the API management service, but we can also set the policies at the product scope. This will affect all the APIs under this specific product. We can also set API scope. This will affect only single API. In the end, we can also set policy operation at scope, at operation scope, and this affects only one operation within the single API. Great. But there is another important question. When do policies execute? Inbound policies executes when a request is received from a client. Backend policies execute before a request is forwarded to managed API. Outbound policies execute before a response is sent to a client, and on error policies execute when an exception is raised. So I hope it is clear. 4 types of policies, when and where they are executed: inbound, backend policies, outbound policies, on error policies. Now let's discuss a simple policy structure here. Policies are defined using XML format. We can see that there is inbound section where we can define inbound policies. In this case, we are setting the rate limit for 5 calls and renewal period is 10 seconds. We are also setting up cache. There is a section called outbound, and here we are setting cache storage duration and to 60 seconds. And there is also second section called error, where we can define policies that will be executed when an error occurred, and one more on error, and then So that's it actually. So one more, there is a backend policy which is having nothing. So yeah, that's kind of the structure you have in this demo. Now demo part, we will learn how to protect APIs from unauthorized access. We will see how to access API with API key and client certificate. And one more thing before we start, as short reminder, we will use existing API which we created previously, and our focus is Azure API Management Services. And one more thing, in this demo we will use Postman, a free tool that enables us to send requests to API. And yeah, let's get started.
All right, we are here in my Azure portal again, and here you see I have created AZ-204 API management yesterday. I created this yesterday with you all, and now I have it is deployed, so I see it in function. And you see I have direct link here for the developer portal. This is also here developer portal URL. Then you have gateway URL. There is no SLA because it's a developer edition. And yeah, so let's move to developer portal right away. So it is saying some re-authenticate with the Azure portal because your session expired. Anyway, I will do it. Okay, so this is how your developer portal looks like. And as a developer you have a possibility to change it and make it how it will look to the other users who will use your products or your API. So basically it is giving you option like how can you display your API, Contours API 1, Contours API 2, 3, multiple APIs you have. Then you are just giving them an example of call, how you can make a call. And this is like presenting your clients your products actually. And that's another good way, because here you can configure it. And then here if I go down here, you see I have option to look for APIs. I have option to look for products, which we have already discussed. You have subscriptions list, named value, backends, and you have policy fragments, API tags, schemas, authorization, power platform, a lot of things. And you can add backends as well. If I talk about, you see for example custom URL name test AZ API 204 just. And here you can put the CDN app which we created yesterday. And that will be doable. I'm not gonna add it. So we go back, and if I go back here, you will see this is I have already added test Azure API in the backend. So you see uh, if you go to APIs here, you already have Echo API which was created by default by Azure, and this one I added it. And in this API you see I don't have any front end for now. I can add a front end here. That means this API management will listen to this front end, and any call coming from this front end will be treated with inbound processing, then forwarded to backend, which is my API, Azure CDN app.azure websites, which we created previously. And then after that, you can have another policy, which is outbound processing. So, when we say adding authentication or validating secrets or credentials, when we say that, we are simply saying that our API management will process these requests coming from this front end, will process them here, and we can add the policies here. And you see in the policy part, I can say inbound, and in the inbound, I can say what I want to do with these policies. Okay, so I'm gonna go and discard it, and I'm gonna present you some examples where you see API management policy samples. You can search this on Microsoft Docs documents,
And here you have a lot of examples. So add a forwarded header to allow the backend API to construct proper URLs, add a header containing a correlation ID, add capabilities to a backend service and cache the response, authorize JWT access based on JWT claims, authorize requests using externally authorizer, authorize access using Google OAuth token. You have a lot of options here, and you have then samples how you would do that. And I clicked on this one, authorize access based on JWT claims, and this is the sample I have. So in the policies, in the inbound policy, and then you say base, choose when condition is your request method, context or request method, which is the request coming from the front end, and then you say patch, uh, string comparison ordinal, ignore cases, and then here you are validating the JWT token. So JWT, validate the JWT header name authorization. That means your front end is sending a JWT token with the header name authorization, and then issuer signing keys are signing key, and then required claims is like name added and its value 2. So simply what you're doing here, you're validating this JWT token sent in the request. Same way, and here you see you also checking for another claim which is create, and otherwise authorization, and validate this key with the with this signing key only. So you see in the inbound you have three choose choose sorry three when choose. So do it when this otherwise this. So if I go back here, shows how to authorize access to specific HTTP methods on an API based on JWT claim. So basically your half work is done through this sample check here, and then it forwards your query request, sorry, it forwards it to your backend here, you see. So it is forwarding it to the backend, and then backend will be working on it and responding accordingly. And our backend is cdn app azure websites.net. Then it will respond, and then again in the outbound policy, outbound processing, you can again add something like that. So basically what is happening is you are validating your JWT token, forwarding the request to the backend, and then on the response back you are adding other points as well. You can also add something on error, which means when there is error from the backend, you simply forward it to a specific generic page which your website might not be having, but this front end is applying that policy. That means you are applying consistency. So maybe let's say you have multiple front ends, and then multiple teams are working on those front ends and they react to errors differently. But you don't want it. You want a unique page which displays some error messages or some other type of unique behaviors. Then you can have a specific page where you redirect it to, so you can redirect it to that page. Basically you can go through this, and I would really highly recommend you to go through this actually and look for API management policy samples, and I think you will like it. Apart from this, what we have discussed, I'm going through everything in this demo, or actually, so I will not go one by one. Let's talk about products. In the products you have one starter and one unlimited. These are by default created. You can add another product and display and description, and then you add more things here. But let's look at the already created products. In the already created products you have three things. It is talking about APIs. So it has Eco API, which is default API created by Microsoft. It has these three roles.
So administrators, developers, and guests. Administrators are the one who provides developers access to few things, and then developers are the one who modify their apps and presents how it will look like to the guests or users. And guests are like a simple, as we discussed previously, a simple user on kind of on request. So here in the APIs, you have Eco API, which was created by default. You have policies if you have any. If you don't, then it doesn't matter. Sorry, it was still loading. I hate it when it takes a long time. Anyways, not so much important. And then in access control, you see again the same thing what we have already discussed: administrators, developers, and guests, and explanation about them. In the subscription part, it displays who has subscribed to your product. Okay, so these are the subscribers. We have already discussed this. And then the subscriptions, you have overall subscriptions overview, where all the people who have subscribed to your products. Then you have backends. In the backends, you can add the same APIs you want to add as a pool of the as a pool. So it is kind of a pool of all the backend APIs you might have. Policies, no policy. You can create some policies that can be used in the requests, other requests. What else? Developer portal. It's a separate tab here, and inside the tab you have users, which are really important and useful part. You can add directly groups, identities. You can add, um, of course, this OAuth. But portal overview, here in the portal overview, um, it says your developer portal has not been published yet. I can just publish it. I can enable course. So the course isn't configured for this yet. Who access the port through the domain can't use the interactive console. So let's publish. And it says revision this was created on this and published on this. So it is having the information about the portal. And if I go developer portal now, you see it gives me all the options. So I can just add more widgets, can change this, edit button, blah blah blah. A lot of things are there. So basically, uh, and now I see the deployed version. This is how it will look like. Okay, if I go back here, so I get the information that the developer portal was published. I can enable course, um, and that will enable course. That means I will not have any problem related to cross origin requests. Enable user sign in with Azure Active Directory and enable Azure AD. That means then I can directly log in myself on developer portal. All right. I hope it is clear. I can also go to portal settings. I see content security policy, self-hosted portal configuration. You see content security policy disabled, not restrict the sources. Yeah, so there is a lot there, and from the exams perspective, you will not have this much detailed questions, but I want you to go through it and just want you can check it out there, how it looks like, and you will have fun, I guess. So I hope you liked it. Let's continue.
All right, this is the end of this module. This part of the last part, and please continue watching the last part, which is part 5. This was the end part, sorry, end section of the part 4, and now we are going to talk about part 5. Welcome to the last part of the course, Microsoft Azure Developer. This section of the path covers the objective found in the Monitor, Troubleshoot and Optimize Azure Solutions section of the exam guide, including implement API management, develop event-based solutions, develop message-based solutions. You have made till here, then you did a great job. Just keep doing and continue. Let's go ahead. Hello friends, welcome to the Microsoft Develop Event-Based Solutions course, and my name is Nitesh Sharma and I am your host for this course. And one thing I have learned is that cloud-based applications need to be loosely coupled but yet still able to communicate. An event-based solution is a great way to accomplish that. In this course, you are going to learn how to implement solutions in 3 event services that Azure offers. Starting off with the Azure Event Grid, there are 3 major types of events that you will deal with creating Azure applications. The first type are discrete events. These are meant to report state change of an application. For example, an account was created or an image was uploaded. If something is listening or subscribing to that event, there is generally some action that is taken upon receiving the notification. Azure Event Grid is a service that you will use for discrete events in this course. The second type of event is series event. These are time ordered and analyzable. You can think of these as reporting a condition of an application like telemetry. Azure Event Hubs will be used for these series type of events, and then there are user notifications. Unlike the previous 2 events which are application to application notification, these type of events are meant to get the attention of end user of the application. Although there is a push notification type meant only for the device the application is running on. Regardless, these users notifications all run on these Azure Notification Hub. Azure Event Grid deals with discrete events and what makes it perfect for implementing event-based architecture. You will hear them described as pub-sub architecture too. For publication and subscription, publishers emit event or state change that happen, and subscribers listen for them and take some sort of action when they receive an event notification. The publishers and subscribers can be Azure services like Azure Function, Azure Storage, or custom webhook that you create yourself. A cool thing about Azure Event Grid is that it supports sending a single publisher's event to many subscribers at once. It also allows a subscriber to set up filtering rules so only events get delivered that match the rules. Event Grid is highly scalable both up and down. In fact, it's scalable all the way down to 0. You only pay for what you use, so this makes Event Grid a serverless proposition for your cloud event needs. Grid needs to be enabled. There isn't a service that's created like Azure and Azure Function. You register it as a resource provider. This way, other services can send events to it, and it needs to be done at a subscription level. This is how you do it. From Azure command line interface or CLI, you run a command saying AZ provider register -- namespace Microsoft.EventGrid. I have also shown you in previous clips that how can you do it for via Azure portal, where I registered Azure CDN. You can also do it like this, so you can check Azure provider show -- namespace Microsoft Event Grid query registration state, which tells you what is the status of the registration. And let's do a demo where we will show you from the Azure portal at how can you enable Azure Grid, and let's go there. Back again to my Azure portal. I'm here in my home page, and here if I go to subscription, because registration is done on the subscription level, and then you go all the way down to resource providers. So here you have resource providers, and then you can just check if you have already registered Event Grid. So I'll check for event, and it is not registered, neither the Event Hub is registered. So I just go on this and say register, and it is registering. And same way I can do for this, register, and it will start registering. So, and let's take a look back later on, because it will take some time. And this is not only about Event Grid. Anything you want to use in Azure portal, any service you want to use, you need to register it. So everything else is registered by default. Many things are not registered by default. Here you see it's still registering, and few things like these things which are, this is third party which is not registered, Dynatrace. Many things are not registered by default because you might not need them, and that is why these providers are not registered by default. And if they are not available, you cannot use them. So simple as that. Before really getting into how to implement solutions with Event Grid, here are some pub sub concepts. An event within pub sub world is meant to signify something that changed, and that's it. Event will have some info that travels along with it, but a very minimal amount of information, just enough to tell what has happened. Once the publisher has sent the event to indicate something has happened, that's it. The publisher does not care what action any subscriber take on that event. Whatever happens next is up to the subscriber. So event notifier is not involved in the processing, and that's it. That's as simple as it. So let's continue. The message included in any event has no info on what to do. There is a lot of terminology used when talking about Event Grid, and it definitely helps to be familiar with all of it. First off is the event. The event is meant to describe what just happened, and while it will contain some data, it contains the smallest amount of data to describe what happened. Then you have publisher. The publisher is a thing that originates the event. It tells Azure Event Hub something happened, like Azure Storage could say a blob was just created. And then topic. Now topic can take a little time to get your mind around. A topic is an event grid construct. It is an endpoint, and a publisher will send its events to the topic. You can think of a topic as collection of related events that Event Grid will then take care of. And one of the ways Event Grid takes care of it is having applications subscribe to a topic. So the next topic comes next topic. Next thing comes subscription. Those are called subscription. And what's neat about those is that you can set up filter parameters to only allow a subset of events to flow through. In Azure Storage Blob example, you could set up a filter to only allow blobs with the file extension JPG to flow through. Alright. Then you have also on the subscription, you define the handling application, or where Event Grid will send the event notification to. At the heart of it, these handling applications are just endpoints to Event Grid, and Event Grid posts a message to them. And then there can be multiple handling applications or subscriptions per topic. So I hope these 5 things are clear. Let's move on. So many Azure services are configured to publish events to Event Grid. all you need to do is essentially turn them on. I won't enumerate all of them, but these are the event publishers. So keyvault, IoT, event hubs, container registry, communication services, blob storage, app services, app configuration, and many more. Machine learning maps, media service, resource groups, service bus, signal R, subscription. But you can see that there are so many. So in fact, there were two slides and one to note that even resource groups and subscription things that you wouldn't think as Azure product necessarily can send events to event grid, right? These subscription and Azure groups, I would never imagine sending, but it is possible. Event grid is not limited to accepting events from Azure based services. You can create your own publisher such as ASP.NET Web API. The events emitted from the custom publisher will have the same schema, one from the system or Azure topics, but there is a property in schema where you can define the send custom event data. So you have a user defined custom topic, same message schema as Azure topics, and you can send that with the custom info with the message. What about things that handle the events or applications that are attached to the subscription? Azure functions can receive events. There is a specific event grid trigger function that gets invoked every time an event gets fired, and the input binding of the function is strongly typed, meaning you don't have to mess around with deserializing any event data JSON. Azure Event Hub can be target for event grid events, Azure Service Bus 2, Azure Storage Queue 2, and then you can create your own custom application to receive events from event grid. You are not just limited to Azure services. In fact, the custom webhook doesn't even need to reside in Azure to receive an event. So events can be sent to any handler. It just should be a webhook which can receive, or an endpoint. So here are general steps that need to be completed when setting up an eventing solution. First, you will want to create a topic or the endpoint that will represent related events. A publisher application needs to be configured to send events to that topic, and you will want to add a subscriber to that topic, making sure that you add any criteria to filter out events that you don't want the handling application to deal with. It's important to note that every event that's sent to handling application will have a message with it. That message will have the same schema at list of the metadata. There will be a property inside the schema called data that has all of the event specific information that you need. So in the workflow, you need to understand, you create a topic, you send publisher events, and you add subscriber info with the filtering. So let's do a demo, and in this demo you will learn how to create a system topic in order to get a built-in Azure service to send events to event grid. The topic will be Azure Blob storage. You will learn how to create a subscription for that topic, and including adding a filter to it, and then send those events over to Azure function to be handled. In this demo, we are going to create an event grid system topic for Azure storage blob events, and then route that to an Azure function for handling. The first step is to set up event grid topic. Let's go and search for event grid system topics, and let's use a system topic because that means it's ready to go for an Azure service event. Let's go to Azure portal.
All right, I'm in my Azure portal here, and you see I have selected event grid system topics. And if I go back to event grid, here in the event grid, I don't have any event grid yet. So I go to system topics and I create topic, and in here it is asking me for the subscription. Azure subscription 1, then resource I would check, and the resource. So the system topic resource is associated with an existing Azure resource, which allows customer to subscribe events emitted by that resource. That means system topic resource is created in the same subscription and the resource group as the resource. That means I should have a resource which mm, which is a subscriber to this. So let's create that resource first. Alright, for that purpose I am creating this Azure event Azure storage account. Let's wait for the deployment. I will pause the video for some seconds. Also, to be quick, I'm going to create an Azure function which doesn't matter for this course, and that's why I'm skipping to show you all this, and I'll just pause the video while everything gets created. All right, so to explain everything now, we have all the resources ready. I have a system topic created which is looking for storage account, and it is basically an Azure function, and this is a subscription. So what is happening, if I explain it or revise it to you again, I created a topic which is simply a topic. You have a similar type of event subscribed to a single topic, which means like similar triggers type of events are grouped together, and that is called topic. And in that topic you have subscriptions. So here you have one subscription for any uh, change in a blob, that will call the subscription as Azure function here, and the endpoint is simply the Azure function I created. So here I don't have any call yet. So no call yet. And if I go back to event grid, and this is in the events of storage account, you see I am in the storage account here, which I created event grid AZ-204. This is a storage account. If I go to events of this storage account, because we have already subscribed to that specific event, to that specific topic, you see this storage account is subscribed to this topic, and it shows also the relation here, you see. So the connection between topic uh, and the Azure function and the storage account and the event is clear, right? So from whenever we will be dropping anything in this container here, and that will trigger a Azure function, and let's do that. So let's first create a test AZ-204. Let's create just a container here, and in that container I will upload a file. Let's pause for a while. All right, I am in the function app, event grid trigger AZ-204, and I'm looking into triggers. So if I go back, I'll show you, and I go back one more time. This is the Azure function we are using, and if I go to monitor in this, I see a trigger. Come on, quick. So there was a successful trigger for this event, and which is functions if dot event grade trigger AZ-204, which is the name of the function. Event region event grade trigger fired at this, and then other put blob blah blah blah, because I uploaded a file. That means a blob was uploaded. So this is the function put blob, and executed. So because our Azure function is really simple, and it's not doing much, and you see in here it was triggered. And if I go to containers, I uploaded this file in this container, so that is why it was triggered. And in here in the event trace, after that there is no event trace. So if I go to the code and test what it is doing, actually, just to verify with the, so there is not much happening here because it is just saying bindings, and these are the inputs in this Azure function. And if I go to CSX, um, there is just this simple log event grid event grid dot data dot to string, which is simply resulting into this log. If we go here monitor and into resulting into this one simple. So I hope it is clear, and I hope you understood what is it to have a topic, what is event subscription, what is Azure event grid, and how these things are connected to each other, how to make a relation. So just make a logical connection in your mind how everything is connected to each other, and I hope it is clear. Let's continue.
Now you all know that how system topic works, what is topic, what is event subscription, what is event grid, how topics are connected, so how the events are triggered, and how topics are being subscribed and who subscribes the topics, and then how the whole flow works. So from in our previous example, from dropping a file which triggered a simple top topic, and topic to the topic it reported an event, and then topic was subscribed by Azure storage account, sorry, Azure function, and that Azure function was triggered with that event, and that Azure function is still got some information about that specific event, which contained some information about the blob. So basically in the Azure function, I could know that this blob was dropped to this storage account. So basically I can then continue from there and then use that information to do further things. So let's continue here. You already know how to create with portal. Let's do it with the SDK, and I will show you how you can get the example as .NET from the portal itself. Let's continue.
All right, back again in the Azure portal. I am in my Azure Event Grid section, and here in the overview, I have this possibility. So here in the Get Started section of my Event Grid, you can see build event-driven solutions with Azure Event Grid. And here, this place is really important to get started with. You can manage Azure system, Azure service events, but you can also manage custom events, which I just talked about. And then you go here, manage events, custom events, and then you can create a topic and go ahead from here. So this will work the same way as a system topic. And you see here, you name it, you name a region, blah blah blah, and you create it. I'm not gonna create it. I just want to show you here. And then if I go back to overview, and you can, if you want to learn more about the custom events, you can still go to Microsoft Learn, and where you can learn more about custom topics in Azure Event Grid. And it's really easy and explained very well. And I have also explained it, but if you want more information, if you want to get familiar with how to get started with the custom topics, and if you want to work with CLI instead of Azure Portal, and or maybe PowerShell, or maybe ARM template, which is more useful in certain cases, you might want to do that, then it's the great place to be on. And another thing I wanted to do is, sorry, I wanted to take you here, and I wanted to use Azure Event Grid client library for .NET, and the version here is 4.11.0. That's beta version, but you can change it and use it for according to your use, and you can get lower versions as well. But for now, I'm just going to talk about this one. And here, um, what this library can help you to do is publish events to event grid service using event grid event, cloud event, custom schemas, consume events that have been delivered to event handlers, generate SaaS tokens to authenticate the client, publishing events to event grid topics. You will get the source code, and you can also check it from the nugget package. A lot of things are there. It doesn't make sense for me to present you Visual Studio code, or with an example in Visual Studio, because that might be old, and these documents from Microsoft are really great place to look for. And it's a simple .NET nugget package. You just go and install this package first, and that's it. Then you can get started doing your thing actually. So how can you authenticate your client? You just need to get the access key uh, for your event grid publisher client. And that can be also done with access key or with the shared access signature key. And once you are done, you can also do that with the Azure Active Directory, but in that case you need to use default Azure credential, which is simple. If you already know, this is a simple way of uh, authentication, so you can use this one as well. um, on more on this I can talk about in a separate video, but you can just understand that this is a default way of authenticating using .NET SDK in the .NET SDK. And how it works is like it checks for your authentication methods. Previous, if you have already authenticated your client, then it will use the default credentials from there. If you haven't, then it will check step by step different type of authentication possibilities that can be in your application. So it might try headless first. It might try it to open a browser and then ask you to log into Azure portal. So that will be a single sign-on, and it might use your, if you are using Visual Studio, then it might use your Visual Studio credentials. There is this pattern of logging in. I will create a different video on this. This is out of the syllabus of this certification. But yeah, so there are three ways you seeing here: authenticating using Azure Active Directory, authenticating using SaaS, and authenticating using topic key. And this is simply to create a event grid publisher client. And then once you have the publisher client, then you can publish the events to it. And for that matter, um, so this is the event we are creating, um, and then we can send this event to this client, right? So this is like triggering the event programmatically. And there's it's like nothing is happening in reality, but you are creating an event and sending it to the client. So basically that was what I meant, triggering a client programmatically with .NET SDK. And it's really simple, right? So you might be asked for a few things like that in the exam.
how can you authenticate with the client, event grid client, um, what are the possibilities, and so on and so forth. Okay, let's continue, and hope it is little bit more clear, and it gives you a starting point. A starting point is really necessary to get started with anything, and once you have that, you can learn yourself as well, because yeah, I think for a developer you just need a starting point. That's it. Let's continue. Event based architectures. So in this module, to talk about summary, I built event-based solutions using Event Grid. You learned that Event Grid is a great way to build event-based applications in the cloud. It uses the pub-sub model. An event in pub-sub is used to signify something that has changed, and it contains some smallest piece of data possible to describe that event. The publisher doesn't care what happens to the event once it is sent. It just sends it. It's up to the subscribing or handling application to take any action on that event. And Event Grid itself can filter events, support multiple subscribers to a single event source, and it's highly scalable. Make sure you enable the Event Grid on a subscription level. There are many different Azure services that supports Event Grid natively, and you can build up your own application to both send and receive events, including your own event topics through Azure Event Grid. Up next in the event-based solution journey, you are going to learn how to handle some series types events and implement solutions using Azure Event Hubs. So let's continue. Welcome back, friends, to Microsoft Azure Develop event-based solutions. My name is Nitesh Sharma. In the last module, you learned about implementing solutions that handle discrete events in serverless-like manner with Azure Event Grid. In this module, you will learn how to implement solutions for large-scale big data applications where events arrive in a time order fashion using Azure Event Hubs. Azure Event Hubs have a couple of top-level characteristics. And first and foremost, Event Hubs is an event ingestion and processing service, and it is scalable. It's perfect for big data scenarios where you would get millions of events per second, like those you would find in the IoT or banking or manufacturing or numerous other scenarios. Event Hubs decouples a producer sending events from the consumer reading the events, much like Event Grid. The sender and receiver are not dependent on each other, nor do they really care about each other. All they need is event, and the Event Hub facilitates the event processing. You can easily integrate Event Hubs with both Azure and non-Azure services, and you can also set up Event Hubs to automatically capture events directly to Azure Blob storage or data lake as event comes in. And there are many different types of scenarios for Event Hub, but some of the big data types one can include telemetry. So you might have a question in exam, and which is simply differentiating where to use Event Grid and where to use Event Hub. And if it concerns with the big data, then the simple answer is Azure Event Hubs. Let's continue. Think about that could come back from an array of sensors placed to detect earthquakes. There could be many thousands of sensors, each capturing many different variables many times per second. Event Hub is perfect spot for those sensors to send their readings back to an application downstream can read and interpret the data. There is data archival purposes. Send tons of data back and then have another application archive it. Maybe it archives summaries. Maybe it combs through and looks for special events. Regardless, event hubs can hold events representing the data to be archived. Then there is transaction processing. A large financial institute could have millions of events coming through during peak times, and another increasing use is anomaly detection. That same financial institute that uses event hubs for transaction processing could also check out events in real time for anomaly indicating fraud. Let's continue. Components. There are several components that you will hear about when discussing Azure Event Hubs. Here they are along with quick definition, namespace and event hubs. Um, Namespace is a container for one or more individual event hubs. A grouping, if you will, if you will, event producer. These are applications that send data to event hubs. Partitions. Within an event hub, the event messages get delivered to a partition as a bucket for the event messages. The first message goes and the second will go in behind it, and there will be more than one partition per event hub too. Then consumer groups. This one is kind of weird when you first meet it, but it's nothing more than a particular view of the event hub. The consumer group has things like current position where an application is while reading through the partitions with multiple consumer groups. Event hubs can support multiple applications reading through the events all at their own pace. And then there is a subscriber reads data from the events hub. Uh, So, namespaces. The event hub namespace is an important concept. So let's go dig into that bit more. As mentioned, it's a container. Think of it as a scoping container, one or more. Event hub can be contained within the namespace. Any options that you apply to the namespace will apply to all of the event hubs contained within it. This is very applicable when it comes to pricing, and a key component for the pricing is throughput units. A throughput unit is a pre-purchased unit of capacity that controls the throughput of events for the event hub, and you set this as name at the namespace level. So throughput is decided at the namespace level. You need to create an event hub's namespace before creating the event hub, and this is how you do it. That with the Azure command line interface in here, it's a Azure event hub namespace create in the resource group, and then the location and the name and the SKU standard. Then you need to pass in resource group and location parameter. Of course, you also want to give the namespace a name and specify SKUs. So I would definitely like to practice this and do it myself if you want to do the exam. And then once the namespace is created, then you can create the event hub itself. Again, using Azure CLI command with Azure Event Hubs, Event Hub create. You want to give the event hub a name, pass in namespace, the name that you just created before. There is a message retention parameter which says 3 days, partition count, which is now how many bucket you want the event hub's message to flow into. By default it's 4, but you can specify between 2 and 32, and you can also need to specify, of course, a resource group name. And let's continue. So in this demonstration, we are going to learn how to create Azure Event Hub first, creating the namespace, then creating the Event Hub itself, and then you will explore the Event Hub and its namespace in the Azure portal. In this demo, you are going to learn how to create hub using Azure portal. We have already talked about Azure CLI. So what I would like to do is you do it yourself using CLI, and I do it in the Azure portal. Let's continue.
Okay, back in my Azure portal, I am here in my event hubs, and to go here, you just have to search event hubs, and it's here. And you see there is no event namespace, event hubs namespace for now. So you create a namespace first, and in the file creation, you just have to go here, and it just creates one. select the name, test AZ-204. Let's see if it's available. It's not available. Let me add tag of the day, and that should be available generally. And then it's West Europe by default selected. I will set it Europe, North Europe, and here you see a warning: the region selected of support availability zones. Your namespace will have availability zones enabled. And then the pricing tier, which one you want to use. And here you see standard, which is 22 USD per TU per month. It is a bit different to understand this. You have per PU per month, per TU per month. So to understand, you can go here, and here it is more detailed, where you see basic is one consumer group, 100 brokered connections, and ingress events per million, 0.02128 per million, message retention 1 day. So because here we are talking about millions of messages, that's why it is the price is in millions. Don't get confused with it. And then you have a standard and you have premium, and these are the different uh, differences you might have. So schema, registry, capture, it's added in the standard one. I can also go with this one and select this one. Throughput units, it's 1 for now. It can go up to 40, so let's say 5. Advanced, by default TLS version is 1.2 selected, and for the security purpose it is required for you sometimes to get the highest available. Networking is public for now. I don't have any VNet integration, so I will keep it public. And then it's validated, and as always this is an ARM template, so it creates a deployment here, and you can simply download this ARM template, and sorry, not this deployment, but it generated the ARM template, this one, and this can be downloaded and you can use it for your development purpose as well. So in case if you want to deploy Event Hub namespace programmatically, that means using your CI/CD pipelines, you can do that by just downloading this, and then from there on you can just modify it according to your requirements. So you can pass parameter values, and yeah, you can keep it a bit dynamic. Let's see, let's go to the overview. It's still working on it, and I will pause the video for a second, for a few seconds, so that it's, yeah, I'm not wasting your time. All right, the resource is created, and I can go to Event Hub namespace, and here you see all new namespaces are created with minimum. This is just a warning which we just saw when we were creating it as well. And then in the information here, what you can see is just the dates created, zone redundancy enabled, pricing tier basic, throughput 5 we selected. As if you remember, local authentication is enabled. All right, so we have the namespace now, and so if we go back here and in the events hub, okay, and I click create, it is asking me to create events hub, sorry, the namespace, and now I can create the event hub now, as we have created the namespace. So I go to event hub, name is 204, partition count, which we have already talked how many partitions you need, and partitions are just an organization uh, mechanism that relates to downstream parallelism required in consuming applications. The number of partitions in an event hub directly relates to number of concurrent readers you expect to have. So let's say 10 concurrent readers we might have, and message retention, it's in days, I think. um, it's not customizable actually because of the basic, but it's message retention is in days, I think. Next, it's capture. The capture feature is not available for basic tier, of course, but yeah, you can capture the messages. Then review and create, that is just creating the event hub. So we have created event hub namespace. We have created the event hub now, and let's just go through it now. So okay, and if I see it here in the event hub's namespace, I see the event hub, and here I have the event hub. And let's explore this a little bit more. So let's go to events, and events, you see, there is no event, automated event for now, but you can create event subscription. And in the event subscription, let's say test subs AZ-204, and using the event grid schema. There are other different schema as well. I will go with that one. And by default, source resource is took tech of the day as namespace, event hub namespace. System topic name is you can create yourself, is at 204 topic. And event types, captured file created, endpoint, let's say Azure function, and then we have to select an endpoint. um, so it selected this endpoint again. The event grid trigger, let's see what happens. um, Logically we should create a separate Azure function for event hubs instead of event grid. So we created a subscription here, which means we have a subscription to these events in the event hub namespace. And if we go further down, we have shared access policies, root manage shared access key, which can manage and relation. You can create more shared access keys, uh, which you can later on use for creating your clients. For a scale up, you can scale to for throughput unit up to 5. You can change it, you can decrease it, or you can go. Okay, and then the geo recovery. It's related to disaster recovery if you have, but in our basic it is not available. Encryption, again, encryption at is rest is only available for the premium and premium namespace, but yeah, but you can have encryption at rest with Microsoft managed key or a customer managed key. Configurations, then it's simple properties, not much information. Logs, you can create logs as simple as it is on other resources as well. And here in the event hubs, you see we have created one event hub. You can go to this event hub and check for other things as well. You also have shared access policy where you can create another send, listen, manage, and policy name. You can create a policy. um Yeah, well, that's it for now. It looks like I have covered most of the things. Ah, yes, process event hub data with Azure Stream Analytics. You have many other options here apart from these are kind of once you get the data, and if you want to do some analytics over it, you have many other add-ons, and these are the new things which Azure is improving over, because once you get that, they get that data, then you have a lot of seamless opportunities to play with that data. That's why it gives you access to integrate with Synapse, ADLS, capture data to ADLS Gen 2 in packet format, Cosmos DB, filter the ingest to ADLS Gen 2. Yeah, a lot of opportunities there. So once you are there, you can do a lot of things. Then you have these monitoring things which you have for each resource as well, and then same export template for your ARM template. That's it for this one. Let's continue. All right, I am in the Event Hubs. This is my application, a small application which publishes some data. I got this from samples, and what I'm doing here is I just had my connection string and event hub name, and then I created a function called send to same partition, and there is another function which is send to random partition. So we will try both. We will try first send to same partition, and that will send, so that will prepare the, it is creating the client, then creating a batch event data, and this is preparation, um, and then adding to the event batch, and then we send the batch to the client. The partition key is device 1 only. So let's try this first, and let's see what happens. So it is executing now and preparing data and sending to the event hub, and you see here wrote events to single partition, and now I can stop it. Okay, so this is stopped, and now there is another application I created. This is publish, and then there is consume, and in that one we will read partition, and it should display. So let's try this one now, and let's see what happens. I will explain you the application in detail once I'm just running it without any changes, and then I will explain you what is happening inside here. But basically what you do is you create a client. So for publishing, you create the data, batch data, and then you upload that batch data. And for retrieving, you are creating the client and then getting the data from a specific partition. It is stuck. Let me see. Yes, first let's read the partition info as well, the one we just created, because that is more important as well. So let's look if there is any partition which we created. Partition ID empty true, blah blah blah. So here new partition info, partition ID 0 empty true, last sequence no sequence, partition ID 1 last sequence no, empty 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 empty. And then we have partition ID 5, which is empty no, and the last sequence was 199. And then we have another partition ID, uh, all the remaining are empty. Okay, right. And now what is happening is, so let me explain it so that it's clear. There is this function get partition info, which is simply getting the partition info by creating an event hub consumer client using the connection string, event hub name, and the consumer group. And the consumer group is simply event hub default consumer group name. Okay, so we are using a default consumer group name here. And then I created a consumer client, and then to after consumer client is created, you can get the get partition ID async. Once you have the partition IDs, all the partition IDs, then you can go through the IDs and get the partition info. And once you have the partition info, you can just use that, and this is simply a property, a client uh, partition info property. So basically this is what I was doing here, and then I was reading from those specific partitions, so 0 1 2 3, passing them here, and to read them you just say, you create a consumer client for each consumer group, which is by default same consumer group default one. And then partition property, you get the partition properties by getting it from the consumer client by the number of the partition, which is simply you have it here. Okay, there was an exception here. Let's look at it. Threading exception, a task was cancelled anyway. um, okay, don't want to go into detail here because it's a I don't want to teach you programming, right? I want to teach you Azure. Anyway, yeah, so let's continue here. Then it was getting the partition properties by simply calling the get partition property by the partition number, and partition number is this one you passing here. So once the partition prop you have the properties, then you can starting position event from start sequence number, and then you can start from the beginning sequence number or end sequence number. And then you can read from a specific number. So here you are reading the last events from a specific location or number sequence number. Let me show you uh, after this one after running this one, let me show you how it is happening, what is happening. And so if I go to Event Hub instance, here you see in this one what I did, and you see the activity here. Around 200 incoming messages were there because I executed my function, and you see there was a spike like this. So around 17 KB of data was transmitted, and you see 7, and because I ran the application 2 times, so you see the data was there. And you can then add more features to it. So you can add process data, you can connect, you can checkpoint, you can connect uh, with this with the you can add another shared policy here by adding that. So if you go back here, and you can have a checkpoint. uh, this is the consumer group we have by default. So that's it. Let's continue. I hope you understood. Okay, back to the portal. Not to the portal, actually back to Visual Studio, and here this is the application we use to send the data to this partition, and which I explained, send to random partition, send to the same partition, and how you can do it. So for sending this to the same partition, you just specify the partition key here, which was device key. So enough of revision of the last demo, and now enough of things from the previous. This I have shown you this one as well, but the difference is we create Event Hub consumer client instead of producer client here, which we created a producer client. You see, you create a consumer client in this one, and then you read from the specific partition. So read from that partition, so you read it from there. But then you can also specify the starting position, event position. So once you have, what I said, once you have done the reading part, then you wait for new events, uh, and previous events also stay in the same part. So you don't want to read the previous ones, so you want to read from a specific location. So you want to read from a sequence. So read from sequence number, beginning sequence number, or the last enqueued sequence number. You can use that, and then you can continue reading from there on. So that's the different here, and that's the difference here. And that's it about consumer application. I hope it's clear. I just wanted to make the difference clear, and let's continue. All right, back in my Azure portal, and here you see I selected um, notification hub namespaces because this is the thing we need to create first. You go to home page, and then you create notification hub namespaces. You go here, and you need to create one. So let's start. Again, interesting thing I see here is I have not registered notification hub yet. So I need to register it, and to do that, I'm just going here. I have already explained how you can do it. You just go to your app's subscription and then go to your resource providers in the subscription, and then you filter with the resource providers. So by the time it is registering, let's pause the video because it will waste your time. Okay, so now I'm going to create the notification hub. I just went and searched for notification hubs, and now I selected the default resource group. Need to enter a name, so AZ-204, and that is going to be tech of the day. All right, this is a new namespace we are going to create, and then for the next notification hub we can use the existing one and the notification hub name. So I'm going to enter something interesting, not interesting. A AZ 204 204, and it's available. Nice. I can use this name, and North Europe free tier. Next, free is always good, and I just create it. So all right, by the time it will be deployed, I think I will pause the video, but it just created the same thing again, creates a deployment, and this deployment in actual is an ARM template which you can use for your future deployments. Best way to get started with the infrastructure as code. Oh, it's quick, and it's deployed. So you see here I'm in the notification hub now, and what I get in the basic free tier is um, max devices allowed in the namespace are 500, and included process in the namespace are 1 million. So you see, until 500 devices I can use free tier. So that is really a big thing actually, because for small organizations you don't really need much devices. Maybe if your organization is growing, then of course you can pay as well, but yeah, for the small ones it's a big good one. And then in the settings here you see a lot of things. Apple PNS, which is a great thing. Google, GCM, FCM. These are different names according to the brands, according to the provider, but these all are related to notification services. WNS, Windows Notification Service. What is, you need to add the settings here, and then you can continue. Windows Phone, MPNS. Then you have Amazon ADM, same way, same thing. We need to enter client ID, client secret from Amazon. Baidu, it's only for Android China. So again, same thing, API key, secret key. So these are the things you need to enter here in order to use these services. And then access policies you can assign. So you have two different connection strings here that you can use directly in your SDK, and then you can use them. And permissions are listen, manage, listen, send. So this one is only for listening, and this one is for manage, listening, and sending. So depending on the requirements, you can use the connection strings you want. Then pricing tier is free, but you can change, you can go for the bigger ones. You have alerts, and that's it. So you get also matrices. Very easy concept, very easy thing. But one thing you see here in the alerts, you can uh, we will talk you can create alerts rules, you can create action groups, and processing rules, and then you can notify people. So in the action group you can create we have already done that for application insights. We created a alert type for smart detections, and we created actions groups for actions for sending two emails to resource manager. So that is about alert. I don't want to go into detail, we have already done that. So yeah, it's pretty clear. Let's continue.
It's easy not to understand exactly what a notification hub namespace all does. Um, so to help clear things up, a namespace is collection of notification hubs. There can be one or more notification hubs per namespace. Generally, what you will do is create one namespace you are creating for an application or customer loyalty application for a shop. Then you would create a namespace just for that app. Then inside that namespace you would create one notification for each application. Let's say for environment, so for one for production environment, one for development environment, and so on. You can access all the notification hubs within namespace by using credentials supplied at the namespace level, and billing is done also at the namespace level. So everything is built at the namespace level. You have multiple namespace, sorry, notification hubs in a namespace. And let's continue how it's. So let's start how sending notifications workflow. First off, you will need to go to each platform you want to send notifications to and configure it to receive notifications for your application. So for that you need to configuration, and then you will need to set up Azure Notification Hubs instance, just like you learned how to do it in the previous demo. And then you need to map. So after that, you will map keys obtained from the platform notification service to specific areas in notification hubs. So essentially, you are adding credentials from PNS to ANH Azure Notification Hubs. And then you need to register the devices. So now you will only do these first steps once during the initial step setup, and then that's it. In order to send push notifications to a device, you will need to register that device with the notification hubs. Essentially, here you are making a note of the device ID, which operating system it runs on, and so on. You can register it with the notification hubs.net SDK, which will happen through a web API backend. And then you can send finally the push notifications once your device is registered. So the mechanism that triggers the push events can come from web API, and because you are using .NET SDK, it's cross-platform. One SDK triggers multiple different platform pushes, and you can trigger multiple different types of pushes by using SDK too. So you are create update installation async, and here you are talking about the installation, which installation you want to perform, and this is simply notification hub client, which is using action connection string and the name of the notification hub. And same way you can send template notification async. So in this demonstration you will learn how to register devices using the Azure notification hubs.net SDK, and also how to send those notifications as well. So yeah, it's pretty clear, right? You create a message and then you send it to the hub client. So register a device. In this demo, you are going to learn how to register device with notification hub so it can eventually send push notifications to them. Here I will be using a .NET application, which is actually a same web application that was used previously, and there's a controller which is register device controller. Let's go to that API itself. Let's go.
All right, I am in my Visual Studio, and here I am in the controller, send notification controller, and in that controller, sorry, register device controller, and here I am in the post function, which is simply creating a push service, and on that push service, it is creating, calling the function register device. Let's go and deep dive in this push service. So push service is nothing but just having a notification hub client with your supplied connection string and notification hub name, and this hub client is then available for all the remaining functions it will be using. So
above here we have send post, but we also have a register device function, which is simply creating an installation, which I just shown you in the previous slides as well. And then it is creating installation template where it is saying body device specific JSON with variable placeholder blah blah blah, and then you also adding some template, so install template. So basically you are sending install template, and then you are deciding in the registration, which we just registration request, which is coming from the device itself here, and registration request is simply from send notification, which contains installation ID, platform, and push channel. So let's go here, back to the push service, where you are just providing which type of push channel it is. Is it Apple, FCM, WNS, whatever, and then you create or update installation as thing. So basically it's a, then you call this function from this library notification hub client, which is simply pushing it. So I hope it is clear how to register a device, and then once the device is registered, then you can send the notification to it. And these are some private properties here, but what I want to go directly to is to send function here, which is simply getting the stream request from the body, which is a request from your application itself. Then it is creating a body JSON, then deserializing it to event create event, and then simply sending the notification. So I hope it is clear, and enjoy your notification hub adventures, and that's it. So good luck and enjoy your notification hub. Right, that's a wrap. Please write down your comments, questions, and suggestions in the comment box, and good luck with your exam. I hope you learned something, and because I tried to explain everything in my own way, maybe I wasn't clear enough, and maybe you have some feedback for me. So I would really appreciate your feedback. I put a lot of hard work in it, but maybe still it is not enough. I put more than 100 hours in preparing this course because it's really long, and uh, it covers a lot of topics. Still I might not have done a lot of demos maybe, but I would be creating a separate video for that, which will cover labs and some other exam topics. So thank you for watching, and enjoy tech of the day. Enjoy this course, and good luck for your exam. Hope it helped you a little bit, at least some degree. Thank you. Have a nice day or evening, whatever is suitable to you. Thank you. Bye. Have a nice day.